Databook OKI. Microcontroller. Criteria D. Manufacturer's representative. 408-988-6300. 4 SNTE Clara, California 95054. 3350 Scott Boulevard, Building 4, A. 3rd edition. Issue date, March 1988. Preface. A high-technology company with an aggressive approach to innovation, OKI has been supplying single-chip microcontrollers since 1975. OKI's single-chip microcontrollers find wide application in various types of electronic equipment in the consumer and the industrial fields. Our products have been enjoying a good reputation for their high quality and high performance. The most outstanding feature employed in all of OKI's microcontrollers is CMOS technology, which ensures low power operation. OKI will continue to enhance its microcontroller series and program development systems to cater to customers' requirements. Contents: 1 program development system. 2 lineup and typical characteristics. 7. 3 code entry. 15. 1 usable media. 17. 2 single-chip microcontroller development stages. 18. 4 packaging. 19. 5 reliability information. 33. 6 data sheet. 43. OLMS 40 series. 45. MSM 5840. 47. MSM 5842. 58. MSM 58421. 66. MSM 58422. 76. MSM 5847. 84. OLMS 50/60 series. 89. MSM 5052. MSM 5054. 98. MSM 5055. 105. MSM 5056. 112. MSM 6051. 119. MSM 6351. 1. MSM 6052. 139. MSM 6352. 149. OLMS 64 series. 161. MSM 6404. 163. MSM 6404 VS. 175. MSM 6408. 177. MSM 6411. 188. MSM 6422. 199. MSM 6442. 207. MSC 6458. 217. MSC 6458 VS. 233. 3. OLMS 65 series. 235. MSM 6502/6512. 237. 8-bit series, OKI original. 247. MSM 62580. 249. MSM 66301. 258. 8-bit series, Intel compatible. 281. MSM ADC 35/48, MSM ADC 39/49, MSM ADC 40/50. 283. MSM ADC 31F/MSM ADC 51F. 308. MSM ADC 154/MSM AD3C 154. 333. MSM85C154 VS 367. 7 Program Development Support Systems 369. ES40 371. E6400 380. E6502 390. ES80C49 400. ES80C51/MKI 411. Mac 51 420. 4. Program Development Systems 11. Program Development Systems for OKI Microcontrollers OLMS40 Series Target Chip Development Tool Standard Software Adapter Module Field Debugging Package Name, included in package, if necessary, Tool MSM5840 ES40 DB400 Debugger Serial Interface, ASM40 Cross Assembler MSM5842, Bus Interface MSM58421 MPB421 MPB202 MSM58422 MPB422 MSM5847 Dedicated Hardware Simulator Note 1. The standard software DB400 and ASM40 are available on CP/M80 for most personal computers, or ISIS 2.4. Intel MOS CP/M is a registered trademark of Digital Research, and ISIS 2, MDS of Intel. Low Power Series Target Chip Development Tool Package Name MSM5052 ES5052/5S MSM505S MSM5054 ES5054/55 MSM5055 MSMS051 ESAS051 MSMS351 ESAS351/S353 MSMS353 MSMS052 ESAS052 ESAS352/S052 MSMS352 ESAS352/S052 Note 1. The standard software is available under following operating system: CP/M80 for most of personal computers, MISUS for OKI if 800, NEC PC 9801 etc. DOS for IBM PC XT, at IBM 5550. EASE. Host. Monitor. Standard software. ASM50. Cross-assembler. 11. 3. E-Program Development Systems E______. OLMS64 Series. Target Chip. Development Tool I/O Adapter Standard Software Field Debugging. Package Name Module, included in Package, Tool. MSM6404. MSM6408, ASM6408, *. MSM6402. E6400 ES ASM6400. MSM6422 PAM6422 Host PAM6422. Monitor. MSM6411 PAM6411 PAM6411. MSM6442 PAM6442 PAM6442. MSC6458 E6458, ASM6458. Note the standard software is available under following operating system: EASE, ASM6400, ASM6458. CP/M80 for most personal computers. MS-DOS for OKI if 800, NEC PC 9801 etc. DOS for IBM PC XT, at IBM 5550. Asterisk ASM 6408. CP/MAD version. ASM 6400 covers MS-DOS and PDOS for MSM 6408. OLMS 65 series. Piggyback. MSM 6404 VS. MSC 6458 VS. Target chip. Development tool standard software. Field debugging tool. Package name, included in package. MSM 6502/6512 E6502. E65. MPB 6502 EVA. ASM 6502. Note the standard software is available under CP/MAD, MS-DOS, or PDOS. 8-bit series, Intel compatible. Target chip development tool standard software option AL software piggyback. MSM ADC 48. MSM ADC 49 EAS ADC 49. EAS 49. ASM 49. MSM ADC 50. MSM ADC 51 FEC Node 1. MSM 83 C154 EAS ADC 5 IMKIll ASM 51 MSM 85 CI 54 VS. Note. 1 optional software for MSM ADC 51/83 C154. PASM preprocessor, MAC 51 relocatable assembler, RL 51 object linker, LLB 51 librarian SID 51 symbolic debugger. 2. The softwares are available under following operating system. 4. EAS 49. CP/MAD ISIS 1I. ASM 49. CP/MAD ISIS 1I. EAS and ASM 51. CP/MAD for OKI if 800, NEC KD 801 etc. MS-DOS for OKI if 800, NEC PC 9801 etc. PDOS for IBM PC XT, at IBM 5550. PASM, MAC 51, RL 51, LLB 51 MS-DOS for OKI if 80, NEC PC 9801 etc. SID 51 PDOS for IBM PC XT, at IBM 5550. Program Development Systems. 8-bit series, OKI Original. Target chip. Development tool. Package name. MSM 66301 E66301. MSM 62580 E62580. Note. 1 optional software for MSM 66301. C compiler, VMS for UVAX1I. Relocatable assembler, VMS. Object linker and librarian, VMS. CC66 debugger, VMS. Symbolic debugger, VMS. Standard software. Optional software. Included in package. ASM 66301. C Note 1. EAS. As 62580. EAS. Under development. 11. 5. Lineup and typical. Characteristics. OLMS 40 series. Power clock ROM RAM input 1/0. Type No. Process supply frequency, bit, port output port. Voltage. MSM 5840 CMOS 5V 4.2 MHz 2048X8128X46168. MSM 5842 CMOS 5V 4.2 MHz 768X832, 4588. MSM 5B 421 CMOS 5V 4.2 MHz 1536, 840X4535 LCD SEG. B. SLED SEG. Or Logic. MSM 58422 CMOS 5V 4.2 MHz 1536, 840, 457, 5 FLT Seg 85 Discreate. MSM 5847 CMOS 3V 32 kHz 1536 x 896 x 4, 24 x 3 LEC Seg 7. OLMS 50/60 series. Power clock RAM input 110. Type No. Process supply output port. Voltage frequency, bit, port. MSM 5052 CMOS 1.5V 32 kHz 1280 x 1462 x 4B. 26x2 LCD Seg. S logic. MSM 5054 CMOS 1.5V/3V 32 kHz 1024 x 1462 x 4644 x2 LCD Seg. 4 logic. MSM 5055 CMOS 1.5V/3V 32 kHz 1792, 196, 4B. 60x2 LCO Seg. 4 logic. MSM 5056 CMOS 1.5V 32 kHz 1792, 1490 x 4438 x2 LCO Seg. 4 logic. MSM 6051 CMOS 1.5V/3V 32 kHz 2560 x 1120 x 4963 x 3 LCO Seg. 4 logic. MSM 6351 CMOS 1.5V/3V 32 kHz 4096 x 1510 24 x 59 x 3 LCD Seg. Or 2058 x 4 LCD Seg. MSM 6353 CMOS 1.5V, 3V 32 kHz 4096 x 15 1024 x 4, 20. MSM 6052 CMOS 3V 3.58 MHz 2048 x 14640 x 412 4. MSM 6352 CMOS 3V 3.58 MHz 2048 x 14640 x 12 Timer inter-instruct machine. Counter RUPT. Stack TION cycle. 8-bit R/W2498 7.65. 8-bit, 152 7.6s. 12-bit, 152 7.6, 5. 12-bit, 152 7.6, 5. 13-bit, 243 61 OS. Timer inter-instruct machine stack. Counter RUPT TION cycle. 42 122, 5. 41,221s. 42 122, 5. 42 122, 5. 125991. 511s. 3765 61.0. 3760.0. 4-bit 1552 17.911s. 4-bit 2552 17.9i1s. Power consumption. Active standby. 1.6 mAh. 1.SMA. 2.ohma. 2.ohma. 50. Power consumption. Active standby. 3. 3. 3.A. 3. 3. 3.A. 3. 1.2 mAh 0.2. 1.SMA 0.2. Package. 42 dip/44 flat. 280 LP/32 flat. 60 flat. 60 FLL. 44 flat chip. Package. Chip. 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 CHIP/100 flat. Chippy. 42 pins dip. 28 dip I 40 dip slash. Flat. 2 BDIP I 40 dip I. 44 flat. Remarks. Remarks. Built-in temper. Ature detector. Voice. Controller. Connection with. Solar cell available. Built-in DTMF. Built-in DTMF. On-hook dialing. Equals. C. Z. M. C colon. T I. Z. C. T I O. Percent. U. I. M. U. N. Colon colon. N. O. OLMS 54 series. Power clock ROM RAM input 110. Type no. Process supply output port. Voltage frequency, bit, bit. Port. MSM 6404 CMOS 5V 4.2 MHz 4000, 8256X 44-32. MSM 640B CMOS 5V 4.0 MHz 8096X 8256X 44-32. MSM 6411 CMOS 5V 4.2 MHz 1024X 832X 4428. MSM 6422 CMOS 5V 4.2 MHz 2048X 864X 41-18. MSM 6442 CMOS 5V 4.2 MHz 2048X 8128X 4146X2 LCD Seg. 16. MSC 6458 by CMOS 5V 4.3 MHz 8192X 8512X 4912, 12 FLT Seg. 24. I. OLMS 55 series. Power clock ROM RAM input 110. Type no. Process supply frequency, bit, bit, port output port. Voltage. MSM 6502 CMOS 3V 32 kHz 2000X 8128X 4410 LCD Seg. 8. MSM 6512 CMOS 3V 32K _ I 2000X 8128X 4I 4108 LCO Seg. I8. Timer inter instruc. Stack. Counter RUPTTION. 12-bit. 12-bit R/W 121. A bit R/W. 12-bit. 12-bit R/W 121. 8-bit R/W. 2863. 12-bit 21663. 8-bit R/W 41676. 12-bit. 16-bit A/W 832 147. 8-bit R/W. Timer inter instruc. Counter RUPT stack TION. 12-bit 33268. 12-bit 33268. Machine power consumption. Cycle active standby. 952 N56 Ma 1.A. 1.S6 Ma 1.A. 952 N56 Ma 1.A. 952 N56 Ma 1.A. 952 N56 Ma 1.A. 930 N59 Ma 1.A. Machine power consumption. Cycle active standby. 91.5 P.S 45 P.A. I. 30 P.A. 91.5 P.S 30 P.A. 1. 12 P.A. Package remarks. 42 dip/44 flat. 42 dip/44 flat. 16 dip/24 flat. 16 dip/24 flat. BOFLAT built-in LCD controller/driver. 64 shrink dip / built-in FLT con. 64 flat troller/driver. Package remarks. 44 flat / chip. 44 flat / chip. C. Z. M. I. C. U. L. Z. C. I. O. L. R. O. E. L. Laughing face. L. O. I. M. Laughing face. N. O. TJ. 8-bit series, Intel compatible. Power clock ROM RAM input 1/0. Type no. Process supply frequency, bit, port output port. Voltage. MSM ADC35 CMOS 5VL1 MHz, 64, 8 to 24. MADC39 CMOS 5VL1 MHz, 128x 8 to 24. I. MSM ADC40 CMOS 5V6 MHz, 256, 8-24. MSM ADC31 FCMOS 5V16 MHz, 128x 8. I. 32. MSM ADC 154 CMOS 5V16 MHz, 256x 8, I32. Mizambach 48 CMOS 5VL1 MHz 1024x 864x 8. +. 24. MSM ADC 49 CMOS 5VL1 MHz 2048L, 8128x 8, I24. Mizambach 50 CMOS 5V6 MHz 4096x 8 256x 8, I24. MSM ADC 51 FCMOS 5VI16 MHz 4096x 8 128x 8, I32. MSM 83C 154 CMOS 5VI16 MHz 16384x 8 256x 8, I32I. 8-bit series, OKI original. Power clock ROM RAM input 110. Type no. Process supply frequency, bit, port output port. Voltage. MSM 62580 CMOS 5V5 MHz 3072x 8 128x 8. I. IMSM 6630. I. CMOS 5V10 MHz 16384x A 512. I. Timer inter-instruct machine. Counter RUPT stack TION cycle. 8-bit A/W2811 1.365. 8-bit R/W2811 feet 1 inch. 36115. 8-bit RIW2811 2.5s. 16-bit R/WX256411 0.755. 16-bit R/WX362811 0.7s/ls. 8-bit AIW2811 1.365. 8-bit RTW2811 1.365. 8B.TRIW2811 2.55. 16-bit AIWX256411 0.755. 16-bit AIWX362811 0.75 fs. Timer inter-instruct machine. Counter RUPT stack TION cycle. 3295 800N8. 16 bits 47256 99 400N5. Power consumption. Active standby. Lorna Fa. 20 Ma Fa. 20 Ma Fa. Lorna Fa. Lorna Fa. Lorna Fa. 20 Ma Fa. 20 Ma Fa. Power consumption. Active standby. 4 Ma 10p.a. Package remarks. 4 QoIP/44 flat. 40 DIPF 44 flat. 40 DIP/44 flat. 400 IP/44 FLATI. 44 PLCC. 400 IP/44 fault I. 44 PLCC. 40 DIP/44 flat. 40 DIP/44 flat. 40 DIP/44 flat. 400 IP/44 FLATI. 44 PLCC. 400 LPI 44 FLATI. 44 PLCC. Package remarks. 4 iCards. COB underdevelop. MANT. Underdevelop. 64 shrink DIPI MANT. PGB type. 68 PLGAIDC8CHL OBIT. UART 64 flat. PWM. Chapter register. R. Z. M. C. U. J. Z. O. U. O. J. R. N. Z. J. Laughing face, J. N. I. M. Laughing face, 3. I-O. N. Lineup and typical characteristics dash. Low power high speed. OLM 50/60 series OLM 64 series. Power. Type no. RAM consump features. TION. Type no. RAM machine features. Cycle. MSM 5052 1280 x 1462 x 43 PA 52 seg. LCD driver MSM 6404400 aux 8256 x 4952 NS 110, 36. MSM 5054 1024 x 1462 x 43 PA 88 seg. LCD driver MSM 6408 8096 x 8256 x 495208 110, 36. MSM 5055 1792 x 1496 x 43 PA 120 seg. LCO driver MSM 6411 1024 x 832 x 4952 NS 110, 11. MSM 5056 1792 x 149 aux 43 PA 76 seg. LCD driver MSM 6422 2048 x 864 x 495208 110, 19. MISMA 51 2560 x 14 120 x 43 PA 189 seg. LCD driver MSM 6442 2048 x 8128 x 495208 92 seg. LCD driver MSM 6052 2048 x 14640 x 41. ANA DLMF generator 6352 1. ANA MSM 6458 8192 x 8512 x 49 LONS 144 seg. FLT driver MSM 6351 4096 x 1510 24 x 43 PA 232 sag. LCD driver MSM 6353 4096 x 1510 24 x 43 PA serial board, synchronous/idle non-synchronized. OLM 40/65 series. Type no RAM. Machine features. Cycle. MSM 5840 2048 X812 BX4 7.6 S110, 30 IC card. MSM 5840 2768 X832 X4 7.6 110, 21. MSM 5842 11536 X84 OX4 7.6 35 seg.lcd driver. MSM 5842 21536 XB4 OX4 7.6 35 seg. FLT driver. MSM 5847 1536 XS96 X4 672 seg.lcd AIVR 1-chip microcomputer for IC card. MSM 6502 OX812 BX4 91.5 LOB seg. LCD driver type no. ROM-RAM machine features. Cycle. MSM 6512 200 OX8128 X4 91.5 SL04 seg. LCD driver MSM 625 ILO 3072 X8128 X8 Boons built-in EPAM 2048 XS. 4-bit BBIT LJNL. OKI 1 Chi. 12. Dash. Lineup and typical characteristics. I high performance I. MSM ADC 154 series. Type no. ROM-RAM machine cycle. Dash dash. MSM 83C 154 16384 X8 256 X8 75 on 5. Mizambach 154 256, 875 on 5. D. MSM ADC 51 series. Type no. ROM-RAM machine. Cycle. MSM ADC 51/51 F4096 X8 128 X8 0.75s. MSM ADC 31/31 F128, 80.755. 0. MSM ADC 48 series. Type no. ROM-RAM machine. Cycle. MSM ADC 48 1024, 864 X8 1.36.8. MSM ADC 49 2048 X8 128 X8.36.8. MSM 80 CSO 4095 X8 256 X8 2.5.8. MSM ADC 3564 X8 1.36s. R. MSM ADC 39128, 81.365. MSM ADC 4256 X8 2.5s. 8-bit. Microcomputer. High performance. NX series. D. OLMS 66K series. Type no. ROM-RAM machine cycle. MSM 6630116384 X8512 X8 405. 16-bit. 13. Code entry. ECODEENTRVE. Code entry. The program code entering method is outlined below. 1 usable media. 1. 2 pieces of same type EPROMs containing identical data. EPROM specification. 2716. 2732. 27C32. 27C32A. 2764. 27C64. 27128. 27256. 2. 1 copy of object mock-IRI code list. 17. D. Code entry. 2 single-chip microcontroller development stages. 18. User 1. User 2. OKI 3. II. J. 1. OKI 4. OKI 5. Program with OKI development tool. If 800 tool. Prepare 2 PCS of EPROM and programming list. EPROM printout. Print out identical EPROM DTA.1LJ11-TF.FLOL. Engineering sample. Actual production sample of your microcontroller. Chip prepared for final approval. Dash. PORR/2. L. Dash. Volume production of single chip microcontrollers. Packaging. Packaging. Package/pin count. DIP flat PLCC. MSM 5840 42 pin 44 pin. MSM 5842 28 pin 32 pin. MSM 58421 60 pin. MSM 58422 60 pin. MSM 5847 44 pin. MSM 5052 56 pin. MSM 5054 56 pin. MSM 5055 bow pin. MSM 5056. MSM 6051. MSM 6351 100 pin. MSM 6052 28 40ths pin 44 pin. MSM 6352 28 40ths pin 44 pin. MSM 6404 42 pin 44 pin 44 pin. MSM 6404 VS 42 pin piggyback. MSM 6408 42 pin 44 pin 44 pin. MSM 6411 16 pin 24 pin. MSM 6422 24 pin 24 pin. MSM 6442 80 pin. MSC 6458 64 pin shrink 64 pin 68 pin. MSC 6458 VS 64 pin shrink. Piggyback. Note, chip type is available. 21. Packaging dash. Package/pin count. DIP flat PLCC. MSM 6502, 56 pin, S. MSM 6512, 56 pin, S. MSM 62580, Cobb, 5 pin. MSM 66301 64 pin shrink 64 pin 68 pin. MSM ADC 3540 pin 44 pin 44 pin. MSM ADC 3940 pin 44 pin 44 pin. MSM ADC 4040 pin 44 pin 44 pin. MSM ADC 3140 pin 44 pin 44 pin. MSM ADC 4840 pin 44 pin 44 pin. MSM ADC 4940 pin 44 pin 44 pin. MSM ADC 5040 pin 44 pin 44 pin. MSM ADC 31F40 pin 44 pin 44 pin. MSM ADC 51F VS 40 pin piggyback. MSM ADC 51F40 pin 44 pin 44 pin. MSM ADC 15440 pin 44 pin 44 pin. MSM AD3C 15440 pin 44 pin 44 pin. MSM AD5C 154 VS 40 pin piggyback. Note, S, means small package. 22. Dash packaging. 16 pin plastic dip. 18 pin plastic dip. 2. 24.5 max. 0 degree _ 15 degree. 2.54 plus or minus 0.25 seating plane. 2.54 plus or minus 0.25. 0.15 degree. Seating plane. Unit mm. 7.62 plus or minus 0.30. Unit mm. 23. Packaging dash. 24 pin plastic dip. 2.54, 2.25. 0.28 pin plastic dip. 24. L, L. NI00IS. Unit mm. 15.24 plus or minus 0.30. Seating plane. Unit mm. 15.24 plus or minus 0.30. Seating plane. Packaging. 40-pin plastic dip. 52.8 max. Unit. 15.24 plus or minus 0.30. Seating plane. 42-pin plastic dip. 52.8 max. Unit, mm. 15.24 plus or minus 0.30. 2.54 plus or minus 0.25 seating plane. 25. Packaging comma dash. 64-pin shrink dip. 58.0 max, unit, mm. 19.05 plus or minus 0.30. 26. EPACKAGINGE. 24, pin plastic flat. IL. Index mark. 32, pin plastic flat. Index mark. O. At. Unit mm. Unit mm. 0.1 to 0.3. 27. Packaging, dash. 44, pin plastic flat. I. 14.5 plus or minus 0.4. 10.5 plus or minus 0.3. Index mark. 56, pin plastic flat. 14.5 plus or minus 0.4. 10.5 plus or minus 0.3. Index mark. 28. Unit mm. O_10. Unelt mm. Dash. Packaging. 60, pin plastic flat. I. Index mark. 80, pin plastic flat. Index mark. 24.00. 1.001. 25.00. Unit mm. 2.40.2. Unit mm. 2.1 plus or minus 0.2. 0-10. 0.2 plus or minus 0.15. Backslash 0.15. 29. Packaging dash. 44 pin plastic PLCC. I backslash .L. 1.27 tip. 68 pin plastic PLCC. 30. T. I backslash .L. 4.57. 4. Index mark. I. 16.00. I 14.99. Max mm. Und equals dash. Min mm. Max mm. Und equals dash dash. Min mm. I 23.62 I 22.61. E. Packaging. 40 pin piggyback. Unit mm. Therilyl J. HR. 0.35 max. 0.6 max 2i, 2.54 plus or minus 0.25 till. II 15.24 plus or minus 0.30. R1. 42 pin piggyback. Unit mm. 31. E packaging E, comma dash. 64 pin shrink piggyback. Unit, mm. I. 58.00. I. LQL equals 1L. I. Up LL41J.S. Z. F15.24J. J, 1. Ho. 1. I 19.05 to minus 1. 1 dash 33.02, dash plus I. FLULULLLU dash equals 1.788 plus or minus 0.25. 32. Reliability information. Reliability information. 1. Introduction. Semiconductor devices play a leading role in the explosive progress of technology. They use some of the most advanced design and manufacturing technology developed to date. With greater integration, diversity and reliability, their applications have expanded enormously. Their use in large-scale computers, control equipment, calculators, electronic games and in many other fields has increased at a fast rate. A failure in electronic banking or telephone switching equipment, for example, could have far-reaching effects and can cause incalculable losses. So, the demand for stable, high-quality memory devices is strong. We, at OKI, are fully aware of this demand. So we have adopted a comprehensive quality assurance and system based on the concept of consistency in development, manufacturing, and sales. With the increasing demand for improvement in function, capability, and reliability, we will expand our efforts in the future. Our quality assurance system and the underlying concepts are outlined briefly below. 2. Quality assurance system and underlying concepts. The quality assurance system employed by OKI can be divided into 4 major stages: device planning, developmental prototype, production prototype, and mass production. This system is outlined in the following block diagram, Fig. 1. 1. Device planning stage. To manufacture devices that meet market demands and satisfy customer needs, we carefully consider functional and failure rate requirements, utilization, form, environment, and other conditions. Once we determine the proper type, material, and structure, we check the design and manufacturing techniques and the line processing capacity. Then we prepare the development planning and time schedule. 2. Developmental prototype stage. We determine circuits, pattern design, process settings, assembly techniques, and structural requirements during this stage. At the same time, we carry out actual prototype reliability testing. Since device quality is largely determined during the designing stage, OKI pays careful attention to quality confirmation during this stage. This is how we do it. 1. After completion of circuit design, or pattern design, personnel from the design, process, technology, production technology, installation technology and reliability departments get together for a thorough review to ensure design quality and to anticipate problems that may occur during mass production. Past experience and know-how guide these discussions. 2. Since many semiconductor memories involve new concepts and employ high-level manufacturing technology, the TEG evaluation test is often used during this stage. Note, TEG, test element group, refers to the device group designed for stability evaluation of most transistors, diodes, resistors, capacitors and other circuit component element used in LSI memories. 3. Prototypes are subjected to repeated reliability and other special evaluation tests. In addition, the stability and capacity of the manufacturing process are checked. 3. Production prototype stage. During this stage, various tests check the reliability and other special features of the production prototype at the mass production factory level. After confirming the quality of a device, we Pair the various standards required for mass production, and then start production. Although reliability and other special tests performed on the production prototype are much the same as those performed on the developmental prototype, the personnel, facilities, and production site differ for the two prototypes, necessitating repeated confirmation tests. 4. Mass production. During the mass production stage, careful management of purchased materials, parts and facilities used during the manufacturing process. Measuring equipment, manufacturing conditions, and environment is necessary to ensure device quality first stipulated during the designing stages. The manufacturing process, including inspection of the completed device, is followed by a lot guarantee inspection to check that the specified quality is maintained under conditions identical to those under which a customer would actually use the device. This lot guarantee inspection is performed in 3 different forms as shown below. 1. Group A tests, appearance, labels, dimensions and electrical characteristics inspection. 2. Group B tests, check of durability under thermal and mechanical environmental stresses, and operating life characteristics. 3. Group C tests, performed periodically to check operational life, etc. on a long-term basis. Note, like the reliability tests, the Group B tests conform to the following standards: MIL STD 883B, JISC 7022, EIA JIC 121. 35. C. GL. O. C. Plus. C. 21. G. N. Process MANT. Acceptance of order. Development. Design. Production. Inspection. Shipment. Delivery. Service. Quality assurance. And quality control. Staff activities. Design, production, purchasing, production, storage. Sales engineer, production engineer, control, vendors, inspectio. Marketing and product plan MEI. 1 GJ, IVS I. H design review and trial product review I. 1 I. Layout program I production R planning. Underscore I technical operation I. ITS standard N. TI.1 production R. I production II. Process. 2. Process control. Setup T. L. Acceptance. Inspection. 1 per dot chasing. Guidelines. H. In PROCSS. Inspection. Product. Inspection 1. I. H quality testing. Storage. Control. 1. Quality and reliability 1. Information analysis. Reliability. II. Quality evaluation. Engineering. Quality management 1 and education failure analysis. Quality control program plus reliability program. V. Quality assurance. Transportation maintenance service. Aging L. Transportation. Control. Report. 2 failure. R. N. Analysis. Service. R. Customer. R. F. 11. M. R. O. 11. S 5 Z dash reliability information, production process, wafer process, and assembly, acceptance inspection, production process quality control, I lot control, equipment conditions, in-process inspection, thermal screening, seal test, early removal of defective devices, electrical test, regular check of measuring, -R equipment, Group A test, Group B test, Group C test, Figure 2 manufacturing process. Devices which pass these lot guarantee inspections are stored in a warehouse awaiting ship, meant to customers. Standards are also set up for handling, storage and transportation during this period, thereby ensuring quality prior to delivery. Figure 2 shows the manufacturing flow of the completed device. 5. At OKI, all devices are subjected to thorough quality checks. If, by chance, a failure does occur after delivery to the customer, defective devices are processed and the problem rectified immediately to minimize the inconvenience to the customer in accordance with the following flowchart. Request for technical improvement. R, I results of I investigation. ____ and improvement. Report on I results of I investigation. L_.rv:/et. Request for manufacturing improvement. Engineering department. Figure 3 failure report process. 37. Reliability information dash quality assurance and quality control. Quality and reliability information. Quality evaluation. Defective analysis. Reliability engineering. Quality management and education. Operation standard. Technical standard. Qual-ITY standard. Design review. Prototype review. 3 example of reliability test. Results. We have outlined the quality assurance system and the underlying concepts employed by OKI. Now, we will give a few examples of the reliability tests performed during the developmental and production prototype stages. All reliability tests performed by OKI conform to the following standards. MIL STD 883B, JISC 7022, EIA JIC 121. Since these reliability tests must determine performance under actual working conditions in a short period of time, they are performed under severe test conditions. For example, the 125 degrees Celsius high temperature continuous operation test performed for 1000 hours is equivalent to testing device life from 2 to 300 years of use at Ta equals 40 degrees Celsius. By repeating these accelerated reliability tests, device quality is checked and defects analyzed. The resulting information is extremely useful in improving the manufacturing processes. Some of the more common defects in LSI elements and their analysis are described on next page. 38. Target quality. Design quality. Dash. RELIABILLTVINFORMATION. Microcontroller life test results. Part name MSM-ADC31/51 MSM-ADC35/39/48/49 MSM-AD3C154 XXRSXXRSXXRS Function 8-bit 1 chip 8-bit 1 chip 8-bit 1 chip referred Microcontroller standard Test sample test failures Item condition size hours PCS Operating Ta equals 125 degrees Celsius 88 2000 88 2000 88 2000 mil Life test VCC equals 6V H STD883C Method 1005 Temperature Ta equals 85 degrees C 100 20000100 20000100 2000A Humidity test RH equals 85% VCC equals 6V H Temperature - 55 degrees C RT 150 degrees C 100 500 0 100 300 0 100 500 0 mil STD Cycling test 30 minutes T 30 minutes Psi 883C 5 minutes Method 1010 Pressure Ta equals 121 degrees C 5200 0 5200 0 5200 0 Cooker test RH equals 100% H 2 ATM Part name MSM6404XX MSM-ADC31JS Function 4-bit 1 chip 8-bit 1 chip referred Microcontroller standard Test sample test failures Item condition size hours PCS Operating Ta equals 125 degrees C 88 2000 88 2000 mil Life test VCC equals 6V H STD883C Method 1005 Temperature Ta equals 85 degrees C 100 2000 2000A Humidity test RH equals 85% VCC equals 6V H High temperature - 55 degrees C RT 150 OC 100 500 0 100 500 AI mil Cycling test 30 minutes T 30 minutes Psi STD883C 5 minutes Method 1010 Pressure Ta equals 121 degrees C 5200 A 5200A Cooker test RH equals 100% H 2 ATM 39 Reliability information Microcontroller environmental test results Part name MSM-ADC31151 MSM-ADC35/39/48149 MSM-AD3C154 XXRSXXRSXXAS Function 8-bit 1 chip 8-bit 1 chip 8-bit 1 chip referred Microcontroller microcontroller standard Test sample failures Item condition size PCS size Soldering 260 C 220 220 mil Heat test 10 SEC STD883C Method 2003 Temperature 55 CRT 150 C 220 mil Cycling test 30 minutes 5 minutes 30 minutes STD883C. 20 cycles method. 1010. Thermal 100 C0 C220 220 220 mil. Shock, 5 minutes, 5 minutes, STD883C. Test 10 cycles method. 1011. Lead. Tensile 500 G10 SEC mil. Integrity 11011. 110 STD883C. Bending 250 G90 bend method. 3 times 2004. Solderability 230 C5 SEC 220 220 mil. STD883C. Method. 2003. Part name MSM6404 MSM80C31JS. XXJS. Function 4-bit 1 chip 8-bit 1 chip referred. Microcontroller standard. Test sample failures Item condition size, Ps, size, PCS. Pre-bake bake. 1125 degrees Celsius, 6 HRSL. In J soldering vapor phase reflow, 21 ST2QC 90 plus 10. AC. C. Heat test 2 times. E. C. 222.0.20.20. C. Temperature -55 degrees CRT plus equals 150 degrees C mil. W. Cycling test, 30 minutes, 5 minutes, 30 minutes, STD883C. OJ method. E 20 cycles. Q, 1010. R. I. Thermal 100 degree CO degree C mil. Shock, 5 minutes, 5 minutes, STD883C. Test 10 cycles method. 1011. In. Solderability SAK 112 SC, 24H01222020. I immerse into flux. Q, immerse into solder. R. C5, 215 plus or minus 2 degree C tentil sec. 40. Dash. Reliability information. For semiconductor memory. Failures. The lifespan characteristics of semiconductor elements in general, not only semiconductor i.e. devices, are described by the curve shown in the diagram below. Although semiconductor memory failures are similar to those of ordinary integrated circuits, the degree of integration, miniaturization, manufacturing complexity and other circuit element factors influence their incidence. Semiconductor element failure rate curve. Initial shipping wear out. Failure plus random ____ I. Failure. Failure. \m. 1. \m. General / electronic / devices / j / m equals 1 dash plus time. Debugging by burn in semiconductor. Screening elements. 1. Surge destruction. I. This is destruction of the input/output stage CIR. Quits by external surge currents or static electricity. The accompanying photograph shows a point of contact between aluminum and polysilicon that has been dissolved by a surge current. A hole has formed in the substrate silicon, leading to a short circuit. This kind of failure is traceable in about 30% of defective devices returned to the manufacturer. Despite miniaturization Shin of semiconductor memory component ELE. MENS, which means the elements themselves are less resistant. These failures usually occur during assembly and other handling operations. At OKI, all devices are subjected to static electricity intensity tests under simulated operation. Example of surge destruction. AL conditions in the development stage to reduce this type of failure. In addition to checking endurance against surge currents, special protective circuits are incorporated in the input and output sections. AI Aniction Aluminum ULI and __/F Wire I poly SI Destruction Position 2. Oxide film insulation destruction, pinholes. Unlike surge destruction, this kind of failure is caused by manufacturing defects. Locally weakened sections are ruptured when subjected to external electrical stress. Although this problem is accentuated by the miniaturization of circuit elements, it can be resolved by maintaining an ultra-clean manufacturing environment and through 100% burn-in screening. 3. Surface deterioration due to ionic impurities. Under some temperature and electric field conditions, charged ionic impurities moving within the oxide film previously resulted in occasional deterioration of silicon surfaces. This problem has been eliminated by new surface stabilization techniques. 4. Photolithographic defects. Integrated circuits are formed by repeated photographic etching processes. Dust and scratches on the mask, which corresponds to a photographic negative, can cause catastrophic defects. At present, component elements have been reduced in size to the order of 10 cm through miniaturization. However, the size of dust and scratches stays the same. At OKI, a high degree of automation, minimizing human intervention in the process, and unparalleled cleanliness, solves this problem. Photolithographic defect 41. RELIABILLTVINFORMATION-5. Aluminum corrosion. Aluminum corrosion is due to electrolytic reactions caused by the presence of water and minute impurities. When aluminum dissolves, lines break. This problem is unique to the plastic capsules now used widely to reduce costs. OKI has carefully studied the possible cause and effect relationship between structure and manufacturing conditions on the one hand, and the generation of aluminum corrosion on the other. Refinements incorporated in OKI LSLS permit superior endurance to even the most severe high humidity conditions. 6. Alpha particle soft failure. This problem occurs when devices are highly miniaturized, such as in 1 megabit RAMs. The inversion of memory cell data by alpha particle, generated by radioactive elements like uranium and thorium, present in minute quantities, may stored in PPB, in the ceramic package material, causes defects. Since failure is only temporary and normal operation restored quickly, this is referred to as a soft failure. At OKI we have eliminated the problem by coating the chip surface of 1 megabit RAMs with a resin which effectively screens out these alpha particles. Package ceramic dash equals C::7 dot comma dot F dot comma dash silicon oxide dash comma dash r dash comma plus, dash dash plus dash dash 2 im. Substrate silicon. Slash plus plus dash dash. A particle. Ionization along the particle path. 42. 7. Degradation in performance characteristics. Due to hot electrons. With increased miniaturization of circuit ELE. MENS, internal electric field strength in the channels increases since the applied voltage remains the same at 5V. As a result, electrons flowing in the channels, as shown in the accompanying diagram, tend to enter into the oxide film near the drain, leading to degradation of performance. Though previous low-temperature operation tests have indicated an increase of this failure, we have confirmed by our low-temperature acceleration tests, including checks on test element groups, that no such problem exists in OKI LSLS. Drain plus VGI. VDG. Source hot electrons. P. Substrate silicon. Characteristic deterioration caused by hot electrons. Drain. With further progress in the miniaturization of CIR. Quit components, failures related to pinhole oxide film destruction and photolithography have increased. To eliminate these defects during manufacturing, OKI has been continually improving its production processes based on reliability tests and information gained from the field. And we subject all devices to high temperature burn in screening for 48 to 96 hours to ensure even greater reliability. Datasheets. OLMS 40 series. H. OKI semiconductor. MSM 5840. CMOS 4-bit single-chip microcontroller. General description. The OKI MSM 5840 microcontroller is a low-power, high-performance single-chip device implemented in complementary metal oxide semiconductor technology. Integrated within this one chip are 16K bits of mask program ROM, 512 bits of data RAM, 30 input/output lines, a programmable timer/counter, and oscillator. Program memory is byte-wide and data paths are organized in 4-bit nib. Bless. RAM and I/O lines are bit addressable. Up to 4K of external ROM interfaces to the 8-bit bidirectional bus. 98 instructions include binary, BCD, logical operations, bit set, reset, test, 8-bit I/O, relative jumps, multifunctional instructions, increment, modify, skip, 8-bit wide table output, subroutine call, and return. 94% of instructions are single byte, single cycle operations. Features. Low power consumption, 8 MW typical expandable memory and I/O. 100% static logic, 50 JLW standby, typical 2 interrupt levels. 2K x 8 internal ROM. Up to 4K x 8 external ROM. 128 x 4 internal RAM. 30 I/O lines including 8-bit data bus. Programmable 8-bit timer/counter. Cell-contained oscillator. 98 instructions. Functional block diagram. Data RAM. 16, 8, 4. Backslash. PGJPFJPE, IPO-PKI. PF also XL098. Open drain. 4 stack levels. Operating temperature. -40 degrees to +85 degrees C. 3V to 6V operating VDD. Battery powered or battery backup. TTL compatible, with pull-ups. 7.61s cycle time at 4.2 MHz, VDD5V plus or minus 10%. POP EBJ 765432210. ADRL-/ and instruction. Program ROM 2048x8. Sync mode -05V. OGND 1 reset 47 EMSM 5840 Pin configuration, top view. 42 pin plastic dip, RS, 44 pin plastic flat package. Z 0 I of mm. ZA A 0 PH CIN sync H mode H CIN OSC PG G PG EVA G PG RO PGO PK PF K K F K F PKPF K F PK PF 0 E PK PFO D 0 0 GNO 0 IWW Z R3 pin description L I designation pin no function GND21 circuit GND potential VDD42 main power source plus 5V OSCO 10 crystal OSC input external clock input OSC 9 crystal OSC input external clock output not TTL compatible PAPB1T04 pseudo bidirectional ports for 4-bit parallel I/O. Used as a pair for 8-bit I/O. Used 38T041 to output 8 LSBs of address in external ROM mode. Used to read external instruction during if. PDPE 17T020 output ports for 4-bit parallel output and bit set/reset. Specified by internal. PEPG23T034 port pointer, bit position specified by set/reset instruction. PD also used for instruction address MSBs in external ROM mode during if. PK13 to 16 4-bit parallel or bit test input port, unlatched. PH36 and 37 2-bit input port with latched memory, negative level sensitive. Reset 7 reset has priority over every other signal. CMSM 5840 User's Manual for initialization sequence. Mode 8 used to enable external ROM mode during reset and also to enable STBP mode. During execution, 4-stepping program. In 6 negative edge sensitive external interrupt signal associated with EI and DI. Instructions. Vectors to location 200H. CIN35 negative edge sensitive external input for counter associated with ECT and DCT. Instructions. Vectors to location 1 do. Same as timer. Sync 5 general purpose synchronizing signal output at the beginning of each machine. Cycle. Used for address strobe during external ROM mode. RD12 read strobe pulse occurring when port A or B is read, 1A, 1B, 1AB. WR11 write strobe pulse occurring when port A or B is written, OA, OB, OAB, OBS, OTD. If 22 read strobe pulse occurring during an instruction fetch from external ROM. 48. _MSM 5840. Functional description. Program ROM. The MSM5840 will address up to 4 KB of program ROM and can have 2 KB of internal. Masked ROM, or all ROM may be located externally. External EPROM may be used for program development with conversion to internal ROM OC, occurring after program debug and system check out and verification. All instructions are byte-wide. Only 3 of the 98 instructions require 2 bytes of program code. The instructions are routed to a programmed logic array which generates the necessary internal control signals. Data RAM. Data is organized in 4-bit nibbles. Internal data RAM consists of 128 nibbles, 8 nibbles of which are dedicated registers accessible directly under program control. These are the general purpose registers, W, X, Y and Z, and the 4 save exchange registers, CH, A, L, and AX. All other data RAM must be addressed indirectly through the DP, data pointer, registers, a 7-bit pointer, directly accessible by numerous instructions, consisting of 4-bit DPL register and a 3-bit DPH register. Any nibble of internal data RAM can be accessed through the DP registers. Some instructions automatically change the contents of the DP registers, allowing efficient array processing. Input/output ports. PA, PB, these 2 ports are pseudo bidirectional ports which can be used as simple 1/0 lines or used as either a 4-bit or 8-bit parallel bus. An instruction fetches the external ROM data through these ports by outputting the 8 low order bits of address during sync, followed by an if instruction fetch cycle. In addition, synchronized data transfers are possible through these ports with the 1/0 pin signals RU and W are associated with certain input/output instructions dedicated to these ports. In short, PA and PB can be used as a multiplexed address low instruction/data bus. PO, PE, PF, PG, these 4 output ports are addressed indirectly through the 2-bit port pointer whose contents are changed through certain instructions. These ports are bit set/reset, addressable. PO is also used for the high order bits of address during an external instruction fetch. PF and PG are open drain out puts and PG is set high by a hardware reset. PK is an input port without memory, addressable either as a nibble or bit level input. PH is a 2-bit input port with memory, which can be tested and reset under program control. External interrupt. The TNT pin can be tested under program control or enabled to cause a vectored interrupt to location 200H. It is negative edge sensitive. Timer counter. The timer/counter is an 8-bit counter whose input is selected under program control to be either an external signal, CIN, or an internal square wave of 1/128. The frequency of the OSCE input, 2 MHz/128 equals 15.625 kHz. The timer/counter can be enabled or disabled under program control, as can be associated internal interrupt which vectors to location 100H and has higher priority than the external interrupt. Stack. The stack is an LIFO for storing return from interrupt and return from subroutine address information. It is 11 bits wide and 4 levels deep. Program counter, PC. The program counter is 11 bits wide and loaded under program control. Accumulator. The accumulator register is the data path focal point of the CPU. Approximately 1/2 of the instructions involve the accumulator. Its contents are the source and destination for many ALU operations and port operations. Case state ments, computed gotos, are possible by using the jump with accumulator, JA, instruction. Flags. The MSM5840 is endowed with the following set of flags. Z, 0 flag indicates that the result F all ones, 0 all zeros. C, carry. T, timer. CT, counter. TM, timer flag. Int, interrupt. INTE, interrupt. Enable. He memory. X of the previous operation was 0. Indicates a carry from the DPL register. Indicates a borrow from the DPL register. Indicates a carry from the previous operation. Indicates that the timer counter is specified as a timer. Indicates that the timer counter is specified as a counter. Indicates an overflow of the timer/counter register. Latching memory flag for the external interrupt. I indicates that interrupts have been enabled. Indicates that an input has been detected on the he input. Same as he except H1. Input. O indicates internal ROM. 1 indicates external ROM. If all external ROM. O indicates first bank of 2K. 49. EMSM 5840E dash 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 dash. Instruction set. Instruction code. Mnemonic discretion byte cycle. 765432210. CLA clear accumulator 0001000011. CLL clear DPL 0010000011. CLH clear DPH 0110000011. Lie load accumulator with immediate 000113I, 111011. LLI load DPL with immediate 0010I3I, 1. 1011. LHI load DPH with immediate 01100I, 111011. L load accumulator with memory 10010100011. LM load accumulator with memory then modify DPH 10010111111. LAL load accumulator with DPL 0101010111. LLA load DPL with accumulator 0101010011Q. LA load accumulator with W register 10000100011. T3 -0 till. LAX load accumulator with X register 10000101111. Q, lay. Load accumulator with Y register 1000011101112. LAS. Load accumulator with Z register 10000111111.9. N. SI store accumulator to memory then increment DPL 100100000.11. -0 till. SME store accumulator to memory, then modify DPH 0110101001011. J. And increment DPL. LWA load W register with accumulator 10000000011. LXA load X register with accumulator 10000000011. LYA load Y register with accumulator 10000001011. LZA load Z register with accumulator 10000001111. LPA load port pointer with accumulator 0101100011. LTI load timer with immediate 0110100022. 1716 is 1413 I110. RTH read timer H0110101011. RTL read demerl 0110101111. XA exchange accumulator with save register A0100100011. XL exchange DPL with save register L0100101011. Q. XCH exchange DPH and carry with save register CH0100100011C. C. Till. X exchange accumulator with memory 10011000011J. 0x. UJXM exchange accumulator with memory, then modify 10011111011. DPH. XAX exchange accumulator with save register AX0100101111. INA increment accumulator 00000000111. Q. INL increment DPL 01010111. 111A. INM increment memory 010111011110. Q. CLINW increment W register skip if 0100010001. 1. C. 00000011Q, INX increment X register 111. E. INI increment Y register 10001010110. INZ increment Z register 10001011111. 50. Dash. MSM 5840. Instruction set, cont. Instruction code. Mnemonic description byte cycle. 765432210. DCA decrement accumulator, skip if not all ones 00001111111. EDCL decrement DPL \0101011111. QL. EDCM decrement memory 0. 101110011. 0. DCW decrement W register skip if all ones 00000 QL111111A. E. QL. DCX decrement X register 10001101111. EDCY decrement Y register 10001111011. 0 DCZ decrement Z register 10001111111. DCH decrement DPH, skip if all ones and C equals 00101111111. CAO complement accumulator of 10101000011. OJ and accumulator with memory 0100010011. 0. Or accumulator with memory 010001001111. 0. JEOR exclusive or accumulator with memory 0. 100011011. RAL rotate accumulator left through carry 0100011111. AC add memory to accumulator with carry 010011100011. ACS add memory to accumulator with carry skip 0100110111. If carry. As add memory to accumulator, skip if carry 0100111011. 0 ace add immediate to accumulator, skip if carry 0000 is 12 11 10 11. EDOS decimal adjust accumulator in subtraction 0101101011. Equals colon. CM compare accumulator with memory, skip if equals 0101111011. AWS add W register to accumulator, skip if carry 100111011. AXS add X register to accumulator, skip if carry 100111011. Is and Y register to accumulator, skip if carry 10011111011. AZS add Z register to accumulator, skip if carry 10011111111. SPB set port bit 101100I, 1011. RPB reset port bit 101101I, 1011. 5 MB set memory bit 101110I, 1011. RMB reset memory bit 101111I, 1011. U, tab test accumulator bit 101000I, 1011. TMB test memory bit 101001111011 chi. MTKB test K port bit 1010101111. E. Chi THB test H port bit Skype of 110101101111. J. TI test interrupt flag 1010111113. TTM test time flag 1010111111. TC test carry flag 0100001011. SC set carry flag 0100000011. RC reset carry flag 0100000011. 51. EMSM 5840 E Instruction set, co-nt. Instruction code. Mnemonic description byte cycle. 765432210. CDJ jump 0011010 IA22. T, 1716 I 13121110. Dot equals. E. JC jump in current page. Point 0. 11 I 1312111011. JA jump with accumulator. 0100001111C/. S. Cal call subroutine 001111, 0 I220A. T. IR16I, IIG121110-2. In. RT return from subroutine 0101100112. OBS output byte string 0111000012 to 17. OTD output table data 0111000112. OA output accumulator to port A 0111001011. OB output accumulator to port B 0111001111. Co-op output accumulator to port P designated port 0111010011. 0 pointer. Colon. OAB output memory and accumulator to ports A and B 0111010011. Co. .eopm output memory to port P designated port pointer 0111011011. IA input port A in accumulator 0111101011. IB input port B in accumulator 0111101111. IC input port K in accumulator 0111111011. Lab input ports A and B in memory and accumulator 0111110111. EI enable interrupt 0101001111. Disable interrupt 0101001011. ET enable timer 0110111111. EDT disable timer 0110111011. C. ECT enable counter 0111111111. 0. DCT disable counter 0111111111. HLT halt 0110111111. EXP exchange program 0110100111. NOP no operation 0000000011. 52. EMSM 5840E. Absolute maximum ratings. Parameter symbol conditions limits unit. Supply voltage VTA equals 25 degree C-0.3 T07 V. Input voltage 6 Ta equals 25 degree C-0.3 to VOOV. Operating voltage PFPG VOTA equals 25 degree C-0.3 to 25 V. Storage temperature Xt-55 to plus 150 degree C. Note, stresses above those listed under absolute maximum ratings may cause permanent damage to the device. This is a stress rating only and functional operation of the device at these or at any other condition above. Those indicated in the operational sections of this specification is not implied. Exposure to absolute maximum. Rating conditions for extended periods may affect device reliability. Operating conditions. Parameter. Supply voltage. Operating temperature. Fan out. DC. Characteristics. VDD equals 5V plus or minus 10%, Ta equals minus 20 degrees to plus 70 degrees C. Parameter. High input voltage. Low input voltage. High output voltage, 1. Low output voltage. OSCO input leak current. Reset, MOOE leak current. Input leak current, 2. PA, PB high output current. High output current, 1. Low output current. PF, PG output breakdown voltage. Input capacitance. Output capacitance. Current consumption, 3. Notes, 1, except PA, PB, see graphs. 2, except OSCO, mode. 3, typical value of VU is 5V. Symbol conditions. At 1 MHz. VU. At 4.2 MHz. Top. MOS load. N. TTL load. Symbol conditions. VIH. VIL. VOHIO equals -40/LA. VOLIO equals 1.6 mA. IIH. 6 equals VU/OV. IL. IIH. 6 equals VU/OV. IL. IIH. 6 equals VU/OV. IL. IOH/VOH equals 0.4 V. IOH/VOH equals 2.5 V. IOL/VOL equals 0.4 V. BVOHIO equals 10/LA. CI. F equals 1 MHz. Ta equals 25 degrees C. Co. F equals 1 MHz. Ta equals 25 degrees C. 1006 equals VU/OV. 1006 equals VU/OV. F equals 4.2 MHz. Limits unit. 3T06V. 4.5 T05.5 V. -40 to plus 85 degrees C. 15. 1. Min. Tip. Max. Unit. 3.6 V, 0.8 V, 4.2 V, 0.4 V, 25, F/JA, minus 25, 1, F/LA, minus 50, 1, F/LA, minus 1, minus 1 Ma, minus 0.25 Ma, 1.6 Ma, 20 V, 5 PF, 7 PF, 10200/JA, 1.64 Ma, 53, MSM 5840-AC, characteristics, internal ROM mode. VDD equals 5V plus or minus 10%, Ta equals minus 40 degrees to plus 85 degrees C. Parameter symbol conditions min. Cycle time TCY 7.6. Sync pulse width TSW 0.95. RO pulse width TRW 1.9. Sync 1 to RRJ1 TROCL equals 50 PF 1/2 TCY plus 0.5. WR pulse width TWW 0.95. Syncleto WRL2CL equals 50 PF 13/16 TCY plus 0.5. Port input setup time TOSR4/16 TCY. Port input hold time TOHR0. WR1 to new OTA valid to. PAPB. CL equals 50 PF. Sync 1 to new data valid to's. PO, PE, PF, PG. CL equals 50 PF. PHD, PH, input pulse width the 1, 500. CIN input pulse width TCW 250. Int input pulse width TLNTW, 1, 500. Note, 1, the processor logic will ignore the following events. 1. An int falling ig occurring during tin hofa ti instruction. 2. A ph door ph low level occurring GoLang during tin hoia thb instruction. Timing charts. TCY. Sync. ISWJ. RD. RW. WD. PAPB input data. 1. IDSR. PK don't care input data. TDDS. Old data. Tip. Max. 0.8. 0.8. 13/16 TCY plus 0.5. R. WW. Dash. DDW. New output. Data. RTDHR. Don't care. Point 1. Point 1. New data. PDPE. PFPG. PHD. PH. .RTHWJ. I. 54. CW. I. I10. IR --/ 1/2. 1. TLNH. I. 7/16 Psi. Note, 1. All ones must be output before reading port A or B. 1. 1/16 TCY. Unit. S. 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 NS. 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 Dash. MSM 5840. AC. Characteristics, external ROM mode. VDD equals 5V plus or minus 10%, Ta equals minus 40 degrees to plus 85 degrees C. Parameter symbol conditions min. Cycle time TCY 7.6. Sync pulse width TSW 0.95. if pulse width TLW 1.425. Sync I toll FJTIDCL equals 50 PF 3/16 TCY plus 1. Address low delay TLADCL equals 50 PF. Address low hold TLAH 1/16 TCY. Instruction setup TIS 1/16 TCY. Instruction hold TLH. Data recovery TDRCL equals 50 PF 0. Address high delay THADCL equals 50 PF. Address high hold THAH 0. Psi. TSW. Sync dash. TID. TLW underscore point 1. I. TLAD. FF. TLS underscore. Data address instu. Low. THAD Tor. PAPB. Data address high. I1. THAH. II. PO. Cycle dependent timings 4 MHz 2 MHz. 1/16 TCY 0.5.S. 1/16 TCY plus L 1.5.S 2.S. 3/16 TCY plus L 2.5.S 4.S. 4/16 TCY LI.S 3.S. 1/2 TCY plus L 5.S 9.S. 7/16 TCY 3.5.S 7.S. 13/16 TCY plus L 7.5.S 14.S. Tip. Max. Unit. .S. 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 0.8. 1/16 TCY plus L.S. .S. 20 NS. 0.8. 0.5. 0.5. R. Data. Data. LM Hertz 500 kHz. 2.S 4.S. 3.S 5.S. 7.S 13.S. 7.S 15.S. 17.S 33.S. 14.S 28.S. 27.S 53.S. 55. EMSM 5840 Typical performance curves. Supply current vs supply voltage. Ta equals 25 degrees Celsius, no load. 10 m dash comma dash rr dash comma dash dash 1 mr dash plus 7t dash colon hashtag 100 c e 10 0.1 l dash 1 dash underscore dash underscore underscore dot l dash underscore 035 VU V 7 Oscillator frequency vs supply voltage. Ta equals 25 degrees Celsius, CL equals 50 PF. N. J. U. N. G. 56. 10. 8. 6. 4. 2. O. O. I. 3. V. Slash 5 VU V 7 10 10 Supply current vs oscillator frequency. Ta equals 25 degrees Celsius, no load. C. 10m dot dash, dash dash r dash. VU equals 6v. I. 5v. 1m1 dash dash I dash 1 dash 7 SOS. 1001 dash dash T7, C, T underscore underscore T. 10L, dash, underscore L underscore 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 L, dash underscore underscore. 10K look 1M 10M. F, OSC, Hertz. Oscillator frequency vs temperature. CL equals 5 op F. 10. 8. N. J. 6. U. R dash. N. G. 4. 2. Minus 50 050 100. Ta, OC. Dash. MSM 5840. Low current out YS voltage. IS. 9. OL dash underscore 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 underscore. 03S710. VO, V. Fall time YS load. Ta equals 2 SOC, PA, PB, PO, PE, RO, WR, W, sync. 1000. 800. Dash. C, 600. Dash colon. J. T. 400. 200. VU equals SV. Dash. O. 1020 so 100 200 su 1000. CL, PF. High current out YS voltage. Ta equals 2 SOC, except PA, PB. Dash 10 comma dash 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 R dash. Al plus dash dash plus dash F dash plus dash J. I. J. O. Minus 4. Minus 2. Rise time YS load. 710. VO, V. Ta equals 2 SOC, PO, PE, RO, WR, if, sync. 1000. 800. 600. T. J. Slash. I. Slash VU equals SV. I. 400. 200. Slash. V. V. I. O. 1020 so 100 200 500. 1000. CL, PF. 57. OKI semiconductor. MSM 5842. CMOS 4-bit single-chip microcontroller. General description. The OKI MSM 5842 microcontroller is a low-power, high-performance single-chip device implemented in complementary metal oxide semiconductor technology. Integrated with this one chip are 6K bits of mask program ROM, 128 bits of data RAM, 21 input/output lines, an 8-bit binary timer/counter, and oscillator. Program memory is byte-wide and data paths are organized in 4-bit nib. Bless. RAM and I/O lines are bit addressable. 52 instructions include binary, BCD, operations, bitset, reset, test, 8-bit I/O, relative jumps, multifunctional instructions, increment, modify, skip, 8-bit wide. Table output, subroutine call and return. 94% of instructions are single byte, single cycle operations. Available in plastic, ARS, package. Features. Low power consumption, 7 MW typical 52 instructions. 100% static logic, 1 OOP W standby 1 stack level. 768x8 internal ROM -20 0 to +70°C operating temperature. 32x4 internal RAM 3V to 6V operating VDD. 21 I/O lines including 8-bit data bus battery powered or battery backup. 8-bit binary timer/counter TTL compatible, with pull-ups. Self-contained oscillator 7.6 f.ls cycle time at 4.2 MHz. Functional block diagram. 32x4 RAM. FEDSPA 9876543. OEC 321032103. PEPO PK 58. MSM 5842. Pin configuration, top view. 28-pin plastic dip, RS, 32-pin flat package. PA, 0 PA. PA3 PAL. PBO reset. PE. PE. PB, OSC. PE, PB, OSC. PEO PB, sync. PO, NCPH. PD, GND NC. CIN YOD. PKONC. PA, PD. POO. PK, PE3. PBO PK3 PK, PE. PB, PK, PK, PE. PB, PK, NCPEO. PB, PKO. PDUPO. PD, PO. GNOCIN. Pin description. Designation pin no. Function. GND14 circuit GND potential. VDD28 main power source, plus 5V. OSCO 4 crystal OSC input, external clock input. OSC, 3 crystal OSC input, external clock output, not TTL compatible. PAPB 6 to 13 quasi-bidirectional ports for 4-bit parallel I/O. Used as a pair for 8-bit I/O. PDPE 20 to 27 output ports for 4-bit parallel output and bit set/reset. Specified by internal port. Pointer. Bit position specified by set/reset instruction. PK 16 to 19 4-bit parallel or bit test input port, unlatched. PH11 bit input port with latched memory, negative level sensitive. Reset 5 reset must be low for more than one machine cycle and has priority over every other signal. CMSM 5842 User's Manual for Initialization Sequence. CIN15 Negative edge sensitive external input for timer/counter. Sync to general purpose synchronizing signal output at beginning of each machine. Cycle 59. EMSM 5842 E dash 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 dash. Functional description. Program ROM. The MSM 5842 will address up to 768 bytes. A program ROM. All instructions are byte-wide. Only 3 of the 52 instructions require 2 bytes of program code. The instructions are routed to a programmed logic array which generates the necessary internal control signals. Data RAM. Data is organized in 4-bit nibbles. Internal. Data RAM consists of 32 nibbles and 1 nibble, which is a dedicated general-purpose register. W, accessible directly under program control. Data RAM must be addressed indirectly through the DP, data pointer, register, a 5-bit pointer, directly accessible by numerous instructions, consisting of a 4-bit DPL register and a 1-bit DPH register. Any nibble of internal data RAM can be accessed through the DP registers. Some instructions automatically change the contents of the DP register, allowing efficient array processing. Input/output ports. PA, PB, these two ports are pseudo bidirectional ports which can be used as simple I/O lines or used as either a 4-bit or 8-bit parallel bus. PD, PE, these two output ports are addressed indirectly through the 1-bit port pointer whose contents are changed through certain instructions. These ports are bit, set, reset, addressable. PK is an input port without a latch circuit, addressable as a nibble input. PH is a 1-bit input port with a latch circuit, which can be tested and reset under program control. Instruction set. Mnemonic description. CLA clear accumulator. CCL clear DPL. CLH clear DPH. MLI load accumulator with immediate. ULLI load DPL with immediate. -0 LHI load DPH with immediate. As CIA, L load accumulator with memory. $LAL load accumulator with DPL, J. LLA load DPL with accumulator. GLA load accumulator with W register. Timer/counter. The timer/counter is an 8-bit counter whose input is an external signal, CIN. The TM flag is set when the timer/counter generates a carry. Stack. The stack is a single register for storing return from subroutine address information. It is 10 bits wide. Program counter, PC. The program counter is 10 bits wide. Accumulator. The accumulator register is the data path focal point of the CPU. Approximately 1/2 of the instructions involve the accumulator. Its contents are the source and destination for many ALU operations and port operations. Case statements, computed gotos, are possible by using the jump with accumulator, JA, instruction flags. The MSM5842 is endowed with the following set of flags. Z0 flag indicates that the result of the previous operation was 0. C carry indicates a carry from the previous operation. TM timer flag indicates an overflow of the timer/counter register. He memory indicates that an input has been detected on the he input. Instruction code 765432210. Byte cycle 0001000011. 0010000011. 0110000011. 0001I121011. 0010I1011. 011000001011. 10010100011. 0101010011. 010100100011. 10000100011. Point 9 SI store accumulator to memory, then increment DPL 10010000011. LWA load W register with accumulator 10000000011. LPA load port POI enter with accumulator 010110000011. LTI load timer with all zeros 011010000011. 60. MSM5842. Instruction set, cont. Instruction code. Mnemonic discretion byte cycle. 765432210. Q. CL. .R. U. W. C. INA IOMM. I. 0000000111 Q. EINL increment DPL skip if 001010111111. UINM increment memory 0101111111. Q. 0INW increment W register 100010011 : Q. E. DCL decrement DPL. Skip if all ones. 0101011011. UDCM decrement memory. 0101110011. CAO complement accumulator of 101010000011 RAL rotate accumulator left through carry 010001111110. J. AC add memory to accumulator with carry 0100110011. U. As add memory to accumulator, skip if carry 0100111111. EACE add immediate to accumulator, skip if carry 00001012111011. DOS decimal adjust accumulator in subtraction 0101101011. CM compare accumulator with memory, skip if equal 0101111111. 5 MB set memory bit 1011101111. 3. RMB reset memory bit 1011111111. Tab test accumulator bit 1010001111. Q. TMB test memory bit 1010011111. Q. THB test H port bit 1010111011. Q. TTM test timer FIOG 1010111111. F. TC test carry flag 0100001011. 3. SC set carry FLAG 0100000011. RC reset carry flag 0100000011. Q. J jump 00110019 I22. 17 is I10 12 11 10. 5. EJC jump in current FH11 is I10 12 11 10 11. Point 0. JJA jump with accumulator 0100001111. F. Cal call subroutine 0011101922.R. U17I is I10 12 11 10. OTD output table data 0111000012. OA output accumulator to port A 0111001011. 5. OB output accumulator to port B 0111001111. SOP output accumulator to port P designated port 0111010011. J pointer. 5 OPM output memory to port P designated port pointer 0111011011. A. IA input port A in accumulator 0111101011 equals. IB input port B in accumulator 0111101111. IC input port K in accumulator 0111111011. E. C. NOP no operation 0000000011. 0. U. 61. MSM 5842-. Absolute maximum ratings. Parameter symbol conditions limits unit. Supply voltage VTA equals 25 degree C 0.3 T07 V. Input voltage 6 Ta equals 25 degrees C dash 0.3 to VOOV. Storage temperature TSTG dash 55 to plus 150 degrees C. Note, stresses above those listed under absolute maximum ratings may cause permanent damage to the device. This is a stress rating only and functional operation of the device at these or at any other condition above. Those indicated in the operational sections of this specification is not implied. Exposure to absolute maximum. Rating conditions for extended periods may affect device reliability. Operating conditions. Parameter. Supply voltage. Operating temperature. Fan out. DC. Characteristics. VU equals 5V plus or minus 10%, Ta equals minus 40 degrees to plus 85 degrees C. Parameter. High input voltage. Low input voltage. High output voltage, 1. Low output voltage. OSCO input leak current. Reset leak current. Input leak current, 2. PA, PB high output current. High output current, 1. Low output current. Input capacitance. Output capacitance. Current consumption, 3. Notes, 1, except PA, PB, C graphs. 2, except OSCO, reset. 3, typical value of VU is 5V. 62. Symbol. VU. Top. Symbol. VIH. VIL. VOH. VOL. IIH. IL. IIH. IL. IIH. IL. IOH. IOH. IOL. CI. CO. 100. 100. Conditions limits unit. 1 MHz 3T06V. 4.2 MHz 4.5T0 5.5V. Minus 40 to 85 degrees Celsius. MOS load 40. TTL load 1. Conditions min. Tip. Max. Unit. 3.6V. 0.8V. IO equals dash 40 slash LA 4.2V. IO equals 1.6 Ma 0.45V. 25. 6 equals VU slash OV, slash LA. Minus 25. 1. 6 equals VU slash OV, slash LA. Minus 20. 1. 6 equals VU slash OV, slash LA. Minus 1. VOH equals 0.4V minus 1 Ma. VOH equals 2.5V minus 0.25 Ma. Vol equals 0.45V 1.6 Ma. F equals 1 MHz 5 PF. Ta equals 25 degrees C. F equals 1 MHz 7 PF. Ta equals 25 degrees C. 6 equals VU slash OV 2200 slash LA. 6 equals VU slash OV. F equals 4.2 MHz. 1.54 Ma. Dash. MSM 5842. AC. Characteristics. VDD equals 5V plus or minus 10%, Ta equals minus 40 degrees to plus 85 degrees C. Parameter symbol conditions min. Cycle time TCYOSC equals E4 MHz 7.6. Sync pulse width TSW 0.95. Port input invalid time TDV. Port input valid time TOV2. Sync 1 to new data valid 2 SPD. PECL equals 50 PF. Faux input pulse width 1, 250. CIN input pulse width TCW 250. Notes, 1, the processor logic may ignore the following event. A FOLO level occurring only during tin of a THB instruction. 2. All ones must be output before reading port hour B. Timing charts. Sync. RTSW, J. TCY. Dash. PAPB input data. No 2. Tip. TOLV TOV. PK don't care input data. TDOS. POPE old data. FOTT. HW. TQI. 1/2 TCYII 1 TLNH. 7/16 T. CIN. Psi. Max. Unit. ILS. ILS. 1/2 TCY plus 0.5 ILS. ILS. 13/16 TCY plus 0.5 ILS. NS. NS. R. New output 0 ATA. Don't care. New data. I 1/16 TC. I. Y. 63. MSM 5842-. Typical performance curves. Supply current vs supply voltage. 3. C. 0.9. 10 M. 1 M. 100. 10. Ta equals 25 degrees Celsius, no load. J. OSC, equals 8 MHz. 4 MHz, 2 MHz. 1 MHz. 100 kHz, Hz. 0.1, I dash plus dash dash, dash J. 0135710. VU, V. Oscillator frequency vs supply voltage. Ta equals 25 degrees Celsius, CL equals 50 pf. 12. I. 1 slash. N. 10. J. 8. 0. N. 0. 6. Slash. 1 slash. Dash. 4. 2. 0. I. 35710. VU, V. 64. Supply current vs oscillator frequency. Ta equals 25 degrees Celsius, CL equals 15 pf. 10 M. 1 M. 3100. C. I. VOO equals 5 L. Slash. V. 0.9. 10. 10K 100K 1 M 10 M. J. OSC, Hertz. Oscillator frequency vs temperature. N. J. 0. N. 0. Equals. 14. 12. 10. 8. 6. 4. 2. 0. Minus 50. Equals 5V. F. O 5100. Ta, OC. Dash. MSM 5842. Low current out vs voltage. Ta equals 25 degrees Celsius. 20. 15. 10. VI5. IL. O. A1. Fall time vs load. 35. VO, V. VDD equals 5V. 710. Ta equals 25 degrees Celsius, PA, PB, PD, PE, sync. 1000. 800. J. Dot T. 400. 206. I. V. D equals 5V. O. 10 20 50 100,000 200 500 1000. CL, PF. High current out vs voltage. Ta equals 25 degrees C. -4. -3. E. I. 0.9 -2. -1. T dash. I. VDD equals 5V. VDD. 15Y, PA. O. 0135. VO, V. Rise time vs load. PDPE. Sync. 7. Ta equals 25 degrees Celsius, PD, PE, sync. 1000. 10. 800. 600. /VDD. Equals 5V. J. Dot T. 400. 200. V. 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 O. 10 20 50 100 200 500 1000. CL, PF. 65. OKI semiconductor. MSM 58421. CMOS 4-bit single-chip microcontroller with LCD driver. General description. The OKI MSM 58421 is a low-power, high-performance 4-bit single-chip microcontroller implemented in complementary metal oxide semiconductor technology. Integrated within this one chip is a 5-digit 7-segment LCD driver and PLA which can change the character font for the 7 segments freely under the control of the mask programmable data. Also integrated in this chip are mask ROM of 1536 x 8 bits for programming, data RAM of 40 x 4 bits, 13 general-purpose input/output ports, 1 2-bit timer, and clock oscillator to facilitate easy application to equipment with an LCD display. Features: low power consumption CMOS 4-bit. 1-chip microcomputer. 100% static logic. 1536 x 8 bits mask ROM. 40 x 4 bits data RAM. 1 static register. Built-in 12-bit timer, with 32 Hz common output. All input ports contain Schmidt trigger. Circuits. 8-bit interface bus. Functional block diagram. 52 instructions. 94% of the 52 instructions are 1 byte and 1 machine cycle. Integrated with 13 input/output ports and 40 static LCD driver circuit. Plus 5V single power supply, 60-pin mold flat package. 7-segment character user programmable. Font, 32 words x 7 segments. Various functions changeable under mask. Program control. C3210PH321032 loss 0 OVG. 66. PLCDS JPLCD5, JPLCD4, JLPLCD3, JPLCD2J /PLCD1.J-PK, J. MA. N. Crystal oscillator 4.194304 MHz, sync 7.63 SEC LCD common signal 32 Hz. YSSN. PA JPB NCC0. C10. MSM 58421. Logic symbol. Reset. Port K. KO. K. VU. Sync. Common. Pin description. Designation pin no. GND 33. VDD 23. OSCO 17. OSC 16. PAPB 19 to 22. 24 T027. PK 28 T031. PH 14. Reset 18. JPort A. JPort B. PLED 1. JPLCD 2. PLED 3. JPLED 4. JPLED 5. JPLED 6. Dash sync signal output. Common signal output. Circuit GND potential. Main power source, plus 5V. Pin configuration. PLED 1F. Function. 3LJLCO, 2. III. 0, A, 2, 2, 0, 0, 0, 0, 0. QQ0. 0Q. Crystal OSC input, external clock input. Crystal OSC input, external clock output, not TTL compatible. PLC03E. PLCD3D. PLCD3C. PLCD6S. PLC02E. PLC01C. PLC01G. PLCDG1. GNO. Common. Pseudo-bidirectional ports for 4 bits parallel I/O. To input data from these ports, it is necessary to write one to them beforehand. When nothing is applied to their terminals, the content of output ports is written in them, so they can also be used as registers. In addition, it is possible to use them for make 8-bit parallel output. Depending on instructions. Input ports for 4-bit parallel input with no latching function. Input port with latching function to be set by negative logical signal. That is, this terminal is set at the time when the negative logical signal is applied to it. From the outside, it is reset automatically after execution of the test instruction of this port. The reset signal which input has priority over all of other signals and performs the following functions. 1. Resets all bits of the program counter. 2. Resets the timer counter and timer flag. 3. Resets the port pointer. 4. Resets the accumulator. 5. Resets I/O ports PA and PB. 6. Resets the input port PH flag. 7. Initializes the output port PLCD for LCD. 8. Resets the machine cycle to M1. Since the reset terminal is pulled up to VDD by an internal resistor, approximate 800 kΩ, it is possible to make power on/reset by connecting it with an external capacitor. 67. MSM 58421-. Pin description, cont. Designation pin NA. Function. Sync 15 general purpose synchronizing signal output. The signal is output at the beginning of each machine cycle. Output constantly, this signal is used also as clock pulse to external units. The cycle of sync becomes 32 times that of the original oscillation, 8/ls when the clock pulse is 4 MHz. PLCD 1 to 13, PLCD 1 to 6, pins 1 to 13 and 34 to 60. 1-6 34 to 67-bit and 5-bit parallel output ports, respectively. They are used to direct drive an LCD, static type. Specification of each port is done by the port pointer, PP, as shown in the table below. Content of PP. BSB2B, BO. Port specified. X000 PLCD1. X001 PLCD2. X010 PLCD3. X011 PLCD4. X100 PLCD5. X101 PLCD61-4. X110 PLCD65 and by X111. X, don't. By 7-segment decoder PLA blank input. The data of B, of the internal 4-bit bus is written to 5 of PLCD6, and that OLBS to by common 32 common, pin 32. Common output terminal. This output signal is connected to the common electrode of static type LCD. The frequency of the common signal output is given with the following equation. F, com, equals F, OSC, /217. Where the basic clock F, OSC, is 4.19304 MHz, F, com, becomes 32 Hz, duty ratio 50%. Mask option table. ELISC, 4.194304 MHz. Port KO, Port K2, Port K3, commom. Timer. No 28 pin, 30 pin, 31 pin, 32 pin. OK, K3 32 Hz 12-bit. 1 KO buzzer common 32 Hz 12-bit. 2 KO buzzer K3 32 Hz 12-bit. 3 KO buzzer K3 64 Hz 11-bit. 4 KOK, K3 64 Hz 11-bit. 5 0K, K3 128 Hz 10-bit. 6 KO buzzer K3 128 Hz 10-bit. 7 KOK, K3 256 Hz 9-bit. 8 KOK, K3 512 Hz 8-bit. 9 KO buzzer K3 512 Hz 8-bit. II buzzer, 2048 Hz. 68. MSM 58421. Absolute maximum ratings. Parameter symbol conditions. Power supply voltage VDD TA equals 25 degrees C. Input voltage 6 TA equals 25 degrees C. Power dissipation PD TA equals 25 degrees Celsius per 1 package. Storage temperature TA. Operating range. Parameter symbol conditions. Power supply voltage VDDI, OSC, equals OT0 4.2 MHz. Operating temperature top. Fan out, excluding COM, SEC, N. DC. Characteristics. VDD equals 5V plus or minus 10%, TA equals minus 40 to plus 85 degrees C. Parameter symbol. H input voltage VIH. L input voltage VIL. H output voltage, 1, VOH. H output voltage, 2, VOH. H output voltage, 3, VOH. H output voltage, 4, VOH. L output voltage, 1, VOL. L output voltage, 2, VOL. L output voltage, 5, VOL. OSCO input leak current IIH/IIL. Input current, 6, IIH/IIL. PA. H. PB10H. Output current. H output current, 3, 10H. L output current, 4, 10L. Input capacity CI. Output capacity CO. Current consumption IDD. Notes, 1, applied to common. 2, applied to segment. 3, applied to sync. 4, applied to PA, PB. Conditions. 10 equals SWIA. 10 equals -2 OIA. 10 equals -4 OIA. 10 equals -15 IA. 10 equals 801A. 10 equals 2 OA. 10 equals 1.6 Ma. 6 equals V to V equals OV. 6 equals V to V equals OV. VO equals 0.4 V. VO equals 2.5 V. VO equals 0.4 V. 1 equals 1 MHz, TA equals 25 degrees C. 1 equals 1 MHz, TA equals 25 degrees C. 1 equals 4.194304 MHz. at no load. 5. Applied to sync, PA, and PB. 6. APPLE to reset, PK, and PH. MOS load. TTL load. Min. 3.6. VDD. Minus 0.1. VDD. Minus 0.1. 4.2. 4.2. Minus 0.25. 1.6. Tip. 5. 7. 2. Limits unit. Dash 0.3 T07V. 0.3 to VDDV. 200 MW. Dash 55 to plus 150 degree C. Limits unit. 4 T06V. Minus 40 to plus S5 degree C. 15. 1. Max unit. V. O.SV. V. 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 0.1 V. 0.1 V. 0.4 V. 101 to 10 IA. 1/-20 IA. Minus 1 RNA. 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 PF. PF. 5 RNA. 69. EMSM 58421. E____. Switching characteristic. VOD equals 5V plus or minus 10%, Ta equals minus 40 degrees to plus 85 degree C. Parameter symbol. Sync delay time from JD clock, OSCOL. Clock, OSCOL pulse, JWH. Width T, WL. Cycle time TCY. Sync pulse width TSW. PA. PB data valid time TOV. PK. PA. PB data invalid time TDV. PK. Data delay time TUS. Port H set pulse width, 7, the. Common delay time. SCD from sync. Segment delay time. TCSD from common. Clock, OSCO. TL/XL. Sync. 70. Conditions min. Tip. Max. Unit. CL equals 50 PF 800 NS. 115 NS. 1, Ps. 2, Ps. CL equals 50 PF, 3, Ps. CL equals 50 PF, 4, Ps. CL equals 50 PF 500 NS. 500 NS. CL equals 50 PF 2 Ps. CL equals 50 PF 1 Ps. Dash. MSM 58421. Sync. 6. PAPBPK. Dash 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 underscore 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 TCY, L, dash dash. 4, 3. I to IV plus TDV. Invalid valid invalid. Input mu underscore 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 dash J underscore 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 J underscore 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 underscore. PAPB. Output. Mode. Underscore 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 JX backslash dot II underscore dash dot underscore 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 dash underscore 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 OLT underscore underscore colon underscore colon underscore colon underscore colon underscore dash underscore underscore dash underscore dash underscore dash underscore dash underscore dash underscore underscore dash dash I underscore N underscore EU underscore D underscore A underscore T underscore A underscore PH T1 sync underscore 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 0 THB instruction cycle. Point 1. Tin. If. Notes, 11tf equals 32x1/f, 08e. 2. T8w equals 4x1/f, 08e. 3. Tov equals 8x1/f, 08e. 4. Toev equals 16x1/f, 08e, plus 0.5 ps. 5. T008 equals 26x1/f, 08e, plus 1 ps. 16x1/f, OSC, 15x1/f, OSC, 1x1/f, OSC. 6. When data is input from PA or PB, set the contents of PA or PB to 1 prior to reading instruction. 7. At execution of the THB instruction, any input made during a period of tin, 15x1/f, 08e, shown in the above figure may be neglected. Sync. Sed. Common. TCSD. Segment ____________r /. When the display ________________________ j content is fixed. 71. MSM 58421 Description of terminals. GND, pin 33. Circuit grounding potential. VDD, pin 23. Main power supply. OSCO, pin 17. Input of internal oscillation circuit at one side. Of crystal resonator and ceramic vibrator. OSC1, pin 16. Output of internal oscillation circuit at the other side of crystal resonator and ceramic vibra. TOR, not TTL compatible. PA, PB, pins 19 to 22 and 24 to 27. These are quasi-bidirectional ports for 4-bit. Parallel 1/0. To input data from these ports, it is necessary to write one to them beforehand. When nothing is applied to their terminals, the content of output ports is written in them, so they can also be used as registers. In addition, it is possible to use them to make an 8-bit parallel output depending on instructions. PK, pins 28 to 31. Input ports for 4-bit parallel input with no latching function. PH, pin 14. Input port with latching function to be set by negative logical signal. This terminal is set at the time when the negative logical signal is applied to it from the outside. It is reset automatically after execution of the test instruction of this port. Reset, pin 18. Reset must be active for greater than 1 chine cycle. The reset signal, when input, has priority over all of other signals and performs the following functions. 1. Resets all bits of the program counter. 2. Resets the timer counter and timer flag. 3. Resets the port pointer. 4. Resets the accumulator. 5. Resets 1/0 ports PA and PB. 6. Resets the input port PH flag. 7. Initializes the output port PLCD for LCD, and 8. Resets the machine cycle to M1. 72. Since the reset terminal is pulled up to VDD by an internal resistor, approximate 800 ca, it is possible to activate power ONL reset by connecting it to an external capacitor. Sync, pin 15. This is a general purpose synchronizing signal output. The signal is output at the beginning of each machine cycle. Output constantly. This signal is used also as clock pulse to external units. The cycle of sync becomes 32 times that of the original oscillation, 8/ls, when the clock pulse is 4 MHz. PLCD 1 to 6, pins 1 to 13 and 34 to 60. These are 7-bit and 5-bit parallel output ports, respectively. They are used to directly drive an LCD, static type. Specification of each port is done by the port pointer, PP, as shown in the table below. Content of PP: B3, B2, B elbow. Port specified: X000 PLCDL, X001 PLCD2, X010 PLCD3, X011 PLCD4, X100 PLCD5, X101 PLCD6-4, X110 PLCD6-5 and by X111. X, don't care. By 7-segment decoder PLA blank input. The data of BO, of the internal 4-bit bus is written to 5 of PLCD6, and that of B3 to 81. Common, pin 32. This is a common output terminal. This output signal is connected to the common electrode of static type LCD. The frequency of the common signal output is given with the following equation: F, com, equals F, OSC, /217. Where the basic clock F, OSC, is 4.19304 MHz. F, com, becomes 32 Hz, duty ratio, 50%. Dash. MSM 58421. Instructions list. Mnemonic description. Instruction code. Byte cycle. 765432210. CLA clear accumulator 00010000011. CLL clear DPL 00100000011. CLH clear DPH 01100000011. Lie load accumulator with immediate 00011312I, 1011. LLI load DPL with immediate 0010 is 12I, 1011. LHI load DPH with immediate 011010I, 1011. L load accumulator with memory 10010100011. LAL load accumulator with DPL 0101010111. LLA load DPL with accumulator 0101010011. LAW load accumulator with W register 10000100011. SI store accumulator to memory, then increment DPL 10010000011. LWA load W register with accumulator 10000000011. LPA load port pointer with accumulator 0101100011. LTI load timer with immediate 0, clear timer and TMF, 0110100011. X exchange accumulator with memory 10011000011. INA increment accumulator 00000000011. INL increment DPL 0101011111. INM increment memory 0101110111. INW increment W register 10001000011. DCA decrement accumulator 00000111111. DCL decrement DPL 0101011111. DCM decrement memory 0101110011. CAO complement accumulator of 10101000011. RAL rotate accumulator left through carry 0100011111. AC add memory to accumulator with carry 0100110011. As add memory to accumulator, skip if carry 0100111011. ACE add immediate to accumulator, skip if carry 0000 is 12i, 1011. DOS decimal adjust accumulator in subtraction 0101101011. CM compare accumulator with memory 0101111011. 5 MB set memory bit 101110i, 1011. RMB reset memory bit 101111111011. Tab test accumulator bit 101000i, 1011. TMB test memory bit 101001i, 1011. THB test H port bit 1010111011. TTM test time flag 1010111111. TC test carry flag 0100001011. SC set carry flag 0100000011. RC reset carry flag 0100000011. J jump 001101110i822. 1716i is 12i, 10. JC jump in current page 11i1312i, 1011. JA jump with accumulator 0100001111. Cal call subroutine 0011110i822. IRI15i is 121110. RT return from subroutine 0101100111. OTD output table data 0111000011 to 152. OA output accumulator to port A 0111001011. OB output accumulator to port B 0111001111. OP output accumulator to port designated port pointer 0111010011. OPM output memory to port P designated port pointer 0111011011. IA input port A in accumulator 0111101011. IB input port B in accumulator 0111101111. IC input port K in accumulator 0111111011. NOP no operation 0000000011. 73. MSM 58421-. Typical performance curves. Output current, LOL, tip output current, I0H, tip. VDD equals 5V, Ta equals 25 degrees Celsius, VDD equals 5V, Ta equals 25 degrees Celsius. 20. Common terminal. 15. E. PA, PB, sync terminal. I. 9. C. I. 10. 5. U. J. B. J. 05. Segment terminal. 0. 35710. Output voltage VO, V. TIHL, CL characteristic tip. On S. J. 1000. 800. I. 600. 1. 400. J. B. JO. 200. O. 74. Ta equals 25 degrees Celsius. 10 20 50 100 200 500 1000. Load capacity CL, PF. Minus 10. I. 9 minus 6. C. J. U. Minus 4. J. B. J. 0. Minus 2. 0. 03510. Output voltage VO, V. TTLH, CL characteristic tip. Ta equals 25 degrees Celsius. 1000. Bu. C. I. J. 600 T. 400. J. I. VDD5. 1. V. I. VQ. 0200 slash. O. 10 20 50 100 200 500 1000. Load capacity CL, PF. Dash. MSM 58421. T, OSC, VU characteristic tip. CL equals LSPF, Ta equals 20C. 12. N. I. 10. U. FJ. Slash. V. 12. 8. C. J. C. 6. Dot Y. 0. C. E. J. Slash. V. J4. E. X. 2. O. O3S710. Power supply voltage VU, V. 100, VU characteristic tip. 10M. I. Backslash. 1M. 5. G100. Slash. 17. Slash. V. 3S710. Power supply voltage VU, V. T, OSC, Ta characteristic tip. N. I. U. FJ. 12. C. J. C. Dot Y. 0. C. E. J. E. X. 2. 12. 10. 8. 6. 4. O. So. R dash. OSO. Ambient temperature Ta, OC. 100. 100, T, OSC, characteristic tip. S. 0. 0. C. 0A. E. A. C. 0. C. U. CL equals LSPF, Ta equals 2S0C. 10 MR dash 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 comma dash dash equals dash dash comma dash dash. 1M. 100. 10. 10K look 1M 10M. Clock frequency F, OSCI, Hertz. 75. OKI. Semiconductor. MSM 58422. CMOS 4-bit single-chip microcontroller with FLT driver. General description. OKI's MSM 58422 is a low-power, high-performance 4-bit single-chip microcontroller implemented in complementary metal oxide semiconductor technology. Integrated within the one chip is a mask ROM of 1536 x 8 bits, RAM of 40 x 4 bits, 10 input/out. Put ports 11-bit timer counter, clock oscillator, 4-bit parallel arithmetic circuit, 40 static FLT drivers, etc. MSM 58422 has an instruction set which consists of 4-bit arithmetic instructions, Boolean, bit manipulation instructions, bit set, bit reset, bit test, data input/output instructions, and 8-bit code. Translation, table data out, instructions. Also the pseudo-bilateral ports are used for connection to the buses of other 8-bit systems. Features. Low power consumption CMOS 4-bit. One-chip microcomputer. 100% static logic. 1536 x 8 bits mask ROM. 8-bit interface bus. 1 stack register. 52 instructions. Plus 5V single power supply. Functional block diagram. F. ATA AM40W. Phase 65432. PFLT6 PFTL5 PHT4 PFTL3 PFLT2 PFTL1. 76. 9. 60-pin flat package. Built-in 11-bit timer. 94% of the 52 instructions and 1 byte and 1 machine cycle. Integrated with 10 input/output ports and 40. Static FLT driver circuit. PK and PH input contain Schmidt trigger. Circuits. BPK-PH3210. PA. SROOVG. Yes son. NSCC do. CE10. U. ZPB. Z. ET. R. OSC 4.194304 MHz. Sync equals 7.63 JLSEC. Dash. MSM 58422. Pin configuration. 44 pin flat package. PFLT5C. PFLT3A2. PFLT3B. PFLT5D4. PFLT2-1. PFLT5E. PFLT2B. PFLT1-1. PFLT1A11. PFLT1B. PFLT5G. PFLT-PH. PFLT-SYNC1. Flowdisk, 16. Underscore, 0. .HRB : III. Absolute maximum rating. Parameter symbol. Supply voltage VDD. Input voltage 6. Output voltage, FLT, VA. Power dissipation PD. Storage temperature TSTG. Operating conditions. Parameter symbol. Supply voltage VDD. Operating temperature top. Output voltage, FLT, VA. Fan out, excluding FLTS, N. Logic symbol. Xtol. OSC1. OSC. Sync. Test-0 reset. Port H0H. Port K. Dim. Buzzer. 64 Hz. 5V. OV. Conditions. Ta equals 25 degrees C. Ta equals 25 degrees C. Ta equals 25 degrees C. Dim. Dim. Ta equals 25 degrees Celsius per 1 package. Ta equals 25 degrees Celsius per 1 FLT. Condition. HOSC, equals 0 to 4.2 MHz. MOS load. TTL load. PFLT1AG. PFLT2A9. PFLT3AG. PFLT4A9. PFLT5AGL__/. PFLT6015. Limits. -0.3 -7. -0.3 VDD. VDD -30. 200. 8. -55 to +125. Limits. 4 to 6. -40 to +85. VDD, 26. 15. 1. Port A. Ports. FLT drive. Outputting. Unit. V. 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 MW. Degree C. unit, v, degree C, v, 77, MSM 58422, DC characteristics, VU equals 5V plus or minus 10%, Ta equals minus 40, plus 85 degree C. Parameter symbol conditions. H input voltage VIH. L input voltage VIL. H output voltage, 1, VOH 10 equals -15 ILA. H output voltage, 2, VOH 10 equals -4 OILA. L output voltage, 3, Vol 10 equals 1.6 mA. OSCO input leak current IIH/IIL6 equals VU/OV. Input current, 4, IIH/IIL6 equals VU/OV. H output current, 1, 10 HVO equals 0.4 V. H output current, 5, 10 HVO equals 2.5 V. H output current, 6, 10 HVO equals 3 V. L output current, 3, 10 LVO equals 0.4 V. FLT output leak current ILOVO equals VU 26 V. Input capacity CIF equals 1 MHz, Ta equals 25 degrees Celsius. Output capacity CoF equals 1 MHz, Ta equals 25 degrees Celsius. Current consumption 100 F equals 4.2 MHz at no load. Notes, 1, applied to PA, PB. 2, applied to sync, buzzer, 64 Hz, and PFTL. 3, applied to PA, PB, sync, buzzer, and 64 Hz. 4, applied to PH, reset, OIM, and PK. 5, applied to sync and 64 Hz. 6, applied to buzzer and PFLT. 78. Min. Tip. Max. Unit. 3.6 V. 0.8 V. 4.2 V. 4.2 V. 0.4 V. 101 to 10 ILA. 1/-20 ILA. -1 mA. -0.25 mA. -1 mA. 1.6 mA. -10 ILA. 5 PF. 7 PF. 25 mA. Dash. MSM 58422. Switching characteristics. VDD equals 5V plus or minus 10%, Ta equals -40, plus 85 degree C. Parameter. Sync delay time from clock, OSCO. Clock, OSCO, pulse width. Cycle time. SINC pulse width. PA. PB data valid time. PK. PA. PB data invalid time. PK. Data delay time. Port H set pulse width, 8. 64 Hz delay time. From sync. Buzzer delay time. From sync. Segment delay time. From sync. Notes, 1, TCY equals 32x1/f, OSC. 2, TSW equals 4x1/f, OSC. 3, TDV equals 8x1/f, OSC. Symbol. TD. TWH. TWL. TCY. TSW. TDV. TDV. TDDS. B. TSFD. TSBD. TSSD. 4, TDIV equals 16x1 if, OSC, plus 0.5/ls. 5, to OS equals 26x1/f, OSC, plus 1/ls. Clock, OSCOL. Sync. Conditions min tip max unit. CL equals 50 PF 800 NS. 115 NS. 1, /ls 2 /ls CL equals 50 PF 3 /ls CL equals 50 PF 4 /ls CL equals 50 PF 5 NS 500 NS CL equals 50 PF2 /ls CL equals 50 PF2 /ls CL equals 50 PF 8 2 /ls T.pwht.pwl 79 MSM 58422 Sync S PAPBPK dash TCY L dash dash 4 TTDIV colon dot equals dot dash dash plus dash invalid input mode underscore 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 dot J underscore 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 J underscore 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 PAPB output mode PH underscore 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 IOL underscore underscore D underscore colon underscore 5 underscore 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 dash underscore 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 dash NEWDATA U notes 6 when data input from PA or PB set the contents of PA or PB to 1 prior to reading in instruction 7 alteration by the instructions relative to output ports PFLT, it is in the case that the outputs of open drain are pulled down to GND by a resistor below 20K 0.1.01 XL/F, OSC. Sync. Underscore 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 N. THB.MCTO. Cycle. Point 1. Tin. LSXL/F, OSC, 15XL/F, OSC. Notes, 8, at execution of the THB instruction, any input made during a period of tin, 15x. 1 if, OSC, shown in the above figure may be neglected. 80. Dash. MSM 58422. 1024 pulses. 32 pulses. Dash. TSBD. TSFD. TR equals, dash. 64 Hz, dash. DIM 2 SY nil JL underscore LL seg. HL seg. LH seg. Notes, 9, the waveform shown above is in lighting up state, in the case that open drain output of FLT driver is pulled down to GND by a resistor below 20 kilo. DIM1 and DIM2 inputs must be in the state specified above. 81. EMSM 58422E dash 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 dash. Description of terminals. GND pin 33. Circuit grounding potential. VDD, pin 23. Main power supply. OSCO, pin 17. Input of the internal oscillation circuit at one side of the crystal resonator and ceramic. Vibrator. OSC1, pin 16. Output of the internal oscillation circuit at the other side of the crystal resonator and ceramic. Vibrator, not TTL compatible. PA, PB, pins 19 to 22 and 24 to 27. These are quasi-bidirectional ports for a 4-bit parallel I/O. To input data from these ports, it is necessary to write a 1 to them beforehand. When nothing is applied to their terminals, the content of the output ports is written into them. So they can also be used as registers. In addition, it is possible to use them to make an 8-bit parallel output depending on instructions. PK, pin 31. 1-bit input port with no latching function. Contains Schmidt-a-Schmidt trigger circuit. PH, pin 14. Input port with latching function to be set by negative logical signal. This terminal is set at the time the negative logical signal is applied to it from the outside. It is reset automatically after execution of the test instruction at this port. Reset, pin 18. Reset must be active for greater than 1 machine cycle. The reset signal input has priority over all of other signals and performs the following functions. 1. Resets all bits of the program counter. 2. Resets the latches of I/O ports PA, PB and output port PFLT6. 3. Resets the timer flag, TMF. 4. Resets the accumulator. 5. Resets the skip F/F circuit. 6. Resets the machine cycle to MI. Resets the output port PFLT5-1 to the data of 7 seg PLA address 0. Since the reset terminal is pulled up to VDD by an internal resistor, approximate 800 notts, it is possible to activate power on/reset by connecting it to an external capacitor. Sync, pin 15. This is a general purpose synchronizing signal output. The signal is output at the beginning of each machine cycle. Output constantly. This signal is used also as a clock pulse to external units. One sync cycle is 32 times that of the original oscillation, 8f.1s when the clock pulse is 4 MHz. 82. PFLT 1 to 6, pins 1 to 13 and 34 to 60. These are 7-bit and 5-bit parallel output ports, respectively. They are used to directly drive an FLT, static type. Specification of each port is accomplished by the port pointer, PP, which is a 4-bit register and is set to the contents of the accumulator by the LPA instruction. Latching data of each port is output through the logical and operation with the DIMA signal, later described, and via buffer circuits. When the data in the latch is 1, DIMA is output. When it is 0, the output is at high impedance. Content of PP. B3B, B, BO. Port specified. X000 PFLT1. X001 PFLT2. X010 PFLT3. X011 PFLT4. X100 PFLT5. X101 PFLT6-1-4. X110 PFLT6-5, by and BZ. X111. X, don't. By, 7-segment decoder PLA blank input. BZ, control signal output for the buzzer output. The inputs with the latching function of ports PFLT1-5 are connected to the outputs of the 7-segment decoder PLA and that of PFLT6 directly to the internal buses. DIM1, DIM2, pins 28, 29. Input terminals for the dimmer control of output ports PFLT1-6. DIM1 DIM2 DIMA. 1. 1. Buzzer, pin 30. 1. 1. 1/4 duty. 1/8 duty. 1/16 duty. 1. This terminal outputs the value of the logical and operation between latching bit 2 of output, port PFLT6 and the timer output, 05. By externally connecting a resistor and a transistor, this buzzer output terminal is used to control an alarm, buzzer etc. 64 Hz, pin 32. This is an output terminal, whose frequency is 1/65536 of the OSCO. For example, when the frequency of oscillator is 4.194304 MHz, the frequency of the 64 Hz signal output is given 64 Hz. This output pulse is used for adjusting the frequency. Its duty is 50%. MSM 58422. Instructions list. Mnemonic description. Instruction code. Byte cycle. 765432210. CLA clear accumulator 0001000011. CLL clear DPL 0010000011. CLH clear DPH 0110000011. Lie load accumulator with immediate 00011312I, 1011. LLI load DPL with immediate 001013I, 1011. LHI load DPH with immediate 01100010IL 1011. L load accumulator with memory 10010100011. LAL load accumulator with DPL 0101010111. LLA load DPL with accumulator 0101010011. LAW load accumulator with W register 10000100011. SI store accumulator to memory then increment DPL 10010000011. LWA load W register with accumulator 10000000011. LPA load port pointer with accumulator 010110000011. LTI load timer with immediate 0, clear timer and TMF, 0110100011. X exchange accumulator with memory 10011000011. INA increment accumulator 000000001111. INL increment DPL 0101011111. INM increment memory 0101110111. INW increment W register 10001000011. DCA decrement accumulator 0000111111. DCL decrement DPL 0101010111. DCM decrement memory 0101110011. CAO complement accumulator of 10101000011. RAL rotate accumulator left through carry 0100011111. AC add memory to accumulator with carry 0100110011. As add memory to accumulator, skip if carry 0100111111. ACE add immediate to accumulator, skip if carry 0000IIIL 1011. DOS decimal adjust accumulator in subtraction 0101101011. CM compare accumulator with memory 0101111011. 5 MB set memory bit 101110IL 1011. RMB reset memory bit 101111I, 1011. Tab test accumulator bit 101000I, 1011. TMB test memory bit 101001I, 1011. THB test H port bit 1010110011. TTM test time flag 1010111011. TC test carry flag 0100001011. SC set carry flag 0100000011. RC reset carry flag 0100000011. J jump 0011010, IE22. II13 IIL10. JC jump in current page 11 II13 I1011. JA jump with accumulator 0100000111. Cal call subroutine 001111, 0 IE22. 17 II13 IIL10. RT return from subroutine 0101100111. OTD output table data 0111100011 to 152. OA output accumulator to port A 0111100111. OB output accumulator to port B 0111100111. OP output accumulator to port designated port pointer 0111101011. OPM output memory to port P designated port pointer 0111101111. IA input port A in accumulator 0111101011. IB input port B in accumulator 0111101111. IC input port K in accumulator 0111111011. NOP no operation 0000000011. 83. OKI semiconductor. MSM 5847. CMOS 4-bit single-chip microcontroller with LCD driver. General description. OKI's MSM 5847 microcontroller is a low-power, high-performance single-chip device implement. In complementary metal oxide semiconductor technology. Integrated onto single chip are 1536x. 8 bits of mask program ROM, 96x 4 bits of data RAM, 7 input/output lines, 1 output line, a timer, LCD. Driver and oscillator. Program memory is byte-wide and data paths are organized in 4-bit nibbles. RAM is bit addressable. 43 instructions include binary, logical operations, bit set, reset, test, multifunction. AL instruction, increment, skip, subroutine call and return. 95% of instructions are single byte, single cycle operations. Features. Low power consumption 50 JJ atypical. 1.SKX8 internal ROM. 96x4 internal RAM. 7 I/O lines, 1 output line including 8-bit data. Bus. 13-bit timer. Self-contained oscillator. Functional block diagram. 84. IDSPRAM data memory, RAM. W. 16x6x 4-bit. LCD driver. Timing. 1/3 DUDL/3 BIOS. 222018161412109676543210. 232119171511311. Segment. 32134B. \J Hertz U. Common Z. Z. E. R. 43 instructions. 2 stack levels. -20 degrees to +70 degrees C operating temperature. 3V operating VDD. 61 OJJS cycle time at 32.768 kHz. 44 pin flat package. Chip form. 321 0-1 PA 3210 L-J PB. Sruvk. Yesten. NSCCDD. CE01. T. Logic symbol. AO. Orda. A. Bo. Underscore ord B. B. 8 igmento. J. 8 igmenta. 23 seg and 23. 34 Hz output. Buzzer output. Sync __ synchronized. Signal. +3 VVDD common 1 common 1. Common 2 common 2. OVGND common 3 common 3. Absolute maximum rating. Parameter symbol. Supply voltage VU. Input voltage 6. Output voltage VO. Storage temperature TSTG. Operating conditions. Parameter symbol. MSM5847. Pin configuration. 44 pin flat package. PBO. PB. Segment O. Segment 1. Segment 2. Segment 3. Segment 4. Segment 5. Segment 6. Conditions. Ta equals 25 degrees Celsius. Condition. Limits. -0.3 -7. -0.3 VU. -0.3 VU. -55 to +125. Limits. Segment 22. Segment 21. Segment 20. Segment 19. Segment 18. Segment 17. Segment 16. Segment 15. Segment 14. Segment 13. Segment 12. Unit. V. Degree C. Unit. Supply voltage VU HOSC equals 32.768 kHz 2.7 to 3.3 V. Operating temperature top, -20 +70 degree C. 85. EMSM 5847 E dash 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 dash. AC characteristics. VU equals 3V plus or minus 10%, Ta equals -20, plus 70 degree C. Parameter symbol. Sync elay time. T, from clock, OSCO. Clock, OSCO, pulse width TWH. T, WL. Cycle time TCY. Sync pulse width TSW. PA, PB OTA valid time TOV. PA, PB OTA invalid time TOEV. OTA elay time TOS. Note, 1, TCY equals 20x11f, OSC. 2, TSW equals 2x11f, OSC. 3, TOV equals 4x1f, OSC. 4, TOEV equals 8x11f, OSC, plus 20j.ls. 5, 2OS equals 17x11f, OSC, plus 40j.ls. Clock, OSCO. Sync _%. TSW. Sync. K. Condition. CL equals 50 pf. CL equals 50 pf. TQWH. TDIV. Min. Tip. Max. Unit. 5j.ls. 15. J.ls. Note, 1, J.ls. Note, 2, J.ls. Note, 3, j.ls. Note, 4, j.ls. Note, 5, j.ls. F, OSC, equals 32.768 kHz. TCY equals 610 j.ls. TSW equals 61 j.ls. TOV equals 122 j.ls. TOEV equals 264 j.ls. TOOS equals 558.5 j.ls. TQWL dash TCY H TDV PAPB. Input mode invalid. Valid invalid. 86. PAPB. Output mode old data. TDDS. New data. Dash 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 4. MSM 5847. DC characteristics. VU equals 3V plus or minus 10%, TA equals minus 20, plus 70 degrees Celsius. Parameter symbol condition. H input voltage VIH. L input voltage VIL. VO. V. Asterisk 1 applicable to. Common, segment common 1 to 3. Output voltage V2 segment 0 to 23. VA. H output voltage. VOH asterisk 2 asterisk 3 asterisk 4 1. 0 equals 1 Lola. L output voltage asterisk 2 vol 10 equals 1 Lola. L output voltage asterisk 3 asterisk 4 vol 10 equals 1 Ma. OSCO input current IIH/IIL6 equals VV equals OV. Reset input current IIH/IIL6 equals VV equals OV. Current consumption 100. VU equals 3V. F equals 32.768 kHz. No load. Note, asterisk 1 applicable to POW2, LBOA, sync and 34 Hz. Asterisk 2 applicable to PA. Asterisk 3 applicable to buzzer. Min. Tip. Max. VU. Minus 0.2. 0.3. 0 to 0.2. 1/3 VU, 1/3 VU. Minus 0.2 plus 0.2. 2/3 VU, 2/3 VU. Minus 0.2 plus 0.2. VU. VU. Minus 0.2. VU. Minus 0.2. 0.2. 1.0. 5/-5. 1/-15. 5100. Level of output voltage for common segment. Dash 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 V3. Dash 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 V2. V. VO. Unit. V. 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 Lola. 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 87. EMSM 5847 E dash 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 dash. Tip. Output current, low, vs output. Voltage, yo, for high level state. Minus 2.0. Minus 1.8. Minus 1.6. Minus 1.4. 0.5. C minus 1.0. O. Minus 0.8. Minus 0.6. Minus 0.4. Minus 0.2. O. VU equals 3V, Ta equals 25 degrees C. I dash 34 Hz terminal backslash sync terminal 1 backslash 1 backslash C6M I terminal backslash seg underscore PA PB terminal 1 2 3 4 5 6 7 8 9 10 VOH V tip output current 11 12 VS output voltage V1 V2 for middle level state 25 20 15 10 0.35 0 -5 -10 -15 -20 -25 88 VU equals 3V Ta equals 25 degrees C slash 2 VJI 421 IVCOM seg terminal II slash slash ILI I 1 2 3 4 5 6 7 8 9 10 VV V tip output current LOL VS output voltage vol for low level state 0.5 I 9 5 CL CL VU equals 3V Ta equals 25 degrees C 10 9 8 7 6 PA3 terminal 5 4 3 2 I slash buzzer terminal 2 high point 1 I 34 Z termina IJ dash II PAL 2 PBO 3 SIYN TETLNJ ICOM seg terminal 1 2 3 4 5 6 7 8 9 10 vol dash V 10M 5M 1M 500/1 100/1 50/1 10/1 5/1 100N supply current LDO VS supply voltage VU Ta equals 25 degrees C no load F OSC 32.768 kHz slash dot comma O Hertz 1 2 3 4 5 6 7 8 9 10 VU V OLMSO /60 series M OKI semiconductor MSM 5052 CMOS 4-bit single-chip very low-power microcontroller with temperature detection circuit and LCD driver. General description: the OKI MSS 5052 is a low-power and high-performance single-chip microcontroller employing complementary metal oxide semiconductor technology. Integrated onto a single chip are a 4-bit ALU, 18K bits of mask programmable ROM, 248 bits of data RAM, crystal oscillator, voltage doubler, timer, LCD driver, input port, output port, and CR oscillator for temperature detection. The MSM 5052 is widely used in electronic products requiring low power operation, for example, thermometer and clinical thermometer with a timepiece. Features: low power consumption, 3 ILA typical 42 instructions, 1280x14 internal ROM, 1.5V operating voltage, 62x4 internal RAM, 4x2 input port, 5 output port, 4x4 key matrix input, K1 K4, M1 M4, 32.768 kHz crystal oscillator, 122.1p.s instruction cycle. -20 to 75 degrees Celsius operating temperature. 61 pad die. 26 LCD driver. 112 duty, 112 bias, 52 segment. Functional block diagram. BD. A3AO. H equals JJ1. Display. Latch. And. Driver. Key. I. K4. 5. I. 54. I 111,111. Instruct. TLON. Decoder. Segment down. / segment. Out 26. COM1. CQM2. 91. EMSM 5052E dash 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 dash. Logic symbol chip pad layout. Segment out. Oscillation plus OO. Input port. $1 to $54. Segment. Out 26. Input port COM1. IC1K4, COM2. J oscillation output port. .UIT4. IM1M4, temperature. Output port detection. Reset buzzer output. Power source. JDIST S1. Chip size 4,77 x 436 LMM. Pin description. Designation function. VU circuit ground potential. VSS, power source, -1.5 V. VSS2 power source for LCD driver, -3.0 V. This terminal is connected to VU terminal through a 0.1 p.f capacitor. VCP VCM booster capacitor connection terminals. VCP terminal is connected to VCM terminal through a 0.1 p.f capacitor. OSC1 OSC3 input and output terminals of oscillator inverter. 32.768 kHz crystal is connected to these terminals. T1 T5 terminals to test internal logic, T1, T3 and T5 are pulled down to VSS1. T4 is output. Test pins must be normally open. AC terminal to clear internal logic pulled down to VSS. After power is turned on, the MSM5052 must be reset by this terminal. Bow buzzer output. THRC in terminal to CR oscillation circuit for temperature detection. Fundamental resistor, thermistor, capacitor connection terminal. 92. E. MSM5052. Functional description. A block diagram of the MSM5052 is given on page 91. Each block of logic will be briefly discussed. For more information, please refer to the MSM5052 User's Manual. Program ROM. The MSM5052 addresses up to 1.25K words of internal mask program L1 able ROM. Each word consists of 14 bits and all instructions are one word. The instructions are routed to a programmed logic array which generates the signals necessary for control of logic. Data RAM. Data is organized in 4-bit nibbles. Internal data RAM consists of 62 nibbles. The RAM is addressed by page address and column address. Normally page address is specified with page register, but direct addressing is available in page O. Column address is directly addressed by operand of various instructions. ALU. The ALU performs 4-bit parallel operation on RAM and ACC contents, or RAM contents and an immediate digit. It sets or resets the flags, Z, C, depending on the condition. Program counter, PC. The program counter is 11 bits wide and specifies the address of the program ROM. The PC is incremented by 1 every execution of the instruction, and then specifies the next instruction to be executed. However, the contents of the PC are rewritten by the execution of the jump or branch instruction. There is no boundary in the ROM, so a jump or branch instruction can be put anywhere in the ROM. Input/output port. Input port, 51 to 54. Input port, K1, K4. The input port, K1, K4, is a 4-bit parallel input port. Each pin of the port is pulled down to VSS1 by an internal resistor, and the status of the port is fetched by an input instruction. Output port, M1, M4. The output port, M1, M4, is a 4-bit parallel output port. This port consists of data latches and buffers, and the contents of the data latches are rewritten by an output instruction. Output port, LD. The output port, LD, is single output port. This terminal is used for loading of M1 to M4 data. Display function. The MSM5052 is provided with a segment output terminal which can directly drive a half bias, 112 duty LCD and the common drive output terminal COM1 and COM2. The segment drive circuit consists of the display data latch, multiplexer and driver. If the data is sent to the display data latch with a display instruction, the LCD drive waveform is output to the segment drive output terminal. Time base. The time base for the CPU is provided by connecting a 32.768 kHz crystal to the OSC1 and OSC3 pins. One machine cycle is 122.1 FLS. A hardware divider up to 1 Hz is provided, enabling programs to implement a clock function by counting signals between 16 and 1 Hz. Temperature detection circuit. The temperature detection circuit is composed of an external thermistor, a fundamental resistor, a capacitor, and a built-in CR oscillation circuit. Two types of temperature measurement circuit, as shown below, are available in TOI:ISFT, ERTISITJ2, R. MSM5052. Thermometer, R. TH series. MSM5052. Clinical thermometer, R. TH parallel, VSS1 by an internal resistor, and the status of the port is fetched by an input instruction. TH 93. MSM5052-. Absolute maximum ratings. Parameter symbol conditions limits unit. Supply voltage 1 V VSS, Ta equals 25 degrees C minus 0.3 to plus 2.0 V. Supply voltage 2 V VSS 2 Ta equals 25 degrees C minus 0.3 to plus 4.0 V. Input voltage VEN, Ta equals 25 degrees C VSS, minus 0.3 to plus 0.3 V. Storage temperature TSTG minus 55 to 125 degrees Celsius. Operating conditions. Parameter symbol limits unit. Operating voltage VSS, 1.25 to 1.65 V. Operating temperature top here -20 to 75 degrees Celsius. DC characteristics. VU equals OV, VSS equals -1.55 V, VSS2 equals -3.0 V, CI equals 30 KO, Ta equals 25 degrees Celsius. Limits. Parameter symbol condition unit. Min. Tip. Max. Power supply current 100, temperature sampling off, 3.0, LA. Power supply current 1002 temperature sampling on, 100, LA. Oscillation start within 10 seconds 1.45, V. Voltage VOSC VSS, terminal. IOH, VOH, equals -0.2 V minus 4. Output current 1. 10 M, YOM, equals VSS, plus or minus 0.2 V. COM. 4/4, LA. IOL, vol, equals -2.8 V4. Output current 2 IOH2 VOH2 equals -0.2 V minus 0.4. Segment. IOL2 vol2 equals -2.8 V 0.4. LA. Output current 3 IOH3 VOH3 equals -0.4 V minus 400. CR, TH. IOL3 vol3 equals -1.15 V 400. LA. Output current 4 IOH. VOH equals -0.4 V minus 100. M1M. Low. IOL. Vol. Equals -1.15 V10. LA. Output current 5 IOH5 VOH5 equals -0.4 V minus 50 to minus 500. Bo. IOL5 vol5 equals -1.15 V4. LA. Input current IIH, VIH, equals OV110 100. S1 S4 K1 K4. IL, VIL, equals -1.55 V minus 0.2. LA. Oscillator built-in. 25 PF. Capacitor Co. 94. EEMSM 5052E. Measuring circuit. VCP. C4. In VCM. C. OSC3. R. ROSCL. TH. TH. Typical application. LCD. COM2. TH. R. R. In. CMSM 5052. OSCL. C2R:::J, CD equals 25 PF. 32.768 kHz. OSC3. C3. VCP. C2. XTAL. CL. CL20 PF. C2.C3 0.1 PF. C4 3000 PF. XTAL 32.768 kHz. R.TH 10 KO. M. M. High alarm output. F low. M. LD. BD. VSS. VDD. AC. 1. 2. 3. 4. 5. Dash. Asterisk 1. R equals 33 KO. R equals 20 KO. TH40 BT5. 40 KO plus or minus 10% at 25 degrees Celsius. B equals 3550 plus or minus 2%. C equals 680 PF. C equals 5 minus 35 PF. C3 equals 0.1 PF. C equals O.LF.LF. Asterisk 1. Inner switch or pad on PCB. Asterisk 2. Bonding option. Thermometer 1. Second sampling. Thermomet 6110. Second samling. FPTK alarm. T6 fit E alarm. Clock. 95. MSM 5052-. Description of instructions. Instruction code. Mnemonic operation. 131211109876543210. Add SEAP00000P0100AAP plus ACC. Add number 0, AP0110P0AAP plus dash, AP, 0. Add cap 00000P0101AAP plus decimal adjust. AP, plus, ACC, plus, C. 0. Sub hashtag DAP01101P0AAP plus, AP, 0. QJ. C. ZPDAP 00001P0101AAP plus decimal adjust 0. J, AP, ACC, C. ECMPAC, AP00001P1110A, AP, ACC. 5. CMP hashtag DAP01011P0A, AP, 0. INCAP 01100P0001AAP plus TAP, plus 1. DECAP 01101P0001AA plus, AP, 1. CORA CAP00000P0111AAP plus, AP, V-ACC. X or hashtag DAP01111P0AAP plus, AP, IT 0. Bit ACC AP00000P1110A, AP, V, ACC. 0. BISIC, AP00000P0110AAP plus, AP, V, ACC. QJ. BIS hashtag DAPAP plus, AP, VDC01000P0A. 0. 3 by CASI, AP00001P0110AAP plus, AP, A, ACC. Big hashtag DAP01001P0AAP plus dash, AP, AD. Ashrap 00000P0011AL, C, 0, AP::J. C. C slash, ASLAP00001P0011A, C, plus, AP, plus 0. CLZ0000010100000Z plus O. 0. CLA000000010110000Z plus dash 0, C plus dash 0. C. Says 000001010100000Z plus dash 10. 01. Till SEC 000010100100000C plus dash 1U. C 0000101010000Z plus dash 1 C plus dash 1. Move AP111110P00000AAP plus, ACC. Move AX11111000XAAX plus dash, ACC. QJ. MOV hashtag DAP01110P0AAP plus dash 0 UI. Till move XACC11111000XAACC plus, AX. 0. CHGAP 1110P000A, ACC, plus dash plus, AP. CHGAX 111000XA, ACC, plus dash plus, AX. 96. dash 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 EMSM 5052E. Description of instructions, cont. Instruction code. Mnemonic operation. 13 12 11 10 9 8 7 6 5 4 3 2 1 0. JMP ADRs 100A0A9 as A as a 4 a 3 AA, AOPC plus ADRs. JMP at AP00000P1101 APC plus, PC, plus, AP, plus 1. JMPO at AP00001P1101 APC plus, PC, plus, AP, A7H, plus 1. BEP plus N. 000110010N3NN, no PC plus N plus 1. If Z equals 1. BZE plus N. N4. BNE plus N. 00011. 0 BNZ plus N. 0110 N4 N3 NN, no PC plus N plus 1. If Z equals 0. E. BCS plus N. 000110001 PC plus N plus 1. If C equals 1. BLT plus N. N4 N3 NN, no. BCC plus N. 000110101 N4 N3 NN, no PC plus N plus 1. If C equals 0. BGE plus N. BGT plus N 000110111 N4 3 N2 N1 no. PC plus 2 plus 1. If Z equals 0. And C equals 0. BLE plus N 000110011 N4 N3 NN, no. PC plus N plus 1. If Z equals 1. Or C equals 1. INP port. AP1101. 0P port AAP plus, port. Dash 0. Out AP. Port 11011P port A port plus, AP. C. Shocked. Out number 0. Port 000100 port 0 port plus 0. OSP digit. AP00100P digit A digit plus, AP. ACC. OJA. OSPF digit. AP00110P digit A digit plus, AP, via table 15. 0 halt 000100000000000 halt CPU. L. OC. NOP 000000000000000 no operation U8. 97. OKI semiconductor. MSM 5054. CMOS 4-bit single-chip very low-power microcontroller with LCD driver. General description. The OKI MSM 5054 is a low-power, high-performance single-chip microcontroller employing complementary metal oxide semiconductor technology. Integrated onto a single chip are 4-bit of ALU, 14K bits of mask programmable ROM, 248 bits of data RAM, crystal oscillator, voltage doubler, timer, LCD driver, input port, and output port. The MSM 5054 is widely used in electronic products requiring low power operation, for example, clocks, timers and games. Features: low power consumption 3/L atypical 40 instructions. 1024x14 internal ROM 1.5V or 3V operating voltage. 62x4 internal RAM, masking option. 6. Input port 32.768 kHz crystal oscillator. 4. Output port. 4x4 key matrix input, SIS, MLM4. 122.1/-S instruction cycle. -20 to 75 degrees Celsius operating temperature. 44 LCD driver 74 pad die. 1/2 duty, 112 bias, 88 segment. Functional block diagram. 80-1. Low. L == J015 PLA. Latch. .ND. Driver. 98. 5. I. S. 1. III1 1111 3. Instruc. TION. Decoder. Segment. OUTI. / segment. Out 44. COM L. COM. MSM 5054. Logic symbol chip pad layout. Seg 44. OXLLLATION segment. Out 1. Input ORT. 1554. INPU:*J. Segment. Out. COM 1. Output port. COM. MM4, so buzzer output. Reset. Low lamp output. 32 Hz, test. Source T. T. T3. T4. T. Seg 1. Segment output. Chip size 4.68 x 4.23 mm. Pin description. Designation function. VDD circuit ground potential. VSS, power source, -1.5 V. VSS2 power source for LCD driver, -3.0 V. This terminal is connected to VDD terminal through a 0.1 JLF capacitor. V power source for internal logic, -1.5 to -3.0 V. This terminal is connected to VDD terminal through a 0.1 JLF capacitor. VCP, VCM booster capacitor connection terminals. VCP terminal is connected to VCM terminal through a 0.1 JLF capacitor. XT input and output terminals of oscillator inverter. 32.768 kHz crystal is connected to these terminals. TTS terminals to test internal logic, T1, T3 and TS are pulled down to VSS. T4 is output. Test pins must be normally open. AC terminal to clear internal logic pulled down to VSS. After power is turned on, the MSM 5054 must be reset by this terminal. BD buzzer output. LD lamp output. 99. Functional description. A block diagram of the MSM 5054 is given on page 97. Each block of logic will be briefly discussed. For more information, please refer to the MSM 5054 User's Manual. Program ROM. The MSM 5054 addresses up to 1K word of internal mask programmable ROM. Each word consists of 14 bits, and all instructions are 1 word. The instructions are routed to a programmed logic array which generates the signals necessary for control of logic. Data RAM. Data is organized in 4-bit nibbles. Internal data RAM consists of 62 nibbles. The RAM is addressed by page address and column address. Normally page address is specified by the page register, but direct. Addressing is available in page O. Column address is directly addressed by the operand of various instructions. ALU. The ALU performs 4-bit parallel operation of RAM and ACC contents, or RAM contents and an immediate digit. It sets or resets the flags, Z, C, depending on the condition. Program counter, PC. The program counter is 10 bits wide and specifies the address of the program ROM. The PC is incremented by 1 at every execution of the instruction, and then specifies the next instruction to be executed. However, the contents of the PC are rewritten by the execution of the jump or branch instruction. There is no boundary in the ROM, so the jump or branch instruction can be put anywhere in the ROM. 100. Input/output port. Input port, 81 to 84. The input port, S1, S4, is a 4-bit parallel input port. Each pin of the port is pulled down to VSS1 by an internal resistor, and the status of the port is fetched by the switch instruction. Input port, K1, K4. The input port, K1, K2, is a 2-bit parallel input port. Each pin of the port is pulled down to VSS1 by an internal resistor, and the status of the port is fetched by the K-switch instruction. Output port, M1, M4. The output port, M1, M4, is a 4-bit parallel output port. This port consists of data latches and buffers, and the contents of the data latches are rewritten by a matrix instruction. Display function. The MSM5054 is provided with a segment output terminal which can directly drive a half BIOS, 112 duty LCD, and the common drive output terminal COM1 and COM2. The segment drive circuit consists of the display data latch, multiplexer and driver. If the data is sent to the display data latch with a display instruction, the LCD drive waveform is output to the segment drive output terminal. Time base. The time base of the CPU is provided by connecting a 32.768 kHz crystal to the XT and XT pins. One machine cycle is 122.1/ls. A hardware divider of up to 1 Hz is provided, enabling programs to implement a clock function by counting signals between 32 and 1 Hz. __E. MSM5054. Absolute maximum ratings. Parameter symbol conditions limits unit. Supply voltage 1 V VSS, Ta equals 25 degrees Celsius minus 0.32 plus 2.0 V. Supply voltage 2 V VSS 2 Ta equals 25 degrees C minus 0.32 plus 4.0 V. Supply voltage 3 V Ta equals 25 degrees C minus 0.32 plus 4.0 V. Input voltage VEN, Ta equals 25 degrees C VSS, minus 0.32 plus 0.3 V. Storage temperature TSTG minus 55 to 125 degrees Celsius. Operating conditions. Parameter symbol limits unit. Operating voltage VSS, 1.25 to 1.65 V. Operating temperature top air minus 20 to 75 degrees Celsius. DC characteristics. VU equals OV, VSSV equals -1.55 V, VSS2 equals -3.0 V, CI equals 30 knots, Ta equals 25 degrees Celsius. Limits. Parameter symbol condition unit. Min. Tip. Max. Power supply current 100, 3.0/LA. Oscillation start. VOSC. Within 5 seconds. 1.45 V voltage. SS, terminal. IOH, VOH, equals -0.2 V minus 4. Output current 1. 10 M, VOM, equals VSS, plus or minus 0.2 V4/-4/LA com. LOL equals -2.8 V4. Output current 2 IOH2 VOH2 equals -0.2 V minus 0.4. Segment. IOL2 Vol2 equals -2.8 V 0.4/LA. Output current 3 IOH3. VOH3 equals -0.4 V VSS equals -1.25 V minus 50 to minus 500. BO. IOL3. V equals -1.25 V/LA. Vol3 equals -0.8 V VSS2 equals -2.4 V 2.5 to 7.5. Output current 4 IOH4. VOH4 equals -0.55 V VSS equals -1.25 V minus 21 to minus 83. Low. IOL4 Vol4 equals -1.15 V. V equals -2.4 V/LA. VSS2 equals -2.4 V1. Output current 5 IOH5 VOH5 equals -0.5 V minus 100. MM4. IOL5 Vol5 equals -1.0 V. PA, 1.5 to 7.5. Input current 1 IIH, VIH, equals OV 11050. SS4. IL, VIL, equals -1.55 V minus 0.2/LA. Input current 2 IIH2 VIH2 equals OV 2.5612. KK2. IIL2 VIL2 equals -1.55 V/LA. Minus 0.2. Oscillator built-in. 20 PF capacitor counting. 101. EMSM 5054 E dash 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 dash. Measuring circuit. Typical application. LCD. SI, segments. S2 dash. SI. S3, L. S2. S3. S4L. S4. MSM 5054. XT. Co equals 20 PF. AC. CL. 102. VCP. VCM. COM2. XT. XT equals R. O.L.UF. 30 PF. 32.768 kHz. Low. So. VSSI. VU. VV. SS2. CA. XTAL. C3C4. LAMP. 535 PF. O.L.UF. 1.5 V. 20 mH. Dash. MSM 5054. Description of instructions. Instruction code. Mnemonic operation. 131211109876543210. AOOC AP0000P01000AAP, AP, plus, ACC. AOO hashtag OAP01100PDAAP dash, AP, plus 0. Sub ACC AP0001 P0100 AAP, AP, ACC. C. 0 sub hashtag OAP01101 P0 AAP dash, AP, D. Q, AOGISTUN AP1100 PN plus 1 AAP, N adjust, AP, J. A. 0. Back AP000001 P1110A, AP, ACC. I. CMP hashtag OAP01011 PDA, AP, DE. 5. INCAP 01100 P0001 AAP dash, AP, plus 1. DECAP 01101 P0001 AA dash, AP, minus 1. Cora CAP 00000 P0111 AAP, AP, 1I, ACC. X or hashtag DAP01111 P0 AAP dash, AP, 1IO. BITAS CAP 00000 P1110A, AP, V, ACC. C, bid hashtag OAP010. 0. 10 PDAI, AP, VD. Q. BISIC AP00000 P0110A, APV, ACC. A. BIS hashtag OAP01000 PDA, AP, VD. 0. 3 BIC ACC, AP00001 P0110A APA, ACC. BIC number 0, AP01001 P0 AAPAD. Ashrap 00000 P0011AL, C, 0, AP, J. Dot C. C, dash, AP, ORNASL AP00001 P0011A. CLZ 000001010000000. C. CLC 000001000100000CO0. CLA 00ZOCOQ 0000101101000. A. 0 says 000010101000000Z1. 01 CA. U, SECO 0001010100000C1. C00001010100100000Z1 MUVASI AP11110 P0000 AAP dash, ACC. MUVASI AX1111. 000XAAX dash, ACC. C. MOV hashtag DAP01110 PDAAPD. CA. MUVAP ACC11111 P0000 AACC dash, AP, A. CL. ACC dash, AX, MUVAX ACC1111100XA. 103. MSM 5054 dash dash dash. Description of instructions, co-nt. Instruction code. Mnemonic operation. 131211109876543210. JMP ADRs 1000A98A7A6A5A4A3A2A, AOPC. ADRs. JMP at AP00000P1101 APC. PC, plus, AP, plus 1. JMPO at AP00001 P1101 APC. PC, plus, AP, A7H, plus 1. A. BEQ plus N. E. BZE plus N. 000110010 N4 N3 N2 N, no PC. PC, plus N plus 1, if z equals 1. J. BNE plus N. 000110110 PC. PC, plus N plus 1, if z equals O. BNZ plus N. N4 N3 N2 N, no. BCS plus N000110000 N4 N3 N2 N, no PC. PC, plus N plus 1, if C equals 1. BCC plus N000110100 N4 N3 N2 N, no PC. PC, plus N plus 1, if C equals O. Switch app 11010P0001 AAP. Input port, S, S4. K switch app 11010P0010 AAP. Input port, K, K2. Matrix app 11011P0010A output port, M, M4. S. AP. A. S. MATRIXMN00010000010 M3 M2 M, output port, MM4. 0. MN, N equals 1, 2, 3, 4. JA. Buzzer frequency, 000100110B3 B2B, BO frequency. Frequency, reg. Sound. Dash equals sound buzzer start. BSO 0001001100000 buzzer stop. Lamp on / off 00010000010 OB, BO LDON / off. DSP digit, AP 00100P digit A digit. AP, ACC. Formatop 11011P0011 AFMT reg. AP. As. Q. TJ, format HUN 00010000011 NFMT reg. N. 0. DSPF digit, AP 00110P digit A digit. AP, via table. Halt 0001000000000 halt. Intonub 000100100111000. Enable timer. 32/16 0001000100010. TJ, int sab 000100100101100. Disable timer CD. 32/16 0001000100001.c. 0. Add int modiap 11010P0100 AAP. Interrupt mode. G. Pageo 11011001001 A preg. AO. C. 0. Pagan 00010000101 N preg. N0. J. Radip IL. 11010. 0. P1001 AAP. Divider, 8 Hz 1 Hz. R straight 0001001001000 divider, 8 Hz 1 Hz. 0. Backup 00010000001 B3 B200 backup on / off. On / off. NOP 000000000000000 no operation. 104. OKI semiconductor. MSM 5055. CMOS 4-bit single chip very low power microcontroller with LCD driver. General description. The OKI MSM 5055 is a low power, high performance single chip microcontroller employing complementary metal oxide semiconductor technology. Integrated onto a single chip are 4 bits of ALU, 25K bits of mask programmable ROM, 384 bits of data RAM, crystal oscillator, voltage doubler, timer, LCD driver, input port, output port, and interface circuit for voice LSI, MSM6212. The MSM5055 is widely used in electronic products requiring low power operation, for example, multifunctioned watches, voice synthesizer watches and games. Features: low power consumption 3P. A typical 1792x14 internal ROM, 96x4 internal RAM, 4x2 input port, 4x1 output port, 4x4 key matrix input, K1 K4, M1 M4, 60 LCD driver, 112 duty, 112 bias, 120 segment. Functional block diagram. LD M1 backslash M4 low K1 backslash K4 S I S 42 instructions, 1.5 V or 3 V operating voltage. Masking option 32.768 kHz crystal oscillator, 122.1 p.s instruction cycle, -20 to 75 degrees Celsius operating temperature, 94 pad die. Data RAM 96 word x 4 bit, 1792 word x 14 bit. JI ACT1 T2 T3 T4 T5 Instruct TION Decode Segment OUTL Segment Out 60 COML COM2 105 MSM 5055 Logic symbol chip pad layout Oscillation ___ asterisk SL Input port 82 $81 $4 $3 S4 Input port K2 KL KLK4 ML Output port M2 IM1 M4I M3 M4 Load low Reset AC Power source 1-V -VCP VCM Segment Done Segment Out 60 COML COM2 LCD driver BD buzzer output LD_lamp output Stout GD9TULSE AC2 reset TLT2 T3 test T4 T5 Stout AC S S V K K K K R : N N R N N N IMFTI NRRNTI Tirafel Riel Seg 31 VDD VSS2 VCP VCM VSSL SD LD AC T T T T Law 15 com 2 T : dot equals dot J seg 30 SEGL segment output chip size 5.49 x 4.71 mm pin description designation function VDD circuit ground potential. VSS, power source, minus 1.5 V. VSS2 power source for LCD driver, minus 3.0 V. This terminal is connected to VDD terminal through a 0.1 P.F capacitor. V power source for internal logic, minus 1.5 to minus 3.0 V. This terminal is connected to VDD terminal through a 0.1 P.F capacitor. VCP, VCM booster capacitor connection terminals. VCP terminal is connected to VCM terminal through a 0.1 P.F capacitor. XT. Input and output terminals of oscillator inverter. 32.768 kHz crystal is connected to these terminals. T1 T5 terminals to test internal logic, T1, T3 and T5 are pulled down to VSSL. T4 is output. Test pins must be normally open. AC terminal to clear internal logic pulled down to VSSL. After power is turned on, the MSM5055 must be reset by this terminal. BD buzzer output. LD lamp output. Low load data terminal of M1 to M. AC2 reset terminal for external circuit. Stout clock output for external circuit. 106. MSM5055. Functional description. A block diagram of the MSM5055 is given on page 104. Each block of logic will be briefly discussed. For more information, please refer to the MSM5055 User's Manual. Program ROM. The MSM5055 addresses up to 1K word of internal mask programmable ROM. Each word consists of 14 bits, and all instructions are one word. The instructions are routed to a programmed logic array which generates the signals necessary for control of logic. Data RAM. Data is organized in 4-bit nibbles. Internal data RAM consists of 62 nibbles. The RAM is addressed by page address and column address. Normally page address is specified by the page register, but direct addressing is available in page O. Column address is directly addressed by the operand of various instructions. ALU. The ALU performs 4-bit parallel operation of RAM and ACC contents, or RAM contents and an immediate digit. It sets or resets the flags, Z, C, depending on the condition. Program counter, PC. The program counter is 10 bits wide and specifies the address of the program ROM. The PC is incremented by 1 at every execution of the instruction, and then specifies the next instruction to be executed. However, the contents of the PC are rewritten by the execution of the jump or branch instruction. There is no boundary in the ROM, so the jump or branch instruction can be put anywhere in the ROM. Input/output port. Input port, 51 to 54. The input port, S1, S4, is a 4-bit parallel input port. Each pin of the port is pulled down to VSS1 by an internal resistor, and the status of the port is fetched by the switch instruction. Input port, K1, K4. The input port, K1, K2, is a 2-bit parallel input port. Each pin of the port is pulled down to VSS1 by an internal resistor, and the status of the port is fetched by the K-switch instruction. Output port, M1, M4. The output port, M1, M4, is a 4-bit parallel output port. This port consists of data latches and buffers, and the contents of the data latches are rewritten by a matrix instruction. Display function. The MSM5055 is provided with a segment output terminal which can directly drive a half BIOS, 112 duty LCD, and the common drive output terminal COM1 and COM2. The segment drive circuit consists of the display data latch, multiplexer and driver. If the data is sent to the display data latch with a display instruction, the LCD drive waveform is output to the segment drive output terminal. Time base. The time base of the CPU is provided by connecting a 32.768 kHz crystal to the XT and XT pins. One machine cycle is 122.1 JLS. A hardware divider of up to 1 Hz is provided, enabling programs to implement a clock function by counting signals between 32 and 1 Hz. 107. MSM5055-. Absolute maximum ratings. Parameter symbol conditions limits unit. Supply voltage 1 V VSSI Ta equals 25 degrees C minus 0.32 plus 2.0 V. Supply voltage 2 V VSS2 Ta equals 25 degrees Celsius minus 0.32 plus 4.0 V. Supply voltage 3 V V Ta equals 25 degrees Celsius minus 0.32 plus 4.0 V. Input voltage VAN Ta equals 25 degrees Celsius VSS, minus 0.32 plus 0.3 V. Storage temperature TSTG minus 55 to 125 degrees Celsius. Operating conditions. Parameter symbol limits unit. Operating voltage VSSI 1.25 to 1.65 V. Operating temperature top air minus 20 to 75 degrees Celsius. DC characteristics. VU equals OV, VSS. V equals dash 1.55 V, VSS2 equals dash 3.0 V, CI equals 30 K, Ta equals 25 degrees Celsius. Limits. Parameter symbol conditions unit. Min. Tip. Max. Power supply current 100 to 3.0/LA. Oscillation start VOSC within 5 seconds 1.45 V. Voltage VSS, terminal. IOHI VOH, equals dash 0.2 V minus 4. Output current 1. IOMI YOM, equals VSS, plus or minus 0.2 V4/-4/LA. COM. LOL equals dash 2.8 V4. Output current 2 IOH2 VOH2 equals dash 0.2 V minus 0.4. Segment. IOL2 Vol2 equals dash 2.8 V 0.4/LA. Output current 3 IOH3 VOH3 equals dash 0.5 V minus 10. AC2 load, stout. IOL3 Vol3 equals dash 1.05 V10/LA. Output current 4 IOH4 VOH4 equals dash 0.5 V minus 100. M1 M4. IOL4 Vol4 equals dash 1.0 V 1.5 12.7/LA. Output current 5 IOHs VOHs equals dash 0.55 V VSS, equals dash 1.25 V minus 21.6. Minus 83. Low. V equals dash 2.4 V/LA. IOLs vols equals dash 1.15 V VSS2 equals dash 2.4 V1. Output current 5 IOHE VOHE equals 0.4 V VSSI equals V minus 50. So. Equals dash 1.25 V/LA. IO_havol equals -0.8 V VSS2 equals -2.4 V, 5. Input current 1 IIH VIH equals OV 11050. SS4. IL, VIL, equals -1.55 V minus 0.2. /LA. Input current 2 IIH2 VIH2 equals OV 2.5612. KK4. IIL2 VIL2 equals -1.55 V. /LA. Minus 0.2. Oscillator built-in. CD, 20 PF capacitor. 108. Dash. MSM 5055. Measuring circuit. Typical applicat.ion. SLI. COM1. S2, LSL. S2. S3, L. S3. S4L. S4. XT. CD equals 20 PF. C1. VCP. VCM. XT. XT. C1. C2. C3 0.1/LF. C4 30 PF. XTAL 32.768 kHz. LCD. Segments COM2. LD. SD. MSM 5055. VSS1. VDD. AC. C3. XTAL. C4. LAMP. 5, 35 PF. 0.1/LF. 1.5 V. 20 mH. 109. MSM 5055-. Description of instructions. Instruction code. Mnemonic operation. 131211109876543210. Add ACC, AP0000P0100AAP plus, ACC. Add hashtag DAP011000PDAAP plus dash, AP, plus D. Sub ACC AP00001P0100AAP plus, AP, ACC. C. Point 2 sub hashtag DAP01101PDAAP plus dash, AP, D. A. AP plus N adjust, AP, Q, adjust on AP1100PN plus 1A. C. 0 CMPACC, AP00001P1110A, AP, ACC. Q. CMP hashtag DAP01011PDA, AP, D. E. Hesitant face. In cap 01100P0001AAP plus dash, AP, plus 1. Decap 01101P0001AA plus dash, AP, minus 1. X or ACC, AP00000P0111AAP plus, AP, V, ACC. X or hashtag DAP01111PDAAP plus, AP, VD. Bytasi AP00000P1110A, AP, V, ACC. C. Bid hashtag DAP01010PDA, AP, VD. 0. BISIC AP00000. Q. P0110AAPV, ACC. C bis hashtag DAP01000PDA, AP, VD. 0. 3 BICASI AP00001P0110AAPA, ACC. Big hashtag DAP01001PDAAPAD. Colon equals Ashrap 00000P0011AC, C, O dash, AP:(J). .C. and a slap 00001P0011A, C, plus, AP, plus 0. CLZ 000001010000000. C. CLC 000000100100000 C plus 00. CLA 0000010110000 C plus O. CD. C. 0. CL. Says 000010100100000 Z plus L. 3. SEC 000010100100000 C plus LU. C 0000101010000 Z plus L C plus L. MOVACC, AP1110 P0000 AAP plus dash, ACC. CD MOVAC AX11111000 XAAX plus dash, ACC. 0. C. MOV hashtag DAP01110 PDAAP plus D. MOVAP ACC 11111 P0000 AACC plus dash, AP. 0. MOVAX ACC 1111100 XAACC plus dash, AX. JMP ADRs 1008OAG as a 7 as a 4 a 3 a 2 a, AOPC plus ADRs. C. JMP at AP00000 P1101 APC plus, PC, plus, AP, plus 1. E. JMPO at AP00001 P1101 APC plus, PC, plus, AP, A7H plus 1 :L. BEQ plus N. 000110010 PC plus, PC, plus N plus L, if Z equals L. BZE plus N. N4 N3 N2 N, no. 110. Dash. MSM 5055. Description of instructions, cont. Instruction code. Mnemonic operation. 131211109876543210. BNE plus N. 000110110 PC plus, PC, plus N plus 1, if Z equals O. A. BNZ plus N. NN3 N2 N, no. E. JBCS plus N000110000 NN3 N2 N, no PC plus, PC, plus N plus 1, if C equals 1. BCC plus N000110100 NN3 N2 N, no PC plus, PC, plus N plus 1, if C equals O. Switch app 11010 P0001 AAP plus input port, S1, S4. K switch app 11010 P0010 AAP plus input port, K1, K4. Matrix app 11011 P0010 A output port, M1, M4. 5. Plus dash, AP. 0.9 MATRIXMN 000100010M.M3 M2M, output port, M1 M4. J plus MN, N equals 1, 2, 3, 4. 0. Estbon/off 00010001000 OB, boast out on/off. A. Dash equals free on 000100101 N frequency plus N. Buzzer sound 000100110 B3 B210 mreg plus sound, buzzer start. BSO 00010011000 00 buzzer stop. lamp on slash off 00010000010 OB, bo LD on slash off. DSP digit, AP 00100P digit A digit, low part, plus, AP, ACC. DSPH digit, AP 00101P digit A digit, high part, plus, AP, ACC. Formatop 11011P0011A FMT reg. Plus, AP. A. Format HUN 00010000011N FMT reg. Plus N, J. Is DSPF digit, AP 00110P digit A digit, low part, plus, AP. Via table. DSPFH digit, AP 00111P digit A digit, high part, plus, AP. Via table. Halt 000100000000000 halt. Intonub 000100101101100. 32/16. Enable timer. 0001000100010. Int sab 000100100101100. 32/16. Disable timer. 0001000100001. J. Q. Int modiap 11010P01000AAP plus interrupt mode.s. 0. Pageo 11011001001A preg plus dash, AO. O slash, S. E. Pagan 00010001001 preg plus N. E. Areg plus dash, AP, 0 address app 11011P0110A. L Ederson 00010000110N areg plus N. A. Radeep 11010P1001AAP plus divider, 8 Hz 1 Hz. R straight 000100010001000 divider, 8 Hz 1 Hz, plus dash 0. Backup 000100001B3B200 backup on slash off. On slash off. NOP 000000000000000 no operation. 111. OKI semiconductor. MSM 5056. CMOS 4-bit single-chip very low-power microcontroller with LCD driver. General description. The OKI MSM 5056 is a low-power, high-performance single-chip microcontroller employing complementary metal oxide semiconductor technology. Integrated onto a single chip are a 4-bit ALU, 25K bits of mask programmable ROM, 360 bits of data RAM, crystal oscillator, voltage doubler, timer, LCD driver, input port, output port, and overcharge protection circuit for connection to a solar cell. The MSM 5056 is widely used in electronic products requiring low power operation, for example, solar calculator watches and games. Features: low power consumption 3IJ atypical 42 instructions. 1792x14 internal ROM 1.5V operating voltage. 90x4 internal RAM, the solar cell can be connected. 4. Input port 32.768 kHz crystal oscillator. 4. Output port 122.1 IJS instruction cycle. 4x4 key matrix input, KK, mm, -20 to 75 degrees Celsius operating temperature. 38 LCD driver 68 pad die. 112 duty, 112 bias, 88 segment. Functional block diagram. SD data RAM. A3AO. Segment. LD out. T. Display I. Latch segment. MIN out 38. I driver. Dash dash plus com LM. Com2. Key. I. K. Instruct. TION. Echodia. III1I. VODVS $2 VSC VCM. VSS, VVEP VEN. 112. MSM 5056. Logic symbol chip pad layout. Segment output. Oscillation. ASC, segment. ASL out. ASC3. NPUT port segment. KK4, DUT3s. COM2. Output port buzzer output. MIM4, 80. LD lamp output T. Reset T. VDD. VSS, T. Test power. VSS2T. VT, source. VSCT. VCPT. Adjustment 4. VCM. VN. Solar cell cramp. Voltage. Chip size 5.42 x 4.13 mm. Pin description. Designation function. VDD circuit ground potential. VSS, power source, -1.5 V. VSC solar cell connection terminal. VSS2 power source for LCD driver, -3.0 V. This terminal is connected to VDD terminal through a 0.1 P.F capacitor. V power source for internal logic, -1.5 to -3.0 V. This terminal is connected to VDD terminal through a 0.1 P.F capacitor. VCP, VCM booster capacitor connection terminals. VCP terminal is connected to VCM terminal through a 0.1 P.F capacitor. Input and output terminals of oscillator inverter. XT 32.768 kHz crystal is connected to these terminals. TT5 terminals to test internal logic, T, T3 and T5 are pulled down to VSS. T is output. Test pins must be normally open. AC terminal to clear internal logic pulled down to VSS. After power is turned on, the MSM 5056 must be reset by this terminal. BD buzzer output. LD lamp output. VEN adjustment for solar cell cramp voltage. This terminal is connected to VSS, terminal through 50 to 200 K, 1 resistor. 113. EMSM 5056 E dash 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 dash. Functional description. A block diagram of the MISM SO6 is given on page 111. Each block of logic will be briefly discussed. For more information, please refer to the MISM SO6 User's Manual. Program ROM. The MISM SO6 will address up to 1.7 SK words of internal mask programmable ROM. Each word consists of 14 bits and all instructions are one word. The instructions are routed to a programmed logic array which generates the signals necessary for control of logic. Data RAM. Data is organized in 4-bit nibbles. Internal data RAM consists of 90 nibbles. The RAM is addressed by page address and column address. Normally page address is specified with the page register, but direct addressing is available at page O. Column address is directly addressed by the Operands of various instructions. ALU. The ALU performs 4-bit parallel operation of RAM and AC contents, or RAM contents and an immediate digit. It sets or resets the flags, Z, C, depending on the condition. Program counter, PC. The program counter is an 11-bit wide counter and specifies the address of the program ROM. The PC is incremented by 1 at every execution of an instruction, and then specifies the next instruction to be executed. However, the contents of the PC are rewritten by the execution of a jump or branch instruction. There is no boundary in the ROM, so a jump or branch instruction can be put anywhere in the ROM. Input/output port. Input port, K1, K2. The input port, K1, K4, is a 4-bit parallel input port. Each pin of the port is pulled down to VSS1 by an internal resistor, and the status of the port can be fetched by an input instruction. Output port, M1, M4. The output port, M1, M4, is a 4-bit parallel output port. This port consists of data latches and buffers. The contents of data latches are rewritten by an output instruction. A key matrix is used in combination with K1 to K4. 114 KL $K2 K3 I K4 plus ML M2 M3 M4. Display function. The MISM-SO6 is provided with a segment output terminal which can directly drive a half bias 112 duty LCD and common drive output terminals COM1 and COM2. The segment drive circuit consists of the display data latch, multiplexer and driver. If the data is sent to the display data latch with the display instruction, the LCD drive waveform is output to the segment drive output terminal. Time base. Time base of the CPU is provided by connecting a 32.768 kHz crystal to the OSC1 and OSC3 pin. One machine cycle is 122.1/ls. A hardware divider up to 1 Hz is provided, enabling programs to implement and a clock function by counting signals between 16 and 1 Hz. Solar cell overcharge protection circuit. When a solar cell is connected to prolong the useful life of the battery, a resistor is inserted between the VEN pin and VSS1 to adjust the overcharge protection voltage. --1 VSS --AI.FIRI VEN MSMS 056 --MSM 5056. Absolute maximum ratings. Parameter symbol conditions limits unit. Supply voltage 1 V VSS, Ta equals 25 degrees Celsius minus 0.3 to plus 3.0 V. Supply voltage 2 V VSC Ta equals 25 degrees Celsius minus 0.3 to plus 3.5 V. Supply voltage 3 V VSS2 Ta equals 25 degrees Celsius minus 0.3 to plus 6.0 V. Supply voltage 4 V Ta equals 25 degrees Celsius minus 0.3 to plus 6.0 V. Input voltage VEN, Ta equals 25 degrees Celsius VSS, minus 0.3 to plus 0.3 V. Storage temperature TSTG minus 55 to 125 degrees Celsius. Operating conditions. Parameter symbol limits unit. Operating voltage VSS, 1.25 to 1.65 V. Operating temperature top here -20 to 75 degrees Celsius. DC characteristics. VU equals OV, VSSV equals -1.55 V, VSS2 equals -3.0 V, CI equals 30 knots, CG equals 30 pf, Ta equals 25 degrees Celsius. Limits. Parameter symbol condition unit. Min. Tip. Max. Operating voltage 1 VSS, VSS, terminal 1.25 1.55 2.0 V. Operating voltage 2 VSC VSC terminal 0 2.0 3.0 V. Power supply current 100 VSS, terminal, 3.0/LA. Oscillation start. VOSC. Within 10 seconds. Voltage VSS, terminal. 1.45, V. IOH, VOH, equals -0.2 V minus 4. Output current 1. 10 M, YOM, equals VSS, plus or minus 0.2 V4/-4/LA. COM. IOL, vol, equals -2.8 V4. Output current 2 IOH2 VOH2 equals -0.2 V minus 0.4. Segment. IOL2 vol2 equals -2.8 V 0.4/LA. Output current 3 IOH3 VSSV -1.25 V IVOH3 minus 0.4 V minus 100 mm. IOL3 VSS2 -2.3 V IVOL3 -0.85 V 38/LA. Output current 4 IOH. VOH equals -0.4 V minus 50 minus 100 minus 200. So. IOL. Vol equals -1.15 V 31030/LA. Input current IIH, VEN equals OV 51015. KK. IL, VEN equals -1.55 V minus 0.2/LA. Oscillator built-in. Co-20 PF capacitor. Solar battery cramp. RIN. VSS, equals -1.8 V. Resistor VEN terminal 50. 200 knots. 115. MSM 5056, -. Measuring circuit. Typical application. LCD. K1 COM2 segment COM1. K2. K3. K4. M4. M3. MSM 5056. M2. M1. BD. LD. VDD. VSG. VEN. AC. 30 PF. O.LJ1F. 32.768 kHz. TR2. CG, 535 PF. CL, C2, C3, O.LJ1F. TR1 TR2, HFA 200. TR2, VCEO 35V. LL, 2030 mH. B, 1.5V. __4 R, 5200 knots. 116. __E. MSM 5056. Description of instructions. Instruction code. Mnemonic operation. 131211109876543210. Add ACC, AP00000P0100AAP, AP, plus, ACC. Add hashtag DAP01100PDAAP- AP, D. Add cap 00000P0101AAP, decimal adjust. AP, plus, ACE, plus, E, L. C sub ACC, AP00001P01000 AP, ACC. 0. Q. Sub hashtag D, AP01101PDA AP AP, D. C. SPAP 00001P0101 AAP, decimal adjust 0.2, AP, ACC, E, L. Chi. ECMP ACC, AP00001P1110A, AP, ACC. 5. CMP hashtag D, AP01011PDA, AP, D. INCAP 01100P0001 AAP dash, AP, plus 1. DEC AP01101P00012. A dash, AP, dash 1. X or ACC, AP00000P0111 AAP, AP, V dash, ACC. X or hashtag DAP01111PDAAP dash, AP, VD. Bit ACC, AP00000P1110A, AP, V, ACC. C bit hashtag D, AP01010PDA, AP, VD. 0. BISIC, AP00000P0110AAP, AP, V, ACC. AP dash, AP, VDC. BIS hashtag D, AP01000PDA. 0. Co. BICA C, AP00001P0110AAP, AP, A, ACC. BIC hashtag D, AP01001PDAAP dash, AP, AD. Ashrap 00000P0011AL, C, 0, AP, equals J. Dot T. ASLAP00001P0011A, C, dash, AP, O, F. CLZ00000101000000000. CCLC000000010000000CO. 0. CLA000000010100000ZOCO. C. Says 000010100100000Z10. CL. TTLSEC000010010000000C1U. C00001010100100000Z1C1. MUVASI AP111110P0000AAP dash, ACC. MUVASI AX11111000XAAX dash, AEC. MOV hashtag DAP01110PDAAPDUI. C. MUVAP ACC111111P0000AACC dash, AP. TTL MUVAX ACC11111000XAACC dash, AX. 2. C. CHGAP 111000P0000A, ACE, dash, AP. CHGAX 111000XA, AEC, dash, AX. 117. EMSM 5056E dash 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 dash. Description of instructions co-nt. Instruction code. Mnemonic operation. 131211109876543210. JMP ADRs 100810 AG as a 7 a 6 a 5 a 3 a 2 a, AOPC ADRs. JMP at AP00000P1101 APC, PC, plus, AP, plus 1. JMPO at AP00001P1101 APC, PC, plus, AP, /7H plus 1. BEQ plus N. 000110010 PC, PC, plus N plus 1, if Z equals 1. BZE plus N. NN3 N2 N, no. BNE plus N. 000110110 PC, PC, plus N plus 1, if Z equals 00. BNZ. NN3 N2 N, no. E plus N. BCS plus N. BLT plus N. 000110001 NN3 N2 N, no PC, PC, plus N plus 1, if C equals 1. BCC plus N. 000110101 PC, PC, plus N plus 1, if C equals 0. BGE plus N. NN3 N2 N, no. BGT plus N 000110111 NN3 N2 N, no PC, PC, plus N plus 1, if Z equals 0. And C equals 0. BLE plus N 000110011 NN3 N2 N, no PC. PC, plus N plus 1, if Z equals 1. Or C equals 1. INP port, AP11010P port AAP, port. -0. Out AP, port 11011P port A port, AP. 0. C. -0 out #D, port 000100 port D port, D. DSP digit, AP00100P digit A digit, AP, ACC. C. DSPF digit, AP00110P digit A digit, AP, via table is. E halt 001000000000000 halt CPU. Colon. ACNOP 000000000000000 no operation. 08. 118. OKI. Semiconductor. MSM 6051. CMOS 4-bit high-performance single-chip very low power. Microcontroller with LCD driver. General description. OKI's MSM 6051 is a low-power and high-performance single-chip microcontroller employing complementary metal oxide semiconductor technology. Integrated onto a single chip are a 4-bit ALU, 35K bits of mask programmable ROM, 480 bits of data RAM, crystal oscillator, voltage doubler, timer, LCD driver, input port, and output port. The MSM 6051 is widely used in electronic products requiring low power operation, for example, stopwatches with lap time memory, calculator WC, CHIS and handy terminals. Features: low power consumption 3 ILA typical. 2560 x 14 internal ROM. 120 x 4 internal RAM. 9 input port. 4 output port. 4x4 key matrix input, K1 K4, M1 M4. 66 LCD driver, including 3 common. 1/3 duty, 1/3 bias, 189 segment. Functional block diagram. LD. M1. 1. M4. Low. K. I. K. S. Option. 59 instructions. 1.5 V or 3 V operating voltage. Masking option. 32.768 kHz crystal oscillator. 91.5/1s instruction cycle. -20 to 75 degrees Celsius operating temperature. 101 pad die. Data RAM. 120 word x 4-bit. Segment. Done. / segment. Cut 66. Program 256 word x 1 4-bit. VSST VSS3 VCP. I1JJJJI. Instruct. TION. Decoder. VU VSS2 VVCM. IIJ. ACTTT2 T3 T4 T5 32 Hz. 119. MSM 6051-. Logic symbol chip pad layout. Oscillation. Input port. S1-84. Input port. R. K1 K4, L. Option input. Output port. R. M1 M4, L. Load. Segment down. Segment. Out 6S. BD. LD. Buzzer output. Lamp output. Clock pulse. Output. Reset. Test. Segment output. Chip size 5.85 x 4.10 mm. Pin description. Designation function. VDD circuit ground potential. VSS, power source, -1.5 V. VSS2 power source for LCD driver, -3.0 V. This terminal is connected to VDD terminal through a 0.1 JTF capacitor. VSS3 power source for LCD driver, -4.5 V. This terminal is connected to VDD terminal through a 0.1 JTF capacitor. V power source for internal logic, -1.5 to -3.0 V. This terminal is connected to VDD terminal through a 0.1/IF capacitor. VCP, VCM booster capacitor connection terminals. VCP terminal is connected to VCM terminal through a 0.1 JTF capacitor. XT. Input and output terminals of oscillator inverter. 32.768 kHz crystal is connected to these terminals. TT5 terminals to test internal logic, T1, T3 and T5 are pulled down to .VSS. T4 is output. Test pins must be normally open. AC terminal to clear internal logic pulled down to VSS. After power is turned on, the MSM 6051 must be reset by this terminal. BD buzzer output. LD lamp output. Low load data terminal of M1 to M4. AC2 reset terminal for external circuit. Stout clock output for external circuit. 120. EEMSM 6051A. Functional description. A block diagram of the MSM 6051 is given on page 118. Each block of logic will be briefly discussed. For more information, please refer to the MSM 6051 User's Manual. Program ROM. The MSM 6051 addresses up to 2.5K words of internal mask programmable ROM. Each word consists of 14 bits, and all instructions are one word. The instructions are routed to a programmed logic array which generates the signals necessary for control of logic. Data RAM. Data is organized in 4-bit nibbles. Internal data RAM consists of 120 nibbles. The RAM is addressed by page address and Column address. Normally page address is specified the with page register, but direct addressing is available at page O. Column address is directly addressed by operand of various instructions. ALU. The ALU performs 4-bit parallel operation of RAM and ACC contents, or RAM contents and an immediate digit. It sets or resets the flags, Z, C, G, depending on the condition. Program counter, PC. The program counter is 12 bits wide and specifies the address of the program ROM. The PC is incremented by 1 at every execution of the instruction, and then specifies the next instruction to be executed. However, the contents of the PC are rewritten by the execution of a jump, call or branch instruction. There is no boundary in the ROM, so a jump or branch instruction can be put anywhere in the ROM stack. The MSM6051 has a 3-level stack apart from data RAM. The contents of the PC are loaded into the stack when a call instruction is executed or an interrupt is generated. Input/output port. Input port, SL, S4. The input port, S1, S4, is a 4-bit parallel input port. Each pin of the port is pulled down to VSS by an internal resistor, and the status of the port is fetched by a switch instruction. Input port, K1, K4. The input port, K1, K4, is a 4-bit parallel input port. Each pin of the port is pulled down to VSS1 by an internal resistor, and the status of the port is fetched by a K-switch instruction. Input port, OPIN. The input port, OPIN, is single input port. OPIN is pulled down to VSS by an internal power save circuit, and the status of the port is fetched by an input instruction. Output port, M1, M4. The output port, M1, M4, is a 4-bit parallel output port. This port consists of data latches and buffers, and the contents of data latches are rewritten by a matrix instruction. Display function. The MSM6051 is provided with the segment output terminal, which can directly drive a 1/3 bias, 1/3 duty LCD, and the common drive output terminals COM1, COM2, and COM3. The segment drive circuit consists of the display data latch, multiplexer, and driver. If the data is sent to the display data latch with the display instruction, the LCD drive waveform is output to the segment drive output terminal. Time base. The time base of the CPU is provided by connecting 32.768 kHz crystal to the XT and XT pin. One machine cycle is 91.5 s. A hardware divider up to 1 Hz is provided, enabling programs to implement a clock function by counting signals between 32 and 1 Hz. Also, a 1/100 second digit counting function is provided as a hardware feature to make for easy implementation of a stopwatch function. 121. MSM6051-. Absolute maximum ratings. Parameter symbol conditions limits unit. Supply voltage 1 V VSSL Ta equals 25 degrees C minus 2.0 to plus 0.3 V. Supply voltage 2 V VSS2 Ta equals 25 degrees Celsius minus 4.0 to plus 0.3 V. Supply voltage 3 V VSS 3 Ta equals 25 degrees C minus 6.0 to plus 0.3 V. Supply voltage 4 V Ta equals 25 degrees Celsius minus 4.0 to plus 0.3 V. Input voltage VINL Ta equals 25 degrees C VSSL minus 0.3 to plus 0.3 V. Storage temperature TSTG minus 55 to 125 degrees Celsius. Operating conditions. Parameter symbol limits unit. Operating voltage VSSL 1.25 to 1.65 V. Operating temperature top air -20 to 75 degrees Celsius. DC characteristics. VU equals OV, VSS1, V equals -1.55 V, VSS2 equals -3.0 V, VSS3 equals -4.5 V, CI equals 30 kLL, Ta equals 25 degrees Celsius. Limits. Parameter symbol conditions unit. Min. Tip. Max. Power supply current 100 VSS terminal, 3.0/JA. Oscillation start within 5 seconds 1.45 V. Voltage VOSC VSSL terminal. IOHL VOHL equals -0.2 V minus 4. Output current 1 IOMHL VOMHL equals VSSL plus or minus 0.2. 4/-4/JA. COM. IOMLL VOML1 equals VSS2 plus or minus 0.24/-4. LOL equals -4.3 V4. IOH2 VOH2 equals -0.2 V minus 4. Output current 2 IOMH2 VOMH2 equals VSS1 plus or minus 0.2. 4/-4. Segment. IOML2 VOML2 equals VSS2 plus or minus 0.24/-4. /JA. IOL2 Vol2 equals -4.3 V4. Output current 3 IOH3 VOH3 equals -0.5 V. -10. /JAAC2 load stout. IOL3 Vol3 equals -1.15 V10. Output current 4 IOH4 VOH4 equals -0.5 V. -100. MLM4. IOL4 Vol4 equals -1.0 V210. /JA. Output current 5 IOHs VOHs equals -0.55 V VSSL equals -1.25 V minus 12.5 minus 25 minus 83. Low V equals -2.0 V/JA. IOLs vols equals -0.85 V VSS2 equals -2.0 V1. Output current 6 IOHA VOHA equals -0.55 V VSSL equals -1.25 V minus 17 minus 30 minus 62. So V equals -2.0 V/JA. Lola vol equals -0.85 V VSS2 equals -2.0 V, 5. 122. MSM 6051. Parameter 8 Imbal conditions. Input current 1 IIHI VIH equals OV. 8-8. IILI VIL equals -1.55 V. Input current 2 IIH2 VIH2 equals OV. KK. IIL2 VIL2 equals -1.55 V. Input current 3 IIH3 VIH3 equals OV. OPIN. IIL3 VIL3 equals -1.55 V. Oscillator built-in. CD capacitance. Measuring circuit. VCP. C4. VCM. XT. VXT. C5. Typical application. LCD. 81-. COM1 to COM3. 82. 81. 82 LD, 83 83, 84 84, BD, M8 M60 51, V88T, XTAL, XT, IJ, CD equals 20 PF, VDD, C1, limits, unit, min, tip, max, 220-100, minus 0.2, PA, 513-26, minus 0.2, PA, 3045, minus 0.2, PA, 20, PF, C1.C2.C3.C40.L/LF, C530 PF, XTAL 32.768 kHz, C1, C2 TOC5, B, L, 5 to 35 PF, O.L/LF, 1.5 B, 20 mH, lamp, B, 123, MSM 6051-. Description of instructions. Instruction code. Mnemonic operation. 131211109876543210. Add ACC, AP0000P0100AAP, AP, plus, ACC. Add hashtag DAP01100PDAAP- AP, plus D. Add cap 00000P0101AAP, decimal adjust. AP, plus dot, ACC, plus, C, L. Add knap 11000PNAAP, N adjust, AP, plus, CLL. Sub ACC AP00001P0100AAP, AP, ACC. C. Sub hashtag DAP01101PDAAP- AP, D. 0. SPDAP 00001P0101AAP, decimal adjust. QJHAP, ACC, C, L. A. 0 SPNAP 11001PNAAP and adjust, AP, C, L. Dot. Back AP00001P1110A, AP, ACC. E. CMP hashtag DAP01011PDA, AP, D. In cap 11100P0000AAP, AP, plus 1. In CAX 1110000XAAX-AX, plus 1. Decap 11101P0000AAP, AP, dash 1. Dec AX 1110100XAAX-AX, dash 1. Cora CAP 00000P0111AAP, AP, V, ACC. X or hashtag DAP01111PDAAP, AP, VD. Bit ACC AP00000P1110A, AP, V, ACC. C bit hashtag DAP01010PDA, AP, VD. 0. BISIC AP00000P0110A, AP, V, ACC. QJ. A. BIS hashtag DAP01000PDA, AP, VD0. I11 BIC ACC, AP00001P0110A, AP, ACC. BIC hashtag DAP01001PDA, AP, D. RARAP 00000P0010AL. C, AP, --J. C. PAL, C, AP, JN rollup 0000100010. L. C, 0, AP, dot JI Ashrap 00000P0011A. 0. C, dash, AP, OA, ASLAP 00001P0011A. CLZ 0000010100000ZO. CCLC 000000010000000CO. 0. CLG 000001000000000GO. QJ. A. CLA 00000001011000000Z-0, C-0, GO0. OLS. Says 000101010000000Z1 SEC 000010010000000C1. 124. MSM 6051. Description of instructions, cont. Instruction code. Mnemonic operation. 131211109876543210. Seg 000010100000000G1. C 000010101100000Z1 C1G1. MOVASI AP 11110P0000AAP-ACC. S1 MOVASI AX 1111000XAAX-ACC. MOV hashtag DAP011110PDAAPD. S MOVAP ACC 11111P0000AACC-AP. CL. MOVAX ACC 111111000XAACC-AX. Call ADRs 1011 and 98 a 7 a 6 a 5 a a 2 a, AO stack, PC, PC ADRs. Q, RET 000000110000000 PC, stack, +1. S. PC, stack, +1, or 0.0. LLPC dash, stack, CL, E. RTI 00000101100000000 ACC, Z. Z, CC. GG, Preg. Preg. JMP ADRs 10 a low a 9 a 8 a 7 a 6 a 5 a a 2 a, AOPC ADRs. JMP at AP 00000P1101 APC, PC, plus, AP, +1. JMPO at AP 00001P1101 APC, PC, plus, AP, 27H +1. BEQ plus N. 000110010 PC, PC, plus N plus 1, if Z equals 1. BZE plus N. NNAN2N, no. BEQN. 000111010 PC, PC, N, if Z equals 1. BZEN. NNAN2N, no. BNE plus N. 000110110 PC, PC, plus N plus 1, if Z equals O. BNZ plus N. NNAN2N, no. BNEN. 000111110 PC, PC, N, if Z equals O. BNZN. NNAN2N, no. BCS plus N 00011. A. 0000NNAN2N, no PC, PC, plus N plus 1, if C equals 1. EBCSN0001110000. NNAN2N, no PC, PC, N, if C equals 1L. Dash. BCC plus N0001101000 NNAN2N, no PC, PC, plus N plus 1, if C equals O. BCC N0001111000 NNAN2N, no PC, PC, N, if C equals O. BGT plus N0001100001 NNAN2N, no PC, PC, plus N plus 1, if G equals 1. BGT N0001110001 NNAN2N, no PC, PC, N, if G equals L. BLE plus N0001101001 NNAN2N, no PC, PC, plus N plus 1, if G equals O. BLE N00011101 NNAN2N, no PC, PC, N, if G equals O. BGE plus N0001100011 NNAN2N, no F equals C, PC, plus N plus 1, if Z equals 1 or G equals. BGE N00011101 NNAN2N, no PC, PC, N, if Z equals 1 or G equals 1. BLT plus N00011011 NNAN2N, no PC, PC, plus N plus 1, if Z equals O. And G equals O. BLT N00011111 NNAN2N, no PC, PC, N, if Z equals O and G equals O. iSwitch app 11010. P0001 AAP input port, S1 S4. 0. AP input port, K1 K4, dash equals 0 K switch AP 11010 P0010A. 125. MSM 6051, dash. Description of instructions, co-nt. Instruction code. Mnemonic operation. 131211109876543210. Matrix app 11011 P0010A output port, M1 M4. AP. Matrix MN0001000010 M.M3 M2 M, output port, M1 M4. S. MN, N equals L, 2, 3, 4. A. S-spawn / off 0001001000000 OB, boast out on / off. 0. Pitch N0001001100 N pit reg N. S. A. MSI address 10101 stack, PC, PC, ADRs, .S as a 7 a 6 as a 3 a 2 a, AO. Melody start. MSO00010010100000 melody stop. Lamp on / off 00010000010 OB, Bo LD on / off. DSP digit, AP00100 P digit A digit, low part, AP, ACC. DSPH digit, AP00101 P digit A digit, high part, AP, ACC. Format AP11011 P0011 AFMT reg. AP 0. RN format N0001000011 NFM treg N. 0. DSPF digit, AP00110 P digit A digit, low part, AP, via table. DSPFH digit, AP00111 P digit A digit, high part, AP, via table. Halt 000100000000000 halt. Intinub 000 10010111100 32/16/2 00010001000B30B 0. Enable timer interrupt. Int sab 0001001010100 32/16/2 00010001000B20 BO. Disable timer interrupt. Activate 000100100100000 activate main routine. Int modiap 11010p01000 AAP interrupt mode. RN Q Canub 0001000111100 enable input port K1 K4. .R KZAB 0001000111010 disable input port K1 K4. 5. CD status app 11010p1010 AAP status E. Pageo 11011001001 preg dash AO E 0. Pagan 00010000101 N preg N J C. Address app 11011p0110 A. Areg API. Ederson 00010001110 N Areg N. Radeep 11010p1001 AAP, divider, 8 Hz 1 Hz. R straight 000100010001000 divider, 8 Hz 1 Hz, O. Flagon app 11010p1110 AAP SL on flag, S2 on flag. SLRATEAP 11010p1100 AAP SL reg. S2 rate AP 11010p1101 AAP S2 reg. Backup 000000001B3B200 backup on/off. On/off. NOP 000000000000000 no operation. 126. OKI semiconductor. MSM 6351. CMOS 4-bit high performance and very low power single chip. Microcontroller with LCD driver. General description. OKI's MSM 6351 is a low power, high performance single chip microcontroller employing silicon gate CMOS technology. Integrated onto a single chip are 4-bit ALU, 61K bits of mask programmable ROM, 4096 bits of RAM, 20 bits of I/O port, serial I/O port, time base counter, LCD driver, 3 interrupts, crystal oscillator and voltage tripler. The MSM 6351 is widely used in electronic products requiring low power consumption, a large number of L.CD drivers and a large size of memory. Features: low power consumption 3i1 atypical, 4096x15 internal ROM, 1024x4 internal RAM, 20 input/output ports, 62 LCD drivers, 1/3 duty, 1/3 bias, or 1/4 duty, 1/3 bias. Selectable by software. Serial I/O port. 8 bits or 5 bits data frame mode. Asynchronous. Receiver/transmitter mode. Internal or external clock mode. 15 stages time base counter. Watchdog timer. Capture function by external trigger signal. 3 interrupt sources. Real-time interrupt. External interrupt. Serial I/O port interrupt. Melody circuit. 65 instructions. Subroutine nesting, 7 levels. 32.768 kHz crystal oscillator. Machine cycle, 61.0 I1 SEC. Power supply, 1.5 V or 3.0 V, selectable by mask option. 100 pad die or 100 pin flat package. Silicon gate CMOS process. 127. MSM 6351. Functional block diagram. Logic symbol. Porto. CPO.D. PO.L. PO.2. PO.3. PORTLC. P1.D. P1. P1.2. P1.3. P2.0. Port 2 CP2.1 P2.2. P2.3. Port 3. CP. P3.1. P3.2. P3.3. PQRT4. CP4.0 underscore. P4. P4.2. P43. Clock out stout. VDD. Dash LTL colon, OI. XT. She. Reset. Test C. Equals TESTL. Test 2. Test 3. 128. Sin equals. J. Serial port, SOUT. SCK. Bow buzzer. Driver. CAO. Seg1. Seg2. Seg3. Seg4. LCD. Driver. Seg58. Seg59. Seg60. Seg6L. VU. VSSL. VSS2. L. Power. VSS3 supply. VJ. VCM. VCP. SEGO. SEGI. SEG2. SEGJ. ISI. VSS2. VSS3 equals dash. MSM 6351. Pin description. Designation function. PO.O. Capture. 4-bit I/O port 0. Trigger signal. PO.1 the input, /output, the existence, /. absence of pull-down resistance, and the PO.2 halt function release enable /disable. Condition can be selected for each bit. PO.3. P1.0, P1.3 port 1 4-bit I/O port 1. P2.0. The input, */output, the P2.1 existence, */absence of. External port 2. 4-bit I/O port 2 pull-down resistance, and interrupt signal. P2.2 the halt function. Release enable /disable. P2.3 condition can be selected for each bit. P3.0, P3.3 port 3 4-bit I/O port 3. P4.0, P4.3 port 4 4-bit I/O port 4. Stout. Oscillator clock output. The oscillator clock is output when XTF, 4th bit of port POOC, is set to 1. XT. Oscillator connection terminal. XT. Reset. Reset input. Input with a pull-down resistance, the system is reset when 1 is input. Test 1. Test 2. Test input. Input with a pull-down resistance. Generally used when the resistance is open. Test 3. SIN circuit configuration. Serial port data input. South. The circuit is set at high impedance level when 1 is set to Hs out, the fourth bit of port P4XC, or when no data is transmitted. Serial port clock input and output. The input and output, asterisk, are switched from each other. The serial port control SCK register SCNT. In the output mode, the serial clock frequency can be selected from the demultiplied signal, 1/1, 1/2 or 1/4 of the original base clock. See Note 1L. BD melody output, buzzer drive output, not available in the MSM6353. LCD drive output. SIGO. LCD drive output with the 1/3 bias, or the 1/3 or 1/4 dusty system. SEG61. He duty can be switched by LCD control register LCD-CNT. A maximum of 177 segments can be displayed with the 1/3 duty and 232 with the 1/4 duty. 129. EMSM6351E. Designation function. VDDEOV power supply terminal. VSS1-1.5V power terminal, for the 1.5V specification. VSS2-3.0V power terminal, for the 3.0V specification. VSS3-4.5V power terminal, not available in the MSM6353. V. Internal logic power terminal. VCM. Internal power generator capacitor connecting terminal. VCP. Note 1. The base clock refers to an oscillator output signal demultiplied into 1/1, 1/2, 1/4, or 1/8 of the output frequency, with the masking option. 130. Dash 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 EMSM6351E. Functional description. A block diagram of MSM6351 is given on page 128. Each block of logic will be briefly discussed. For further information, please refer to MSM6351/53 User's Manual. Programmable ROM. The programmable ROM has a capacity of 4096 words, each of which is 15 bits long. It is provided with the address space of 000 to FFFH. In the MSM6351, the programmable ROM is not only used for programming but also used to save the following items. 1. LCD indicator segment conversion table. 2. Melody tone data. The program instructions are all MDE up of 1 word. Thus the ROM can save up to 4096 instructions in it. Data RAM. The data RAM has a capacity of 1024 words, each consisting of 4 bits. It is provided with the space for address between 0 and 3 FFH. Data is organized in 4-bit nibble. Page register, page. The page register specifies one of 16 pages in each bank of the data RAM. It is used in the addressing bank mode or in the paging mode. Bank register, bank. The bank register specifies one of 4 banks in the data RAM. It is used together with the page register in the bank paging mode. Working specification register. The working specification register specifies one of 16 pages in bank 0 of the data RAM. It is used in the addressed working specification mode. Operational section. The operational section consists of the ALU, accumulator, ACC, and conditional flags C, Z, and G. This operational section performs 4-bit computation of the contents of the data RAM with the contents of ACC or the immediate data fetched into the instruction words. This computation is mainly performed with the data RAM, which functions as a register. The resultant data of the computation are input to the data RAM or to ACC for operation other than comparison. Program counter, PC. The program counter, PC, generates addresses for the programmable ROM. The addresses for programming are changed according to the instructions executed. These addresses are incremented by 1 each time the instruction is executed. When an interrupt is generated, the current address is stored in the stack. The address is set to 400H, 401H, or 402H depending on the type of the interrupt, see Fig 3.5.1. These addresses are set to the start addresses of each interrupt routine. In the MSM 6351, the PC also gives LCD indica, TOR segment conversion table or melody tone data addresses to the programmable ROM. The output data of the programmable ROM, whose address is specified by the PC, is fetched into the instruction register, or if the output data is an instruction, it is decoded by the instruction decoder. Then, control signals to each section are generated. Ports. The MSM 6351/6353 handle the I/O ports, flags, and registers collectively as ports. Therefore, each of the I/O ports, flags, and registers are selected by specifying their own addresses. All of these ports are accessed by the INP and OUT instructions. 131. MSM1- Port names, addresses, and their contents. Port name address bit 3 bit 2 bit 1 bit 0 access mode, asterisk. Port 000 po.3 po.2 po.1 po.or/w. Port 101 p1.3 p1.2 p1.1 p1.0 r/w. Port 202 p2.3 p2.2 p2.1 p2.0 r/w. Port 303 p3.3 p3.2 p3.1 p3.0 r/w. Port 404 p4.3 p4.2 p4.1 p4.0 r/w. POOC05XTF300HZ00 DIRU r/w. P01C06 buff HRE01 Hz 01 DIR01 r/w. P02C07 HRE02 Hz 02 DIR02 r/w. P03C08 HRE03 Hz 03 DIR03 r/w. P1XC09 HRE1X Hz 1X DIR1X r/w. P2XC0AH South HRE2X Hz 2X DIR2X r/w. P3XCOBIGO HRE3X Hz 3X DIR3X r/w. P4XCOC5/8 HRE4X Hz 4X DIR4X r/w. SBFOD L1D3 D2 DL2 r/w. U D7 D6 DSD4 SCNTOECLKSL1 case low mode LSB/MSB r/w. Bit SCND of CO and STP area NRC enter 3 and 2 R 1 and 0 r/w. IROX10 IROP22 IROP21 IROP20 R EIRT11 EI 256 Hz EI 32 Hz EI 16 Hz EI 1 Hz R/W IRAT 12 IR 0256 Hz IR 032 Hz IR 016 Hz IR 01 Hz R EXMO 13 EIP 20L/EOP/NO R/W IEXM 114 EIP 21L/E1P/N1 R/W IEXM 215 EIP 22L/E2P/N2 R/W TMT 16 15th 14th 13th 12th R %% R 32 Hz 64 Hz 128 Hz 256 Hz Caprite 17 Capmt Cap 1 FK POF BIDI 2 R/W Other bits R Flag 18 Mistart GZC BIDI 3 R Other bits R/W WDOG 19 W03 W02 WOIWU R/W WI3 WI2 WIO FRAMP 1AF F25FO R/W LCDCT1BAE on DRTY 3/4 FLM1 FLMO R/W 132 EMSM 6351E Port names, addresses, and their contents, continued. Port name address bit 3 bit 2 bit 1 BITO access mode, asterisk. Tempo 1 CP3 P2P. PO R/W. Bank 10 B3 B2B, BO R/W. Page 1 EP3 P, PO R/W. Work 1 FW2 W2W, WO R/W. Note, in access mode, asterisk, R denotes readable bits and W writable bits. Bits marked with denote bits which are not present. I/O ports. The MSM 6351/6353 are provided with 5 ports, port 0 to port 4. Each port consists of 4 bits. Ports are controlled by the I/O port control register. The register controls port 1 to port 4. Port by port and controls port 0 in bit units. Each port is accessed by the OUT and INP. Instruction. Time base counter. The MSM 6351/6353 have their built-in time base counters consisting of a 15-stage binary counter. System base clock CPO is input to the time base counter clock. Capture circuit. The MSM 6351/6353 are provided with a cap tour function that fetches the 1 kHz to 128 Hz outputs at stages 5 to 8 of the time base counter, or the 256 Hz to 32 Hz outputs at stages 7 to 10. When PO.0 or PO.1 of I/O port 0 is set at the H level. Watchdog timer. The MSM 6351/6353 have their built-in watchdog timer to prevent any program runaway occur. Rents. The time may be set with 2 types of set. Ting time, 250 milliseconds and 2s_. Serial port, serial I/O. The MSM 6351/6353 have their built-in serial port. It is used for asynchronous data communications. A data length of 5 or 8 bits can be selected. Either internal or external clock can be selected as the driving clock. At the end of data transfer, a serial port interrupt can be generated. The serial port registers and their functions are described in the following sections. Melody output circuit, built in the MSM 6351. Memory. The melody output circuit automatically outputs melody or buzzer sound. It is built in the MSM6351. The melody circuit initiates its operation by the MSA instruction, automatically fetching the musical note data defined in the program ROM. The MSA instruction outputs the melody from buzzer driving output terminal BO. Liquid crystal display circuit, LCD driver. The MSM6351 has its built-in liquid crystal display circuit that can drive the liquid crystal LCD. The liquid crystal display consists of the display data register for writing the data to indicate, and the display driver. After data is written in the display data register with an display instruction, the display driver automatically fetches data from the display data register to output the driving waveform. Interruption controller, interrupt control. There are 4 types of interruptions as follows. 1. Real-time interruption, interruption with the time base counter output. 2. External interruption, interruption from port 2. 3. Serial port interruption, interruption by terminating serial port data transfer. 4. Melody interruption, interruption by requesting melody data, not available in the MSM6353. 133. EMSM6351E. Absolute maximum rating, target specification. VDD equals OV, VSS2 equals battery voltage. Parameter symbol conditions limits unit. Supply voltage VDD-6.0 plus 0.3 V. Input voltage VEN VSS2-0.3 plus 0.3 V. Ta equals 25 degrees Celsius. Output voltage V01 VSS2-0.3 plus 0.3 V. Output voltage V02-6.0 plus 0.3 V. Storage temperature TSTG-55 plus 125 degrees C. 1 normal output. 2 when LCD driver in use. Operating condition, target specification. Parameter symbol limits units. Operating voltage VSS2 2.63.3 V. Operating temperature top here -20 to 60 degrees Celsius. 134. Dash 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 EMSM6351E. DC characteristics 3V Li battery, target specification. VU equals OV, VSS1 equals -1.5 V, VSS2 equals -3.0 V, VSS3 equals -4.5 V, F equals 32,768 Hz, Ta equals 25 degrees C asterisk. Rating terminal. Parameter symbol conditions unit. Applied. Min. Tip. Max. Current consumption 100*3, 3.0/LA. Voltage for oscilla. VOSC within 2 seconds. 2.4 V start. IOH1 VOH1 equals -0.2 V4. Output CURrent 1 EMIT 11 VOMH1 equals VSS1 plus or minus 0.2 V4. /LAC Go, 661. Common segment, 20 ml11 VOML1 equals VSS2 plus or minus 0.2 V4. 10 L1 Vol1 equals -4.3 V4. Asterisk 2. IOH2 VOH2 equals -0.5 V500, port 4. Output current 2/LA SOUT, SCLK. IOL2 vol2 equals dash 2.5 v500, stout. Ion 3. Von4 equals 0.5 v. 7. VSS2 equals 3.0 v. Output current 3/LA so. IOL3. Von4 equals dash 2.5 v. 20. VSS2 equals 3.0 v. Ven1 equals OV. Input current 1 II and 1 IO input, 150 300 600/LA port 4. With pull down. Ven2 equals OV, dash 3V. Port 4. Input current 2 11121 IO input, 1/LA. Sin, SCLK without pull down. Input current 3 IIH3 VIH3. Equals OV. 25/LA reset. With pull down. VIH, 0.5. All input. Input voltage V. Terminals. VIH 2.5. *1. When 3V battery with Haver is used. *2. Port O equals PO.O, PO.3, port 1 equals P1.0, P1.3, port 2 equals P2.0, P2.3, port 3 equals P3.0, P3.3. Port 4 equals P4.0, P4.3. *3. This value changes depending on the soft duty, halt to halt. 135. CJ. Instruction list. Mnemonic. Add ACC, reg 1. Add #I, reg 1. ADC reg 1. ADCN reg 1. Sub ACC, reg 1. C. Sub #I, reg 10. U. SBC reg 1. C. SBCN reg 1. C. 0. CMPACC, reg 1F. C. CMP3, reg 10. OMC reg 1. INCD reg 2. DEC reg 1. DECD reg 2. Bit ACC, reg 1. C. 0 bit 3, reg 1. U. BIS ACC, reg 1. Equals. BIS 3, reg 1C. 0. BIC ACC, reg 1F. C0. BIC number 1, reg 1. Co. X or ACC, reg 1. X or 3, reg 1. 14. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 1. 0. 1. 0. 0. 0. 0. 0. 0. 0. 0. 13 12 11 10 9. 0 0 0 0 0. 0 1 1 0 0. 0 0 0 0 0. 1 1 0 0 0. 0 0 0 0 1. 0 1 1 0 1. 0 0 0 0 1. 1 1 0 0 1. 0 0 0 0 1. 0 1 0 1 1. 0 0 0 0 0. 0 0 0 B, BO. 0 0 0 0 1. 0 0 1 B, BO. 0 0 0 0 0. 0 1 0 1 0. 0 0 0 0 0. 0 1 0 0 0. 0 0 0 0 1. 0 1 0 0 1. 0 0 0 0 0. 0 1 1 1 1. Instruction code. 87I65I4. P0100. IO. P0101. PN, no. P0100. IO. P0101. PN, no. P1110. IO. P0001. 0P, PO. P0001. 0P, PIPO. P1110. IO. P0110. IO. P0110. IO. P0111. IO. 3I2I10. R0. 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 Description. RP, ACC, Z, C. RP, plus, ACC. RP, ACC, Z, C, RP, plus I. RP, ACC, Z, C, decimal adjective, RP, plus, ACC, plus, C, L. RP, ACC, Z, C, and adjust, RP, plus, C, L. RP, ACC, Z, C, RP, ACC. RP, ACC, Z, C, RP, I. RP, ACC, Z, C, decimal adjective, RP, ACC, C, L. RP, ACC, Z, C, and adjust, RP, C, L. Z, G, RP, ACC. Z, G, RP, I. RP, ACC, Z, C, RP, plus 1. RPB, ACC, Z, C, RPB, plus 1. RP, ACC, Z, C, RP, 1. RPB, ACC, Z, C, RPB, 1. Z, RP, slash backslash, ACC, V, RP, slash backslash, ACC, V, RP, slash backslash, ACC, V, RP0, slash backslash, ACCO. Z, RP, slash backslash I, V, RP, slash backslash I, V, RP, slash backslash I, V, RPO, slash backslash I. RP, ACC, Z, RP, V, ACC. RP, ACC, Z, RP, 6. RP, ACC, Z, RP, //acc rp ace z rp // rp acc z rp v acc rp acc z rp vi ma chun cycle 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 page s colon n s colon instruction list continued mnemonic 14 13 12 11 10 9 roreg.l000000 c 0 roll regl000001 asr regl000000 0a dot s asl regl000001 clg000000 c clc000000 0 clz00000002 1 dot scla000000 c 0 seg000001 sec0000 001 0 0 says 000001u C000001 MOVACC REGL000000 C 0 MOVDACC Reg 21010B B MOV hashtag I REGL001110 S MOV Reg 1 ACC 000001 T C MOVD Reg 2 ACC 1011B B L LEXGREGL000001 CL EXGD Reg 20111B B C C dot S call add S111A A 0 RET 000000 dot Q dot SRTL000001 C JMP add S110 A0 JMP REGL000000 E JMPO REGL000001 INST auction code 876543 P0010 P00110 P0011 P0011 010000 010010 010100 010110 010000 010010 010100 010110 P1111 0P P P P PI I P1111 0P P P PR P0000 0P P P PR AA A AA 011000 011000 AA AA P1101R P1101R 210 R1R0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 R R R R R A 0 0 0 0 0 0 A R R Description Z ACC Co C P 0 1 Z ACC I C P J Z ACC 0 P C Z ACC C P 0 G O C O Z O Z C G 0 G L C L Z L Z C G L RP dash ACC PB ACC P ACC Z I ACC Z RP ACC Z PB RP ACC PB ACC Stack 0 PC PC A SP SP plus 1 PC Stack plus 1 SP SP 1 PC Stack plus 1 SP SP 1 at int routine PC A PC PC plus RP plus 1 PC PC plus 7A P plus 1 M Chine Cycle 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 page I T N I M X instruction list continued instruction code mnemonic 14 13 12 11 10 9 8 7 6 5 4 BGTN 000011 P001N BLEN 000011 P101N BCSN 000011 P000N 0 Pound BCCN 000011 P100 N BEQN BZEN 000011 P010N C E BNEN BNZN 000011 P110N dash BGEN 000011 P011N BLTN 000011 P111N Melody MSAADRs 000010A A Start DSP dig Reg 10001000 P dig dig 0 DSPH dig Reg 100101 PB0 dig O DSPF dig Reg 10001110 P dig O 5 DSPFH dig Reg 100011 P dig out Reg 1 port 01010Y 4 PY Y Yo 0 Dash out hashtag I, port 01011Y0V, Y, VO colon. 5.9 dash. C colon C, INP port, reg 101000V, PY, V, YO. 0. NAP 00000000000. Halt 00000100011U. Note, instructions marked with an asterisk, dot, are available for MSM 6351 ONLV. 3210. N, 0. N, no. 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 A, AO. R, RO. R, R0. R, R0. R0. I, R, 0000. I0000. Description. If, G, 1 then, PC, plus N. Else, PC, plus 1. If, G, 0 then, PC, plus N. Else, PC, plus 1. If, C, 1 then, PC, plus N. Else, PC, plus 1. If, C, equals 0 then, PC, plus N when P equals 0. Else, PC, plus 1 in bit 8. If, Z, 1 then, PC, plus N. N equals N plus 1. When P equals 1. Else, PC, plus 1. N equals N. If, Z, equals 0 then, PC, plus N. Else, PC, plus 1. If, G, 1 or, Z, minus 1 then, PC, plus N. Else, PC, plus 1. If, G, 0 or, Z, 0 then, PC, plus N. Else, PC, plus 1. Specifies the first address of note data. EOOH, FFFH. Digit, lower part, RP, ACC. Digit, high part, RP, ACC. Digit, low part, RP, via table. Digit, high part, RP, via table. Port Y, RP. Party, I. RP, ACC, port V. No operation. Halt CPU. Ma. Chime. Cycle. 1. 1. 1. 1. 1. 1. 1. 1. 2. 1. 1. 2. 2. 1. 1. 1. 1. 1. Page. 3. N. 3. OKI semiconductor. MSM 6052. CMOS 4-bit single-chip low-power microcontroller for telephone. General description. The OKI MSM 6052 is low-power, high-performance single-chip 4-bit microcontroller employing complementary metal oxide semiconductor technology, especially designed for use in sophisticated Telephone sets. Integrated onto a single chip are 4 bits of ALU, 28K bits of mask programmable ROM, 2560 bits of data RAM, programmable timer, oscillator, 12 bits of input port, 12 bits of output port and 4 bits of input/output port. In addition to these units, a DTMF generator is provided. With the MSM6052, sophisticated telephone sets become feasible through a single chip instead of the conventional 3-chip configuration. Features: low power consumption 0.3 mAh typical at 3V. DTMF output off. 2048x14 internal ROM. 640x4 internal RAM. 3x4 input port. 3x4 output port. 1x4 input/output port. DTMF generator. Buzzer sound output. 4-bit programmable timer applicable for output of dial pulse. Functional block diagram. 11, 12, 13, 14, C1, C2, C3, C4, 01, 02, 03, 04, E01, E02, E03, E04, 101, 102, 103, 104, 10E. HRL-XT. 11. 32 kHz timing generator. Programmable DTMF. Timer circuit. 1 AC test. Instruction. Decoder. 1. Do VSS. BD. Interrupt by programmable timer. 5-level stack. Power down mode. 52 instructions. Instructions useful for data management. Data search and block data transfer. 2.5 to 6.0 V operating voltage. 3.58 MHz oscillator. 17.9 p.s instruction cycle. -20 to 75 degrees Celsius operating temperature. 28-pin dip or 40-pin dip. 2 == L equals, IDN. DOUT. Data RAM. 640 word x 4-bit. Program ROM. 2048 word x 4-bit. Dash. 139. MSM 6052 dash. 140. Pin configuration. EO. C. 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 I. 0. 0. DTMF out. 10. 10. IO3. 10. VDD. BD. AC. A. 40 lead plastic 01P, B. 28 lead plastic dip. Logic symbol. Keyboard. Input. Keyboard. Input. Input port. 11. 12. 13. 14. C1. Keyboard C2. Output C3. C4. 01. Output 02. Port 03. 04. Hook switch. Oscillation. R. 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 HS. I. NC. I. 0. 0. 0. NC. 0. Op out. DTMF out. 10. 10. 10. DC, don't connect. C. 44, lead plastic flat package. NC pin must not be connected to any signal. E01. Output port. E02. E03. E03. 101. 10 port. 102. 103. 104. 10E output enable. Out. Dial puzzle. Output. Output. BD buzzer output. 32 kHz 32 kHz output. Reset. Test. Power. Dash. MSM 6052. Pin description. Designation function. VDD power source. VSS circuit ground potential. AC terminal to clear internal logic, pulled down to VSS. After power is turned on, the MSM 6052 must be reset by this terminal. Test terminal to test internal logic, pulled down to VSS. This terminal must be open in normal operation. XT. Input and output terminals of oscillator inverter. 3.58 MHz ceramic resonator is connected to these terminals. HS input terminal connected to the hook switch, pulled up TP-VDD. Output terminal of dial pulse. Dial pulse rate, 10 pps or 20 pps, and make break ratio, 40% or 33%, can be selected by software. Output terminal of DTMF signal. BD output terminal of buzzer sound. 32 kHz output terminal of 32 kHz clock. RR. Input port pulled down to VSS. Rs. 1-1. Input port having clocked pull down resistor to VSS. Only when this port is accessed, pull down resistors are connected to this port. CC, output port. 0-0. 10-10. Tri-state bidirectional port. 10E output terminal. When 10, -10 is accessed, input completion signal, when read, or load signal, when written, is output from 10E terminal. 141. MSM 6052. Functional description. A block diagram of the MSM 6052 is given on page 129. Each block of logic will be briefly discussed. For more information, please refer to the MSM 6052 User's Manual. Program ROM. The MSM 6052 will address up to 2K words of internal mask programmable ROM. Each word consists of 14 bits and all instructions are 1 word. The instructions are routed to a programmed logic array which generates the signals necessary for control of logic. Data RAM. Data is organized in 4-bit nibbles. Internal data RAM consists of 640 nibbles. All locations are addressed by 10-bit address registers, AR1, ARJ, 2-bit bank register, B, 4-bit page register, P, or a part of the instructions operand. ALU. The ALU performs a 4-bit parallel operation on RAM and ACC contents, or on RAM contents, and an immediate digit. It sets or resets the 3 flags, Z, C, G, depending on the condition. Program counter, PC. The program counter is an 11-bit wide counter that specifies the address of program ROM. The PC is incremented by 1 at every execution of the instruction, and then specifies the next instruction to be executed. However, the Contents of the PC are rewritten by the execution of a jump, call or branch instruction. As there is no boundary in the ROM, and a jump, call or branch instruction can be put anywhere in the ROM stack. The MSM6052 has a 5-level stack apart from the data RAM. The contents of the PC are loaded into stack when a call instruction is executed or an interrupt is generated. Nesting of subroutines within subroutines can continue up to 4 times, including the interrupt. Input port R1, R4, 4-bit input port. Each pin of the port is pulled down to VSS by an internal resistor, and status of the port is fetched by an input instruction. Port R5, R8, 4-bit input port. Each pin of the port is pulled down to VSS by an internal resistor, and the status of the port is fetched by an input instruction. 142. Port 11 to 14, 4-bit input port. Each pin of the port is pulled down to VSS by an internal resistor and transistor. Only when it is desired to fetch status of the port, input current flows through these pins. Status of the port is fetched by an input instruction. Output port C1, C4, 4-bit output port. These ports consist of data latches and buffers, and the contents of the data latches are rewritten by an output instruction. Port 01, 04, 4-bit output port. This port consists of data latches and buffers, and the contents of the data latches are rewritten by an output instruction. Electrical characteristics of 03 and 04 are different from those of 01 and 02. 03 and 04 of the ports are used as XMIT mute and mute. Normally, port E01, E04, 4-bit output port. This port consists of data latches and buffers, and the contents of data latches are rewritten by an output instruction. Input/output port 101 to 104, 4-bit bidirectional port. This port consists of data latches, output buffers and input buffers. The contents of the data latches are rewritten by an output instruction, and status of the port is fetched by an input instruction. Address registers, AR1, AR2. The address registers are used to specify the 10-bit address of data RAM, when a data search instruction, ROR, or block data transfer instruction, MVAR, is executed. This register is an up/down counter, and is incremented or decremented by 1 with execution of the instruction. Timing generator. By connecting a 3.58 MHz ceramic resonator to the XT and XT terminal, the timing generator generates a basic timing signal to control the MSM6052. The MSM6052 can operate in 2 modes: normal operating mode and power down mode. Stop instruction is used to place the MSM6052 in the power down mode. The oscillation stops, and all functions are stopped. However, the contents of RAM and all registers are maintained. underscore 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 1. MSM 6052. Programmable timer. The programmable timer consists of a 4-bit down counter and a 1/100 prescaler. Any of a 7990.1 Hz clock, 1997.5 Hz clock, and 998.8 Hz clock is input to the 1/100 prescaler. Output of the 1/100 prescaler decrements the 4-bit down counter by 1. When the contents of the 4-bit down counter is decremented to 0, the programmable timer generates an interrupt. This programmable timer can be used as a dial pulse generator. The dial pulse rate, 10 pps, 20 pps, and make/break ratio, 40%, 33%, of the absolute maximum ratings. Parameter symbol. Supply voltage. Input voltage. Output voltage. Storage temperature. Power dissipation. Operating conditions. Parameter. Operating voltage. Memory retention. Voltage. Operating temperature. DC characteristics. VU equals 3V, Ta equals -20 to 75 degrees Celsius. Parameter symbol. H input voltage VIH. L input voltage VIL. H output current, 1, 10H. L output current, 1, 10L. H output current, 2, IOH2. L output current, 2, IOL2. H output current, 3, IOH3. L output current, 3, IOL3. VU. 6. VO. TSTG. PO. Symbol. VU. VOOM. Top here. VU equals 3V. VU equals 6V. VU equals 3V. VU equals 6V. 03,04. Out. CC4. 002, VO. Dial pulse which the programmable timer generates are selectable. DTMF circuit. OTMF circuit is used to generate a OTMF signal. 12 kinds of OTMF signal, 0 to 9, hashtag, asterisk, can be output by an output instruction. BD circuit. The BO circuit generates the square wave, which can be used as the confirmation sound, warning sound and so on. 15 kinds of sound. 4.66 to 0.82 kHz, are output by an output instruction specifying the frequency. Conditions limits unit. Ta equals 25 degrees C minus 0.3 to 7.0 V. Ta equals 25 degrees Celsius minus 0.3 to VU plus 0.3 V. Ta equals 25 degrees Celsius minus 0.3 to VU plus 0.3 V. Minus 55 to 125 degrees Celsius. Ta equals 25 degrees C 200 MW. Limits unit. 2.5 to 6.0 V. 1.2 to 6.0 V. Minus 20 to 75 degrees Celsius. Limits. Conditions unit. Min. Tip. Max. 2.2 V. 4.4 V. 0.8 V. 1.6 V. VOH equals 2.6 V minus 200, PA. Vol equals 0.4 V 500, PA. VOH equals 2.6 V minus 1, Ma. Vol equals 0.4 V 10, PA. VOH equals 2.6 V minus 20, PA. Vol equals 0.4 V 10, PA. 143. MSM 6052-. DC characteristics, cont. Parameter symbol. H output current, 4, 10H. L output current, 4, 10L. H output current, 5, IOH5. L output current, 5, IOL5. Pull up resistance RUP. Pull downward 1. Resistance, 1. Pull downward 2. Resistance, 2. Input leak current IL. Current loop. Consumption, 1. Current loot. Consumption, 2. Memory retention 100 M. Current. AC characteristics. VU equals 3V, Ta equals minus 20 to 75 degrees Celsius. Parameter symbol. Key input time TKIN. Tone output voltage VOUT. High/low level ratio dBCR. Distortion ratio %OIS. Rise/fall time, 1. TTLHL. TTHLL. Rise/fall time, 2. TTLH2. TTHL2. Rise/fall time, 3. TTLHS. TTHL3. Rise/fall time, 4. TTLH. TTHL. 144. Conditions. 10-10. VOH equals 2.6 V. 10E. EO. Vol equals 0.4 V. 32 kHz. VOH equals 2.6 V. Vol equals 0.4 V. HS. RRs. AC, test. 10-10. OS Ven S VU. VU equals 2.5 to 6.0 V. OTMF output VU equals 3 V. Off. VU equals 6 V. OTMF output VU equals 3 V. On. VU equals 6 V. On hook. Ta equals 25 degrees C. VU equals 2.5 V. Ta equals -20 to 75 degrees C. Conditions. VU equals 2.5 to 6.0 V. VU equals 2.5 V. Row only. VU equals 4.0 V. RL equals 1 kF. VU equals 6.0 V. VU equals 2.5 to 6.0 V. RL equals LKF. OS, 0, opt-out. CL equals 50 PF. CC. CL equals 50 PF. 002, BO, 32 kHz. CL equals 50 PF. 10-10 IOE, EO. CL equals 50 PF. Limits. Unit. Min. Tip. Max. -150/LA. 300/LA. -40/LA. 25/LA. 17 to 150 kF. 33 to 300 kF. 10-100 kF. Plus or minus 2/LA. 0.3 0.6 mA. 1.2 2.4 mA. 1.2 2.4 mA. 3.5 7.0 mA. 0.010.2/LA 2/LA Limits Unit Min Tip Max 33 ms 150 250 350 200 350 570 MV 300 480 850 RMS 123 dB 15% 0.5 0.5 /LS 0.5 10 /LS 5 10 /LS 1 /LS 1 dash MSM 6052 Description of instructions Instruction code Mnemonic operation 1312 11 1 10 1 9 1 876543211A Add ACC-APAAAAPA1AAAAP plus ACC. Add hashtag DAPA11AAPDAAP plus dash, AP, plus D. You add cap AAAAPA101AAP plus, AP, plus ACC plus C. 06. Q sub ACC, APAAAA1PA1AAAAP plus, AP, ACC 0. C, sub hashtag DAPA1101PDAAP plus dash, AP, D. 2. U. ZPAP AAAA1PA101AAP plus dash, AP, ACC, C. E. Back APAAAA1P111AA, AP, ACC 5. CMP hashtag DAPA1011PDA, AP, D. X or ACC, APAAAAPA111AAP plus, AP, VACC. X or hashtag DAPA1111PDAAP plus dash, AP, VD. By TASI APAAAAP111AA, AP, VACC. C. 0. Bid hashtag DAPA101APDA, AP, VD. BISIC APAAAAPA11AAAP plus, AP, VACC. COBIS hashtag DAPA1AAAPDAAP plus dash, AP, VD. 0. 3 BIC ACC, APAAAA1PA11AAAP plus, AP, AACC. BIC hashtag DAPA1AA1PDAAP plus, AP, AD. RAP AAAAPAA1AAC, AP, C:'J. Q, ROLAP AAAA1PAA1AAL, AP, plus C-J. 0. OSHRAP AAAAPAA11AO-, AP, CA. ASLAP AAAA1PAA11AC plus dash, AP, plus dash 0. Says AAAA10101AAAAZ plus dash 1. CLZ AAAAA101AAAAZ plus O. C, SEC AAAA101AA1AAAAC plus dash 1. 09. CLC AAAAA1AA1AAAAC plus O. COSEG AAAA101AAAAAG plus dash 1. 0. 01. To CLG AAAAA1AAAAAG plus dash 0 U. CAAAA10101AAAAZ plus 1, C plus 1, G plus dash 1. CLAAAAAA10111AAAAZ plus dash 0, C plus dash 0, G plus dash 0. MUVASI AP111101AAAAAP plus ACC. MUVASI AX1111AAXAAX plus ACC. 3. C. MOV hashtag DAPA111 APDAAP plus D. To move app ACC 111111 AAAAAACC plus dash AP. ACC plus dash AX CL MoveX ACC 11111 AXA. CHGAP 111 AA1 AAAAA AP ACC. 145. MSM 6052 dash. Description of instructions, cont. Instruction code. Mnemonic operation. 1312 11 10 9 8 7 6 5 4 3 2 1 0. CHGAX 111000XA, AX, dash ACC. ROR 1100000000000000 ACC dash, AR. ROR plus H1100000001 oil 0000 ACC, AR1, AR1 plus or minus 1. ACC dash, AR. ROR plus HZ110000001000/10000 if, AR1, equals 0 then PC, PC plus 1. Else AR1 plus or minus 1, repeat. ACC dash, AR. ROR plus HN11000010 OL 0000 if, AR1, FO then PC, PC plus 1. Else AR1 plus or minus 1, repeat. ACC, AR1, L, 1. ROR plus HZL1100100010 OL 0000 if, AR1, equals 0 or L equals O. Then PC plus 1. Else AR1 plus or minus 1, repeat. ACC, AR1, L, 1. ROR plus HNL11001010 OL 0000 if, AR1, FO or L equals O. Then PC plus 1. Else AR1 plus or minus 1, repeat. Chi MV AR11000000000000 AR2 dash, AR. UI. MVAR plus, 1101000001 oil 0000 AR2 dash, AR. CA. AR2 dash, AR, 3. CLMVAR plus HZ1101000010 OL 0000 if, AR1, equals 0 then PC plus 1. Else AR1 plus or minus 1. AR2 plus or minus 1, repeat. AR2 dash, AR. MVAR plus HN11010010 OL 0000 if, AR1, 10 then PC plus 1. Else AR1 plus or minus 1. AR2 plus or minus 1, repeat. AR2 dash, AR, LL1. MVAR plus H, L11011000 OL 0000 if L equals O then PC plus 1. Else AR1 plus or minus 1. AR2 plus or minus 1, repeat. AR2, LL1. If, AR, equals O or L equals O. MVAR plus HZ, L11011001 OL 0000 then PC plus 1. Else AR1 plus or minus 1. AR2 plus or minus 1, repeat. AR2 dash, AR, LL1. If, AR1, 10 or L equals O. MVAR plus HNL11011010 OL 0000 then PC plus 1. Else AR plus or minus 1. AR2 plus or minus 1, repeat. Q, call ADRs 101 a 0 AG as a 7 as a 3 a 2 a, AO stack, PC, PC, ADRs. C. SRET. E000000110000000 PC, stack, +1. .crti 000010110000000 PC, stack, or :lpc dash, stack, +1. / 146. E. MSM 6052. Description of instructions, cont. I instruction code. Mnemonic operation. 1312 11 10 9 8 7 6 5 4 3 2 1 0. JMP ADRs 100A 0A 9 8 a 7 a 6 as a 3 a 2 a, AOPC ADRs. 0. EJMP at AP 00000 P1101 APC, PC, plus, AP, +1. :L. JMPO at AP 00001 P1101 APC, PC, plus, AP, A7H +1. Bean if Z equals 1 then PC PC, N or BZEN, 11101 P010 N N3 N2 N, no PC PC plus N +1. Else PC PC +1. BNN if Z equals O then PC PC, N or BNZN, 11101 P110 N N3 N2 N, no PC PC plus N +1. Else PC PC +1. If C equals 1 then PC PC N or BCSN 11101 P000 N N3 N2 N, no PC PC plus N +1. Else PC PC +1. If C equals O then PC PC, N or BCCN 11101 P100 N N3 N2 N, no PC PC plus N +1. R equals else PC PC +1. 0. BGTN 11101 P001 N N3 N2 N, no PC PC plus N +1. Else PC PC +1. If G equals O then PC PC, N or BLN 11101 P101 N N3 N2 N, no PC PC plus N +1. Else PC PC +1. If G equals 1 or Z equals 1. BGN 11101 P011 N N3 N2 N, no then PC PC, N or PC PC plus N +1. Else PC PC +1. If G equals O and Z equals O. BLT N 11101 P111 N N3 N2 N, no then PC PC N or PC PC plus N +1. Else PC PC +1. In port AP 00010 PPLAAP, port ::also. OutApp, port 0010 PHPPLA port, AP 0. -0 out number 0, port 0011 PH0. PLD port D. Stop 00111000000000 stop system clock. RN halt 001110000000 halt CPU. CD. ACT 001110000000 activate CPU. R equals 0. 0 EI 00111000110000 enable timer interrupt. DIS 00111000110000 disable timer interrupt. EET 00111000110010 enable timer activate. 0. 0. : DT0011100110100001 disable timer activate. A. EC00111001111000 enable output port, CC. DC0011100111101000 disable output port, CC. 147. MSM 6052. Description of instructions, cont. Instruction code. Mnemonic operation. 1312 11 10 9 8 7 6 5 4 3 2 1 LJ. OM 00110011100010 set IO port, 101 to 104, 2. OM. Output mode. CD1M00111001110001 set 1/0 port, 101 to 104, 2. OC. 0 feet 0 inches input mode. Equals 0. Doc, RST 00111010001000 reset divider. 0. NOP 00000000000000 no operation. 148. OKI semiconductor. MSM 6352. CMOS 4-bit single-chip low-power microcontroller for telephone. General description. The OKI MSM 6352 is a low-power, high-performance single-chip 4-bit microcontroller employing complementary metal oxide semiconductor technology, especially designed for use in sophisticated telephone sets. Integrated onto a single chip are a 4-bit ALU, 28K bits of mask programmable ROM, 2560 bits of data RAM, programmable timer, oscillator, 12 bits of input port, 12 bits of output port and 4 bits of input/output port. In addition to these units, a DTMF generator is provided. With the MSM 6352, sophisticated telephone sets become feasible through a single chip instead. Features. Low power consumption 1.8 mAh typical at 3V. DTMF output off. 2048x14 internal ROM. 640x4 internal RAM. 3x4 input port. 3x4 output port. 1x4 input/output port. DTMF generator, single tone mode or dual tone mode. Buzzer sound output. 4 bits programmable timer applicable for output of dial pulse. Watchdog timer. On-hook dialing and off-hook dialing. Function. Functional block diagram. A 2. A 3A. A 5. H. 12. 1. Dash, dot, 4. 8. 03U. EO. E02. 8.0. I. 10A. HS dash dash equals J comma J. XT. She. 32 kHz timing generator. Instruction. Decoder. Interrupt. Programmable timer interrupt. Real-time interrupt. 5-level stack. Power down mode. 52 instruction set. Instructions useful for data management. Data search and block data transfer. 2.0 to S.SV, 2.2 to S.SV at tone mode. Operating voltage. Low voltage detector. 3.58 MHz oscillator. 17.9 FIS instruction cycle. -20 to 75 degrees Celsius operating temperature. 28 pin dip, 40 pin dip or 44 pin flat. Software compatibility with MSM6052. Data RAM 640W, DLL4-bit. Program ROM 2046 Word x 14-bit. IIACTETII. Do VSS equals underscore equals underscore equals underscore equals underscore underscore equals underscore equals underscore equals underscore equals underscore underscore equals underscore equals underscore equals underscore equals underscore underscore equals underscore underscore J. 149. MSM 6352. Pin configuration. E01. C. 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 I. 0. DTMF out. IO3. 10. VDD. BD. C. 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 I. 0. 0. 10. Out. 1 DTMF out. VDD. AC. VSS. R. 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 HS. I. NC. I. 0. 0. 0. NC. 0. Out. DTMF out. 10. 10. 10. DC, don't connect. A. 40 lead plastic dip. B. 28 lead plastic dip. C. 44 lead plastic flat package. NC pin must not be connected to any signal. Logic symbol. E01. Output port. Keyboard E02. Input E03. E03. 101. 10-port keyboard. 102. Input 103. 104. 10E output enable. Input port. 11 dial puzzle. 12 out output. 13. 14 mf output. C1 BD buzzer output. Keyboard C2. Output C3 32 kHz 32 kHz output. C4. AC reset. 01. Output 02 test. Port 03. 04 VDD. Power. Hook switch HS. VSS. Oscillation, XT. 150. Dash. MSM 6352. Pin description. Designation function. VDD power source. VSS circuit ground potential. AC terminal to clear internal logic, pulled down to VSS. After power is turned on, the MSM 6052 must be reset by this terminal. Test terminal to test internal logic, pulled down to VSS. This terminal must be open in normal operation. XT. Input and output terminals of oscillator inverter. 3.58 MHz ceramic resonator is connected to these terminals. HS input terminal connected to the hook dot switch, pulled up TP VDD. Output terminal of dial pulse. Dial pulse rate, 10 pps. Or 20 pps, and make break ratio, 40% or 33%, can be selected by software. Output terminal of DTMF signal. BD output terminal of buzzer sound. 32 kHz output terminal of 32 kHz clock. RR4 input port pulled down to VSS. R5 R8. 1-14 input port having clocked pull down resistor to VSS. Only when this port is accessed, pull down resistors are connected to this port. CC4 output port. 0-04. 10-104 Tri-State Bidirectional Port. 10E Output Terminal. When 10-104 is accessed, input completion signal, when read, or load signal, when written, is output from 10E terminal. 151. MS2-. Functional description. A block diagram of the MSM6352 is given on page 149. Each block of logic will be briefly discussed. For more information, please refer to the MSM6352 User's Manual. Program ROM. The MSM6352 will address up to 1K words of internal mask programmable ROM. Each word consists of 14 bits and all instructions are one word. The instructions are routed to a programmed logic array which generates the signals necessary for control of logic. Data RAM. Data is organized in 4-bit nibbles. Internal data. RAM consists of 640 nibbles. All locations are addressed by 10-bit address registers, ARAR, 2-bit bank register, B, 4-bit page register, P, or a part of the instructions. Operand. Program counter, PC. The PC is an 11-bit counter to specify the ROM's address. The PC is normally incremented by 1 by every execution of the instruction, and then specifies the next instruction to be executed. However, jump, conditional branch, and routine instructions are exceptions. When the JMP ADRs or call ADRs instruction is executed, all of the PC contents are rewritten. So jump can be done to any address of the ROM. Bank register, B. The bank register is a 2-bits register which specifies the bank of the RAM. Read/write operation is performed by the input/output instruction. Page register, P. The page register is a 4-bits register which specifies the page of the RAM. Read/write operation is performed by the input/output instruction. Address register 1, AR. The address register AR is a 10-bits register which specifies the RAM's address. This register is used by the RDAR instruction or the MVAR instruction. Read/write operation is performed by the input/output instruction. Address register 2, AR. The address register AR is a 10-bits register which specifies the RAM's address. This register is LLSED by the MVAR instruction. Read/write operation is performed by the input/output instruction. Loop counter, L. The loop counter is a 10-bits down counter which specifies a number of words of the data to be searched or to be moved by the RDAR instruction or the MVAR instruction. Its contents can be rewritten by the output instruction. 152. ALU, conditional flag, ACC. A, ALU. The ALU performs 4 bits parallel operation of the RAM contents and ACC contents, or the RAM contents and an immediate data. The arithmetic, logic, comparison, and rotate operations can be done. B. Conditional flag. The zero flag, Z, carry flag, C, and greater flag, G, are provided. These flags are set or reset depending on the operation result and referred to by the conditional branch instruction. The flag operation instruction enables these Flags to be set or reset individually or allowed. The ACC. The ACC is 4 bits register for arithmetic, and equipped with data transfer instruction between ACC and RAM. Stack. The stack consists of a RAM of 5 words x 11 bits. It is used to save the PC contents when the subroutine is called or a timer interrupt is generated. And 5-level nesting can be done including a timer interrupt. The PC contents saved in the stack is popped to the PC by the return instruction. Interrupt. MSM6352 has 2 kinds of interrupt as below. Real-time interrupt. Programmable timer interrupt. Stop mode. Stop mode is established by the execution of the stop instruction. In the stop mode, oscillation of system clock stops and all operations are suspended, but the RAM contents and all register contents are maintained. Halt mode. Halt mode is established by the execution of the halt instruction and the execution of program of main routine is suspended. In the halt mode, all RAM contents and register contents are maintained. Timer activation and real-time interrupt circuit. The timer activation and real-time interrupt circuit are to release halt mode, timer activation, and to generate interrupt, real-time interrupt, at the tailing edge of the 31.21 Hz clock. Obtained by dividing the 3.579545 MHz system clock by 114,688. The timer active/ld on and real time interrupt circuit can be used for the generation of timer activation and real-time interrupt by setting or resetting the mode setting flag, TMF. MSM6352. Divider circuit. The 3-stage binary divider circuit to which 31.21 Hz clock is supplied is provided. The divider circuit's contents can be read by the input instruction, LN2, AP, and at the same time HS input. Port data is also read. The divider circuit can be reset by the RST instruction. Programmable timer and programmable timer interrupt. The programmable timer is used for dial pulse output or timer interrupt generation. This timer consists of control resistor PTL, 1/100 divider circuit, 4-bit presettable down counter PTC. Interrupt flag IRQF, interrupt enable flag ELF. Selection flag EOF of off and on hook dialing. Made, and dial pulse phase selection flag DPE. 1/100 divider circuit, PTC, IRQF, ELF, EOF and DPF are reset at system reset. DTMF output circuit. The DTMF output circuit is to generate DTMF tone signal and is controlled by DTMF and tone register. Rewrite ENG the contents of the output latch. For DTMF circuit by output instructions, 12 kinds of dual or single tones can be output to the DTMF output port. The tone output frequency is selected by the DTMF register. BD circuit. The BD circuit generates the square wave which can be used as the confirmation sound, warning sound and so on. 15 kinds of sound, 4.66 to 0.82 kHz, are output by an output instruction specify ing the frequency. Watchdog timer WDT. The watchdog timer is to generate the system reset signal to recover from system ran away trouble. Input port, R, R. R is 4 bits input port, which status is fetched by the input instruction. The port is pulled down to the low level, VSS, by resistor, so it can be used as keyboard input port. Input, RS, R. RS, R is 4 bits input port, which status is fetched by the input instruction. The port is pulled down to the low level, VSS, by resistor, so it can be used as keyboard input port. Input port, I is 4 bits input port, which status can be fetched by the input instruction. It is pulled down to low level, VSS, by register via transistor only. When it is desired to fetch the port status or input signal is low level. As input current is restricted, it can be used. Being fixed at high level, VU. HS input pin. It is 1-bit input pin, which status can be fetched by the input instruction. It is pulled up to high level, VU, by resistor. It is used as a hook. Switch input pin. Output port, C is 4 bits output port. The contents of the output latch can be rewritten by the output instruction. The low level is output at each output pin after the system is reset. When the HS input pin is open or at high level, the low level is output to each output pin irrespective of the contents of the output latch. The outputs of C are all CMOS output. Output port, 0, 0, 0, O is 4-bit output port. The contents of the output latch can be rewritten by the output instruction. Output latch of 0 and 0 are reset and 0, 3 and O are set at system reset. Each output from 0, O port is CMOS. Output port EO is 4 bits output port. The contents of the output latch can be rewritten by the output instruction. The level is output at each output pin after the system is reset. Each output of EO is CMOS output. Input/output port, 10 is 4 bits input/output port. Fetching of the port status and rewriting of the output latch contents can be done by the input/output instruction. Each output of 10 is CMOS at output mode. 10E output pin. It is 1-bit output pin. A load signal is output at this pin when the output latches 10. Contents are rewritten. DTMF output pin. It is output pin to output DTMF signals. Start and stop of the OTMF output are done by the output instruction. DP output pin. It is an output pin for dial pulse output. Start and top of the dial pulse output can be done by the output instruction. The op-out pin output is CMOS output. BD output pin. It is output pin for the buzzer output. The buzzer output can be started and stopped by the output instruction. Output of bow port is CMOS. Output 32 kHz output pin. It is an output pin to output 31.960 kHz clock. Duty 50%, which is obtained by dividing the 3.579545 MHz system clock by 112. This clock keep outputting as long as system clock oscillation is executed. Output of 32 kHz pin is CMOS out. Out. 153. EMSM 6352 E dash 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 XT pins. These are input and output pins of the oscilla Tor inverter, and the oscillator circuit is provided with the built-in feedback resistor. By connecting to them oscillation of system clock status. 3.579545 MHz ceramic resonator and capacitors. Electric characteristics. Absolute maximum ratings. Parameter symbol conditions. Supply voltage VTA equals 25 C. Input voltage 6 Ta equals 25 C. Output voltage VOTA equals 25 C. Power dissipation POTA equals 25 C. Storage temperature TSTG. Operating conditions. Parameter symbol conditions. Operating voltage VO. Pulse mode. FOSC equals 3.58 MHz. Memory retention voltage VOOM. Operating temperature pair. Note, operating conditions for tone mode is VO equals 2.2, 5.5 V. 154. Limits unit. -30 -7 V. -0.3, VO plus 0.3 V. -0.3, VO plus 0.3 V. 200 maximum MW. -55 to plus 125 degrees C. Limits unit. 2.0 to 5.5 V. 1.2 to 5.5 V. -20 to plus 75 degrees C. Dash. MSM 6352. DC characteristics, Ta equals -20, plus 75 degrees C. Parameter symbol conditions. Supply. Min. Tip. Max. Unit. Survey. Voltage circuit. H output current, 1, 10H. 03, OVOH equals 2.6 V 3.0 V minus 0.2, mA. L output current, 1, LOL, op-out vol equals 0.4 V 3.0 V 0.5, mA. H output current, 2, 10 Hz VOH equals 2.6 V 3.0 V minus 1.0, mA. CC. L output current, 2, 10 LZ vol equals 0.4 V 3.0 V 10, FJA. H output current, 3, IOH 30. Oz VOH equals 2.6 V 3.0 V minus 2.0, J1.A. 1. L output current, 3, IOL 3, Barrio vol equals 0.4 V 3.0 V 10, J1.A. H output current, 4, 10H. 10, minus 10. VOH equals 2.6 V 3.0 V minus 150, J1.A. 10E. L output current, 4, 10L. EO, EO. Vol equals 0.4 V 3.0 V 300, J1.A. H output current, 5, 10 HS VOH equals 2.6 V 3.0 V minus 40, J1.A. 32 kHz. L output current, 5, 10 LS vol equals 0.4 V 3.0 V 25, J1.A. 3.0 V 2.2. H input voltage VIH, V. 5.5 V 40. 2. 3.0 V, 0.8. L input voltage VIL, V. 5.5 V, 1.4. H input current, 1, IIH, VIH equals 5.5V 5.5V, 2J1.A. HS 3.0V minus 2.0 to minus 180. L input current, 1, IL, VIL equals OVJ1.A. 5.5V minus 40 to minus 360. VIH equals 5.5V 5.5V 20 to 180. H input current, 2, 11 Hz J1.A. RR3 VIH equals 3.01/3.0 V10 to 90. L input current, 2, 2 LZ VIL equals OV 5.5V, minus 2 J1.A. 1-1. VIH equals 5.5V 5.5V 60 to 600. H input current, 3, IIH3 J1.A3. AC, VIH equals 3.0V 3.0V 30 to 300. L input current, 3, IIL3 test VIL equals OV 5.5V, minus 2 J1.A. H input current, 4, IIH. VIH equals 5.5V 5.5V, 2 J1.A. 10-10. L input current, 4, 2 L VIL equals OV 5.5V, minus 2 J1.A. Tone output off 2.5V, 0.25 0.5. Current consumption, 1, loop Ma. With no load 5.0V, 1.5 2.4. Tone output on 2.5V, 1.3 2.4. Current consumption, 2, load Ma 4. With unload 5.0V, 4.26.8. Current consumption, 3, 100 M. On hook, Ta equals 25 degrees Celsius. 2.5V, 0.2 J1.A. With no load. 155. EMSM 6352E dash 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 dash. AC characteristics, Ta equals minus 20, plus 75 degrees C. Parameter symbol conditions. Supply. Min. Tip. Max. Unit. Survey. Voltage circuit. Cycle time TCYF equals 3.579545 MHz 3.0V, 17.9, f.ls. 2.2V, 180. Row side only MV. Tone output VOUT 4.0V, 260. RL equals 1K NRMS. 5.5V, 330. 3.0V 123. High/low level ratio dBCR, dB. 5.5V 123. 3.0V, 5. Distortion ratio %DLSRL equals 1 0%. 5.5V, 5. Switch input time TKIN, 3.3, MS5. TTLH, Q3. QDP out 3.0V, 0.5. Rise/fall time, 1. F.ls. TTHL, CL equals 50 PF 3.0V, 0.5. TTLH2CC 3.0V, 0.5. Rise/fall time, 2. F.ls. TTHL2CL equals 50 PF 3.0V, 10. TTLH3Q. Q2. BD 32 kHz 3.0V, 5. Rise/fall time, 3. F.ls. TTHL3CL equals 50 PF 3.0V, 10. TTLH. 10, 1010 E3.0 V, 1. Rise/fall time, 4, EOEO. F.ls. TTHL. CL equals 50 PF 3.0 V, 1. DTMF tone output frequency. Standard frequency, Hertz, output frequency, Hertz, deviation, percent. R1 697 699.1 plus 0.30. R2 770 766.2 minus 0.49. R3 852 847.4 minus 0.54. R4 941 948.0 plus 0.74. C1 1209 1215.9 plus 0.57. C2 1336 1331.7 minus 0.32. C3 1477 1471.9 minus 0.35. FOSC equals 3.579545 MHz. 156. MSM 6352. Instruction code. Mnemonic U0 description U. C3 13 12 11 10 9 8 7 6 5 4 3 2 1 0 OJ. Add ACC. AP0000P0100AA equals OFH. P equals O or 1. API plus ACE. Add hashtag D. AP011000PDA. D equals OFH, AP. IAPI plus D. A equals OFH. P equals O or 1. Add cap 00000P0101AA equals OFH. P equals O or 1. API plus ACE plus C. C sub ACC. AP0001P0100AA equals OFH. P equals O or 1. API ACC. 0. Sub hashtag D. AP011001PDAD equals OFH. API D. 15A equals OFH. P equals O or 1. 0. Use PTAP 00001P0101AA equals OFH. P equals O or 1. API ACC, C. E. Back. AP0. 0001P1110AA equals OFH. P equals O or 1. IAPI ACC. CMP hashtag D. AP0101PDAD OFH. IAPI DA equals OFH. P equals O or 1. X or ACC. AP0000P0111AA equals OFH. P equals O or 1. API VACC. X or hashtag D. AP0111PDAD equals OFH. API VDA equals OFH. P equals O or 1. Bit ACC. AP0000P1110AA equals OFH. P equals O or 1. IAPI VACC. Bit hashtag D. AP011010PDAD equals OFH. IAPI VO. C. A equals OFH. P equals O or 1. 0. BIS ACC. AP0000P1110AA equals OFH. P equals O or 1, API. ACC. E. D equals OFH. API VD0 BIS hashtag D. AP01000 PDA. A equals OFP equals Q or 1. 3. BIC ACC AP00001 P0110AA equals OFH. P equals O or 1. API AACC. BIC hashtag D. AP01001 PDAD equals OFH. API AD. AO.IF. ROR AP00000 P0010AA equals OFH. P equals O or 1. C. IAPIC. 2 Rollup 00001 P0010AA equals OFH. P equals O or 1. IAPICJ. I. 0 CR. ASRAP 00000 P0011AA equals OFH. P equals O or 1, OIAPIC. ASLAP 00001 P0011AA equals OFH. P equals O or 1. CIAPIO. Says 0001010100000 to 1, Z1. CLZ 0000010100000 to 0, ZO. CSEC 0001010100000 1, C1. 0. CLC 000001000100000, 0, CO. 0. SEG 0001010000000, 1 G1. 2. CLG 0000010000000, 0 GO. C000010101100000 to 111Z1.C1.G1. CLA 0000010110000 to 000ZOCOG0. Mubasi. AP1111010000AA equals OFH, APACC. MOVACC. AX111100XA. X equals OFH, AXACC. A equals OFH. MOV hashtag D. AP01110 PDA. D equals OFH, APD. A equals OFH. P equals O or 1. MOV AP. ACC 1111110000 equals OFH. ACC lap I. X equals OFHA. MOVAX. ACC 111110XA. ACCIAXI. A equals OFH. CHGAP 1110010000AA equals OFH. IAPIACC. CHGAX 111000XA. X equals OFH. IAXI. ACC. A equals OFH. 157. EMSM 6352 E dash 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 dash. Instruction code E. Mnemonic U2R, description. 13 12 11 10 9 8 7 6 5 4 3 2 1 0. U8. RDAR 11000000000000. ACC, AR. RDAR plus, 1100000001D/I0000D/I or 1. ACE plus, ARI, ART plus or minus 1. ACC, AR. RDAR plus, Z1100000010D/I00000D/IO or 101, if, AR, O then PC plus 1. Else RE plus AR1 plus or minus 1, repeat. ACC, AR. RDAR plus, N11000010OD/I00000D/I000 or 1. 0, if, AR, O then PC plus 1. Else AR plus ART plus or minus 1. Repeat. ACC, AR, LL1. RDAR plus, IZL11001001OD/I0000D/I0 or 1. If, AR, equals Q or L equals Q then PC. PC plus L. Else AR1 plus or minus 1, repeat. ACC, AR, LL1. RDAR plus, NL11001010OD/I0000D/I0 or 1. AR11 equals O or L equals Q then PC, PC plus L. Else RL plus AR, plus or minus L, repeat. S. MVAR1101000000000000. AR, S. AR, T. MVAR plus, 1101000001D/I000D/I0 or 1. ARJ plus ART plus or minus L, error plus or minus L. AR, MVAR plus, Z1101000010D/I000D/I or 1 to 1, if, ART, equals O then PC plus L. Else ART plus ART plus or minus L. AR plus AR2 plus or minus L, repeat. AR, MVAR plus, N11001010OD/I0000D/I or 1 to 0, if, ART, equals 0 then PC plus L. Else ART plus or minus L, error plus or minus L, repeat. AR, LL1. MVAR plus, L11011000OD/I0000D/I or 1. If L equals O then PC plus L. Else ARI plus AR, plus or minus L, AR plus AR2 plus or minus L, repeat. AR, LL1. MVAR plus, ZL11011001OD/I0000D/I or 1. If, ART, equals 0 or L equals Q then PC plus L. Else RL plus RE plus or minus L, RS plus ARZFL, repeat. AR, LL1. MVAR plus, NL11011010OD/I0000D/I or 1. If, ART, equals 0 or L equals O then PC plus L. Else AR1 plus AR, plus or minus L, RS ARZ plus or minus L, repeat. Call ADRs 10181089888786A, 8382A, A810AO equals 07FFH, stack. Plus, PC plus ADRs. 0. RET 00000011000000, PC, stack, plus 1. RTI 00001011000000, PC, stack, or PC, stack, plus 1. JMP ADRs 10081089A, ALLO equals 07FFH, PC ADRs. A. EJMP at AP00000P1101AAOFH, PO or 1, PC, PC, plus, AP, plus 1. JMPO at AP00001P1101AAOFH, PO or 1, PC, PC, plus, AP, A7 plus 1. BEQN 11101P010. 04 no QOHLFH, if Z equals 1 then PC plus dash PCN or PC plus N plus L. BZEN, N, 21 N PZO or 1. Else PC plus L. BNN 11101P110. N4 N001 FH if Z equals O then PCN or PC plus N plus L. BNZN, 43 NZINP equals O or 1. Else PC plus L. BCSN 11101P000. 04 no OLFH, if CL then PC plus PCN or PC plus N plus L. 432100P equals or 1 else PC plus L. Colon, BCCN 11101P1004N001FH, if C equals Q then PCN or PC plus N plus L. 403 ounces 01 no P equals or 1 else PC plus L. Lee. BGTN 11101P001. 4, no equals QOW, FH. If GL then PCN or PC plus N plus L 43 NZ1 no. P equals Q or 1 else PC plus L. BLE N11101P101 N4N, NZN1 no. 04 NOOLFH, if GO then PCN or PC plus N plus L. P equals O or 1 else PC plus L. BGEN 11101P011. N4. No OOW, FH. If Z1 or GL then PCN or N4 NAOS NLN. P equals O or 1 PC plus N plus L else PC plus L. BLTN 11101P111. 4 NO equals OLFH. If 2 equals 0 then PCN or PC plus N plus L 04 NA2IN. P equals Q or 1 and G equals Q else PC plus 1. In port, AP00010PPLAPLOFH star. AP, port. BA equals OFH, PO or 1. 8 OUTAP. PDRT001OPHPPLAPLOFHPW or 1, port, AP. AOFH, PO or 1. A. PLOFHPWO or 1. .eout hashtag D, port 0011PH0PLD. DOFH. PDRTD. 158. Dash 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 EMSM 6352E. I instruction code. Mnemonic U description U. 13 12 11 10 9 8 7 6 5 4 3 2 1 0 NU. Stop 0 0 1 1 1 0 0 0 0 0 0 0 0 0, stop system clock. Halt 0 0 1 1 1 0 0 0 0 1 0 0 0 0, halt CPU. Act 0 0 1 1 1 0 0 0 1 0 0 0 0 0, activate CPU. EI 0 0 1 1 1 0 0 1 1 0 1 0 0 0, enable timer interrupt. 0 1 0 0 1 1 1 0 0 1 1 0 0 1 0 0, disable timer interrupt. ET00111001100010, enable timer activate. OT00111001100001, disable timer activate. EC00111001111000, enable output port, C. C1. 5. DC00111001110010, disable output port lel C. Set IO port, 10.1. 10.1 to output G. OM00111001110010, mode. C. 0 set IO port, LOI. IO. To input mode. U1 M00111001110001, colon. 0U. RST 001110100000, reset divider. Solent 00111011001000, select interrupt mode. Celair 00111011000010, select timer activation mode. EHLH 00111011000010, enable hook switch low to high trans star. Mission. OHLH 00111011000001, disable hook switch low to high transmission. SELN 00111011001010, select negative phase. SELP 001110110001, select positive phase. EO 001110111000, enable on hook dial. Do 0011101100101000, disable on hook dial. NOP 0000000000, no operation. 159. OLMS64 series. RN. OKI semiconductor. MSM6404. High-speed 4-bit single-chip microcontroller. General description. The OKI MSM6404 microcontroller is a low-power, high-performance single-chip device. Implemented in complementary metal oxide semiconductor technology. 32K bits of mask program. ROM, 1024 bits of data RAM, 36 input/output lines, a programmable timer/event counter, and oscillator are integrated onto one chip. Program memory is byte-wide and data paths are organized in 4-bit nibbles. RAM and I/O lines are bit addressable. 122 instructions include binary, BCD. Operations, bit set, reset, test, 8-bit I/O, relative jumps, multifunctional instructional, increment. Modify, skip, 8-bit wide table output, subroutine call and return. Features. 4000x8 mask ROM 32 stack levels, in RAM. An evaluation board is available for up to 8K. X8. LED direct drive available, 8 MA X5 ports at the same time. 256x4 RAM, including the stack area. 9x4 ports, 36 I/O lines. 4 lines for input ports having a latch, and the other 32 lines for bit operation are available. 3 built-in counters. 12-bit time base counter. 12-bit programmable timer. 8-bit high-speed programmable timer/event counter. Built-in 8-bit serial I/O register, with 3-bit counter. 5 interrupts with 5 priority levels. 4 internal, 1 external. Block diagram. Power down features. Instruction execution time. 952 ns 4.2 MHz clock. Instruction system suitable for control. 122 instructions. Mask option. P60-63 for input port. Full static operation. Low power consumption. Tip 0.4J1W at VU equals 2V. Tip 5J1W at VU equals 5V Hz clock. 5V single power supply, 42 pin dip or 44 pin flat. 1T. ROM. 4000x8. GND. 3210 3210 32 10 32 10 underscore 32 10 3210 into LL and ILCKCTO ELK TMOLSO TCK51 163 MSM 6404- Pin configuration. Top view, 42 pin plastic dip, top view, 44 pin plastic flat package. 000 G 0 0 0 0 IL P3 0 P32 P33 05 Co P73 P72 OSC reset P7 test P20 P70 P20 P2 P3 P2 P22 P82 P22 P23 P8 P23 POO P80 PO P3 P02 P2 P03 PLL PO 00 0ZZA A IL Pin description. Pin name input/output function. POO 4BIL input/output port. P01/SCK P02/S0 Input/output P01 to P03 are also used as serial interface. P03/SI Terminals. P10/CIN P11/TMO Input/output 4BIL input port with latch. P12/TCK built-in pull-up register for all bit input. P13 P20/int 4-bit input port with a latch. P20 is shared with int. P21 P22 Input Fall trigger input, P21, 23 are level input. P23 Built-in pull-up register for all bit input. P30-33 input/output 4-bit input/output port. P40-43 input/output 4-bit input/output port. 8-bit output port. P50-53 input/output 4-bit input/output port. P60-63 input/output 4-bit input/output port *1. P70-73 input/output 4-bit input/output port. P80-83 input/output 4-bit input/output port. OSCO Input/output XTAL connection terminal for system clock oscillation. OSC Test output, test terminal for maker. Reset input system reset input terminal. VDD Power source voltage supply. GND Note, when each port is used for output, it is possible to drive one TTL, one input. *1 can be made a support dedicated to input, mask option. 164. 0. If IL. P62. P6. P60. NC. P73. P72. P7. P90. P83. PA2. PA. 0 A, IL. When reset. 1. 1. The latch is reset. 1. 0. 0. 0. 0. 0. Oscillation. Wave. Pulse output. Dash. MSM 6404. Instruction list. Mnemonic escri plian code 6 eel cycle. LINAN 9N11. LLINLN 8N11. LHLINNHLNN 15NN22. LMINNM, W, NN14NN22. LAL 2111. LLALA 211. LAAH 2211. LHAHA 2 times 10 to the power of first 1. LAM AM 3811. LMAMA 2F11. LAM plus AM, LL plus 1 Skype if L equals 0 2411. C. 0 LAM AM, LL1, skip if L equals F2511A. Pound. TJ, LMA plus MA, LL plus 1 Skype if L equals O2611. JA. Minus 0. LMAMA LL1 Skype if L equals F2711. 0. Dash. LAMN, AMHHVN, 39 to 3611. LAMOMMAMD 10 mm 22. LMAOMMMDA 11 mm 22. LMTOMMMD, W, T, M, W, A, T equals ROM label 19 mm 23. LMCTM, W, CT 3 times 10 to the power of 59th 22. LCTM, W, 3 times 10 to the power of 51st 22. LMSRM, W, SR3E5A22. LSRM, W, 3 times 10 to the power of 52nd 22. LTMMTM, M, W, A, 3 times 10 to the power of 50th 22. Push STC, A, H, L, SP SP41C13. Pop C, A, H, L dash, ST SP SP plus 4113. XAM 2811. Q, XMAMHHVN, 29 to 2611. CLN, C. .CX plus AM, LL plus 1 Skype if L equals 03C11. X. LU. XAM, LL1 Skype if L equals F2C11. INA AA plus 1, skip if A equals 0311. CCQ. Q, EE. Q, INMMM plus 1 skip if M equals 03311. Q. Q, EO. INLLL plus 1 Skype if L equals 03111. 165. MSM 6404. Instruction list, continued. Mnemonic description code byte cycle. INHHH plus 1 Skype if M 03211. CINMDMMMDMD plus 1, skip if MD 012 mm 22. CI. E. DCAAA 1 Skype if AF 3411. CI. 0 DCMMM 1 Skype if MF 3711. Colon. DCLLL1, skip if FE 3511. DCHHH1 Skype if HF. E3611. DCMDMMMDMD1 Skype if MDF 13 mm 22. Adds AA plus M, skip if Psi 10211. ADCSA, CA plus M plus C, skip if Psi 10111. ADCACA plus M plus C 0311. ACE NA, A plus N, skip if psi13E4N22. DAAAA plus 60611. DOS AA plus 10OA11. And AAVM0011. A. Or AAVM0511. E. 5. EOR AAVM0411. CMAAAOB11. CIAAA plus 10C11. RAL rotate left with COE11. RAR rotate right with C of 11. TC Skype of C10911. SCC10711. RCC00811. Cal N Skype of AN3EN22. CLIN Skype of LN3E2N22. Q. CPIP, N Skype of PPN17PN22. E. 0. CMIN Skype of MN3E1N. 22. Cam Skype of AM1611. Tab N, skip if a bit, N, 154 to 5711. 0. A bit, N, dash 1 CISABN, 74 to 7711. Q. 0. 3 TMBN, skip if bit, N, 158-5B11. RMBN, bit, N, 068-6B11. 166. Dash. MSM 6404. Instruction list, continued. Mnemonic description code byte cycle. 5 megabytes N bit, N, dash 178-7B11. TFBN, skip if bit, N, equals 15C5F11. RFBN, bit, N, minus 06C6F11. SFB. C. N, bit, N, dash 17C7F11. TPBN, skip if bit, N, equals 150 to 5311. E. QLC. RPBN, bit, N, minus 060 to 63110. 3 SPBN bit, N, dash 170 to 73. 11. TPBDPN, skip if bit, N, equals 13BO322. RPBDPN, bit, N, equals 03DP-22. SPBDPN, bit, N, equals 13DPB22. MEL MEIF 13 times 10 to the power of 60th 22. MDI MEIF 03 times 10 to the power of 61st 22. EITB EITF 13 DC 922. EITM EITF 13 DC A22. EICT EITF 13 DC B22. EIEX EX 13 DC 822. DITB EITF 3 DC 522. DITM EITF 3 DC 622. DICT EITF 3 DC 722. DIEX EX 3 DC 422. CITITB skip if EITF equals 13 DC 122. 2. Q. ETITM skip if EITF equals 13 DC 222. TICT skip if EITF equals 13 DC 322. TIEX skip if EX equals 13 DC 022. TOEX skip if IROX equals 13 D222. TOTB skip if IROTB equals 13 DD022. TOTM skip if IROTM equals 13 DD122. TOCT skip if IROCT equals 13 DD222. TOSR skip if IROSR equals 13 DD322. ROEX IROX 03 D2422. ROTB IROTBO 3 DD422. ROTM IROTMO 3 DD522. ROCT IROCTO 3 DD622. ROSR IROSRO 3 DD722. 167. MSM 6404 Instruction list, continued. Mnemonic description code byte cycle. ECTCTF1, start, 3dBB22. 0.9 ESRSRF-1, start, 3dBA22. Equals. DCTCTFO, stop, 3dB722. DSRSRFO, stop, 3dB622. Dollar. TCT skip if CTF equals 1 3dB322. J. 0. JCPA. PCA. CoFF11. JPA2 PCA12 4 1222. CZPA. STPC plus 1, PC-2A. BA14. SPSP4. CALA 12. STPC plus 2, PCA12. A1224. SPSP4. LD. RTPC-ST, SPSP plus 4 IE14. RTS. PCST, SPSP plus 4. If 14. Skip unconditional. JAPC-PCA, plus 1 IA11. JMPC-M, W, A, IB12. IPAP211. B. IPDAPP3DPD22:JP. 0. JOPPA2311. 0. E. OPDPPPA3DPC22. NOP no operation 0011. EJ. Halt CPU 3dB8220. Stop clock 3dB922. 168. MSM 6404. Absolute maximum ratings. Parameter symbol conditions limits unit. Supply voltage VU-0.3 T07V. Input voltage 6 Ta equals 25 degrees C-0.3 to VOOV. Output voltage VO0.3 to VOOV. Ta equals 25 degrees Celsius per package 200 maximum MW. Power dissipation Po. Ta equals 25 degrees Celsius per output 50 maximum MW. Storage temperature TSTG, minus 55 to plus 150 degrees C. Operating range. Parameter symbol conditions limits unit. I, OSC, $1 MHz 3T06V. Supply voltage VU. I, OSC, $4.2 MHz 4.5 T05.5V. Data hold voltage VOOHI, OSC, equals Hz 2 T06V. Operating temperature top, minus 40 to plus 85 degrees C. MOS load 15. Fan out N. TTL load 1. DC characteristics. VU equals 5V plus or minus 10%, Ta equals minus 40 to plus 85 degrees C. Parameter symbol conditions min. Tip. Max. Unit. Input voltage 1, 2 VIH, 2.4, VUV. Input voltage 3, 4 VIH, 3.6, VUV. Input voltage VIL, -0:3, 0.8 V. H output voltage 1, 5 VOH 10 equals -15/LA 4.2, V. L output voltage *1 vol 10 equals 1.6 mA, 0.4 V. L output voltage *5 vol 10 equals 15/LA, 0.4 V. L output voltage *6 vol La equals BMA, 12 V. Input current *3 IIH/IIL6 equals VU/OV, 15/-15/LA. Input current 2, 4 IIH/IIL6 equals VU/OV, 1/-30/LA. H output current *L10 HVO equals 2.4 V minus 0.1 RNA. H output current *L10 HVO equals 0.4 V minus 1.2 RNA. Input capacity CI1 equals 1 MHz, 5. Output capacity Ta equals 25 degrees C. PF. Co. 7. VU equals 2 V, no load. 0.25/LA. Current dissipation Ta equals 25 degrees C. When stop condition, IOOS. No load, 1/100/LA. Current dissipation 100. Quartz oscillation. 612 RNA. 1 equals 4 MHz, no load. *1 applied to PO, PL, P3, P4, P5, P6, P7 and PB. *2 applied to P2, *3 applied to ASC. *4 applied to reset, *5 applied to 0SC7. *6, in using LED, total output current should be within the limit 0.1 power D. Dissipation in absolute maximum. Rating 169. MSM 6404-. AC characteristics. VU equals 5V plus or minus 10%, Ta equals minus 40 degrees to plus 85 degrees C. Parameter symbol conditions min. Tip. Max. Unit. Clock pulse width. IFW clock, OSC, 119 ns. Cycle time IC, 952 ns. Input data setup time TDS, 120 ns. Input data hold time TDH, 120 ns. Input data, input. TO, 120 ns. Clock pulse width. SR data setup time TSS, 120 ns. SR data hold time TSH, 120 ns. Data delay time TOR CL equals 15 pf, TSI plus 300 ns. Data delay time at TDCRCL equals 15 pf, 7/s TSI plus 300 ns. Mode switching. Data delay time at TOIL CL equals 15 pf, 6/s TSI plus 300 ns. Opt instruction. Data delay time at TDI2CL equals 15 pf, 7/s TCY plus 300 ns. Opt instruction. CT/TM data delay. TCT/TNCL equals 15 pf, 2/s TCY plus 360 ns. Time using TBC clock. SR/TM data delay. TSR/ITRCL equals 15 pf, TSI plus 4S0 ns. Time using PR clock. CT data delay time. TCRCL equals 15 pf, lowest TCY plus 4S0 ns. Using PR clock. CT data delay time. TCPCL equals 15 pf, 2/s TCY plus 360 ns. Using external clock. SR/TM data delay. Time using external teaspoon/LTPCL equals 50 pf, 360 ns. Clock. SR clock invalid time TSINH, 2/s TCY, ns. Int invalid time TRI-NH, I/s TCY, ns. 170. Dash. MSM 6404. Timing charts. Output condition. PO, P, P, PPP, PP, P. OSCO. 0,1,3. PA equals 4,5,6. 7 or A. TAC clock. CT. TM. PO. Clock SR. PI clock TM. P0 clock CT. PO, PO, Pi EXT clock. CT. SR. TM. CN. BBLKL. ITDR RTDCR. F. R TDI1 TD12 J 1 TCTCR J TTCP -0 teaspoon I -0 TTPF Output data to port will be SIOC for SR, TM, or CT. 171. MSM 6404. Input condition. 172. PO PLP. PP4, P. PPP. OSCO. 1 MC. 1 SR clock. TM clock. TDWI. 1 R1. POI SR clock. Input. PO, SI1 \data. TSS/TSH. 1 MC. OSCO. TSINH, POI, SR clock, INH period during LMSRINST. Note, POI is used for clock of SR. 1 / 1 \, 1 \, QINWPO, interrupt, INH period during RPB and RPBDINST. TSINH. MSM 6404. Tip. Current YS voltage for high state output. E. I. 0.9. Low, VOH. -1.0. -0.9. -0.8. -0.7. -0.6. -0.5. I. -0.4. -0.3 R. -0.2 I. -0.1. 0. R. VDD equals 6 VR. NVR \. I4V. \. \. \. 2 3 4 5 6 7. VOH, V. Tip. Maximum oscillator frequency YS. F, OSC, temperature. Ta. CL equals 15 PF. 11. 10. 9. 8. N 7. I. 6. U. DD equals 5 V. I. R. N. 9 5. 4. 3. 2. O. -40 -20 0 20 40 60 80 100. Ta, OC. Tip. Current YS. Voltage for low state output. E. J. 0.9. LOL, vol. 20. 18. 16. 14. 12. 10. 8. 6. 4. 2. 0. 6 V. I underscore VDD 5 V. Slash. I. 2 I. RL. 4 V. F // 3 V. 2 3 4 5 6 7 8 9 10. Vol. V. Tip. Maximum oscillator frequency YS. 11. 10. 9. 8. and 7. I. 6. U. N. 9 5. 4. 3. 2. 0. F. OSC, supply voltage. VU. Ta equals 25 degrees C, CL equals 15 PF. Slash. V. Slash. 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 2 3 4 5 6 7 8. VDD, V. 173. EMSM 6404E dash 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 5 C. 0.9 174. Tip. Supply current vs. Supply voltage. Odd, VDD. Ta equals 25 degrees C, no load. 10 M. 1 M. 1001. 101. 11. 100 N. O. 1 I, SC, equals 4 MHz. 2 JHz. V. 1 JHZ. 500 kHz. 100 kHz. Slash. IO Hertz. I. 2 3 4 5 6 7 8 9 10. VU, V. OKI and ME conductor. MSM 6404 VS. MSM 6404 piggyback. General description. The MSM 6404 VS is a device whose built-in ROM is replaced by external EPROM using the piggyback method. Features. Supply voltage, 5V plus or minus 5% frequency, DC, 4.2 MHz operating temperature, 0 to 70 degrees Celsius. Note, there are a few differences in the electrical characteristics of this chip and the evaluation chip. Please refer to next page for the detail. Putting method of ROM. Please refer to drawing below. Pin configuration. M6404 VS. OKI. Japan 4x30. Pin connection between MSM 6404 VS and EPROM. 2A0A12. Of MSM 6404 VS sent. Address. To DL0D711 data. Of MSM 6404 VSY. Note, when putting 2732A. Pin 1, 2, 27, 28 are not used. V. A12I. All. 10. 9. 8. 7. 6. 1. J2. 1. 2. 3. 4. 5. 6. 0 7. GND. Underscore VPP1-28 VCC. A 12227 PGM. A 7326 N.C. A 6425 A8. A 5524 A9. A 4623 all. A 37276,422 A 2821. AL 920 CE. AO 10 1907. 0011 1806. 01 12 1705. 02. RGND 14 1503. 175. EMSM 6404 VSE. Differences between MSM 6404 and MSM 6404 VS, piggyback. Item 6404 6404 VS, piggyback. 1 port po, 1,3 are set to 1 and port po, 1,3 are set to 1 and port 2. Initialization 2,4, 5, 6, 7, 8 are reset to 0, 4, 5, 6, 7, 8 are reset to 0 during reset. During reset directly by signal put into the cycle being executed. Reset. 2 timer after being reset, timer stops. It is undecidable whether the timer operation counting until data are set in it starts counting or not after being reset. Therefore, the timer should be initialized by software. 3 shift register serial out f/f, soft/f, is set to 0. It is undecidable whether serial out after being reset. f/f, soft/f, is set to 0 or 1 after being reset. Therefore serial out f/f should be initialized by software. 4 port. Internal clock input/output. Timing. 1t. Data are input. At this moment. Synchronized. Internal clock with falling edge internal clock. J1SL. C equals. K equals. Data are output. At this moment. TTLFO equals 1 LSTLFO equals 1. 5 port. LOL equals 1.6 Ma 0.4 V, LOL equals 0.4 Ma 0.4 V. Input/output. Maractiris. VDD ticks. 4. P20-3 TTL compatible input CMOS input. POOP83E90. POO83OTO. Except P20-3, except P20-3. Available 4K byte, accessible up to 8K byte. ROM capacity. IPL call not available. Instruction 176. OKI semiconductor. MSM6408. High-speed 4-bit single-chip microcontroller. General description. The OKI MSM6408 microcontroller is a low-power, high-performance single-chip device. Implemented in complementary metal oxide semiconductor technology. 64K bits of mask program. ROM, 1024 bits of data RAM, 36 input/output lines, a programmable timer/event counter, and oscillator are integrated onto one chip. Program memory is byte-wide and data paths are organized in 4-bit nibbles. RAM and 110 lines are bit addressable. 122 instructions include binary, BCD. Operations, bit set, reset, test, 8-bit 110, relative jumps, multifunctional instructional, increment. Modify, skip, 8-bit wide table output, subroutine call and return. Features. 8096x8 mask ROM. An evaluation board is available for up to 8K. X8. 256x4 RAM, including the stack area. 9x4 ports, 36 I/O lines. 4 lines for input ports having a latch, and the other 32 lines for bit operation are available. 3 built-in counters. 1 2-bit time base counter. 1 2-bit programmable timer. 8-bit high-speed programmable timer/event counter. Built-in 8-bit serial I/O register, with 3-bit counter. 5 interrupts with 5 priority levels. 4 internal, 1 external. Block diagram. 32 stack levels, in RAM. LED direct drive available, SMAX5 ports at the same time. Power down features. Instruction execution time 1.0/ls 4.0 MHz clock. Instruction system suitable for control. 122 instructions. 0 mask option I. P60-63 for input port. Full static operation. Low power consumption. Tip 0.4/LW at VDO equals 2V. Tip 5/LW at VDD equals 5V Hz clock. 5V single power supply, 42 pin dip or 44 pin flat. ROM. B000X8. VOD. GND. 3210 3210 3210 3210 3210 3210 3210 3210 into IL, ILCK etc. ELK. LTCK LSI. 177. EMSM 640 SE dash 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 dash. Pin configuration. Top view, 42 pin plastic dip 44 pin plastic flat package. P40. P41. P2L. P22. P23. P00. POI. P02. P03. Pin description. Pin name input/output. P00. P01/SCK. P02/S0. Input/output. P03/S1. P10/CIN. P11ITMO. Input/output. P12/TCK. P13. P20/LNT. P21. P22. Input. P23. P30-33 input/output. P40-43 input/output. P50-53 input/output. P60-63 input/output. P70-73 input/output. POA3 input/output. N_0. 0, NL. C. If. P31. P32-0. P33. OSC. ESC. REI. Test. P20. P21. P22. P23. 80F000N, ZZA, A. 0. Function. 4-bit input/output port. P01 to P03 are also used as serial interface. Terminals. 4-bit input port with latch. Built-in pull-up register for all bit input. 4-bit input port with a latch. P20 is shared with int. Input. Fall trigger input, P21, 23 are level input. Built-in pull-up register for all bit input. 4BLT input/output port. 4-bit input/output port. A-bit output port. 4-bit input/output port. 4BLT input/output port *1. 4BLT input/output port. 4-bit input/output port. OSC. Input/output X-TAL connection terminal for system clock oscillation. OSCI. Test output, test terminal for maker. Reset input system reset input terminal. VU. Power source voltage supply. GNO. Note, When each port is used for output, it is possible to drive one TTL, one input. *1 can be made as a port dedicated to input, mask option. 178. If PE2, PEL, P60, NC, P73, P72, P71, P90, P63, P82, P81, 0. When reset. 111. IL. The latch is reset. L. 0. 0. Lion. 0. 0. Oscillation. Wave. Pulse output. Dash. MSM 6408. Instruction list. Mnemonic description code byte cycle. LINAN9N11. LLINLN8N11. LHLINNHLNN15NN22. LMINNM, W, NN14NN22. LAL2111. LLALA2D11. LAH2211. LHAHA 2 times 10 to the power of first 1. LAM AM3811. LMAMA2F11. LAM plus C. AM, LL plus 1, skip if L equals O2411. LAM AM, LL1, Skype if L equals F. Pound. 2511. RTL. Colon LLMA plus MA, LL plus 1 Skype if L equals 02611C. Minus 0. LMAMA, LL1 Skype if L equals F271011. 0. J. LAM N. AMHHVN 39-3B11. LAMD MMAMD 10 mm 22. LMAD MMMDA 11 mm 22. LMTD MMMD, W, T, M, W, A, T equals ROM table 19 mm 23. LMCTM, W, CT 3 times 10 to the power of 59th 22. LCTM, W, 3 times 10 to the power of 51st 22. LMSRM, W, SR3E5A22. LSRM, W, 3 times 10 to the power of 52nd 22. LTMM, W, A, 3 times 10 to the power of 50th 22. Push STCAHL, SPSP41C13. Pop C, A, H, L, STSPSP plus 41D13. XAM2811. Q. CLXMN. AMHHVN 29 to 2811C. 01.C. 0x plus AM, LL plus 1, skip if L equals 03C11. W. XAMLL1 Skype if L equals F2C11. INA AA plus 1, skip if A equals 0311C. C, Q. Q, E. INMAM plus 1, skip if M equals 03311 EQ. I. GG. INLLL plus 1 Skype if L equals 03111 underscore 0. 179. MSM 6408. Instruction list, continued. Mnemonic description code byte cycle. INHHH plus 1. Skype if M equals 03211. C. INMD MMMD MD plus 1. Skip if MD equals 012 mm 22Q. E. DCAAA1. Skip if A equals F3411. 0. Q. CLDCMMM1.SkypeFM equals F3711. R. Q. DCLLL1.SkypeFL equals F3511. E. 0 DCHHH1.SkipIfH equals F3611. E. DCMDMMMDMD1.SkypeIfMD equals F13mm22. Adds A plus M. Skip if psi equals 10211. ADCSAC, A plus M plus C. Skip if psi equals 10111. ADCA.CA plus M plus C0311. ACE NAA plus N. Skip if psi equals 13E4N22. DAAAA plus 60611. DOS AA plus 10OA11. 0. And AAVM0011. Or AAVM0511A. EOR AAVM0411. CMAAAOB11. CIAAA plus 10C11. RAL rotate left with COE11. RAR rotate right with C of 11. TC Skype of C equals 10911. SCC 10711. RCC00811. Cal N skip if A equals N3EN22. CLIN Skype if L equals N3E2N22. As CCPIP.N skip if PP equals N17PN22. E. 0. Cam Skype if A equals M1611. Tab N2 skip if a bit, N2, equals 154 to 5711. R, Rab N2 a bit, N2, dash 064 to 6711. 0. SAB N2 a bit, N dash 174 to 7711 Q. C. 0. 3 TMB N2 skip if bit, N, equals 158-5B11. RMB N2 bit, N2, dash 068 to 6811. 180. Dash. MSM 6408. Instruction list, continued. Mnemonic description code byte cycle. 5 megabytes N bill, N. L78-7B11. TFBN, skip if FBI. N, equals 15C5F11. RFBN, FBI, N, 06C6F11. CSFBN, FBIL, N. L7C7F11. 0. TPBN, skip if LBIL, N, equals 150 to 5311. CDC. 0 RPBN. LBIL, N. 060 to 6311. 3. SPBN LBIL, N. L70 to 7311. TPBOPN, skip if bill, N, equals 130 PO 322. RPBOPN, PPBLL, N, equals 030 P-722. SPBOPN, bill, N, equals 13 DPBB22. MEL MEIF 13 times 10 to the power of 60th 22. MOL MEIF 03 times 10 to the power of 61st 22. EITB EITF 130 C922. EITM EITF 130 CA22. EICT EICF 13 DCB22. EIEX EIXF 130 C822. OITB EITF 03 DC522. OITM EITF 30 C622. OICT EICF 30 C722. OIEX EIXF 30 C422. TLTB skip if EITF equals 13 DC122. 15. TLTM skip if EITF equals 13 DC222E. TICT skip if EICF equals 130 C322E. TLEX skip if EXF equals 130 code 22. TOEX skip if IROX equals 13022. TOTB skip if IROTB equals 13022. TOTM skip if IROTM equals 1300122. TOCT skip if IROCT equals 1300222. TOSR skip if IROSR equals 1300322. ROEX IROXO 302422. ROTB IROTBO 300422. ROTM IROTMO 300522. ROCT IROCTO 300622. ROSR IROSRO 300722. 181. MSM 6408. Instruction list, continued. Mnemonic description code byte cycle. ECTCTF-1, start, 30BB22. 0.9 ESRSRF-1, start, 30BA22. Dot. E. CNOC-CTF-0, stop, 30B7. 22. OSRSRF-0, stop, 30B622. 0.2 L. C. TCT skip if CTF equals 130B322 L. 0. TSR skip if SRF equals 130B222. JCPAEPCAE CoFF11. JPA2PCA24222. LJPA3PCA133F34. CZPA. ST, PC plus 1 PC-2A. BA14. SPSP4. STPC plus 2 PCA2. Pound Cala 2. SPSP4. A1224. RTPC ST, SPSP plus 4 IE14. RTS. PCST, SPSP plus 4. If 14. Skip unconditional. JAPC PCA, plus 1 IA11. JMPC, M, W, A, IB12. IPAP211. L. 0.9 IPOPAPP30 PO22. L. 0. 5 OPPA2311. Co. E. OPOPPPA30 PC22. NOP no operation 0011. E: L. F. Halt CPU 30B822. Stop clock 30B922. 182. Dash. MSM 6408. Absolute maximum ratings. Parameter symbol conditions limits unit. Supply voltage VU-0.3 T07V. Input voltage 6 Ta equals 25 DC minus 0.3 to VV. Output voltage VO minus 0.3 to VV. Ta equals 25 DC per package 200 maximum MW. Power dissipation Po. Ta equals 25 DC per output 50 max MW. Storage temperature TSTG-55 to plus 150 DC. Operating range. Parameter symbol conditions limits unit. F, OSC, 1 MHz 3T06V. Supply voltage VU. F, OSC, 4.0 MHz 4.5 T05.5V. Data hold voltage VOOHF, OSC, equals 0 Hz 2 T06V. Operating temperature top, minus 40 to plus 85 DC. MOS load 15. Fan out N. TTL load 1. DC characteristics. VU equals 5V plus or minus 10%, Ta equals minus 40 to plus 85 DC. Parameter symbol conditions min. Tip. Max. Unit. H input voltage 1, 2 VIH, 2.4, VV. H input voltage 3, 4 VIH, 3.6, VV. L input voltage VIL, minus 0.3 to 0.8 V. H output voltage 1, 5 VOHIO equals dash 15 F. A 4.2, V. L output voltage asterisk 1 vol IO equals 1.6 mA, 0.4 V. L output voltage asterisk 5 vol 10 equals 15 F. A, 0.4 V. L output voltage asterisk 6 vol IO equals BMA, 12 V. Input current 3 IIH slash IIL6 equals VU slash OV, 15 slash dash 15 F. A. Input current 2, 4 IIH slash IIL6 equals VU slash OV, 1 slash dash 30 F. A. H output current asterisk 1 IOHVO equals 2.4 V minus 0.1, RNA. H output current asterisk 1 IOHVO equals 0.4 V, minus 1.2 RNA. Input capacity CIF equals 1 MHz, 5. Output capacity COTA equals 25. DC. 7. PF. VU equals 2 V, no load. 0.25 F. A. Current dissipation Ta equals 25 DC. When stop condition, IOOS. No load, 100 F. A. Current dissipation 100. Quartz oscillation. I, 612 RNA. F equals 4 MHz, no load. Asterisk 1 applied to PO, P1, P3, P4, P5, P6, P7 and P8. Asterisk 2 applied to P2 asterisk 3 applied to OSCO asterisk 4 applied to reset asterisk 5 applied to OSC. Asterisk 6 in using LED, total output current should be within the limit of power dissipation in absolute maximum. Rating 183. MSM 6408. AC characteristics. VU equals 5V plus or minus 10%, Ta equals minus 40 to plus 85 degrees C. Parameter symbol conditions min. Tip. Max. Unit. Clock pulse width. TQW 125 ns. Clock, OSC. Cycle time TOI, 1/ls. Input data setup time TOS, 120, ns. Input data hold time TO, 120, ns. Input data, input. TO, 120, ns clock pulse width. SR data setup time TSS, 120, ns. SR data hold time TSH, 120, ns. Data delay time TOR CL equals 15 pf, TSI plus 300 ns. Data delay time at TDCRCL equals 15 pf, 7/STCY plus 300 ns mode switching. CT/TM data delay. TCT/TTTCL equals 15 pf, 2/STCY plus 360 ns time using TBC clock. SR/TM data delay. TSR/TTRCL equals 15 pf, TSI plus 4S0 ns time using PR clock. CT data delay time. TCRCL equals 15 pf, 10/STCY plus 4S0 ns USING PR clock. CT data delay time. TCPCL equals 15 pf, 2/STCY plus 360 ns. Using external clock. SR/TM data delay. Time using external teaspoon/TTPCL equals 50 pf, 360 ns. Clock. SR clock invalid time TSINH, 2/stcy, ns. Int invalid time tllnh, l/stcy, ns. 184. Dash. MSM 6408. Timing charts. Output condition. PO PP. PPP. P. P. OSCO. 0, 1, 3. PA equals 4, 5, 6. 7 or 8. PA equals gar A. PO. CT. P. TBC clock TM. PO. P. PO. Clock SR. P clock TM. PO clock CT. P.O PO P. EXCIC. CT. S. TM. 0 \VN. ITDR dash dash, dash dash. I dash TDCRJ dash. TSRT. TTR. L. 1 \, F dash TCP. Teaspoon. TTPI. Output data to port will be clock for SR, TM, or CT. 185. EMSM 640 SE dash 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 dash. Input condition. 186. PO. PIP. PPP. PP. P. OSCO. SR clock. TM clock. POI SR clock. OSCO. LMC. I \, J. TDWF4. Input B. Data. TSSTSH. LMC. TSINH, POI, SR clock, INH period during LMSRINST. Note, POI is used for clock of SR. TTINH, PO, Jane Terap len H period during RP band RPBDINST. TSINH. Dash. MSM 6408. Tip. Current Vs voltage for high state output. Low, VOH. Ta 25 degrees Celsius. Minus 1.0. Minus 0.9. Minus 0.8. Minus 0.7. Minus 0.6. Dot E minus 0.5. C. Minus 0.4. 0.9. Minus 0.3. Minus 0.2. Minus 0.1. 0. F. Dash dot, VU6V. L dash. VF \, L. 4V \, \F I. \, 2 3 4 5 6 7. VOH, V. Tip. Maximum oscillator frequency Vs. NC. U. Till. Q. 1. 10. 9. 8. 7. 6. 5. 4. 3. 2. 1. O. HOSC. CL15PF. T dash. Temperature. Ta. VU5V. 1 dash 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 T dash dash. R. Minus 40 minus 20 0 20 40 60 80 100. Ta. C. Tip. Current Vs. Voltage for low state output. Dot E. L. .9. LOL, vol. 20. 18. 16. 14. 12. 10. 8. 6. 4. 2. 0. Ta 25 degrees Celsius. 6v// IVU 5v slash 1 slash FJ comma 4v F slash I3v 2 3 4 5 6 7 8 9 10 vol v tip maximum oscillator frequency Vs HOSC supply voltage VU Ta 25 degrees Celsius CL 15 PF 11 10 9 V 8 N 7 C 6 V slash U till Q5 I 2 4 slash 3 2 0 2 3 4 5 6 7 8 VU V 187 OKI semiconductor MSM 6411 CMOS 4-bit single-chip microcontroller. General description. The OKI MSM 6411 microcontroller is a low-power, high-performance single-chip device. Implemented in complementary metal oxide semiconductor technology. 1024 x 8 bits of program ROM, 32 x 4 bits of data RAM, 11 input/output lines and oscillator. Program memory is byte wide. And data paths are organized as 4-bit wide. 63 instructions include binary, logical operations, bit set, reset, test, multifunctional. Features: 1024 x 8 internal ROM, 32 x 4 internal RAM, 11 I/O lines, 8 I/O lines, 3 input lines, 8-bit serial I/O register, 2 interrupt levels, 8 stack levels, LED direct drive available, SMAX5 ports at the same time, 952 NS 4.2 MHz, VU 5V plus or minus 10%. Functional block diagram. Int 188 8180 Psi 63 instructions. Self-contained oscillator. -40 to +85 degrees C operating temperature. 3 to 6 V operating VU. Low power consumption 5W typical. Stop, VU equals 5V, no load. Mask option crystal/ceramic. Oscillator. INST. DEC. Reset OSC. OSC. ROM. 1024 x 8. RR. VUND. E. MSM 6411. E. Logic symbol pin configuration. Top view. 16-pin plastic dip, RS. 5V VU. SI. L. VU. OV2. PO. Reset. SCK. 10P10. 0. Clock. 31P02/S0. 21. 2. 11P01/SCKA. P20. J. Int 0. Pin description. Designation input/output pin no. Function reset. P0010 4 bits 1/0 port. P01/Psi. Input/output. 11P01 to P03 are used both 1/0. 1P02/S012. Port and terminal of shift resistor. P03/S113. P1014. P11. Input/output. 15. 4 bits 1/0 port 1. P12-1. P13-2. P20/LNT33 bits input port with latch. Latch is reset. P21 input for P20 is used as both input port and 0. P22-5 input terminal of int, input of falling edge trigger. OSCO input 7 input terminal of system clock. Clock pulse in. Oscillation circuit consists of OSCO and OSCI. 0 SC1 output 6 oscillation circuit consists of OSCO and OSCI. Reset input 9 input terminal of system reset. VDD16 main power source and circuit. GND. Input. 8 GND potential. 189. EMSM 6411 Functional description. ROM. ROM is organized in 1024 words by 8 bits. It is used to store developed application programs, instructions. It is addressed by the program counter, PC. PC. The PC consists of a 10-bit binary counter and is used to address ROM. Stack and stack pointer. An interrupt or cal instruction causes the contents of the PC to be saved in the stack. The PC is restored from the stack by RT instruction. All RAM locations, up to 8 levels, are available as the stack. Note that 4 words of RAM are used for each level. The stack pointer is a 5-bit up-down counter that points to the address of the next stack to be used. It allows the RAM locations to be used as a push-down stack. RAM. RAM consists of up to 32 words 4 bits wide. It is addressed by the H and L registers or by the contents of the second byte of an instruction. L register. A 4-bit register which specifies RAM locations A3-A0. H register. A L-bit register which specifies RAM location. A 190. ALU. A 4-bit logic circuit that provides arithmetic and logical operations. ACC. Consisting of a 4-bit register, the accumulator holds the result of operations or the data present on ports. Flag. The flag that holds a carry generated from the result of operations. Input/output ports, 2x 4-bit. Organized into 4 bits, 2 ports are provided for affecting and controlling data transfer to and from an external source. The ports are selected by codes included in instructions. Input ports, 1x 4-bit. Contained port 2, P2, which is an input port with latching function. P20 is set at falling edge of the input signal. P21 and P22 are set at 0 level inputs. Also, P20 is used as an interrupt request flag. When P20 is set and an interrupt operation occurs, it is automatically reset. Timing control, TC. A 0 level on the reset pin for longer than 2 machine cycles initializes the internal circuitry. Clock pulses are supplied to the XT pin from an external source. Also, by mask option, it Organizes a circuit of oscillation with P20 and produces clock pulses, by connecting externally to crystal, ceramic, or CR. MSM 6411. Instruction list. Mnemonic description code byte cycle. LINA plus N90-9F11. LLINL plus N80-8F11. LHLINNHL plus NN15NN22. LAL-A plus L2111. 0. LLAL plus A2D11. LAM-A plus M3811.C. UI. I. LMAM plus A2F11C. C. LAMDA plus MD 10 mm 22 as mm. 0. J. LMAD MMMD plus A 11 mm 22. LMSRM, W, plus SR3E5A22. LSRM-SR plus M, W, 3 times 10 to the power of 52nd 22. Push ST plus C, A, H, L, SP plus SP11C13. Pop C, A, H, L plus ST, SP plus SP plus 11D13. IPDPA plus PP3DPD22:I. Minus 0. Colon 1. 0::1. OPDPP plus A3DPC22 equals 0p. Adds A plus M, skip if psi equals 10211. ADCC A plus M0311. ACE N A plus N, skip if psi equals 13E4N22. DOS A plus 10OA11. And A plus AAMOD11. Degree. EORA plus ABM0411. E. Equals, CMAA plus AOB11. CAM Skypifa equals M1611. SCC plus -10711. RCC plus HO0811. TC skip if C equals 10911. RAL. RA ___________. OE11. Q. C plus -3 plus -2 plus -1 plus degree I. Underscore C. Dot. XAM2811, J. Woo. INLL plus L plus 1, skip if L equals 03111C. CCD. CDE. INHH plus H plus 1, skip if H equals 03211 ECD. CD. 0. Degree CDINMM plus M plus 1, skip if M equals 03311 equals 0. 191. MSM 6411-. Instruction list, co-nt. Mnemonic description code byte cycle. INMOMMMD, MD plus L, skip if MD equals 012 mm 22. CCO. OCLL, LL, skip if L equals F3511. E. I. OKHHLU 361100. .eo. OCMM, ML, skip if M equals F3711. Tab N2 skip if a bit N2 equals 154 to 5711. TMB N2 skip if M bit N2 equals 158-5B11. C. RMB M bit N2, 068-6B0 N211. 5 megabytes N2 M bit N2, 178-7B11. 0. TPBOP N2 skip if PP bit N2 equals 13DPO322. 3. RPBOP N2 PP bit N2, 030P4-722. SPBOP, N2 PP bit N2, 130PBB22. JCP is 6 PC is 6 CoFF11. JPL0 PCL0 4043 22.T 00FFU CS ST PC plus 2 PC AL0 A0A3 Tilcal AL0 SPSPLOOFF 24 RTPC ST SP SP plus LLE14 MEL MEIF-L 3 times 10 to the power of 60th 22 Mol MEIF-O 3 times 10 to the power of 61st 22 EICT-EIF-L 30 CB 22 EIEX-EX-L 30 C8 22 OICT-EIF-O 30 C7 22 is OIEX-EX-O 30 C4 2 23 L E TICT skip if EIF equals 130 C3 22 TIEX skip if EX equals 130 code 22 TQEX skip if IRCX equals 13022 TQSR skip if IRCSR equals 1300322 RQEX IRCX-O 3024 22 RQSR IRCSR-O 3007 22 ESR SRF-130 BA 22.9 equals dot AOSR SRF-O 30 B 622 RN dot TI N TSR skip if SRF equals 130 B 222 0 stop clock 30 B 922 colon dash equals ILC NOP no operation 001 OG 1 192 dash MSM 6411 absolute maximum rating parameter symbol conditions limits unit supply voltage VDD -0.3 -7 V input voltage 6 Ta equals 25 degrees Celsius -0.3 VDD V output voltage VO -0.3 VDD V Ta equals 25 degrees Celsius 200 maximum MW per 1 package power dissipation PD Ta equals 25 degrees Celsius per 1 output 50 maximum MW storage temperature TSTG -55 to +150 degrees C operating conditions parameter symbol condition limits unit F OSC 1 MHz 3 to 6 V supply voltage VDD F OSC 4.2 MHz 4.5 -5.5 V data hold voltage VDD HHOSC equals OHz 2 to 6 V operating temperature top -40 +85 degrees C MOS load 15 fan out N TTL load 1 193 MSM 6411 DC characteristics VU equals SV plus or minus 10%, Ta equals -40 to +8 S0 C parameter H input voltage *1 *2 H input voltage *3 *4 L input voltage H output voltage *1 *5 L output voltage *1 L output voltage *5 L output voltage *6 input current *3 input current *2 4 H output current 1 H output current 1 input capacitance output capacitance power consumption stop power consumption 1 applied to PO and P1 2 applied to P2 3 applied to ASIA 4 applied to reset *5 applied to OSC1 symbol VIH VIH VIL VOH VOL VOL vol. 2. Il. I. Il. 10h. 10h. CI. Co. IOOS. 100. Condition. 10 equals dash 1s slash LA. 10 equals 1.6 ma. 10 equals 1s slash LA. Low equals 8 ma. 6 equals vu slash OV. 6 equals vu slash OV. VO equals 2.4 V. VO equals 0.4 V. F equals 1 MHz, Ta equals 25 degrees Celsius. VOD equals 2 V, no load. Ta equals 25 degrees Celsius. No load. Crystal oscillation. No load, 4.2 MHz. Min. Tip max. Unit. 2.4, VuV. 3.6, VuV. Minus 0.3 to 0.8 V. 4.2, V. 0.4 V. 0.4 V. 1.2 V. Minus 15 slash LA. AO. Slash LA. Minus 0.1, RNA. Minus 1.2 RNA. 5. PF. 7. 0.25 slash LA. 100 slash LA. 612 RNA. 6 In using LEO, total output current should be within the limit of power dissipation in absolute maximum. Rating. 194. Dash. MSM 6411. AC characteristics. VDD equals 5V plus or minus 10%, Ta equals minus 40, plus 85 degrees C. Parameter symbol condition min. Tip max. Unit. Clock, OSCO, pulse width T slash, W, 119, NS. Cycle time TCY, 952, NS. Input data setup time TDS, 120, NS. Input data hold time TDH, 120, NS. Input data slash input clock. TDW, 120, NS pulse width. SR clock pulse width TSW, TRJ1.W, NS. SR data setup time TSS, 120, NS. SR data hold time TSH, 120, NS. Data delay time TDRCL equals 15 PF. TCY. NS. Plus 300. SR data delay time TSRCL equals 15 PF. TCY. NS. Plus 480. SR data delay time. Teaspoon CL equals 15 PF, 360 NS using external clock. SR clock invalid time TSINH. 2/8. NS. TCY. When SR clock is oscillated by alternate output of 1 or 0 to P01. 195. MSM 6411 dash. Timing chart. 196. OSCO. PO, P1, P2. PO P1. P02/S0. P01/SCK. P03/SI. P02/S0. P2. OSCO. P01/SCK inhibit period. During LMSRINST. Dash 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 1 MC dash 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 dash. TCY. OSTOH. Tour. TSR. IRLU. TSW TSW. IRI. INPULI. OATA. H. X. Dash. Teaspoon. Dash 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 1 MC dash 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 MSM 6411. Tip. Maximum oscillator frequency. F. OSC. YS supply voltage. VDD. Ta equals 25 degrees C. CL equals 15 PF. 10, 9, 8, 7, and 6. R. S5. 6. 4N. G. 3. 2. 1. 0. V. V. Slash. 1 slash. J. 1 2 3 4 5 6 7 8 9 10. VDD, V. Tip. Maximum oscillator frequency. F. OSC. YS temperature. Ta. CL equals 15 PF. 10. 9. 8. 7. I. R dash. R. VDD equals 5V. N. 6R. S5. 6. and 4. G. 3. 2. O. Minus 40 0 40 80 120. Minus 20 20 60 100. Ta. OC. Tip. Current YS voltage for high state output. Low, VOH. Minus 1.0. Minus 0.9. Minus 0.8. Minus 0.7. Dot S. F. R. Minus 0.5. 9. Minus 0.4. R. Minus 0.3. 4V. R. Minus 0.2. Minus 0.1. T. 0. VDD equals 6V. T backslash. 5V backslash. 1 backslash 1 backslash. Backslash. 1 backslash R backslash 1 backslash. R backslash. 2 3 4 5 6 7 8 9 10. VOH, V. Tip. Current YS voltage for low state output. 20. 18. 16. 14. 12. J8. 9. 6. 4. 2. 0. LOL, vol. 6VJL VDD equals 5V. 117. Slash. 71, 4V. I. R7. 3V. 17. 2 3 4 5 6 7 8 9 10. Vol. V. 197. MSM 6411-5. D. FL. 198. Tip. Supply current vs supply voltage. 10 M. 1 M. 100 IL. 1 oil. 1 IL. 100 N. 2, V. 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 Slash. IV. V. Slash. Slash. V. Slash. V. V. Slash. 1, dash dash. V. 1, dash dash. V. V. Ta equals 25 degrees C. No load. Hose, equals 4 MHz. I. 2 MHz, I. 1001 MHz. I. 500 kHz. LJ. L0 Hz. 0123456789110. VDD, V. OKI Semiconductor. MSM6422. CMOS 4-bit single-chip microcontroller. General description. The OKI MSM6422 is a low-power, high-performance single-chip device implemented in complementary metal oxide semiconductor technology. Integrated onto a single chip are 16K bits of mask program ROM, 256 bits of data RAM, 18 input/output lines and oscillator. Program memory is byte-wide and data paths are organized in 4-bit nibbles. RAM and 1/0 lines are bit addressable. 63 instructions include binary, BCD operations, bit set, reset, test, subroutine call and return. Features: low power consumption, 30 MW typical, 2048x8 internal ROM, 64x4 internal RAM. 18 1/0 lines include 8-bit data bus. Self-contained oscillator. 63 instructions. 2 interrupt levels. 16 stack levels. Functional block diagram. W. JV. 10 3210 3210 3210. LED direct drive available, 8 mA X5 ports at the same time. -40 to +85 degrees C operating temperature. 4.5 to 5.5 V operating VDD at 4.2 MHz. 3 to 6 V operating VDD at 1 MHz. TTL compatible. 952 ns cycle time at 4.2 MHz. VDD 5V plus or minus 10%. 1111. I12B, NBCL plus. TT. 3210 0. IGV. No. Do. N. T. ROM. 2048x8. Timing. And. Control. I11. 00R. SSE. CCS. 10E. T. 199. EMSM6422.E. Logic symbol, top view. 24-pin plastic dip, Rs. Pin description. Terminal symbol. POO. P01. P02. P03. P10. P11. P12. P13. P30. P31. P32. P33. P40. P41. P42. P43. P50. P51. P20/int. OSCO. OSC. Reset. VDD. GND. 200. VU. P5. P43. P33. P32. P3. P30. Input/output. IO. IO. 110. IO. IO. Input. Input. Output. Input. Input. 24-pin flat package. O. Function reset. 4-bit I/O ports. Pseudo bidirectional 1. Configuration. 4-bit I/O ports. Pseudo bidirectional 1. Configuration. 4-bit I/O ports. Pseudo bidirectional 1. Configuration. 4-bit I/O ports. Pseudo bidirectional 0. Configuration. 2-bit I/O ports. Pseudo bidirectional 110. Configuration. 1-bit input port with a latch. Combined use within the latch is interrupt input, falling edge reset to 0. Trigger input. System clock, SYSCLK. Input terminal. This provides an oscillation circle with OSC, terminal. System clock output. Terminal. This provides an oscillation circle with OSCO terminal. Reset input terminal. Power supply terminals. Dash. MSM6422. Functional description. Program ROM. Organized into as many as 2048 words by 8 bits, ROM is used to store developed application programs, instructions. It is addressed by the program counter, PC. Data RAM. RAM consists of up to 64 words 4 bits wide. It is addressed by the H and L registers or by the contents of the second byte of an instruction. Input/output ports. 18 input/output port lines are provided for affecting and controlling data transfer to and from an external source. The ports are selected by codes included in instructions. P20/LNT pin, 1 line. A low on this interrupt input pin sets the interrupt request flag. The flag is automatically reset when an external interrupt occurs. The line can be used as an input port when interrupt is not used. 12-bit time base counter, TBC. The time base counter consists of a 12-bit binary counter. An interrupt request is generated each time an overflow occurs from the division of OSCD input signals by 2 feet 2 inches. Program counter, PC. The program counter, PC, consists of a 11-bit binary up counter. It is used to address ROM. Stack and stack pointer, SP. An interrupt or subroutine call, CAL, causes the contents of the program counter to be saved. Absolute maximum rating. Parameter symbol. Supply voltage VDD. Input voltage 6. Output voltage VA. In the stack, the program counter is restored from the stack by the RT instruction. All RAM locations, up to 16 levels, are available as the stack. Note that 4 words of RAM are used for each level. The stack pointer is a 4-bit up-down counter that points to the address of the next stack to be used. It allows the RAM locations to be used as a push-down stack. L register. A 4-bit register which specifies RAM low. Cations A3AO. H register. A 4-bit register whose 2 low-order bits specify RAM locations A5, A4. ALU. The 4-bit logic circuit that provides arithmetic and logical operations. Accumulator, ACE. Consisting of a 4-bit register, the accumulator holds the result of operations or the data present on ports. C flag. The flag that holds a carry generated from the result of operations. Timing control, TC. A 0 level on the reset pin for longer than a predetermined period initializes the internal circuitry and ports. Clock pulses are supplied to the OSCD pin from an external source. A crystal or ceramic oscillator may be connected to OSCD and OSC. To form an oscillator circuit to produce clock pulses. Conditions limits unit. -0.3 7 V. Ta equals 25 degrees Celsius minus 0.3 VDDV. -0.3 VDDV. Ta equals 25 degrees Celsius. 200 maximum MW per 1 package. Power dissipation PD. Ta equals 25 degrees Celsius. Per 1 output 50 maximum MW. Storage temperature TSTG minus 55 to plus 150 degrees C. 201. MSM 6422-. Operating conditions. Parameter symbol. Supply voltage VU. Memory hold voltage VOOH. Operating temperature top. Fan out N. DC characteristics. VU equals 5V plus or minus 10%, Ta equals minus 40, plus 85 degrees C. Parameter symbol. H input voltage *1, *2 VIH. H input voltage *3, *4 VIH. L input voltage VIL. H output voltage *1, *5 VOH. L output voltage *1 vol. L output voltage *5 vol. L output voltage 6 vol. Input current *3 IIH/. IL. Input current *2, *42. IL. H output current *110H. H output current *110H. Input capacity CI. Output capacity CO. Current consumption. Stop, IOOS. Current consumption 100. *1 applied to PO, P1, P3, P4, and P5. *2 applied to P2. *3 applied to OSCO. *4 applied to reset. *5 applied to OSC. Condition. HOSC, 1 MHz. HOSC, 4.2 MHz. MOS load. TTL load. Condition. 10 equals -15/LA. 10 equals 1.6 mA. 10 equals 15/LA. Low equals 8 mA. 6 equals VU/OV. 6 equals VU/OV. VO equals 2.4 V. VO equals 0.4 V. F equals 1 MHz, Ta equals 25 degrees Celsius. VU equals 2 V, no load. Ta equals 25 degrees Celsius. No load. Crystal oscillation. No load, 4.194304 MHz. Limits unit. 3 to 6 V. 4.5 minus 5.5 V. 2 to 6 V. Minus 40 to plus 85 degrees C. 15. 1. Min. Tip. Max. Unit. 2.4, VUV. 4.2, VUV. Minus 0.3 to 0.8 V. 4.2, V. 0.4 V. 0.4 V. 1 2 V. 1 minus 15. /LA. Ho. /LA. Minus 0.1, mA. Minus 1.2 mA. 5. PF. 7. 0.25/LA. 1/100/LA. 612 mA. 6 in using LED. Total output current should be within the limit of power dissipation in absolute maximum. Rating. 202. MSM 6422. AC characteristics. VDD equals 5V plus or minus 10%, Ta equals minus 40, plus 85 degrees C. Parameter. Clock, OSCO, pulse width. Cycle time. Input data setup time. Input data hold time. Input data / input clock. Pulse width. Data delay time. POPP3. PP. Symbol. TCFW. TCY. TDS. TDH. TDW. TDR. 1MC. TCY. Condition min. Tip. Max. 119. 952. 120. 120. 120. CL equals 15 PF, TCY plus 300. POP. P3. PP. I. TDR. J-. Unit. NS. 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 203. EMSM 6422 E dash 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 dash. Instruction set. Mnemonic hex opcode byte cycle ascription. Li N90-9F11 ACCN. LLIN SO SF11LN. LAL 2111 ACCL. LLA 2111 LACC. LA 2211 ACCH. LHA 2 times 10 to the power of first 1 HACC. 0. LAM 3s 11 ACCM. OS. 0 LMA 2 F11 MACC. J. X2s 11 ACCM. LMINN 14 NN22M, W, NN. LHLINN 15 NN22HLNN. LAMOMM 10 mm 22 ACCMD. LMAOMM 11 mm 22 MDACC. IPOP 30 PO 22 ACCPP. OPOP 30 PC 22 PPACC. MEL 3 times 10 to the power of -60th 22 MEIF-1. MOL 3 times 10 to the power of -61st 22 MEIF-0. EIEX 30 CS22 EX-1. EITB 30 C922 EF-1. OIEX 30 C422 EX-0. E. OITB 30 C522 EF-0. E. TIEX 30 co-skip if EX equals 1022. TITB 30 C122 skip if EF equals 1. TQEX 30 to 22 skip if IRCX equals 1. TQTB 30 0022 skip if IRCB equals 1. RQEX 30 to 2422 IRCX-0. RQTB 30 0422 IRCB-0. INL 3111L, L plus 1, skip if L equals O. INH 3211H, H plus 1, skip if H equals O. INM 3311M, M plus 1, skip if M equals O. IQ. OCLL, L1, skip LFL equals FQ, E3511. EQ. Q. 0 OC 3611H, H1, skip if H equals F. 0 Q. Dash equals 0. OCM 3711M, M1, skip if M equals F. INMOMM 12 mm 22. MD plus 1. Skip if MD equals O. 204. Dash. MSM 6422. Instruction set, cont. Mnemonic hex opcode byte cycle description. Tab N254-5711 skip if, ACC bit N2, equals 1. TMB N258-5B11 skip if, M bit N2, equals 1. RMB N268-6B11, M bit N2, 0. CL5 MB N278-7B11, M bit N2, 1.S. 15. TPBDP N23 Depot 322 skip if, PP bit N2, equals 1C. List.S:, PP bit N2, 0. RPBDP N23 DP4-722. 3. SPBDP N23 DP8B22, PP bit N2, 1. TC0911 skip IFC equals 1. RC0811C-0. SC0711C-1. ADS 0211. ACC plus M. Skip if psi equals 1. ADC 0311C, ACC, C plus ACC plus M. ACE N3E4 N22. ACC plus N. Skip if psi equals 1. DOS OA11 ACC plus 10. And 0011 ACC XM. Or 0511 ACC ACME. .S:, EOR 0411 ACC VM. CMAOB11 ACC ACE. CAM 1611 skip if ACC equals M. CAL N3E on 22 skip if ACC equals N. RAL OE11. .ACC, C3-2-1Q-. JCP 6 CO FF11 PC 6. JP 11. 40-47. 22 PC 11.S:, 00, FF. C. AOA 7 stack, PC plus 2, PC 11. MCALA 11. 00 FF. 24. SP 1. RT1 times 10 to the power of first 4 PC, stack, SP, SP plus 1. Push 1C13. Stack, PC plus 2, PC 11. SP 1. 3. Pop. C, ACC, H, L, stack. Q, 1013 SP plus 1. .S:, 0. Stop 3dB922 clock stop. NOP 0011 no operation. 205. MSM 6422-. Tip. Current, low, Vs voltage, VOH. For high state output. -1.0. -0.9. -0.8. -0.7. -0.6. I 0.5. 0.9 to 0.4. -0.3. -0.2. -0.1. O. LF. VU equals 6V. LI backslash. 5V. I4V backslash. Backslash. 1 backslash. K. N1 backslash backslash. Backslash backslash backslash. 1 2 3 4 5 6 7 8 9 10. VOH, V. Tip. Maximum oscillator frequency. F, OSC, Vs supply voltage, VD. Ta equals 25 degrees Celsius. CL equals 15 PF. 10. 9. Slash. 8. N 7. J, 6. 0. 5. 2. J. 2. N. 4.9. 3. I. 2. O. 1 2 3 4 5 6 7 8 9 10. VU, V. Tip. Maximum oscillator frequency. F, OSC, Vs temperature, Ta. N. J. 0. N. 0.9. 206. 10. 9. 8. 7. 6. 5. 4. 3. 2. 1. O. VU equals 5V. CL equals 15 PF. I. R dash. Minus 40 minus 20 0 20 46,000 and 80 100,000 120. Ta, OC. Tip. Current, load vs voltage, vol. For low state output. 20. 18. 16. 14. E. Dash colon 10. 0.98. 6. 4. 2. 6 VI. I. 1 slash slash. RL. R slash. Slash. Slash, VU equals 5V. Slash 4V. I 3V. 1 2 3 4 5 6 7 8 9 10. Vol, V. Tip. Supply current, LDD. Vs supply voltage, VDD. 10M. 5M. 1M. 5001. 100N. Ta equals 25 degrees Celsius. No load. HOSC, 4M. 2 MHz. F. V. 1 MHz, 500 kHz equals 100 kHz. Slash O Hertz. Hertz. 1 2 3 4 5 6 7 8 9 10. VU, V. OKI semiconductor. MSM 6442. CMOS 4-bit single-chip microcontroller with LCD driver. General description. The OKI MSM 6442 is a low-power, high-performance single-chip device implemented in complementary metal oxide semiconductor technology with 46 segment outputs and 2 commons. Also integrated onto this chip are 16K bits mask program ROM, 512 bits of data RAM, 28 input/output lines and oscillator. 71 instructions include binary, BCD, logical operations, bit set, reset, test, subroutine call and return. Features: low power consumption 30 MW, tip, 2048x8 internal ROM, 128x4 internal RAM, 2 built-in counters, 1 2-bit time base counter, 8-bit programmable timer/event counter, 16 input/output ports and 46 LCD output port and 2 common output, 1/2 OUTI, 1/2 BIOS. Leo direct drive available. Functional block diagram. RAM. III. LCD GND-COM 2 seg 46 XT test 3 int. VM-COM 1 seg 1 BZ in out. Self-contained oscillator. 71 instructions. 4 interrupt levels. 6 stack levels. -40 to +85 degrees C operating temperature. 4.5 to 5.5 V operating VOD at 4.2 MHz. 3.0 to 6.0 V operating VOD at 1 MHz. TTL compatible. 3210. CIN. OSCO. OSC. Test 1. Test 2. Resout. VDD. GND. 207. MSM6442-. Logic symbol. 5V. OV. Reset input. Reset output. Test. Clock. LCDCLOCKC. Interrupt input. Interrupt output. Fuzzer output. Port 3. Pin description. Terminal. POOP03. P10 P13. P30 P33. P40 P43. Seg1 Seg16. Seg17 Seg46. COM1. COM2. Int. Int out. Reset. Reset out. BZ. OSCO. OSC. XT. XT. Test 1. Test 2. Test 3. VU. VLCD-GND. VM. GNO. $7 SA. $59. $W. $4. $5. $16. SH. $18. $19. $20. $21. $22. $23. $24. $25. $26. $27. Seg 528. $29. $30. $31. $3. $33. $3. $35. $36. $37. $38. $39. $8. $42. $8. Output. Input. Output. Input. Output. 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 Input. Output. 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 Input. Output. Input. Output. Input. 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 Output. Input. Pin configuration, top view. Function. When. Reset. 1/0 port. 1/0 port, P10 and count inputs EINR in 1. 1/0 port. Common. IO port 0. LCD output port, can be assigned to data. Output in 4-bit wide. OL. LCD output port. LCD common output terminal 1. 0*. LCD common output terminal 2. Input port of external interrupt. Interrupt output port 1. Reset input port. Reset output terminal 1. Buzzer pulse output port in 2048 kHz 0*. Crystal OSC or ceramic OSC connection. Crystal OSC or ceramic OSC connection. System clock. 32.768 kHz crystal oscillator connection. Use for LCD control. Test terminal 1, open, connected to VU. Test terminal 2, open. Test terminal 3, open. Power supply, 5V. Power supply for LCO. VU VLCO, /2 supply voltage output. Or supply voltage input. 0*. Power supply, OV. A indicates the LCD GND voltage level. 208. dash 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 EMSM 6442E. Electric characteristics. Absolute maximum ratings. Parameter symbol conditions limits unit. Supply voltage VDD minus 0.327 V. Input voltage 6. Ta equals 25 degrees Celsius. Minus 0.3 VDD V. Output voltage VO minus 0.3 VDD V. LCD voltage LCD GND VOD minus 9 VDD V. Storage temperature TSTG, minus 55 to plus 150 degrees C. Operating conditions. Parameter symbol conditions limits unit. F, OSC, 1 MHz 3 to 6 V. Supply voltage VDD. F, OSC, 4.2 MHz 4.5 to 5.5 V. LCD voltage LCD GND *1 VDD minus 8 to 0 V. Memory retention voltage VDOH oscillation off 2 to 6 V. Operating temperature top, minus 40 to plus 85 degrees C. LCD clock. F, XT, *232.768 kHz. Oscillation frequency. Mohs load 15. Fan out, 1/0 port N. TTL load 1. *1 voltage applied to LCD is, DDV LCD. *2 oscillation circuit for LCD clock, XT, XT port, is for crystal oscillation only. 209. EMSM 6442E dash 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 dash. DC characteristics. Parameter symbol. 1. Int. H input voltage VIH. 3. L input voltage 1. 4 VIL. 1. OSC 1. H output 2. Voltage. VOH. Seg 1 Seg 46. COM 1, COM 2. 1, 2. L output OSC 1. Voltage. Vol. Seg 1 Seg 46. COM 1, COM 2. M output. COM 1, COM 2 YAM. Voltage. OSCO. H input current XTIIH. Int, reset. OSCO. L input current XTIL. Int, reset. H output. Current. 110H. Current. Consumption. IDDS at stop mode. No oscillation. Current. Consumption IDDL. At stop mode. Current. IDD. Consumption. 1 applied to PO, P1, P2, and P4. 2 applied to IFIL TRNIT, reset, and BZ. 3 applied to OSCO, XT, and reset. 4 applied to XT, int, and reset. VDD equals 5V plus or minus 10%, LDCGND equals OV, Ta equals minus 40, plus 85 degrees C. Condition min tip max unit. 2.4, VDDV. 3.6, VDDV. 0 to 0.8 V. 10 equals dash 15 slash LA 4.2, J. 10 equals dash 4002.4, V. 10 equals dash 10 slash LA VU 0.2, V. 10 equals dash 50 slash LA VU 0.2, V. 10 equals 1.6 ma, 0.4 v. 10 equals 15 ma, 0.4 v. 10 equals 10/LA, 0.2 v. 10 equals 50/LA, 0.2 v. 10 plus or minus 0.5 vu/2 0.2, vu/2 r0.2 v. 15/LA. 6 equals VDD, 7/LA. 1/LA. Minus 15/LA. 6 equals OV, 7/LA. Minus 30/LA. VO equals 2.4 V minus 0.1, ma. VO equals 0.4 V, minus 1.2 ma. VU equals 2 V, Ta equals 25 degrees C. No load. 0.210/LA display 011. XT port is fixed to L. Display 011. XT port is fixed to L. 100/LA. No load. Display off. 100/200/LA. At stop mode. F, XT, equals 32.768 kHz. No load. Display 011. 612 ma F, OSC, equals 4.2 MHz. F, XT, equals 32.768 kHz. Note, M output voltage is intermediate voltage of the output from common port at dynamic display. 210. EMSM and M2E. AC characteristics. VDD equals 5V plus or minus 10%, Ta equals minus 40, plus 85 degree. Parameter symbol condition min tip max unit. Clock, OSC, pulse width TO, 119, ns. Cycle time TCV, 952, ns. Input data setup time T08, 120, ns. Input data hold time TDH node 120, ns. Int input data pulse width TDWL, 120, ns. CT clock pulse width TDW2, 2 ISTCY 7120, ns. Data delay time TDRCL equals 15 pf, 300 ns. Reset input pulse width towers node 22 TCY, ns. Node 1 star. Node 2 star. To release power down by inputting L level into int port, pulse width should be longer than the time for the oscillation stabilization at OSC. 0 the condition of stable oscillation. To release power down by reset, pulse width should be longer I than the time for oscillation stabilization at OSC. 211/M dash. Timing chart. 212. OSCO. OSCO. PO, P1. P3, P4. OSCO. PO, P1. P3, P4. P10/CIN. TCY. I output data. I. TOR. If. J. TO1. Dash. 1 backslash. TO2 TO2. V. Towers. EMSM and W2E. Output waveform of LCD river. Static mode. COM1, COM2. SEGN. N equals 146. VDD. TVCDGND. VDD. TLCDGND. VDDLCDGND. COM1 SEGN. COM2 SEGN dash 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 4 dash 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 0. Display. Off. Dynamic mode. COM1. COM2. SEGN. N equals 146. com1 segn underscore 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 plus underscore plus. Display. Off. com2 segn dash plus. Display. Off. On off. On. VDD-LCD-GND. Display. Off. VDD. VM. LCD-GND. VDD. LCD-GND. VDD-LCD-GND. VM-LCD-GND. O. VM-LCD-GND. VDD-LCD-GND. Off. VDD-LCD-GND. VM-LCD-GND. 0. Dash. VM-LCD-GND. Dash. VDD-LCD-GND. Off. EMSM6442E dash 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 dash. Functional description. ROM. Organized into 2048 words by 8 bits, ROM is used to store developed application programs. Instructions. It is addressed by the program counter, PC. Program counter, PC. The program counter consists of a 11-bit binary counter. It is used to address ROM. Stack. An interrupt or cal instruction causes the contents of the PC to be saved in the stack. Also, the push instruction causes the contents of accumulator, carry flag, H and L register to be saved in it. These are allowed to be restored by the RT instruction or pop instruction. RAM. Organized into 128 words of 4 bits, RAM is addressed by the H and L register or the contents of the second byte of an instruction. L register. A 4-bit register which specifies the row address of RAM and the port address in the port. Operation instructions. It is also used as a working register. H register. A 4-bit register which specifies the column address of RAM and is used as a working register. ALU. A 4-bit logic circuit which provides arithmetic and logical operations. Accumulator, ACL. Consisting of a 4-bit register, the accumulator holds the result of operations or the date present on ports. C flag. The flag that holds a carry generated from the result of operations. Input/output ports, 16 bits. 16 input/output ports are provided for affecting and controlling data transfer to and from an external source. The ports are selected by codes included in the instructions. 12-bit time base counter. The time base counter consists of a 12-bit binary counter. It is used to divide the frequency of the OSCO input by 2 feet 2 inches and generate the .RLPT request at every overflow signal. 8-bit timer event counter. The timer event counter consists of a 8-bit counter, 8-bit register, comparing and controlling circuits. It is used to count pulses of an internal or external source. Coincidentally, if value between the counter and the register causes interrupt request occur. LCD driver. The LCD driver is used to affect LCD display by transferring data in a program to the register assigned as port 5 and 6. It is available to _select driving in static or dynamic operation, 1/2 duty cycle, and frame frequency, 128 Hz/64 Hz, and to drive up to 92 segments at 1/2 duty. Also, 16 outputs, seg1 seg16, of the segment terminals can be used as normal data outputs. A standard LCD clock is produced by the oscillation dividing a crystal oscillator, 32.768 kHz, connected to XT and XT terminals. This is also used as standard clock of displaying, clock, interrupting and watchdog timer. This clock can be also produced by dividing a frequency of 4.194304 MHz. Note the selection of the frame frequency when the crystal oscillator is used. Without a frequency of 4.194304 MHz. Interrupt. As shown below, 1 to 4 is available to interrupt. One external interrupt at the falling edge of int signal input. 2 clock interrupt at every second, 32.768 kHz. Crystal oscillator. 3 time base counter interrupt at the occurrence of an overflow of the timer base counter. 4 timer event counter interrupt coinciding between the signals of the 8-bit counter and register. Interrupts 1 and 2 are also used to release the power down mode. Watchdog timer, WDT. A timer for detecting the overrunning of the program. This timer produces the overflow signal by dividing the 64 Hz frequency by 4 generated from the oscillation of a frequency of 32.768 kHz. It can be also halted when unused. Timing control, T.C. A 0 level on the reset pin for longer than predetermined period initializes the internal circuitry and ports. Clock pulses are supplied to the OSCO pin from an external source. A crystal or ceramic oscillator may be connected to OSCO and OSC1 to form an oscillator circuit to produce clock pulses. MSM 6442. Instruction set. Mnemonic hex opcode byte cycle description. LI N90-9F11 ACCN. LLIN 80-8 F11 LN. LAL 2111 ACCL. LLA2D11 LACC. LA 2211 ACCH. LHA 2 times 10 to the power of first 1 HACC. LAM 3811 ACCM. -0. LMA2 F11 MACC. As 0x2811 ACCM. I. LMINN 14 NN22M, W, NN. LHLINN 15 NN22HLNN. LAMD MM10 MM22 ACCMD. LMAD MM11 MM22MD ACC. LMCT3 E5922M, W, CT. LCTM3 E5122 CTM, W. IPDP3 Depot 22 ACCPP. OPOP30 PC22 PPACC. MEL 3 E6222 MEIF-1. MOL 3 E6122 MEIF-0. EIEX30C822 EX-1. EICT30CB22 EX-1. DIEX30C422 EX-0. 0 dict. 30C722 EX-0. C. 0 TIEX30 Co22 skip if EX equals 1. U. TICT3DC322 skip if EX equals 1. TQEX3022 skip if ERCX equals 1. TQCT30D222 skip if ERC equals 1. RQEX3D2422 ERCX-0. RQCT3DD622-0. INL3111L, L plus 1, skip if L equals O. INH3211H, H plus 1, skip if H equals O. INM3311M, M plus 1, skip if M equals O dash. 0, O, E. DCL3511L, L1, skip if L equals FEO. 0. 0 DCH3611H, H1, skip if H equals F. 0 0. Silent smiley, DCM3711M, M1, skip if M equals M. INMD MM12MM22MD, MD plus 1, skip if MD equals O. MSM6442-. Instruction set, co-nt. Mnemonic hex opcode byte cycle description. Tab N254 to 5711 skip if ACC bit N2 equals 1. TPB N250 to 5311 skip if P bit N2 equals 1. RPB N260 to 6311 P bit N2 0. SPB N270-7311 P bit N2 I. TMB N258-5B11 skip if M bit N2 equals 1. CL. RMB N268-6B11 M bit N2 0.S equals C. M bit N2 1C5 megabytes N278-7B11 as .J. 3. TPB op N230 PO322 skip if PP bit N2 equals 1. RPB op N230 P4-722 PP bit N2 0. SPB op N23 DP8B22 PP bit N2 1. TC0911 skip if C equals 1. RC0811C-O. SC0711C-1. Adds 0211 ACC, ACC plus M, skip if Psi equals 1. AOC 0311C, ACC, C plus ACC plus M. ACE N3E4 N22 ACC, ACC plus N, skip if Psi equals 1. OAS OA11 ACC ACC plus 10. U. And 0011 ACC ACC AM. E or 0511 ACC ACC VM. 5. EOR 0411 ACC ACC VM. CMA 0811 ACC ACC. CAM 1611 skip if ACC equals M. Cal N3E on 22 skip if ACC equals N. Dash ACC. RAL OE11C, 3-2-1-0. JCP is 6 co, FF11 PC is 6. .J, JP all. 4047. 22 PC, A11. U00, FF. C. A11. AOA7 stack, PC plus 2, N. Cal. 00, FF. 24. PCA11, SPSP1. RTLE14 PC stack, SPSP plus 1. Push 1C13 stack, C, ACC, H, L. SPSP1. POP 1013C, ACC, H, L, stack. SPSP plus 1. J, stop 30B922 clock stop. .S. 5 NOP0011 no operation. ECT3DBB22CTF, 1, counter start. OCT3DB722CTF, 0, counter stop. TCT3DB322 skip if CTF equals 1. OKI semiconductor. MSC 6458. OKI 4-bit 1-chip microcontroller. General description. The MSC6458 is a high-speed, 4-bit 1-chip microcontroller with built-in FLT drivers/controllers developed to support relatively large control systems. Features: ROM, 8000 x 8 bits. RAM, 512 x 4 bits. Ports, I/O 24 ports, 8 having 10L equals 20 mal. Input 9, 2 also serving as interrupt inputs. FLT drivers, withstand 12, IOH equals 2 ohms. Voltage for OV12, IOH equals 6 mA. LED direct drive available. Interrupts, 7 lines, 2 external, 5 internal. Built-in counters, 12 bits, time-based counter. 16 bits, programmable counter. 8 bits, high speed. Programmable timer/event. Counter. Block diagram. VFL.T. 10. T1. TL1. SEGO. SEGL. SEG11. 3M211, 3210 3210 3210 3210. Serial I/O, built-in 8-bit SIO register. Oscillation circuit, crystal or ceramic oscillation. Number of instructions, 147. Cycle time, 930 ns, 4.3 MHz. Operating ranges, 4.5 to 5.5 V, 4.3 MHz. Voltage, 3.0 to 6.0 V, 1 MHz. Temperature, -40 to +85 degrees C. Power dissipation, typical. Display off 9 mA, 5 V, 4.3 MHz. 2 mA, 3 V, 1 MHz. Power down, stop instruction. Package, 64-pin shrink DLP/64-pin flat. OSC. OSCI. Test. L_.jrese. VU. GND. 217. MSC6458. Logic symbol. Reset. Test. 5V. OV. FLT power. Porn. Port 2. Pin description. Terminal. POO. P01/SCK. P02/S0. P03/S1. P10/CIN. P11ITMO. P12/TCK. P13. P20/LNTO. P22/1NT1. P30 P33. P60 P63. P40, P43. P50 P53. P70, P72. P80 P83. SEGO SEG11. T11/SEG12. T8/SEG15. T7/0UT7. Toyota. OSCO. OSC1. Reset. Test. VFLT. VDD. GND. 218. Pin configuration, top view. 64-pin plastic RU0. Shrink dip. 1110. IGMOTD. For FLT. J. 7. Equals. Underscore dot. Input. Function. When. Output reset. 1/0 port underscore. Input. 1/0 port, also used as serial clock input SCK. 1. Output 1/0 port, also used as serial data output so 1/0 port, also serial data input SI. 1/0 port, also used as count input GIN. Input 1/0 port, also used as timer output TMO, 1. Output 1/0 port, also used timer clock input TCK. 1/0 port. Input port with latch, falling edge sensitive. Also used as interrupt input into. Input port with latch, 0 level sensitive. Also used as interrupt input int 1. Input 1/0 port 1. Output input 1/0 port UO. Output 1/0 port, LOL equals 20 ma max, 0. Input port with pull down register. Pull down register of P70, P72 can be removed. By instruction. Output FLT segment driver, dynamic, 0. Output FLT segment driver, dynamic, /timing output 0. Output FLT segment driver, static, /timing output 0. Input crystal connection terminal for system clock. Output oscillation. Input system reset input. Output test pin, open. Input power supply for FLT driving. Input system power supply. Dash. MSC 6458. Functional description. 1 ROM. The ROM, organized in 8 bits, has a maximum capacity of 8000 bytes. 2 RAM. The RAM is organized in 4 bits per word, with a capacity of 512 words. It is separated into 2 banks, each 256 words long. Bank selection is accomplished via internal ports. The RAM location in the banks is addressed by the handle registers or by the second byte of each instruction. 3 ports, 24 1/0,7 input. The 24 pseudo bidirection LIO ports affect or control the exchange of data with external sources. The ports are specified by the L register or by codes contained in instructions. Ports 4 and May5 draw 10 L up to 20 Ma. The 7 input ports have built-in pull-down resistors. Up to 84 keys can be scanned by assembling them in key matrices with the timing. Outputs of the FLT drivers, with 1-2 segments x. 12 timings on display, also during automatic display. 4 interrupt input pins, 2 terminals. The IL_RFO/P20 and int1/P22 pins are interrupt input pins. External interrupt request. Flags of int2/P20 pin and int1/P22 pin can be set by using interrupt input pins. int2/P20 pin, positive edge or negative edge. Input int1/P22 pin. 0 level input. These flags are automatically reset when the appropriate external interrupts occur. These pins are available for use as input ports when not used as interrupt input pins. 5 FLT drivers/controllers, automatic display. The FLT drivers have a withstand voltage of 40 V in the positive direction from the GND level. They comprise 12 ports that can draw 20 mA as 10H, timing outputs, and 12 ports that can draw 6 mA as such, segment outputs. A choice of 4 display modes is supported, as listed below. A display RAM area is allocated as part of the RAM space. Data is automatically displayed when transferred to the display RAM. Two different display frequencies are selectable. Static output data can be displayed by controlling the FLT drivers by programming. Display modes, at 4.194304 MHz. 1. 12 segments x 12 timings. 1/12 duty, 85.3/341.3 Hz. 2. 16 segments x 8 timings. 1/8 duty, 128/512 Hz. 3. 16 segments x 4 timings plus 4 output. 1/4 duty, 256/1024 Hz. 4. 16 segments plus 8 output. Program controlled. Output, static outputs. 6 stack, and stack pointer, SP. The PC is saved in the stack when an interrupt occurs or a cal instruction is executed. It is recovered by the execution of an RT instruction. 1/4 of the RAM space, 128 words. Maximum, 32 levels, is available as a stack area. A 4-word RAM area is used for 1 level in the stack. The stack pointer is an 8-bit up-down counter, the MSB and 2 bits from LSB being fixed at 1, indicating the next stack address to use. It enables the RAM space to be used as a push-down stack. Data can also be transferred between stack pointer and the H/L registers. 7 interrupts. 7 interrupt lines are provided for 8 sources and 8 levels of interrupts as follows. 2 external inputs. 1. Display interrupt. Update to timing signals, positive edge. 2. External interrupt 1. Negative edge on the into/P20 pin. 3. External interrupt 2. Positive edge on the into/P20 pin. 4. External interrupt 3. Input on the int1/P22 pin. 5. Time base interrupt. 1 2-bit time base counter overflow. 6. Timer interrupt. 16-bit timer and timer register matched signal. 7. Counter interrupt. 8-bit counter and counter register matched signal. 8. Serial/O interrupt. 8-bit shift register shift end signal. 8 12-bit time base counter. The time base counter is made up of a 12-bit binary counter. It generates an interrupt request every time it overflows as a result of dividing the OSCO input 2 feet 2 inches. 9 16-bit programmable timer/event counter. Comprising a 16-bit register, a 16-bit binary counter, a comparator circuit, and a control circuit. The programmable timer generates an interrupt request when the register and CU enter values are matched. 10 8-bit high-speed programmable timer/event counter. The high-speed programmable timer/event counter comprises an 8-bit register, an 8-bit binary counter, a comparator circuit, and a control circuit. Starting and stopping the counter can be controlled by instructions. It generates an interrupt request when the register and counter values are matched. 219. MSC 6458. 11 8-bit serial 1/0. Serial 1/0 consists of an 8-bit shift register, a 3-bit shift counter, and a control circuit. It is used for serial data input and output. Serial data input and output takes place synchronized with a shift clock, which is selectable between internal and external clocks. The shift counter automatically terminates a data transfer on counting 8 shift clock pulses and generates an interrupt request. 1-2. Registers, ACE, H, L, F. The accumulator, ACC, is a 4-bit register used to perform data transfers or calculations. With the RAM, other registers, ports and so on. The hand-L registers are each a 4-bit register. They transfer data to and from ACC and SP, stack pointer, and address the RAM. The L register is also used to specify ports to use. The F register is made up of 4 independent flip-flops. It can be used as a program flag or general purpose register. Because each of these flip-flops permits set/reset testing and transferring 4-bit parallel data to and from ACC by instructions. 13 Timing control, TC. A 0 input on the reset pin for a certain period initializes internal circuitry and ports. As the input side of clock pulses, the OSCO pin accepts clock pulses from an external source. Clock pulses may also be obtained by configuring an oscillation circuit with a crystal oscillator or ceramic resonator connected to OSCO and OSC1. 220. MSC 6458. Load instructions, etc. Mnemonic code byte cycles description. LIN 90-9F11A. LLIN BO 8F11L. LHIN 3E7N22H. LHLIN N15NN22HL. LMIN N14NN22M, W. LAL 2111A. LLA2D11L. LA 2211A. LHA 2 times 10 to the power of first 1H. LAM 3811A. LMA2F11M. LAM plus 2411A. M, L. L plus 1, skip if L equals 0. LAM 2511A. LMA plus 2611M. LMA 2711M. LAM N239-3B11A. LAMDMM10MM22A. LMADMM11MM22MD. X plus 3C11A. X2C11A. XMN229-2B11A. LMTMM19MM24M, W. LAF 3E5422A. LFA3E5C22F. LHLS 3E5322HL. LSHL 3E5B22SP. IP211A. OP23111P. IPDP3DPD22A. OPDP3DPC22PP. Opt1813P4, P5. 221. MSC 6458. Interrupt control instructions. Mnemonic code byte cycles description. MEL 3E622MEIF. MOL 3E6122MEIF. EIXO3DE822XOF. EIXU3DE922XOV. EIXL3DE822XELF. EIOP3DEB22EOP. EITB308222EV. EITM30922EV. EICT30822EIV. EISR3DDB22ASRF. OIXO3DE422XOF. OIXU3DE522XOV. OIXL3DE622XELF. OIOP3DE722EIOPF. DITB30422EV. OITM30522EV. OICT30622EIV. OISR30722ASRF. TIXO3DEO22 skip if XOF equals 1. TIXU3DE122 skip if IGSOV equals 1. TIXL3DE222 skip if EXELF equals 1. TIOP3DE322 skip if EOP equals 1. TITB3D22 skip if ETF equals 1. TITM30122 skip if ETF equals 1. TICT30222 skip if EICF equals 1. TISR30322 skip if ESRF equals 1. TQXO30222 skip if IRCOF equals 1. TQXU30222 skip if IRCSF equals 1. TQXL30222 skip if IRCSLOF equals 1. TQOP32322 skip if IRCOP equals 1. TQTB3D-code22 skip if IRCP equals 1. TQTM3DC122 skip if IRCP equals 1. TQCT3DC222 skip if IRCP equals 1. TQSR3DC322 skip if IRCSRF equals 1. RQXD302422 IRCOF. RQXU302522 IRCSF. RQXL302622 IRCSLOF. RQDP302722 IRCF. RQTB3DC422 IRCF. RQTM3DC522 IRCF. RQCT3DC622 IRCF. RQSR3DC722 IRCSRF. 222. MSC 6458. Increment/decrement instructions. Mnemonic code byte cycles description. INA 311A. INL 3111L. INH 3211H. INM 3311M. DCA 3411A. DCL 3511L. DCH 3611H. DCM 3711M. INMD MM12MM22MD. DCMD MM13MM22MD. Bit handling instructions, etc. Mnemonic code byte cycles description. Tab N2 54 to 5711 skip if A, N2, equals 1. RAB N2 64 to 6711A, N2. SAB N2 74 to 7711A, N2. TPB N2 50 to 5311 skip if P, N2, equals 1. RPB N2 60 to 6311P, N2. SPB N2 70 to 7311P, N2. TMB N2 58-5B11 skip if M, N2, equals 1. RMB N2 68-6B11M, N2. 5 MB N2 78-7B11M, N2. TFB N2 5C5F11 skip if F, N2, equals 1. RFB N2 6C6F11F, N2. SFB N2 7C7F11F, N2. TPBDP N2 3DPO322 skip if PP, N2, equals 1. RPBDP, N2 3DP4722PP, N2. SPBDP, N2 3DP8B22PP, N2. TC0911 skip if C equals 1. RC0811C. SC0711C plus 1. 223. Arithmetic instructions. Mnemonic code byte cycles description. ADCS0111C, A_C plus M, skip if C equals 1. ADS 0211A plus M, skip if Psi equals 1. ADC0311C A_C plus M. ACE N3E4 N22A _A skip if Psi equals 1. DAA0611A _ A+6. DOS OA11A _ A 10. And OD11A _ AAM. Or 0511A _ AVM. EOR 0411A +ANM. CMAOB11A underscore A. CIAOC11A plus 1. RAL OE11. Dash A underscore 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 underscore. CC plus 3 plus dash 2 underscore 1 plus O. Dash A underscore 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 underscore. RAR of 11 TC. Dash 3 dash 2 dash 1 dash 0. Cam 1611 Skype of A equals M. Cal N3E on 22 Skype of A equals N. CMI N3E1 N22 Skype of M equals N. CLI N3E2 N22 Skype of L equals N. CPIP N17P N22 skip if PP equals N. Branch instructions, etc. Mnemonic code byte cycles description. JCP is 6 co FF11 PC is 6. JA1A12 PC underscore A, plus 1. JM1B12 PC underscore, M, W, A. JP A12. 44F. 22 PC underscore A1200FF. Cal A12. AOAF. 24ST underscore PC plus 2, PC underscore A12, SP underscore SP400FF. CZP ABA14ST plus PC plus 1, PC plus 2A, SP underscore SP4. 3F3F. WP A13001F34 PC underscore A13. 00FF. 3F3F. LCAL A13 Bo9 F34ST, PC plus 3, PC, A13, SP plus SP4. 00FF. RT1 times 10 to the power of first 4 PC plus ST, SP underscore SP plus 4. RTS1 F14 PC underscore ST, SP underscore SP plus 4, then skip. 224. Dash. MSC 6458. Counter control instruct Lona, etc. Mnemonic code byte cycles description. LCTM3E5122CTR underscore M, W. LMCT3E5922M, W, underscore CT. ECT3DBB22CTF underscore 1, counter start. DCT3DB722CTF underscore O, counter stop. TCT3DB322 skip if CTF equals 1. LTMM3E523TMR underscore M, 2W. LMTM3E5823M, 2W, underscore TM. LSRM3E5222SR underscore M, W, SC underscore 0SC, shift counter. LMSR3E5A22M, W, underscore SR. ESR3DBA22SRF. DSR3DB622SRF. TSR3DB222 skip if SRF equals 1. CPU control Natruck Lona, etc. Mnemonic code byte cycles description. Push 1C13ST underscore C, A, H, L, SP plus SP4. Pop 1013C, A, H, L plus ST, SP plus SP plus 4. Halt 3DB822 halt CPU. Stop 3DB922 stop CPU. NOP0011 no operation. 225. U. EMSC 645 SE dash 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 dash. Explanations of instruction symbols. A. H. L. F. M. MD. M, W. MD, W. M, 2W, ST, SP, PC, P, PP, CTR, CT, CTF, TMR, TM, SR, SRF, X, Y, T, X, Y, N, NN, N2, N2, A, X, MM, C, Psi, 226. Accumulator, 4-bit. H register, 4-bit. L register, 4-bit. F register, 4-bit. RAM word addressed by the hand L registers. RAM word addressed by second byte of an instruction code. 2 RAM words addressed by the hand L register /H3-0 and L3-1, S-bit. 2 RAM words addressed by second byte of an instruction code, S-bit. 4 RAM words addressed by the hand L register /H30 and L3-2, 16-bit. 4 RAM words, 16-bit, allocated as a stack area. Stack pointer, S-bit. Program counter. Port specified by the L register, 4-bit. Port specified by 4 high order by degree TS of second byte of an instruction code, 4-bit. S-bit counter /register. S-bit programmable counter. Programmable counter start flag. 16-bit timer /register. 16-bit programmable timer. S-bit shift register. Shift register start flag. ROM address data specified by a 11-4 as X and a 30 as Y, 12-bit. ROM table data specified by a 11-4 as X and a 30 as Y, S-bit. Immediate data, 4-bit. Immediate data, S-bit. 2 low-order bits of an instruction code. Bit specified by the 2 low-order bits of an instruction code. ROM address data. ROM address data, X-bit. RAM address data, S-bit. Carry flag. Flag indicating a carry in a calculation result. -MSM8. Electric characteristics. Absolute maximum ratings. Parameter symbol conditions. Supply voltage VU. Indicated supply voltage VFLT TA equals 25 degrees Celsius. Input voltage 6. Input voltage VO TA equals 25 C. Input/output. Indicated output. C go seg 1. Per pin 2, TT1. H output current. 10 HOUTO out 7, indicated output. Output terminal C go, seg 11. Total 2, TT1. Per terminal. L output current. 10 LP4 total, P4, P5. P5 total. Per package. Power dissipation PO. Per input/output terminal. Storage temperature TSTG. Asterisk when timing output is used as static output. Operating conditions. Parameter symbol conditions. F, OS, S, 4.3 MHz. Supply voltage VU. F, OS, S, 1 MHz. Indicated supply voltage VFLT. Memory retention voltage VOOH oscillation off. Operating temperature top here. MOS load. Fan out, input/output port, N. TTL load. Limits unit. -0.3 -7 V. VU -45 V. -0.3, VU V. -0.3, VU V. -0.3 VFLTV. 10 mA. 40 mA. Asterisk 30 mA. 72 FUA. 72 mA. 20 mA. 40 mA. 40 mA. 600 MW. 50 MW. minus 55 to plus 150 degrees C. Limits unit 4.5 to 5.5 V, 3 to 6 V, 10 minus 40 V, 2 to 6 V, minus 40, plus S5 degrees C. 15. 1. DC characteristics, VU equals 5V plus or minus 10%, TA equals minus 40, plus S5 degrees C. Parameter terminal applied symbol conditions min tip max unit. Asterisk 1, 2.4, VU V. H input voltage OSCO reset VIH, 3.S, VU V. P7, PS, 3.4, VU V. Asterisk 2, 0, O.BV. L input voltage. P7, PS. VIL. 01.SV. Asterisk 310 equals dash 15A 4.2, V. H output voltage CGO, seg 11 VOH 10 equals SMA VFLT 2.5, V. 2, T11 10 equals dash 20 Ma VFLT 3.5, V. PO, P1, P3, PS 10 equals 1.6 Ma, 0.4 V. P4 P5 10 equals 0.10 Ma, O.BV. L output voltage OSC 1 Vol 10 equals 15A, 0.4 V. CGO, seg 11 10 equals LMA, 1.SV. 2, T11 10 equals 1 Ma, 1.4 V. OSCO, 15A. P2, reset, 1A. H input current IIH6 equals VU. P7, P73 equals 0, PB, so A. P7, P73 equals 1, 1A. 227. EMSM 645 SE dash 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 dash. Parameter terminal applied symbol conditions. OSCO. L input current P2, reset IL6 equals OV. P7 P8. PO, PL, P3, VO 2.4 V. H output current. P4 P5 P6. IOH. VO equals 0.4 V. No load. Current consumption 100. F, OSC, equals 4.3 MHz. Current consumption. IOOS, when stop mode condition. Current consumption. FLT driver section, IFLT. Asterisk 1. Applied to PO, PL, P2, P3, P4, P5, P6. Asterisk 2. Applied to PO, PL, P2, P3, P4, P5, P6, OSCO, reset. Asterisk 3. Applied to PO, PL, P3, P4, P5, P6, OSCL. No load. No load. VU equals 2V. TA equals 25 degrees Celsius. No load. All FLT driver. L level. Min tip max unit. Minus 15 PA. Minus 30 PA. Minus 1 PA. Minus 0.1, RNA. Minus 1.2 RNA. 1220 RNA. 100 PA. 0.510 PA. 100 PA. AC characteristics, VU equals 5V plus or minus 10%, TA equals 40, plus 85 degrees C. Parameter symbol conditions min tip max unit. Clock, O.S.C0, pulse width T, W, 116, ns. Cycle time TCY, 928, ns. Input data setup time TOS, 120, ns. Input data hold time TO, 120, ns. P2 input data pulse width TOW P2 node 1 120 ns. SR clock. Pulse width TO1 120 ns. CT clock. PUISE width TO2 2/8 Psi plus 120 ns. TM clock. Pulse width TO3 T Psi plus 120 ns. SR data setup time TSS 120 ns. SR data hold time TSH 120 ns. SR clock invalid time *TSINH 2/8 TCY ns. Data delay time TOR CL equals 15 PF 300 ns. SR clock delay time teaspoon CL equals 15 PF 360 ns. Reset input. Rise time towers no 22 TCY ns. Segment output. Rise time TTLHSVFLT equals 40V 3P.SS. Segment output. Rise time TTHLSCLD equals 15 PF 1 PS. Timing output. Rise time TTLHTVFLT equals 40V 3 PS. Timing output. Rise time TTHLTCLD equals 15 PF 1 PS. *1. When stop mode is to be released by L level input from P20/into, it is necessary to keep the pulse width of more than oscillation stability time for OSCO. *2. This indicates when OSCO oscillation is stabilized. However, when stop mode is released by reset input, the pulse width of more than OSCO oscillation stability time as requested. *3. TSINH, when shift register commands LMS are during shift in operation, its inner part will not change. If clock, which inputs P01/SCK during TSINH period, changes. 228. .MSM8. Standard characteristics. H output current IOH, output voltage. VOH characteristics eta equals 25 degrees Celsius. PO P1 P3 P4 P5 P6. Minus 1.0. Minus 0.9. Minus 0.8. Minus 0.7. Minus 0.5. I. 9 minus 0.4. Minus 0.3. Minus 0.2. Minus 0.1. O. F dash. 10. VU equals 6V. F backslash. 5V1 backslash. 4V1 backslash. R. 3VL backslash. 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 1-1. 1 2 3 4 5 6 7 8 9 10. VOH, V. L output current IOL output voltage. Vol characteristics eta equals 25 C. PO, P1, P3, P6. 24. 22. 20. 18. 16. J. FL. I. J. 2. 1. 14. J12. 9. 10. 8. 6. 4. 2. 0. 6V. 2/. I4. IIJ. RLV. / 3V underscore. F. 2345. Vol, V. VU. Equals 5V. L output current IOL output voltage. Vol characteristics eta equals 25 degree. P450. P5. 40. 30. J. 920. 10. O. 6 V VU equals 5 V. FL. JV. HL slash. Z. RT. V. I slash. V. L4 VL dash. LI. 23. Vol. V. 3V. 45. H output current IOH output voltage. VOH characteristics eta equals 25C, VFLT equals 4OV. Segment output. Minus 20 VU equals 5V. Minus 18. Minus 16. Minus 14. Underscore minus 12. 1. Minus 10. I. 9 OS. OS. Q4. Dash 02. O. 3536. 1 backslash. Backslash. 1 backslash. 1 backslash. Backslash. 1. 1 backslash. 37 38 39 40. VOH, V. L output current IOH output voltage. Vol characteristics eta equals 25 degrees C, VFLT equals 4 OV. Timing output. Minus 50. Minus 40. Minus 20. Minus 10. VU equals 5V. Backslash. 1. Backslash. Backslash. R backslash. Backslash. 0 35 36 37 38 39 40. VOH, V. L output current IOL output current. Vol characteristics eta equals 25 degrees Celsius, VFLT equals 4 OV. Segment output. 10. 9. 8. 7. 16J5. 9. 4 VU equals 5V. 3. I slash. 2. Slash. J. 2345. Vol. V. 229. MSM dash. L output current IOL, output current. Vol characteristics eta equals 25C, VFLT equals 4 OV. Timing output. 10. 9. 8. 7. 1. 6.95. 4. 3. 2. O. O. Slash. I. J. Dash. R. Slash. I. 23. Vol. V. VU 5V. 45. Maximum clock frequency flask, supply. Voltage VDD characteristics. Eta equals 25 degrees Celsius, CL equals 15 pF. 10. 9. 8. N. 7. J. 6. 5. Pound. 4. 3. 2. 1. 0. V. V. J. I. 1 2 3 4 5 6 7 8 9 10. VU, V. Maximum clock frequency flask, ambient. Temperature Ta, VDD equals 5V, CL equals 15 pF. N. J. Pound. 230. 10. 9. 8. 7. 6. IVU equals 5V. R. 5. 4. 3. 2. 0 to 40, 20-0204060801001220. Ta, 0C. Current consumption IDD, supply voltage VDD. eta equals 25 degrees Celsius, no load. 100 m, 10 m, 1 m, 1001, 0.9, 101, lun. F, os, equals 4 hmz. Slash. V. 2 MHz I. 1 MHz. 500 kHz dash equals F equals. Dash slash. V. Stop mode. Slash. 02345678910. VU, V. Dash 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 EMSMM5SE. Timing chart. PO P1 P3 P4 P5 P6 P7 P8 PO P1 P3 P4 P5 P6 SIGO I SEG 11 2 I T11 JYYUY TCV Input data TDS TDH I TTLHS Output data T 0.9 VF-T-VM TT 0.1 VFLTGND TTHLS II OVFCTVM I4 T comma underscore equals 0.1 VFLTGND TTLHTTTHLT 231 MSM 232 P01/SCK P03/S1 P02/S0 P2CIINTO P22/int1 P10/CIN P12/TCK R TDW1 TDW1 Input I data TSS/TSH Input data output data IJS dash 1 OMOM J 1 dash equals TD equals W3 dash I dash underscore dash equals colon TDW3 IJ 1 dash tau S J TSLNH 1 MC 2 MC LMSR instruction OKI semiconductor MSC 6458 VS MSC 6458 piggyback General description. The MSC 6458 VS is a device whose built-in ROM is replaced by external EPROM using the piggyback method. Features: supply voltage 5V plus or minus 5%, operating temperature 0 to 70 degrees Celsius. Frequency DC 4.3 MHz. ROM insertion. Please refer to drawing below. Pin configuration. Pin connection between MSC 6458 VS and EPROM. Toad A13, address of MSC 6458 VSY 10 to 1. MSC 6458 VSY data. Note, when inserting a 2764, pin 26 is not used. V. A 13. A 12. All. 10. 9. 8. 7. 6. 5. 4. 3. 2. 1. AD. Do. 1. 2. 3. 4. 5. 6. 0 7. GND, VPP, A12, A7, A6, A5, A4, A3, A2, AL, AD, 00, 01, 02, GND, C6458, OKI, Japan, 1-28, 227, 326, 425, 524, 623, 727128222, 821, 920, 1019, 1118, 1217, 1316, 1415, VCC, PGM, A13, A8, A9, ALL, D, A1D, CE, 07, 06, 05, G, JL, 233, OLMS 65 series, H, OKI, Semiconductor, MSM 6502/6512, CMOS 4-bit single-chip microcontroller with LCD driver. General description. The OKI MSM 6502/6512 is a low-power, high-performance 4-bit single-chip microcontroller implemented in complementary metal oxide semiconductor technology. Integrated within this one chip is a 108, 4x27, LCD driver. Also integrated in this chip are 16K bits of mask program ROM, 512 bits of data RAM, input/output lines, a programmable timer/counter, and oscillator. The advantages of the MSM 6502/6512 in comparison with the OLMS 40 series include, among other features, a lower drive voltage, multiplexed interrupts, a larger number of drivable liquid crystal elements, a buzzer output, and larger memories. Features: ROM, RAM, number of instructions, clock oscillation, cycle time, timer interrupt, I/O ports, input ports, LCD drive, buzzer, interrupt, 2000x 8-bit, 128x 4-bit, 68, crystal 32.768 kHz, 9151 ls, dual, 16 and 128 Hz, 4-bit x2 port, 4-bit x1 port, 108, 4x27. Picture elements: 2K/1K/51 2Hz/soft. 3 types: external, 2 timer. Types: functional block diagram, stack, power down, operating power, supply voltage, consumption, current. VDD equals 3V. OSC equals 32.768 kHz. Package: nesting RAM stack. Pointer equals 7 bits. Halt mode available: 2.4V 3.6V. MSM 6502. 45 ILA, typical. 30 ILA, halt mode. MSM 6512. 30 ILA, typical. 12 ILA, halt mode. 56 pin flat, small type, slash. Chip form: 237. MSM 6502/6512. Logic symbol: crystal. Resonator. Connection: reset. Interrupt. Test pins. L. Plus 3V. OV. OSCO. ASL. Test 3. Test. VU. GNO. Port 00. 01. 02. 03. 25. 26. BZ. BZ. Pin description. Designation pin no. GND 24. VDD 21,49. OSCO 22. OSC 23. POP 1124. 5T08. P29T012. IN 16. 238. Pin configuration, top view. JPort input/output ports. Port I. Input/output ports. LCO. Common output. LCD. Segment output. JBuzzer output. 8Z13. BZ14. C Alt L-T, O, N. O0C5. www. C/josig/W, FOOCL, CNOOCIJ. WL, C, C/I. OMCO. III. C81UCIWLLZWWW0NCI, ZU00. C_I-000OQO. Function. Circuit GND potential. Main power source. Crystal OSC input, internal clock input. Crystal OSC input, internal clock output. 42 SEGI3. Pseudo bidirectional ports for 4 bits parallel 1/0. To input data from these ports, it is necessary to write one beforehand. The port to be selected is specified by the L register. The register contents and the corresponding specified ports are listed below. Content of L register port specified: 0.8 PO, 1.9 P1, 2.0 AP2, 3.0 BHP3, 4.0 CHP4, 5.0 DHP5, 6.7.0 ed.ofh. No designation. Note: P3, P4, P5 are internal ports. Input ports for 4-bit parallel input with no latching function. Input pin to request an interrupt from the external circuit. The input flag is set by the fall of the input signal. Dash. MSM 6502/6512. Designation pin no. Function. Reset 15. The reset mode starts after 0 is input to the reset pin for more than 2 machine cycles. The reset signal has priority over all of other signals and performs the following operations automatically. 1. Resets all bits of the PC program counter to 0. 2. Sets all bits old parallel 110 ports P00 to P13 to 1. 3. Resets the internal resistor H, L, ACC, C, P3, P4, P5. 4. Resets the skip flag. 5. Resets all bits of the time base counter, TBC. 6. Resets the interrupt request flag, LRQF. 7. Resets the interrupt enable flag, ELF. 8. Resets the master interrupt enable flag, MEIF. 9. Sets all bits of the stack pointer, SP, to 1. 10. Initializes the segment and common outputs. 11. Sets all bits of the index register, LOR, to 1. Since the reset pin is pulled up to VDD by an internal resistor, approximate 800 kΩ, it is possible to achieve power on/reset by connecting it with an external capacitor. LCD drive pins. A special AC waveform designed to comply with liquid crystal properties is CGO 2629T048 required for liquid crystal drive purpose. The MSM6502B is equipped with a 50T056 duty 1/3 bias liquid crystal drive circuit with 4 common output ports and COM1-425T02827 segments to enable displays of 108 picture elements. On/off selection of picture element displays involves writing 0 or 1 in the corresponding bits in the RAM 02 through 1A display area, and subsequent automatic hardware controlled display. The frame frequency is 64 Hz. BZ/BZ13,14 BZ and BZ are used in the generation of alarms and other sounds. The selectable frequencies include 3 hardware frequencies: TBC output, 51 to 1024 and 2048 Hz, and a software type based on P50 data. These frequencies are selected at P3. When one of the hardware frequencies is selected by P3, output of that frequency is continuous. But selection of the software type results in output of P50 contents to generate a melody by program. Instruction list. Grouping mnemonic code byte cycle function. LIN8N11ACCN. LLIN7N11LN. LHLIN86AN822HLN8. LXIN869N822XN8. Lambo11ACCM. LoadLAL-BL11ACCL. LAB211ACCH. LMA8411MACC. LLAB511LACC. LHAB611HACC. LMADM7LBM722MACC. 239. MSM6502/6512. Instruction list, CoNT. Grouping mnemonic code byte cycle function. LAMDM71AM722ACCM. LMT6712M ROM. Push HLBC12 stack HL, SP/SP2. Load. Push CABD12 stack C, ACC, SP/SP2. Pop HLB12 HL stack, SP/SP+2. Pop CABF12C, ACC stack, SP/SP+2. XAMB811ACCM. Exchange XAMDM71CM722ACCM. XHS3F11HLSP. INA1011ACC, ACC+1, skip if ACC equals 0. INL1111LL+1 Skype if L equals O. INM1211MM+1 skip if increment M equals O. And decrement INX5C11XX+1. DCA1411ACC, ACC1, skip if ACC equals F. DCL1511LL1 Skype if L equals F. DCM1611MM-1 skip if M equals F. DCX5D11XX1. DSC6111C ACCC plus M adjust if C equals O. DAC6111C ACCC plus M plus 6, adjust if C equals O. Add 6211 ACC plus M, skip if Psi equals 1. ADCS 6311C ACCC plus M skip if C equals 1. ACE N on 11 ACC plus N, skip if Psi equals 1. CMA 6511 ACC EOR 6611 ACC LFM Operation N4C11 ACC/M or 4D11 ACC ICVM CAM 6B11 skip if ACC equals M CPAL 6C11 skip if ACC equals L CAXL 6D11 skip if ACC equals XL CAXH 6 times 10 to the power of first 1 skip if ACC equals XH SC1F11C-1 RC1 times 10 to the power of first 1 C-O TC4 times 10 to the power of first 1 skip if C equals 1 240 dash MSM 6502/6512 Instruction list, co-ent Grouping mnemonic code byte cycle function Rally teen 11 .acc ______ Operation C-3-2-10 RAR 1911R ACC C 3-2-1-0 5 MB N230 to 3311 M bit on 2-1 5 MBO M7 N2 50 to 53 22 M bit on 2-1 M7 SPB N220 to 2311 bit on 2-1 RMB N234-3711 M bit on 2-0 bit RMBO M7 N2 54 to 57 22 M bit on 2-0 M7 Operation RPB N224 to 2711 bit on 2-0 TMB N238-3B11 Skype FM bit on 2 equals 1 TMBO M7 N2 58 5B 22 skip if M bit on 2 equals 1 M7 TPB N228-2B11 skip if P bit N2 equals 1 Tab N22C2F11 skip if ACC bit N2 equals 1 TIRB N249-4B11 if IRQF bit N2 equals 1 skip and IRQF bit N2-0 EI5 times 10 to the power of first 1 MEIF-1 Interrupt 015 F11 MEIF-0 JA11 9000-97 CF22 PC0011 Kala 11 A000A7 CF23 Stack PC plus 2 SP3 PCL0011 Branch JCP is 6 CoFF11 PCs OS6 RT3C12 PC Stack SPSP plus 3 RTS311 PC Stack SPSP plus 3 then skip Input IPB311 ACCP Output OP711 PACC CPU HALT 4 F11 HLF-1 Control NOP0011 No Operation 241 EMSM 6502/6512E Electrical characteristic Absolute maximum rating Parameter symbol Power supply voltage VO Input voltage 6 Output voltage VO Power dissipation PO Storage temperature TSTG Operating range Parameter symbol Conditions Ta equals 25 degrees C Ta equals 25 degrees C Per package Conditions Power supply voltage VJ OSC equals 32.768 kHz Operating temperature top 242 Limits unit minus 0.327 V dash 0.3 VOOV dash 0.3 VOOV 200 MV. Minus 55 to plus 150 degrees C. Limits unit. 2.4 to 3.6 V. Minus 20 to plus 70 degrees C. Dash. MSM 6502/6512. DC. Characteristics. VU equals 3V, TA equals minus 20 to plus 70 0E. Parameter symbol. H input voltage VH. L input voltage VL. H out UT. Voltage 1, VOH. L output. Voltage, 2, Vol. V3. V2. LCD drive. Output voltage, 3. V. VO. OSCO input current. HL. Input current, 4, I high L. Input current, 5. HL. Input current, 6. IHL. PO P1. 10 HH output current. 100. Current. IOLT. Consumption. US. Oscillation start. TOSC time. Conditions. 0 equals dash 1 dot ohma. 10 equals 1 dot ohma. MSM 65020 equals dash 5 slash LA. MSM 65120 equals dash 2 slash LA. MSM 65020 equals plus or minus 2 slash LA. MSM 651210 equals plus or minus 0.5 slash LA. MSM 650210 equals plus or minus 2 slash LA. MSM 651210 equals plus or minus 0.5 slash LA. MSM 650210 equals 5 slash LA. MSM 651210 equals plus or minus 2 slash LA. V equals VUV equals OV. V equals VV equals OV. V equals VUV equals OV. V equals VUV equals OV. VO equals OV. MSM 6502. OS equals 32.768 kHz. MSM 6512 at no load. MSM 6502. HOS equals 32.768 kHz. MSM 6512 at HLT execution. MSM 6502. Stattles. MSM 6512. Min. Tip. Max. Unit. 2.6, V. 0.4 V. 2.0, V. 1.0 V. 2.8 to 3.0 V. 1.8 to 2.2 V. 0.8 to 1.2 V. 0.0 to 0.2 V. 2/-2/LA. 1/-10/LA. 1000/-1/LA. 1/-40/LA. -50/LA. 4570 /LA. 3055 3040 /LA. 1225 1525 /LA. 515 10 SEC 243 MSM 6502/6512-1 applied to BZ BZ 2 applied to BZ BZ PO P1 3 applied to common segment 4 applied to reset int 5 applied to P2 when input is unable 6 applied to P2 when input is able. Switching characteristic. VU equals 3V, TA equals -20, plus 7 OC. VA. V. V. Dash VO. Parameter symbol conditions min. Clock, OSCO, pulse width. Cycle time. PO. P1 data valid time. P2. PO. P1 data invalid time. P2. Data delay time. 1. T-sci equals 3x1/f, OSC. 2. TOV equals 112x1/f, OSC. 3. TOLV equals 1x11f, 0SC, plus 1 oils. TQW. TCY. TOV. TOEV. 2CL equals 50pf. 4. 2s equals 5 halves x1/f, OSC, plus 15 ILS. 244. OSCO. PO. P1 input mode. P2. PO. P1 output mode. 1 MCTCY. TCFW Tsent W. Invalid valid. TOLV TOV. Old data. 2s. 15. 1. 2. Tip. Max. Unit. ILS. 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 3. ILS. 4. ILS. Invalid. New data. Dash. MSM 6502/6512. Typical performance curves for MSM 6502. High level output current, low. Output voltage, VOH. VU equals 3V, Ta equals 25 degrees Celsius. -5. -4. S. J. 0.9 -2. BZ terminal. \_. -1 \. Camo, segment terminal. 0.1, PO P1 terminal. O. 1 2 3 4 5 6 7 8 9 10. VOH, V. Middle level output current, 11, 12. Output voltage, V1, V2. VU equals 3V, Ta equals 25 degrees Celsius. 25. 20. 15. V1 V2. 10. 5. N. -5. -10. / J/ common, segment terminal. V2. -15. -20. -25. 1 2 3 4 5 6 7 8 9 10. VV2, V. J. 0.9. 5. 0. FL. Low level output current, LOL. 10. 9. 8. 7. 6. 5. 4. 3. 2. F. If. O. Output voltage, vol. VU equals 3V, Ta equals 25 degrees Celsius. PO, P1 terminal. 2.1-.1. F, BZ terminal. Common SEGMN terminal. 2 3 4 5 6 7 8 9 10. Vol, V. Current consumption, 100, -- Power supply voltage, VU. Ta equals 25 degrees Celsius, no load. 10 M. 5 M. 1 M. 500 IL. 100 IL. 50 IL. 1 oil. HOSC, equals 32,768 kHz. / V. OZ. / 5 IL. 500 N. 100 N 0 2 3 4 5 6 7 8 9 10 VU V 245 EMSM 6502//////////////////////////////////////////////////////////////////////////////////////////////////////////////////////h High-level output current, low. Output voltage, VOH. VU equals 3V, Ta equals 25 degrees Celsius. -5. -4. -3. BZ terminal. 1 backslash. -1 Common, segment terminal. PO, P1 terminal. O 1 2 3 4 5 6 7 8 9 10 VOH, V. Middle level output current, 11, 12. Output voltage, V1, V2. VU equals 3V, Ta equals 25 degrees Celsius. 25. 20. 15. 10. 5. N. -5. -10. V1 V2. JJ. 22. JJ, common, segment terminal. 22. -15. -20. -25. 1 2 3 4 5 6 7 8 9 10 246.9 3 0. 0.9 Low-level output current, LOD. 10 9 8 7 6 5 4 3 2I 2 0 0 Output voltage, VOD. VU equals 3V, Ta equals 25 degrees Celsius. PO, P1 terminal. 1/_1 T, BZ terminal. Common segment terminal. 2 3 4 5 6 7 8 9 10 Vol, V. Current consumption, 100. Power supply voltage, VU. Ta equals 25 degrees Celsius, no load. 10 M. 5 M. 1 M. 5001 dash. 1001 dash. 501 dash. I, OSC, equals 32,768 kHz. V. VOJZ. 101 dash. 51 dash. V. V. 11 dash. 500 N. 100 N. 1 2 3 4 5 6 7 8 9 10 VU, V. 8-bit series, OKI original. N. OKI Saltilcan Luctor. MSM 62580. CMOS 8-bit single-chip microcontroller with 16K-bit E2-PROM. General description. The MSM 62580 is a CMOS single-chip microcontroller with onboard 16K-bit E2-PROM for applications such as IC cards, etc. The powerful instruction set consists of 95 instructions including special instructions for IC cards. Executed by the 8-bit CPU in 800 ns at 5.0 MHz clock frequency. The MSM 62580 has improved hardware and software for security. Consequently, this chip suits applications such as IC cards of low cost, high security, and high reliability. Application examples: IC cards, compact disc players, mechanical controls, audio-video equipment, automobile controls, household appliances, industrial controls, musical instruments. Features: High-speed instruction cycle. High number of instructions, and an efficient instruction set. For example, I instructions for serial interface, SIN, SOUT, daily. Index addressing. 1 byte call addressing, CZP. Small die size. Instructions for auto increment and auto decray. MERN, inc, dec. Simplified E2PROM write/erase operation by using control ROM. From D.C to 5 MHz clock frequency. 9600 baud rate serial interface using DLY instruction. Specifications. Single chip, low power CMOS. 8-bit microcontroller. Clock frequency, 0 to 5.0 MHz. Instruction cycle, soons at 5 MHz. 3 KB program ROM. 512 bytes control ROM. 2 KB E2PROM. Number of instructions, 95. Operation current, 4 RNA typo. Ambient range, 0 to 70 degrees Celsius. 128 bytes data RAM. Number of pads, 5. Supply voltage, plus 5V plus or minus 10%. Die size, 5.0, 4.5 millimeters. 249. EMSM 62580E dash 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 dash. Block diagram. SIO 01 dash 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 1 dash 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 dash. VDD. Res. CLK. GND. A. ALU. B. BA. C. CCR. CLK. D. EPROM. GND. Accumulator. Arithmetic circuit. B register, auxiliary register. B register paired with accumulator. B register higher rank. Carry flag. Condition code register. Clock input pin. D register, data pointer. Rewritable read-only memory. Power supply pin, OV. Asterisk EPROM is not used as instruction. Area. H. P. PC. RAM. Res. SIO. SP. TIC. VDD. Z. ROM. 3KX8. Half carry flag. Asterisk. EPROM. 2KX8. For decimal operations. Parity flag. Program counter. Data memory. Reset input pin. Serial input/output pin. Stack pointer. Timing and control circuit. Power supply pin, 5V. 0 flag. Pin description. Description input/output function. SI/O input/output serial data input/output port. Quasi-bidirection IO port. Set 1 level after reset. VDD, main power source. GND, circuit GND potential. Residential input reset has priority over every other signal. Residential input initialize the processor. Active 0 level. CLK input external clock input. 250. Register diagram. 111. Memory map. 127.7 FH. Rs. RAM. R4. R3. R2. R1. RN RO. O. A. RAM map 17 17 17 17 empty area C-ROM control ROM 01 accumulator 01 B register GGR 0 ID register 01 stack pointer SP 0 I program counter PC ZP0 page address called by CZP instruction 3K 31R O PC FFFH EOOH R1FH W 1 at 4 3 O C ROM map MSM 62580 I 4K 1000H A BA B EPROM map 251 M$M62580 absolute maximum ratings parameter supply voltage input voltage output voltage storage temperature operating conditions parameter supply voltage operating temperature DC characteristics VU equals 5V plus or minus 10%, Ta equals 0 to plus 70 degrees C. Parameter operating current CLK low input voltage res SIO CLK high input voltage res SIO low output voltage high output voltage input current CLK res input current SIO input capacitance output capacitance symbol VU 6 VO TSTG symbol VU top symbol 100 VIL VIH vol VOH IIH1/11L1 IIH2/11L2 CI CO conditions limits Ta equals 25 degrees Celsius minus 0.5 to 7 Ta equals 25 degrees Celsius 0.3 to VDD plus 0.5 Ta equals 25 degrees Celsius minus 0.3 to VDD plus 0.5 O2 plus 70 limits 4.5 to 5.5 O2 plus 70 conditions min tip max F equals 5 MHz 410 minus 0.3 to 0.5 minus 0.3 to 0.5 minus 0.3 to 0.8 2.4 VU 4 VU 2.0 VU 10L max equals 1.6 Ma 0 to 0.4 IOH max dash 100 dot A 2.4 VU 20 6 equals ONOO minus 1 15 F equals 1 MHz Ta equals 25 degrees C 20 notes equals CLK residential has pull down resistance SIO has pull up resistance 252 unit V degree C unit V degree C unit RNA V PA RNA PF dash MSM 62580 AC characteristics VU equals 5V plus or minus 10%, Ta equals 0 to plus 70 degrees C. Parameter CLK cycle time. CLK cycle low width. CLK cycle high width. CLK cycle rise time. CLK cycle fall time. Residential pulse width. SIO input rise time. SIO input fall time. Symbol. TCY. TCL. TCH. TCR. TCR. TRW. TSR. TSF. Note, at output load capacitance co equals 30 pF. Timing charts. Min tip. 200. 0.4 TCY. 0.4 TCY. 8 TCY. TSI dash. TCL. CLK. TCH. TCR TCF. SIO. Res. Backslash 114 dash dash. TRW. Dash dash comma dash dot I slash. Underscore 0.8 V. 0.8 V yen. Max unit. NS. 0.6 TCY NS. 0.6 TCY NS. 5.0 PS. 5.0 PS. PS. 5.0 Ps. 5.0 PS. 253. MSM 62580. Instruction list. Mnemonic operation byte cycle. Flags. Up here. CPHZ. MOVA, up here BA plus B11 star. 0A plus O11 star. At OA plus, D, 11 star. At O plus A plus dash, O, 0 plus dash 0 plus 112 star. At OA plus dash, O, 0 plus dash 0 dash 112 star. NA plus, N, 22 star. N plus at DA plus, N plus O, 23 star. Hashtag NA plus hashtag N22 star. MOV up here, ABB plus A11. 0D plus A11. At O, D, plus, A, 11. At D plus, O, plus A, 0 plus dash 0 plus 112. At O, 0, plus A 0 plus dash 0 dash 112. N, N, plus A22. N plus at O, N plus O, plus A23. MOV 0, up here RNO plus RN12. Hashtag NO plus hashtag N22. MOV RN, up here 0 RN plus 012. Hashtag NRN plus hashtag N23. MOV at BA, APR at O, BA, plus, D, 14. MOV at O, APR at BA, D, plus, BA, 14. MOV at O plus, APR hashtag N, D, plus hashtag NO plus O plus 122. MOV at O plus. APR BA, O, plus A, 0 plus 1, plus B13. MOV WBA. APR at OA plus dash, O, B plus dash, 0 plus 1, 13 star. MOV WBA, APR hashtag NA plus dash hashtag N1, B plus dash hashtag N233 star. 254. Dash. MSM 62580. Flags. Mnemonic CPR operation byte cycle. CPHZ. XCHA CPR BAB12 star. 0A012 star. At OA. D, 12 star. NA. N, 22 star. XCHO CPR BO. B12. SP0. SP12. XCHC CPR PC, P11 asterisk star. Add ACPR at OA plus A plus, O, 11 asterisk asterisk star. NA plus A plus, N, 22 asterisk asterisk star. Hashtag NA plus A plus hashtag N22 asterisk asterisk star. AOKCPR at OA plus A plus, O, plus C11 asterisk asterisk star. NA plus A plus, N, plus C22 asterisk asterisk star. Hashtag NA plus A plus hashtag N plus C22 asterisk asterisk star. OAA decimal adjust 11 asterisk star. CMPACPR at OA dash, D, 11 asterisk star. NA dash, N, 22 asterisk star. Hashtag NA dash hashtag N22 asterisk star. CMP at OCPR hashtag BA, D, BA, 14 asterisk star. EORACPR at OA plus AB, O, 11 star. NA plus AIT, N, 22 star. Hashtag NA plus AIT hashtag N22 star. Or ACPR at OA plus AB, O, 11 star. NA plus AB, N, 22 star. Hashtag NA plus AB hashtag N22 star. And ACPR at OA. NA. Hashtag NA. Flags. April, CPHZ. INKPRAAA plus 111 star. 00-0 plus 111. At O, D, 0, plus 111 star. N, 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 plus 122 star. DEC APRAA plus A111 star. 00 plus dash 0 dash 111. At O, D, 0, dash 111 star. N, N, plus, N, dash 122 star. RRC APRAC, C dash plus A7 underscore OJ11 asterisk star. At O4 C dash plus, 0, 7 dash 0 J11 asterisk star. NI, C dash plus, N, 7 dash 0 J22 asterisk star. RLC APRAC C plus A7 dash 0, 111 asterisk star. At OC plus, 0, 7 dash 0 plus 111 asterisk star. NLC plus, N, 7 dash 0, 122 asterisk star. Push April. PSW. P, plus A, SP1, plus CCR. P plus SP2. 13. 0, SP, plus O, SP plus SP112. Pop April. PSW. CCR plus dash, SP1, A plus dash, SP2. SP plus SP plus 2. 13 asterisk 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 star. 0D, SP plus 1, SP, SP plus 112. JZAPR address if Z equals 1, PC plus 2 plus address to 213. JNZAPR address if Z, tongue sticking out, 1, PC plus 2 plus address 2 2/3. JCAPR address if C equals 1, PC plus 2 plus address 2 2/3. JNCAPR address if C, tongue sticking out, 1, PC plus 2 plus address 2 2/3. JBAPR Badr address if, Badr, equals 1 PC plus 3 plus address 3 3/4. JNBAPR Badr address if, Badr, tongue sticking out, 1, PC plus 3 plus address 3 3/4. OJNZAPR RN address. RN plus RN1, if RN, tongue sticking out, 0. 2 3/4. PC plus 2 plus address, N equals 4-7. JMNEAPR hashtag N address if, D. Hashtag N, PC plus 3 plus address 3 3/4. Joan APR hashtag N address if 0. Asterisk hashtag n, PC plus 3 plus address. 3 3/4. 256. Dash. MSM 62580. Flags. Mnemonic Opere Operation Byte Cycle. CPHZ. JMP Opere Address PC plus address, 04K, 22. Cal Opere Address. SP, plus PC plus 2, PC plus address, 04K. P plus SP2. 24. CZP Opere Address, SP, plus PC plus 2 PC plus ZP SP plus SP214. RTPC plus dash, SP, SP plus 213. NOP No Operation 11. CLR Opere AA plus 0111. RCC plus 0110. SCC plus dash 1111. RB Badr, plus 022. SB Badr, plus 122. CPL Opere AA plus A11 star. CC plus C11 star. Check Opere PP plus C, if A equals odd, C plus dash 1 else C plus 011 asterisk star. Sin C plus SI011 star. South Silo plus C11. Daily Opere hashtag and delay n plus 3 cycles 23 to 258. 257. OKI. And M conductor. MSM 66301. OKI Original High Performance. CMO Single Component 8/16-bit Microcontroller. General Description. The OKI MSM 66301 is a new generation, high-performance single-component microcontroller. Implemented in silicon gate complementary metal oxide semiconductor technology, CMOS. Integrated within this chip are 16-bit ALU, 16K bytes of mask program ROM, 512 bytes of data RAM. 481/0 lines, built-in 16-bit timers, 10-bit aid converter, serial 110-port, pulse width modulator, PWM. And oscillator. Features. 8-bit external data bus interface. 16-bit internal architecture. 64K address space for program memory. Including 16K bytes on chip ROM. 512K address space for data memory. Including 512 bytes on chip RAM. High-speed execution. Minimum cycle for instruction, 400 ns. 10 MHz. The abundance of powerful instructions. 8/16 data transfer operation. 8/16 bit arithmetic operation. 16, 8, bit x 16, 8, bit, 32, 16, bit. 32, 16, bit 16, 8, bit, 32, 16, bit. 16, 8, bit plus or minus 16, 8, bit dash 16, 8, bit. 8/16 logic operation. Bit operation. String operation. User stack operation. ROM table access operation. The same instruction allows both byte and word width operation according to data descriptor. That is to say, the same algorithm and the same source program lines are applicable to byte and word width data manipulation with only changing data descriptor. Many addressing modes. 258. 8 input lines, 40 input/output lines. Built-in 16-bit timer X4. Each timer has the following 4 modes. Auto reload timer mode. Clock out mode. Capture register mode. Real-time output mode. Serial port X1CH. Variable bit length, baud rate generators 4. Transmitter and receiver. Asynchronous normal mode. Asynchronous multiprocessor. Communication mode. Synchronous normal mode. Synchronous multiprocessor. Communication mode. 16-bit pulse width modulator X2. Transition detector X4. 10-bit 8 converter, 8 channel. 1 non-maskable interrupt, 16 maskable. Interrupts. Standby function. Software clock stop. Software CPU stop. Hardware CPU stop. 64-pin shrink dip / 64-pin plastic flat. Package / 68-pin PLCC. Dash. MSM 66301. Pin configuration. ADU / P001. AU / I05. AD / PO. AOD / POD. AS / P109. A9 / P1. A10 / P12. ALL / PT3. A12 / P14. A13 / P15. A14 / P16. A15 / P17. A16 / P20. A17 / P21. A18 / P22. Resout. AL. VDD. VREF. AGND. PS7 / AI7. P56 / AI6. P55 / AI5. P54 / AI4. P53 / AI3. PS1 / all. P50 / AIO. P47 FTRANS3. P46, Trans2. P45 ITRANSL. P44 / Transo. P43 / PWML. P42 / PWMO. P41 / TMLCK. P40 FTMOCK. P37 / TM310. P36, TM210. P35 ITM1IO. P34 ITMOIO. P33 / 1 NTL. P32 / 1 NTO. P3L / RXE. P3Q / TXD. P27 / RXC. P26 ITXC. P2S / HLDA. OSCL P24 / hold. GNONMI --__. Functional block diagram. TMCK1. TMCO. TMIOA. TMI02. 1MI01. TMIOO. RXD. RXD. RXC. TXC. Trans3. Trans2. Trans1. Transib. VREF. AI7AID. AGND. PWM1. PWMD. TT. VG. ON. DO. HHTT. OLNN. LATIO. A10. P5 P4 P3 P2 PLPO. EA. Ready. AL. PSEN. RD. WR. Is. A. ROM F. Z. 0. AD7. Dash ADU. F. XUJ. As. 259. EMSM 66301. E. Pin description. Designation input / output function. POOP07 / PO, a bit IO port. Each bit can be assigned to input or output. ADU AD7 IOAD, outputs the lower bits of program counter during external program memory fetch, and receives the addressed instruction under the control of PSEN. Also outputs the address, outputs, or inputs data during an external data memory access instruction, under control of AL, RD, and WR. PL0P17/IOP1, 8-bit I/O port. Each bit can be assigned to input or output. A15A, outputs the middle bits of program counter. PCA1S, during external program memory fetch. Also outputs the middle bits of address during an external data memory access instructions. P20 P221 P2, 8-bit I/O port. Each bit can be assigned to input or output. ALB-ALB-A, outputs the upper 3 bits of address during external data memory access instructions. P2VCLKOUT clockout, clock output pin. Output frequency range is equal to or twice the system clock. P24/hold IO hold, input pin to request the CPU to enter the hardware power down state. P2S/HLDA hold acknowledge, the HLDA signal appears in response to the hold signal and indicates that the CPU has entered the power down state. P2SITXCTXC, transmitter clock input pin. P27/RXCRXC, receiver clock input pin. P301TXDP3, 8-bit I/O port. Each bit can be assigned to input or output. P3L/RxDTXD, transmitter data output pin. P321 into RxD, receiver data input pin. P33/FNJFIOINT, interrupt request input pin. Falling edge trigger or level trigger is selectable. P34 ITMOI0 TMOIO, TM310, one of the following signals is output or input. P3S/TM110 clock twice the frequency range of the 16-bit timer overflow. P3BITM210 load trigger signal to the capture register. Input. Setting value output. The signal that is input or output depends on the mode. P37 ITM310. 260. MSM 66301. Pin description, continued. Designation input/output function. P40/TMOC P4, 8-bit I/O port. Each bit can be assigned to input or output. P4 ITM1CK TMOC, TM1CK, clock input pins of timer 0, timer 1. P421 PWMOIOTRNS, transition detector. The input pins which sense the failing edge and set the flag. P43/PWM1 PWM, pulse wide modulator output pin. P44 P47/ Transo, TRNS3. P50 P571 input P5, 8-bit input port. A 10A17AI, analog signal input pin to 8 converter. Resout output H level when the CPU is in reset cycle. Reset to L level by program. AL output address latch the timing pulse to latch the lower. Enable, 8-bit of the address output from port 0 when the CPU accesses the external data memory. PSEN output program store the strobe pulse to fetch to exter. Enable, NAL program memory. RD output strobe activated during a bus read. Can be used to enable data onto the bus from the external data memory. WR output strobe during a bus write. Used as write strobe to external data memory. Ready input used when the CPU accesses low-speed peripherals. EA input normally set to H level. If set to L level, the CPU fetches the code to external program memory. FLT input if FLT is H level, AL, WR, RD, PSEN are set H level. When reset. If FLT is set to L, AL, WR, RD, PSEN are set to floating level when reset. Reset input pin 261 EMSM 66301 E. Pin description, continued. Designation input/output function. OSCO OSC, oscillation circuit consists of OSCO. OSC1. NMI input non-maskable interrupt input pin, falling edge. VREF reference voltage input pin for aid converter. AGND ground for aid converter. VDD system power supply. GND ground. Registers. 15.0. Accumulator. ACC. Control registers, CR. Program status word PSW. Program counter PC. Local register base LRB. System stack pointer SSP. Pointing registers, PR. Index register 1XL. Index register 2X2. Data pointer DP. User stack pointer USP. Local registers. Arrow RLRO. ERL RS R2. ER2 R5 R4. ERS R7 R6. Special function registers, SFR. All of the 1/0 functions are controlled by SFRs. Also, some of the internal functions, timer, WDT, etc., are controlled by SFRs. SFRs are located in the top of RAM space, 007FH. 262. MSM 66301. MSM 66301 Special Function Registers 1. 8/16 when. Address name abbreviation R/W Operation Reset. 0000 System Stack Pointer SSPL R/W 8/16 FF. 0001 SSPHFF. 0002 Local Register Base LRB LR/W 8/16 unknown. 0003 LRBH. 0004 Program Status Word PSWLRIW 8/16 00. 0005 PSWH00. 0006 Accumulator ACCLR/W 8/16 0007 ACCH00. 0008 Source Index Register SIR/W 16 unknown. 0009 for block transfer. 0008 Destination Index Register 01R/W 16 unknown. 000B for block transfer. 00 DC Counter Register CXR/W 16 unknown. 0000 for block transfer. Source/destination BSDIR/W 8 unknown. 000E. Bank Register. 0010 Standby Control Registers Beacon R/W 800. 0011 Watchdog Timer WDTW 8. 0012 Peripheral Control Register PRPHFR/W 801. 0016 Work Area for Emulator R/W 16 unknown. 0017. 0018 Interrupt Request Flag IRQLR/W 8/16 00. 0019 IRQH00. 001A Interrupt Enable Flag ILR/W 8/16 00. 001B IEH00. 001C external interrupt execon r/w800. Control register. 263. MSM66301-. MSM66301 special function registers 2. 8/16 when. Address name abbreviation r/w operation reset. 0020 port 0 data register PO r/w8 unknown. 0021 port 0 mode register polo r/w800. 0022 port 1 data register P1 r/w8 unknown. 0023 port 1 mode register P110 r/w800. 0024 port 2 data register P2 r/w8 unknown. 0025 port 2 mode register P210 r/w800. 0026 port 2 special function P2SF r/w800. Control register. 0028 port 3 data register P3 r/w8 unknown. 0029 port 3 mode register P310 r/w800. 0028 port 3 special function P3SF r/w800. Control register. 002C port 4 data register P4 r/w8 unknown. 0020 port 4 mode register P410 r/w800. 002E port 4 special function P4SF r/w800. Control register. 002F port 5 P5 R8. 0030 timer 0 counter TMO r/w1600. 003100. 0032 timer 0 register TMRO r/w1600. 003300. 0034 timer 1 counter TM1 r/w1600. 003500. 0036 timer 1 register TMR1 r/w1600. 003700. 0038 timer 2 counter TM2 r/w1600. 003900. 0038 timer 2 register TMR2 r/w1600. 003800. 003C timer 3 counter TM3 r/w1600. 003000. 003E timer 3 register TMR3 r/w1600. 003F00. 264. MSM66301. MSM66301 special function registers 3. 8/16 when. Address name abbreviation r/w operation reset. 0040 timer 0 control registered cano r/w800. 0041 timer 1 control register TCON1 r/w800. 0042 timer 2 control register TCON2 r/w800. 0043 timer 3 control register TCON3 r/w800. 0046 transition detector reg. TRNS r/w800. 0013 stop mode buffer flag W8. 265. EMSM66301E. MSM66301 special function registers 4. 8/16 when. Address name abbreviation r/w operation reset. 0046 transition detect / or TRNS r/w800. 0048 transmitter clock generator STTM r/w800. 0049 transmitter clock generator STTMR r/w800. Control register. 0048 Transmitter Control Register STTMCRIW800 004C Receiver Clock Generator SRTMRIW800 0040 Receiver Clock Generator SRTMRIW800 Control Register 004E Receiver Control Register SRTMCR/W800 0050 Transmitter Mode Control Register STCNR/W800 0051 Transmitter Data Buffer STBUB W8 unknown 0054 Receiver Mode Control Register SRCNR/W800 0055 Receiver Data Buffer SRBUF R8 unknown 0056 Receiver Error or Status Register SRSTAT R800 0058 Scanning Mode Register ADSCAN RIW800 00598 Select Mode Register ADSEL R/W800 00608 Convert Result Register 0 ADCROL R8/16 unknown 0061 ADCRO 00628 Convert Result Register 1 ADCR1L R8/16 unknown 0063 ADCR1H 00648 Convert Result Register 2 ADCR2L R8/16 unknown 0065 ADCR2H 00668 Convert Result Register 3 ADCR3L R8/16 unknown 0067 ADCR3H 00688 Convert Result Register 4 ADCR4L R8/16 unknown 0069 ADCR4H 00688 Convert Result Register 5 ADCR5L R8/16 unknown 006B ADCR5H 006C8 Convert Result Register 6 ADCR6L R8/16 unknown 006D ADCR6H 006E8 Convert Result Register 7 ADCR7L R8/16 unknown 006F ADCR7H 266 MSM66301 MSM66301 Special Function Registers 5 8/16 when Address Name Abbreviation R/W Operation Reset 0070 PWM0 Counter Punkel 00 R/W 8/16 0071 Pumco 00 0072 PWM0 Register Pumral 00 R/W 8/16 0073 Pumro 00 0074 PWM1 Counter PWMC1L 00 R/W 8/16 0075 PWMC1H 00 0076 PWM1 Register PWMR1L 00 R/W 8/16 0077 PWMR1H 00 0078 PWM0 Control Register Pukino R/W 800 0078 PWM1 Control Register Pukin 1 R/W 800 267 MSM66301 Addressing Mode. The MSM66301 supports 512 KB, 64 KB x 8 banks, 05 data space and 64 KB of program space. With various types of addressing methods. These methods divide into the following types. 1. RAM addressing, for data space. 1.1 Register direct addressing. ROR DP. T, N. v//FFIQW//fill. 1.2 Displacement addressing. A. 0 page. LA, 10H. LN////1. B, direct page. Underscore X. 51A, off XX10H. \0 underscore dash 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 dash. 1.3 pointing register indirect addressing. A, data pointer, DP, indirect. SLL. B, user stack pointer, USP, indirect. RX. DP. DP. SRL10H. Equals, 0 to 255. 268. U5P. I. RAM. USPI. J. Dash. O. 0010H. XXOOH. XXL0H. RAM. Dash. MSM66301. C. Index register, X1 X2, indirect. X. Inc 300H X1. X1. 1.4 immediate addressing. MOVSSP, hashtag 127FH. 2 ROM addressing, for program space. 2.1 direct addressing. JMP. 2.2 pointing register indirect addressing. A, date pointer, DP, indirect. LCDP. I. DP. B, user stack pointer, USP, indirect. Dot dash dash. J10H USP. C, pointing register, X1, X2, DP, USP, indirect with 16-bit displacement. Dash. CMPC 300H X1. X1. 0 to 65,535. J. 269. EMSM 66301E. Instructions. Data transfer. Instruction function. LAA. LBA, asterisk AL. Asterisk. STA. A. STBA asterisk AL. MOV. Underscore, A. AMOVBA, asterisk AI. MOV hashtag. 1ME. MOVB asterisk A star. AL. MOVER. Asterisk ER. MOVB asterisk, hashtag. IM. MOVD, D. MOVBR, R. MOVDP, DP. MOVBD, D. MOVX1, X1. MOVBPSWO, asterisk PSWO. MOVX2, X2. MOVBSCB, SCB. MOVUSP. WSP. MOVPSW. PSW. Asterisk. MOVSSP. SSP. Asterisk. MOVLRB. LRB. CLR. Asterisk asterisk. 0 CLRB. 0. Swap A5-8A7-0 swap A7-4A3-0. XCHGA, A asterisk XCHGBAL. XNBLA, A3-0 asterisk 3-0. TRNS USP, LRB USP 5-3. LRB 2-0. USP 2-0. 0. TRNS LRB, USP LRB 20. USP 5-3. LRB 5-3. 0. Push and pop. Instruction function. Pushu asterisk. User stack pushub. User stack. POPUAA. User stack POPUB AAL. User stack. Push asterisk star. System stack. Pop star. System stack. 270. Dash. MSM 66301. Rotate and shift. Instruction function. Roll asterisk rotate. ROLB rotate. ROR asterisk rotate. RORB asterisk rotate. SLL asterisk shift. Logical SLLB asterisk shift. Logical. SRL asterisk shift. Logical SRLB asterisk shift. Logical. SRA asterisk shift. Arithmetic SRAB asterisk shift. Arithmetic. Increment and decrement. Instruction function. Inc asterisk star. Asterisk plus 1 INCB asterisk star. Asterisk plus 1. Dec asterisk star. Asterisk dash 1 DECB asterisk star. Asterisk 1. ROM table reference. Instruction function. LCA asterisk A, asterisk, ROM, LCBA, asterisk AL, asterisk, ROM. CMPCA asterisk A dash asterisk, ROM, CMPCBA, asterisk AL dash asterisk, ROM. 271. MSM 66301. Arithmetic operation. Instruction function. Mul ER1, A. A0 MULBA. ALXRO. DIV arrow, A. Arrow, ALR2 DIVBA. ALRO. Add A, A. A plus ADDBA, asterisk AL. AL plus. Add dash, A. Dash plus AADDB asterisk A. Plus AL. Add dash, D. Plus, D, ADDB asterisk, D. Asterisk plus, D. Add asterisk, hashtag. Plus im. ADDB dash, hashtag. Asterisk plus im. ADCA, A. A plus plus CADCBA asterisk AL. AL plus plus C. ADC asterisk, A star. Asterisk plus A plus CADCB asterisk, A. Asterisk plus AL plus C. ADC dash, D. Plus, D, plus CADCB dash, D star. Plus, D, plus C. ADC asterisk, hashtag star. Plus im. Plus CADCB asterisk, hashtag. Plus im. Plus C. Sub A, A. ASUBBA, AL. AL. Sub asterisk A star. ASUBB asterisk A. AL. Sub asterisk, D star. Asterisk, D, SUBB asterisk, D. D. Sub dash, hashtag. Im. SUBB asterisk, hashtag. Im. SBCA, asterisk A. A dash asterisk C SBCBA, asterisk AL. AL, asterisk, C. SBC asterisk A star. Asterisk AC SBCB asterisk A. Asterisk, ALC. SBC asterisk, D star. D, C SBCB asterisk, D star. Asterisk, D, C. SBC asterisk, hashtag star. MC SBCB dash, hashtag star. Asterisk im. C. 272. Dash. MSM 66301. Logical operation. Instruction function. and AA. Und ANDBAAL. Allund. And asterisk, A. Asterisk and AANDB dash A. And AL. And asterisk, D asterisk. Asterisk and, D, ANDB dash, D. Asterisk and, D. And asterisk, hashtag asterisk. Asterisk and IM. ANDB dash, hashtag. Or AA. Our. Or BAL. Allor. Or dash, A. Or A orb asterisk, A asterisk. Or dash, D. Asterisk or, D, orb asterisk, D asterisk. Or dash, hashtag. Asterisk or IM. Orb asterisk, hashtag asterisk. X or AA. Axor XORBAAL. Al X or A asterisk. Asterisk X or A XORBA. X or dash, D. X or, D, XORB dash, D. X or asterisk, hashtag. X or IM. XORB asterisk, hashtag asterisk. Comparison. Instruction function CMPAA CMPBA asterisk AL. Asterisk. CMP-A is CMPBA AL. CMP dash, D asterisk, D, CMPB asterisk, D asterisk, D. CMP asterisk, hashtag IM. CMPB dash, hashtag IM. 273. MSM 66301 dash. Stack operation. Instruction function. Add A. Plus USP dash. USP plus 2, A dash. A plus USP. ADCA. Plus USP dash. USP plus 2, A dash. A plus USP plus C. Sub A. Plus USP dash. USP plus 2A dash. A USP. SBCA. Plus USP dash. USP plus 2A dash. A USPC. NA. Plus USP dash. USP plus 2, A dash. Und USP. Or A. Plus USP dash. USP plus 2, A dash. Our USP. X or A. Plus USP dash. USP plus 2, A dash. Axor USP. CMPA. Plus USP dash. USP plus 2, A, USP. Decimal adjust. Instruction function. DAA decimal adjust for addition. DOS decimal adjust for subtract. Bit operation. Instruction function SBR asterisk bit dash. 1 SB asterisk bit dash. 1. RBR asterisk bit dash. 0 RB asterisk bit dash. 0. MBRCC dash. Bit MBCC. Bit. MBR asterisk, C bit dash. CMB asterisk C bit dash. C. TRB asterisk Z dash. Bit. Execute. Instruction function. X. Asterisk execute specified data as the instruction. 274. Dash. MSM 66301. Jump and call. Instruction function SJADRs short jump SCLADRs. I jump. Cal. JCEO, ADRs jump if equals JCNE, ADRs. JCLE, ADRs jump if. JCGE, ADRs jump if equals JCGT, ADRs. JBS bit, ADRs jump if bit on JBR bit, ADRs. JRNZ, DP, ADRs loop function VCL ADRs. Return. Instruction function. RT return from subroutine. RTI return from interrupt. String operation. Instruction function. SMOV string transfer with increasing pointers. SMOV string transfer with decreasing pointers. SCMP string compare. Others. Instruction function instruction. SCC. 1 RC. SS stack flag. 1 break. NOP no operation. Note. Hashtag and im. Addressing expression, see addressing mode. Immediate value. And dash plus bit shift direction. Function. Short call. Call subroutine. Jump if all. Jump if. Jump if. Jump if bit off. Vector call. Function. C. 0. Software reset. 275. EMSM 66301. E. Absolute maximum rating, target specification. Item symbol condition value unit. Power supply voltage VDD -0.3 to 7.0 V. Input voltage 6-0.3, VDDV. Output voltage VA to 25 degrees Celsius -0.3, VDDV. Analog reference voltage VR -0.3, VDDV. Analog input voltage val -0.3, VRV. Ta equals 25 degrees Celsius, per package 400 max MW. Power dissipation PD. Ta equals 25 degrees Celsius, per output 50 max MW. Storage temperature TSTG, -55 -150 degrees Celsius. Operating range. Item symbol condition value unit. Power supply voltage VDDF, OSC, 10 MHz 4.5 to 5.5 V. Data retention voltage VOOHF, OSC, equals 0 Hz 2 to 6 V. Analog reference voltage VR 4.5, VDDV. Analog ground voltage VAG, 0 to 0.2 V. Analog input voltage val VAG, VRV. MOS load 30. Fan out NPOO, P072. TTL load. P0, P471. 276. Dash. MSM 66301. DC characteristics, target specification. VU equals 5V plus or minus 10%, Ta equals -40, plus 85C. Item symbol condition min. Tip. Max. H input voltage 1, 2, 3, 7 VIH, 2.4 VU. H input voltage 6, 7 *9 VIH, 4.0 VU. L input voltage *1, 2, 3 *7 VIL, -3.00.8. L input voltage 6, 8 *9 VIL, -0.30.8. H output voltage 1, 2, 4, 5 VOH10 equals -30 FJA 4.2. H output voltage *10 VOH10 equals -15 FJA 4.2. L output voltage 1, 4 Vol 10 equals 3.2 Ma 0.45. L output voltage 2, 5 Vol 10 equals 1.6 Ma 0.45. L output voltage *10 Vol 10 equals -15 FJA 0.4. Input current 1, 2, 3, 7 *8 IIH/IILI6 equals VU/OV1/-1. I input C urent *6 IIH/IIL6 equals VU/OV1/-20. Input current asterisk 9 IIH/IIL6 equals VU/OV10/-10. H output current 1, 2, 4, 5 10 HVO equals 2.4 V minus 0.2. Analog reference voltage. RR VAG equals OV16. Supply resistance. Analog input leak current RLAI VAG equals OV plus or minus 1. RI/O converter active 1. Analog input impedance end. Cal in sampling condition 10. Input capacity C, F equals 1 MHz, Ta equals 25 C5. Output capacity Co F equals 1 MHz, Ta equals 25 C7. VU equals 2V, no load, Ta equals 25 C0.2. Current consumption, stop, IOOS. No load 1. Current consumption 100 F, OSC, equals 10 MHz, no load 20. Asterisk 1 specification applied to PO. Asterisk 2 specification applied to P1, P2, P3, P4. Asterisk 3 specification applied to P5. Asterisk 4 specification applied to AL, PSEN, RD, WR. Asterisk 5 specification applied to RESOUT. Asterisk 6 specification applied to RES, NMI. Asterisk 7 specification applied to REAE, EA. Asterisk 8 specification applied to FLT. Asterisk 9 specification applied to OSCO. Asterisk 10 specification applied to OSC. Unit. V. 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 FJA. 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 MA. KN. FJA. MN. PF. 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 FJA. FJA. MA. 277. EMSM 66301E. AC characteristics, target specification. External program memory control, VDD equals 5V plus or minus 10%, Ta equals minus 40, plus 85 degrees C. Item symbol condition min. Tip. Max. Unit. OSC clock pulse width TRPW, 50 ns. AL pulse width Ta, 100 ns. PSEN pulse width TPW, 250 ns. PSEN pulse delay time TPAD TCPW plus 20 ns. L address setup time TOS TCPW 30 TCPW plus 30 ns. L address hold time TAAH TRPW 30 TCPW plus 30 ns. H address delay time TAADCL equals 50 PF plus 30 ns. H address hold time TAPH TRPW 10 TRPW plus 40 ns. Instruction setup time TIS 80 ns. Instruction hold time TLH 50 ns. External data memory control, VDD equals 5V plus or minus 10%, Ta equals minus 40, plus 85 degrees C. Item symbol condition min. Tip. Max. Unit. OSC clock pulse width TRPW, 50 ns. AL pulse width Ta, 100 ns. RD pulse width TRW, 250 ns. WR pulse width TWW, 200 ns. RD pulse delay time TRAD TCPW plus 20 ns. WR pulse delay time TWAD TCPW plus 20 ns. L address setup time TOS TCPW 30 TRPW plus 30 ns. L address hold time TAAH TCPW 30 TRPW plus 30 ns. H address delay time TAAD TCPW plus 30 ns. H address hold time, RD, TARHCL equals 50 PFTCPW 10 TCPW plus 40 NS. H address hold time, WR, TAWH2 TRPW 10 2 TRPW plus 40 NS. Memory data setup time TMS 80 NS. Memory data hold time TMH 50 NS. Data delay time TDD TCPW plus 30 NS. Data hold time TDH2 TRPW 10 2 TRPW plus 40 NS. 278. Dash 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 EMSM 66301E. 8 Conversion characteristics, target specification. VDD equals 5V plus or minus 10%, comma. Item symbol condition min. Tip. Max. Unit. Resolution N 10 bits. 0 point error EZS. VR equals VDD. Plus or minus 2 LSB. Foo scale error EFS VAG equals GND equals OV plus or minus 2 LSB. Line arity error L. Analog input. Impt ans 5 knots. Plus or minus 3 LSB. Input crosstalk Ta equals 25 degrees Celsius plus or minus 2 LSB. Channel conversion speed TC 64320S/ch. 279. MSM01 dash. Timing chart. CLK. AL. Ta. PSEN. TPAD. ITPWI. Slash. PC0-7, INS-7 IADU7. I, TOS TAAHTLSTLHIII. Slash. PC8-15. Backslash A8-15. M. I. RD. Trad. ITRWI. Slash backslash slash. Backslash. Slash. ADU 7. IT AASTAAHI. TMS. TMHI. 2L. J. DP8-18. Backslash. 1 backslash. A8-18. TAADH. F. II. WR. TWAD. ITWWI. ADU 7. Slash. DOUTO7. Backslash. Backslash DO7 slash. 1 AST, colon, F. TDH1. I. DP8-18. Backslash F. A8-18. TAWHL. 280. 8-bit series, Intel compatible. I. OKI semiconductor. MSM80C35/48. MSM80C39/49. MSM80C40/50. CMOS 8-bit single-chip microcontroller. General description. The OKI MSM80C48/MSM80C49/MSM80C50 microcontroller is a low-power, high-performance 8-bit single-chip device implemented in silicon gate complementary metal oxide semiconductor technology. Integrated within these chips are 8K/16K/32K bits of mask program ROM. 512/1024/2048 bits of data RAM, 27 I/O lines, built-in 8-bit timer/counter, and oscillator. Program. Memory and data paths are byte-wide. 11 new instructions have been added to the NMOS ver. Zion's instruction set, thereby optimizing power down, port data transfer, decrement and port float. Functions. Available in 40-pin plastic DIP, ARS, or 44-pin plastic flat packages, GSK. Features. Lower power consumption enabled by CMOS. Silicon gate process. Completely static operation. Improved power down feature. Minimum instruction cycle 1.36 JLS, 11 MHz. At VCC equals +5V plus or minus 10%. 11 MHz version of MSM-ADC 40/50, 6 MHz. Every signal input terminal is provided with a Schmidt circuit, except XTAL1 pin. Every signal output terminal is capable of driving a standard TTL, except XTAL2 pin. 111 instructions. All instructions are usable even during execution of external ROM instructions. Operation facility. Addition, logical operations, and decimal. Adjust. Program memory, ROM. Data memory, RAM. 1K x 8 bits. MSM-ADC 48. 2K x 8 bits. MSM-ADC 49. 4K x 8 bits. MSM-ADC 50. 64 x 8 bits. MSM-ADC 48. 128 x 8 bits. MSM-ADC 49. 256 x 8 bits. MSM-ADC 50. 2 sets of working registers. External and timer interrupts. 2 test inputs. Built-in 8-bit timer counter. Extendable external memory and I/O ports. Input/output ports. Input/output ports. 8 bits x2. Data bus input/output. -8 bits 1. Single-step execution function. Every signal input terminal is provided with a Schmidt circuit, except XTAL2 pin. Every signal output terminal is capable of driving a standard TTL, except XTAL2 pin. Wide range of operating voltage, from +2.5 V to +6 V VCC. High noise margin action. 2 kinds of package, 40-pin plastic DIP and 44-pin plastic flat package. Compatible with Intel's 8048, 8049 and 8050. 283. MSM-ADC 3S/48, ADC 39/49, ADC 40/S0, Functional block diagram. Port 2. Initialize CPU memory. Separate. Pin configuration. Top view, 40 lead plastic DIP. 2V. XTAL1T. XTAL2P2. Reset P2. SSP2. INT P2. EAP. ADP. PSENP. P. LP. 08P. P. 08, P. VDD. 08, Prog. 08, P2. 08, P2. 08, P2. VSSP2. 284. Single. Step. Pin name. P10, P1. P20, P2. DBO, DB. 2, T1. Int. RD. WR. Data store. Data memory tram. 64I, AMSM-ADC 48 Rs. 2828 MSM-80C 49 Rs. 2568 MSM-80C 50 Rs. Top view, 44, lead plastic flat. P2. 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 T V 2 xtol 1 xtol 2 R NE prog P2 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 VSS DB 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 Input/output port 1 AL address latch enable Input/output port 2 PSEN program store enable Data bus port reset Test SS single step Interrupt EA ROM mode Red XTAL 1, 2 controlled Write oscillator dash MSM ADC3S/48 ADC39/49 ADC40/S0 Pin description Designation input/output function P10P1 input/output 8-bit quasi-bidirectional port 1 P20P2 input/output 8-bit quasi-bidirectional port 2 The high-order FOU by TS of external program memory addresses can be output from P20 P23, to which the I/O expander MSM82C43Rs may also be connected. DBODB, input/output bidirectional port. Bus, the low-order 8 bits of external program memory address can be output from this port, and the addressed instruction is fetched under the control of PSEN signal. Also, the external data memory address is output, and data is read and written synchronously using RD and WR signals. The port can also serve as either a statically latched output port or a non-latching input port. To input/output, the input can be tested with the conditional jump instructions JTO and test0, JNTO. The execution of the ento CLK instruction causes a clock output to be generated. T1 input. The input can be tested with the conditional jump instructions JT1 and JNT1. The execution of a strtcnt instruction causes an internal counter input low be activated. Int input interrupt input. If interrupt is enabled, int input initiates an interrupt. Interrupt is disabled after a reset. Also testable with a JNI instruction. Can be used to terminate the power down mode. Active O level. RD output a signal to read data from external data memory. Active O level. Read. WFF a signal to write data to external data memory. Active 0 level. Write. AL. This signal is generated in each cycle. It may be used as a clock output. Address and external data memory or external program memory is addressed upon the data latch falling edge. For the external ROM, this signal is used to latch the bus port. Clock data upon the AL signal rise up after the execution of the OUTL bus, A instruction. PSEN output a signal to fetch an instruction from external program memory. Program, active 0 level. Store enable. Reset output, reset, input initialize the processor. Active O level. Used to terminate the power down mode. SS output a program is executed step by step. This pin can also be used to control single step, internal oscillation when the power down mode is reset. Active O level. EA input when held at high level, all instructions are fetched from external memory. External access, active 1 level. Prog output. This output strobes the MSM82C43Rs I/O expander. Expander strobe 285. MSM ADC35/48, ADC39/49, ADC40/50. Pin description, cont. Designation input/output function. XTAL1 input one side old crystal input for the internal oscillator. An external source can. Crystal 1, also be input. XTAL2 output other side of crystal input for internal oscillator. Crystal 2. VCC, power supply terminal. VDD, standby control input. Normally, 1 level. When set to 0 level, oscillation is stopped and processor goes into standby mode. VSS, GND. Note, the required reset pulse duration is at least 2 machine cycles under the condition that the power supply and the oscillator have been stabilized. 286. EMSM ADC35/48, ADC39/49, ADC40/50E. Added functions of MSM-ADC48, MSM-ADC49, and MSM-ADC50. The MSM-ADC48, MSM-ADC49 and MSM-ADC50 basically incorporate the capabilities of Intel's 8048, 8049, and 8050 plus the following new functions. 1 power down mode enhancements. 1,1 power down by software. 1. Clock, see item 4, power down mode, 4. Details. A. Crystal controlled oscillator halt, HLTS. Instruction. Power requirements can be minimized. B. Clock supply halt, halt instruction. Restart is accomplished without oscillator wait. 2. 1/0 ports, see table 4-1 and 4-24. Details. 1/0 port floating instructions. Power consumption resulting from input slow. Outputs can be minimized with FLT and FLTT instructions. Port floating is cancelled while executing. FRES instruction, 0 level at int pin or 0 level at RESR pin. 3. 6 types of power down can be done by a combination of HLTS/HALT and FLTI/FLTT. Instructions. 1.2 power down by hardware, see 4.3. Power down mode by VDD pin utilization. For details. Crystal controlled oscillators can be halted by controlling the VDD terminal, thereby floating all 1/0 ports for minimum power consumption. 2 additional instructions, 11. HLTS. Halt. FLT. FLTT. FRES. MOVA, P1. MOVA, P2. MOVP1, at R3. MOVP1P, at R3. DEC at RR. DJNZ at R, address. 3 improved uses of buspo, 7, P107. P20, 7, and SS terminals. 3.1 BUSPO 7. The MSM-ADC48, MSM-ADC49, and MSM-ADC50 remove the limitation on the use of OUTL bus, A instructions during the external ROM access mode by having an independent data latch and external ROM mode address. Latch in buspo, 7. Consequently, there is no need to relocate bus port instructions when in the external ROM access mode. 3.2 P107 and P20, 7. The MSM-ADC48, MSM-ADC49 and MSM-ADC50 are designed to minimize power consumption when P107 and P20, 7 are used as input/output ports, to maximize the performance of CMOS. When these ports are used as output ports, The acceleration circuit is actuated only when output data changes from 0 to 1, thus speeding up the rise time of the output signals. When these ports are used as input ports, the internal pull-up resistance becomes approximately 9K0 when input data is 1. The internal pull-up resistance rises to approximately 100K0 when input data is 0. Thus, a high noise margin can be obtained by selecting the impedance, and thus the outflow of current is minimized whenever these ports are used as output or input ports. 3.3 Clock generation control via the SS terminal. When the crystal-controlled oscillator is halted in the HLTS or hardware power-down mode, the SS terminal is pulled down by a raises torque of 20 to 50 kO, while its internal pull-up raises torque of 200 to 500 knots is isolated from VEC. When the power-down mode is cancelled, the internal resistor of the SS terminal is changed from pull down to pull up. Consequently, the CPU can be halted for any period of time until the crystal-controlled oscillator resumes normal oscillation. When a capacitor is connected to the SS terminal NAL for power-down mode, the MSM-ADC48, MSM-ADC49, and MSM-ADC50 power-down mode can be enabled in two different ways: through software by a combination of clock control and port floating instructions, and through hardware by control of the VDD pin. 4.1 Software power-down mode. Power-down mode can be done by a combination of the following instructions. 1. Halt, clock supply halt to control circuit. Instruction I0000 I0001I. Code description: although crystal controlled oscillator operation is continued, the clock supply to the CPU control circuit is halted and CPU operations suspended. When cancelling this software mode, restart is accomplished without OS delay or wait. Timing charts are outlined in Figs 4:1 and 4:2. 2. HLTS, oscillation stop. Instruction RL1000100101. Code description: the oscillator operation is halted and CPU operations suspended. In cancelling this power down mode, connecting a capacitor to the SS pin enables a reasonable 287 MSM ADC 35/48, ADC 39/49, ADC 40/50, wait period to be accomplished before normal operation is resumed. Accept it. The case of using the reset pin timing charts are outlined in Figs 4:3 and 4:4. 3. FLT, floating P107, P20, and BPO, 7. Instruction. Code description: internal ROM mode Pi floating, P2 floating, BP floating. External ROM mode floating, P20, 3 operation, P2 7 floating operation. Details of IC pin status as a result of executing the FLT instruction are shown in table 4:1. 4. FLTT, floating of all output pins. 288. Instruction. Code description: I internal ROM mode External ROM mode. AL floating operation. PSEN floating operation. Prog floating floating. WR floating floating. RD floating floating. To out floating floating. Pi floating floating. P2 floating. P20, 3 operation. P2, 7 floating. BP floating operation. XTAL operation. Details of IC pin status as a result of execut ing the FLTT instruction are shown in table 4-2. Example 1, power down mode ACOM. Plushed by stopping oscillation. O setting by execution of HLTS82H instruction. Example 2, power down mode ACOM. Plushed by stopping the clock. Supply to the CPU control circuit. O setting by execution of HALT01H instruction. Example 3, power down mode by floating of P10 to 7, P20, 7 and BPO 7, and subsequent stopping of CPU oscillation. O setting by first executing the FLTA2H instruction, and then the HLTS82H instruction. Example 4, power down mode by floating P10, 7, P20, 7 and BPO 7, and then stopping the clock. Supply to the CPU control CIR. Quit. O setting by first executing the FLTA2H instruction, and then the HALT01H instruction. Example 5, power down mode by floating all output pins, followed by stopping oscillation. O setting by first executing the FLTTC2H instruction, followed by execution of the HLTS82H instruction. Example 6, power down mode by floating all output pins, followed by stopping of the clock supply to the CPU control circuit. O setting by first executing the FLTTC2H instruction, followed by execution of the HALT01H instruction. 4.2 Cancellation of software power down mode. The power down mode status outlined above in examples 1 to 6 can be cancelled by using either the interrupt pin or the reset pin. 1. Use of the int pin during external interrupt. Enabled mode, LE following execution of NI instruction. O the clock generator is activated and the CPU started J. P when a 0 level is AP. Applied to the int pin. If this 0 level is maintained until at least 2 AL output signals occur, an external interrupt is generated, and execution proceeds from address 3. If, however, the power down mode has been done during the interrupt processing routine, execution is resumed just after the power down instruction. 2. Use of the int pin during external interrupt. Disabled mode, LE following execution of DISI instruction or hardware reset. O the clock generator is activated and the CPU started J. P when a 0 level is AP. Applied to the int pin. If this 0 level is maintained until at least 2 AL output signals occur, execution is resumed just after the power down instruction. 3. Use of the reset pin. O the clock generator is activated and the CPU started, P, Y when a 0 level is AP. Applied to the reset pin. If this 0 level is maintained until at least 2 AL output signals occur, the CPU is reset and EXE Cushion proceeds from address O. In case cancellation is done in oscillation stop mode, the 0 level must be input to the reset pin until oscillation is stabilized. _EMSM ADC 35/48, ADC 39/49, ADC 40/50E. Table 4:1 details of pin status following execution of FLT instruction. Pin No. Pin name internal ROM external ROM. LP2 active 2PXTAL1 acti, LE active. 3PXTAL2 active 4P reset active 5PSS 200 to 500 kilograms pull up 200 to 500 kilograms pull up 6P int active 7PEA active 8PRD active 9PPSEN active LOP WR active LLPAL active L2PDBO floating active L3PDBL floating active L4PDB2 floating active L5PDB3 floating active 16PDB4 floating active 17PDB5 floating active L8PDB6 floating active 19PDB7 floating active 20PVSSOV, OV 21PP20 floating active 22PP21 floating active 23PP22 floating active 24PP23 floating active 25pprog active 26pvdd1 level 27pp10 floating 28pp11 floating 29pp12 floating 30pp13 floating 31pp14 floating 32pp15 floating 33pp16 floating 34pp17 floating 35pp24 floating 36pp25 floating 37pp26 floating 38pp27 floating 39pt1 active 40pv plus 2 to plus 6v plus 2 to plus 6v. Note, the FLT mode itself is reset by executing the FRES instruction, or supplying O level to int or reset pin. 289. MSM ADC 35/48, ADC 39/49, ADC 40/50-. Table 4:2 details of pin status following execution of FLTT instruction. Pin No. Pin name internal ROM external ROM. 1P2 floating if output enabled floating if output enabled. 2PXTAL1 active 3PXTAL2 active 4P reset active 5PSS 200 to 500 KD pull up 200 to 500 KD pull up 6P int active 7PEA active 8PRD floating 9PPSEN floating active 10PWR floating 11PAL floating active 12PDBO floating active 13PDB1 floating active 14PDB2 floating active 15PDB3 floating active 16PDB4 floating active 17PDB5 floating active 18PDB6 floating active 19POB7 floating active 20PVSSOV 21PP20 floating active 22PP21 floating active 23PP22 floating active 24PP23 floating active 25pprog floating 26pvdd1 level 27 pp 10 floating floating, 28 pp 11 floating floating, 29 pp 12 floating floating, 30 pp 13 floating floating, 31 pp 14 floating floating, 32 pp 15 floating floating, 33 pp 16 floating floating, 34 pp 17 floating floating, 35 pp 24 floating floating, 36 pp 25 floating floating, 37 pp 26 floating floating, 38 pp 27 floating floating, 39 pt1 active active, 40 pv plus 2.5 to plus 6v plus 2.5 to plus 6v. Note, the FLTT mode itself is reset by executing the FRES instruction, or supplying 0 level to int or reset pin. 290. MSM ADC 35/48, ADC 39/49, ADC 40/50. ITL IT2 IT3 IT4. 1 IIIIIR, RI, in. XTAL1. RT ILFLOW JLFLILILIMMJL. OIIIIIII, I2. 11 III, 1. MFTLH. IIIIL, I underscore plus I underscore dash plus dash underscore. I, 2 IIO. III. II. IHALTEXECUT ERLI. III. CPU mode run I stop FSIIIRUNIII. II. III. 2 IIIRUN-1 I dash plus plus I dash plus dash dash plus dash I dash plus I underscore I dash plus XTALLIIF1 III. II. III. 11 III is III. III. OR plus dash R dash plus dash RJ dash plus TT dash. III. III reset execute I. III. III. AL. Reset. Cancellation condition, use reset pin. Fig 4.1 halt 01H instruction execution timing chart. I. TLIT2, T3, FT4. 1 I. XTAL 1 NNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNNn. If I, IRRWJI, I. LIIIII, M. 2, IO. III plus comma dash plus dash 111 dash plus, 1. II1 III. IIIHALT execute III. CPU mode RUI, stop FL, IIIRUNIII. III. XTAL 1. 2 II is IIRUN plus dash dot L, I plus 1 dash plus IRITII dash 1 it. 2 III. 1 III. Int IIIIIIIIIIIIIO plus dash comma dash RT. Comma dot dash IJ dash dash I dash dot dash R. III. I1 III inter UPTEXPCUTEII. III. I. 3. Cancellation condition, use TNT pin. Fig 4-2 halt 01H instruction execution timing chart. TL, T2, 13, 2 IT-4 underscore 4 I comma dot comma, dash plus dash underscore I dash colon 4 dot colon equals plus dash equals dash I dash, colon dot colon equals I dash comma dot colon. Xtal 11 NNNNNNNNNNNNNIIIJLL. OLURUUU. 1 IIIRIH2I. AL0, III, IP. W. II. IIIHLTS execute, J1I2. CPU mode run RSTOPFFOISCI. III run RI plus dash dash plus dash dash plus dash I dash comma evoke II2. Xtal 1. 2R, run 1 stop, LJ comma colon, I run dash plus dash dash plus dash, dash dash plus dash IL. III reset pin must bell III. III held at 0 level III. 1 III1 until the oscillation III. Reset III.L becomes norma. III. O, dash RT1 dash dash IT RIRT dash dash T. SS1. III. It dash plus plus dash II dash plus ILTI dash plus I plus I, ITI. OIIIII, I. Underscore 1 I1 II underscore III. SS 200 to 500 knots, RSS 200 I. Underscore TT dash plus, RETXEQUTI, dash. I pull up 500 knots I. SS 20 to 50 knots pull down pull up. Cancellation condition, use reset pin. Fig 4-3 HLTS82H instruction execution timing chart. 291. MSM ADC3S/48, ADC39/49, ADC40/S0-. I2. I. Xtal 1. R-JTJAJ. III. III2 IIIRHLIIIII. AL1 IIIIILIII2 IIIRTIIIO. III. III.1 III.1 IIIIW, dash L. III health executel III. CPU mode F, run STOPF. II run, III. Xtal 12 plus dash dash IRUILLSTOPF R1 degree SCE OKI run III. III1. When a 0.47/LF capacitor is 450 I1 connected to the SS pin, 60 milliseconds II. 50 to 60 milliseconds wait II. Plus 1 I. III. 1. I. II2 IIIIO dash 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 I dash R dash 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 III1 III. SS 1 I1 III1 III. O I1 I1 III. Underscore III2 III. SS 200 to 500 knots SS 200 dash II interrupt execute II dash. I pull up I 500 knots pull up 1 III. SS 20 to 50 knots pull down. Asterisk cancellation condition, use int pin. Fig.4-4 HLTS82H instruction execution timing chart. 4.3 hardware power down mode. In the MSM-ADC48, MSM-ADC49 and MSM-ADC50, forcing the level at the VDD pin 26 to a 0 during either external ROM or NAL ROM mode results in suspension of the OS. Delater function and subsequent floating, high impedance, of all the I/O pins except the reset SS and XTAL1/2 pins. The CPU is thereby stopped while maintaining internal status. Details of the IC pin status at this time are outlined in Table 4-3. 4.4 Cancellation of hardware power down. Mode 1. use of reset pin. The clock generator is activated and the CPU started up when a 1 level is applied to TH pin while a 0 level is input to the reset pin. If this 0 level is kept applied to the reset pin until oscillation becomes stable, the CPU will be reset and will start executing from address O. The timing chart is outlined in Fig. 4 to 5. 2. Use of the TNT pin during external interrupt. Enabled status, i.e. following execution of NI instruction. The clock generator is activated and the CPU started up when a 1 level is applied to the VDD pin while a 0 level is applied to the INT pin. 292. If this 0 level is maintained until at least 2 AL output signals occur, an external interrupt is generated, and execution starts from address 3. However, if the power down mode is started during an interrupt processing routine, execution will be continued on the next instruction after the present instruction. The timing chart is outlined in Fig 4 to 6. 3. Use of the INT pin during external interrupt. Disabled mode, i.e. following execution of DISI instruction or hardware reset. The clock generator is activated and the CPU started up when a 1 level is applied to the VDD pin while a 0 level is applied to the INT pin. If this 0 level is maintained until at least 2 AL output signals occur, execution is continued on the next instruction after the present instruction. The timing chart is outlined in Fig 4 to 6. 4. Use of VDD pin only. The clock generator is activated and the CPU started up when a 1 level is applied to the VDD pin while a 1 leave J also applied to both the reset and INT pins. In this case, execution is resumed from the stopped position. The timing chart is outlined in Fig 4 to 7. MSM ADC 35/48, ADC 39/49, ADC 40/50. Table 4 to 3 details of pin status during hardware power down mode. Pin no. Pin name. Normal operation power down mode. VDD equals 1 level, VDO equals 0 level. 1P2 active floating if output enabled. 2P-XTAL1 active. 3P-XTAL2 active. 4P reset aclav active. 5P-SS 200 to 500 KO pull up 20 to 50 KO pull down. 6P int active. 7P EA active. 8P RD active floating. 9P PSEN active floating. 10P WR active floating. 11P AL active floating. 12P DBO active floating. 13P DB1 active floating. 14P DB2 active floating. 15P DB3 active floating. 16P DB4 active floating. 17P DB5 active floating. 18P DB6 active floating. 19P DB7 active floating. 20P VSS OV. 21P P20 active floating. 22P P21 active floating. 23P P22 active floating. 24P P23 active floating. 25P prog active floating. 26P VDD1 level O level. 27P P10 active floating. 28P P11 active floating. 29P P12 active floating. 30P P13 active floating. 31P P14 active floating. 32P P15 active floating. 33 pp16 active floating, 34 pph active floating, 35 pp24 active floating, 36 pp25 active floating, 37 pp26 active floating, 38 pp27 active floating, 39 pt1 active, 40 pv plus 2 to plus 6 6 plus 2 to plus 6v, 293, MSM ADC3S/48, ADC39/49, ADC40/S0-, 294, 0.1 ml or M2 ml, J1L, L, if floating, OIIIIII, III, L dash, RUNL dash, stop, // I __ plus _ dot dash plus dash I dash plus, IIIOSCI, TTRUIIRL stop 1 to 1 ev OKI equals E, T plus dash ITI, III1 __ III, IIIRRESET pin must be held. Xtol 2. AL. CPU mode. Xtol 1. 2. TL1 T2, T3 IIS T4. I. At 0 level UNTII the oscillation becomes I. Normal. TTLI. III. 1 II, III 1. G colon, RLIIIIIIIIIIIII. O, %4J. HY _III dash, comma dash I _ LLL ____ dash plus dash TTT dash dot L. 111 colon 1111111111111. IIOMLII, III. 0 dash 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 comma II1 dash 1 dash 4 dash comma dot dash TT dash. III. 1 II 2 III. OIII reset execute I. SS 200 to 500 knots SS 200 to 500 knots pull up. SS 20 to 50 knots pull down. Asterisk cancellation condition, use reset pin. Xtol. AL. CPU mode. Xtol 2. VDD. Fig.4-5 hardware power down mode timing chart. TLI, R2 I try if T4. J11. Li2 if loading comma dash. .ll. ln. OIIIII. Run TI stop colon dash 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 IIT dash. L dash dot JRUR / I, L plus stop dash. HOSCL dash TII dash plus dash 4 dash 1. III. I evoke I. When a 0.47 ILF capacitor is 50 Ri. Connected to the SS pin, 60 milliseconds. 50 to 60 milliseconds wait. I. 1 m mul. O%, W. 1 I. OTRT low yen. 1 I. OI. SS 200 to 500 knots, pull up 500 knots pull up. SS 20 to 50 knots pull down. Asterisk cancellation condition, use the INT pin. Fig.4-6 hardware power down mode timing chart. Dash. MSM ADC 35/48, ADC 39/49, ADC 40/50. Xtol. AL. CPU mode. Xtol 1. 2. VDD. IT1 IT2 IT3 IT4. III, F. J.JJ. 1 III float in 9. I. O, II. T-tron FI stop SI1I. I plus run dash plus plus stop underscore PSC evoke run I. When a 0.47 IFC CIDR is J50 III. Connected to the SS pin, 60 milliseconds, II. 50 to 60 milliseconds wait. WAITFI. III. 1 IIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIIII j dash dot j dash 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 t1l dash plus dash dash r dash dash underscore ti dash ji I 1 I O plus dash dash underscore colon dash j t underscore dash dot l dash j dash f underscore dash j dash 1 dash colon dash 1 1 I 1 I O dash 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 I dash 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 if dash 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 plus dash 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 j dash 1 I SS 200 500 KNI SS 200 I restart I pull up 500 knots pull up SS 20 50 KN pull down asterisk cancellation condition use the VDD pin on condition reset and int pins are in one level. Fig.4-7 hardware power down mode timing chart 295 CD AL H 0 0 0 0 0 1 0 0 0 1 2 0 0 1 0 3 0 0 1 1 4 0 1 0 0 5 0 1 0 1 6 0 1 1 0 7 0 1 1 1 8 1 0 0 0 9 1 0 0 1 A 1 0 1 0 B 1 0 1 1 C 1 1 0 0 0 1 1 0 1 E 1 1 1 0 F 1111 0 1 2 O 0 0 0 0 0 1 0 0 1 0 NOP Halt Altlbus Added A Inc at RO Inc at R1 JBO dress XCHA at XCHA at ROR1 XCHD XCHD A at ROA at R1 JBL address Orla MOVA T at RO at R1 ANLA JB2 address at RO at R1 ADA MOVTA at RO at R1 ADCA J83 address at RO at R1 MUVCA HLTS at RO at R1 added MOVX at ROA at R1 AJ84 address MOVFLT at ROA at R1A added MOV at RO MOV at R1 hashtag data J8's address DEC at RO DEC at R1 FLTT added XRLA JB6 address at RO at R1 DJNZ at RO DJNZ at R1 FRES added MOVA JB7 address at RO at R1 MISMSOC 4S MISMSOC 49 MISMSOC 50 instruction table 3 4 5 6 7 8 9 AB 001101010101010101010101011. Add a JMPENI DECA INSA bus INA P1 INA P2. Hashtag data. Add call DISIJT FADR INCA INCRR. Hashtag data. MOVA, JMP NTJNTO address CLRAXCHARR. Hashtag data. Call disk DJTO address CPLA outlet1, outlet2. AA. Orla, JMP STRTCNTJNTL address swap a orla.rr. Hashtag data. ANLA, call stat JTL address DAAANLARR. Hashtag data. MOVA, 1. JMP. Stop. Added TCNTRRCA ADA RR. MOVA P2. Added call ENTOCLKJFL address RRA adca.rr. Orlbus, ORLP1, ORLP2. RETJMP Groovy JNL address hashtag data hashtag data hashtag data. ANLBus, ANLP1, ANLP2. RETR call Groovy JN Sadra CLRC hashtag data hashtag data hashtag data. MUPA. Add a JMP CLRF1 CPLC MOVRRA. MOVR. JMPP at a call CPLF1 JFO address hashtag data. MOV, 1P at JMPSEI.RBO JTSADR. MOVA. DECAFR3 added PSW. XRLA. CELRB1. MUAPSW. Hashtag data. Call AXRLARR. MOVP3A. JMP Selmbo JN Cadra RLAD JNZRR at A. MOVP1 at. Selm1 J Cadra RLCA MOVA ARR3 added call. C0. 11001101. MUBDA. PP. MOVDPP. A. ORLDPP. A. ANLOPP. A. EF. 11101111. 31. N. 31. N. Co. CJI. Co. O. N. Co. 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 O. N. T. CJI. O. Underscore E. MSM ADC 35/48, ADC 39/49, ADC 40/50. Explanation of instruction symbols. Symbols are listed below. A. Accumulator. AC auxiliary carry. Address 12-bit program memory address or BB. BS. Bus. C. CLK. CNT. D. Data. DBF. FO, F1. I. Its part. Bit indicator, B equals 0 to 7. Bank switch. Bus port. Carry. Clock. Counter. 4-bit data. 8-bit numerical value. Memory data bank flip-flop. FO flag and F1 flag. Interrupt. List of instructions. Class I instruction code. Fication. Mnemonic. 07D0, D030. ADA.RR01101R. ADA, at RR0110000. ADA hashtag data 000000D7 to D, DD3D. ADCA.RR01111R. ADCA at RR0111100. ADDCA, hashtag data. 000100, D7DD, DD3D, ANLA, RR01011R, U, ANLA at RR010100C, ANLA, hashtag data, 010100, J, D7DD, DD3D, Orla RR01001R, C. Point to Orla at RR010000, 010000C. Orla, hashtag data. D7DD, DD3D. Pound. XRLA at RR110100, 0, 0, 110100. XRLA hashtag data D7DD, DD3D. Inca 000101. Deca 000001. CLRA 001001. CPLA 001101. DAA 010101. DDO. RRO. 0RO. 11. 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 DDO. 11. 11. 11. 11. 11. PC. PP. PSW. RR. SP. T. TF. 2, T1. X. Hashtag. At. X. X. Hexa. Decimal. Byte. 68-6 F1. 80 to 61 1. 03. 2 by 2. 78-7 F1. 70 to 71 1. 13. 2 by 2. 58 SF1. 50 to 51 1. 53. 2 by 2. 48-4 F1. 40 to 41 1. 43. 2 by 2. D8 DF1. 00-011. 03. By 2 2. 17 1. 07 1. 27 1. 37 1. 57 1. Program counter. Port indicator, P equals 4 to 7. Program status word. Resistor indicator, R equals 0 to 7. Stack pointer. Timer. Timer flag. Test pins 2 and T1. External RAM. Symbol denoting immediate data. Symbol denoting indirect address. Denotes contents of X. Denotes contents addressed by X. Transference. Cycle description. 1. AC. C. A. Plus, RR. 1. AC, C. A. Plus RR. 2. AC. C. A. Plus data. 1. AC. C. A. Plus, RR, plus, C. 1. AC, C. A. Dash, A. Plus RR plus, C. 2. AC, C. A. Plus data plus, C. 1. A. N. RR. 1. A. and RR. 2. A. and data. 1. A. or RR. 1. A. or RR. 2, A, or data. 1, A, X or, RR. 1, A, dash, A, X or RR. 2, A, X or data. 1, A, dash, A, plus 1. 1, A, dash, A, dash 1. 1, A, O. 1, A, dash, A. Add 6 to bits 0 to 3 when contents of accumulator bits 0 to 3 exceed 9 or when auxiliary carry, AC, is 1. Then add 6 to bits 4 to 7 when the result of 1. Adding the carry from the 10 where O, 3 exceeds 9, or when carry, C, is 1. Set 1 in the carry flag if an overflow is generated in the end result, or when the carry prior to adjustment is 1. 297. MSM ADC 35/48, ADC 39/49, ADC 40/50-. List of instructions, cont. Class E instruction code hexa. Fication mnemonic decimal byte cycle description. 0, DD040, 0, 0, do. Swap A010001114711, A dash comma, colon, AO dash comma. QA7A6 as A4. AOP. C. A3 LAIRLA111001111 times 10 to the power of 7th 11. Rotate accumulator contents to the L equals left by 1 bit. 0.5. L at dash 1A, A6 as A4 A3 LAIAOJJC. RLCA11110111F711 rotate accumulator contents with carry to the left by 1 bit. C0. 0.9. QA7A6 as A4A, LAIAO. RRA011101117711. Rotate accumulator contents to the E right by 1 bit. L at JA7A6 as A4A, A2AIRRCA011001116711. Rotate accumulator contents with carry to the right by 1 bit. INA P100000100912, A, dash, PH. INA P2000001010A12, A, dash, P2. Outlook 1, A001110013912, P1, dash, A. Outlook 2 A0011101003A12, P2, dash, A. ANLP1, hashtag data. 10011000199. 22, P1, P1, and data D, D, do by 2. ANLP2, hashtag data. 10011001009A. 22, P2, P2, and data D, D4D, D, do by 2. ORLP1, hashtag data. 10001000189. 22, P1, dash, P1, or data D, D4D, D, do by 2. C. ORLP2, hashtag data. 100010108A. 22, P2, or data D, D5 D4D, D, do by 2. 0.5, INSA, bus 0000100000812, A, dash, bus. C. Outbus A000000100212, bus, dash, A. ANL bus, hashtag data. 10011000098. 22, bus, and data CD, DDD4D3D, D, do by 2. E. ORL bus, hashtag data. 1000100088. 22, bus, or data D, DDDD3D, D, do by 2. Mubda PP000011P, PO OC of 12, A03, PP, P equals 4-7. A4-0. MOVD PPA001111P, PO 3C3 F12, PP, dash, AO dash comma, P equals 4-7. ANLD PPA100111P, PO 9C9 F12, PP, dash, PP, N, AO3, P equals 4-7. ORLD PPA100011P, PO 8C8 F12, PP, dash, PP, or, AO dash comma, P equals 4-7. INCRR00011R, R, RO18-1 F11, RR, dash, RR, plus 1. CC. M8 Inc at RR0001000 RO10 to 1111 RR, dash RR, plus 1. OG. 2I. L equals DECRR11001R, ROC8CF11, RR, dash, RR, dash 1. 0, 0.5. Dec at RR110000 ROCOC111 RR, RR, 1. G, PCA-O, address 8-10. .ct equals jmpadra10AA00100, 4E422, PCO comma, address 07. A, AA5 A4 A3A, AO by 2, PC, DBF. C0IL equals JMPP at A10110011B312, PCO comma, dash A, AA. 298. Dash. MSM ADC 35/48, ADC 39/49, ADC 40/50. List of instructions, cont. Classy instruction code hexa. Fication. Mnemonic. Decimal. Byte cycle description. 0, DOSD 0, 0, 0, do. 11101R, R, ROE8F. RR, dash, RR, dash 1. DJNZRR, address 22, PCO dash comma, addrel, AR, OA. A as AA, AO by 2, PC, dash, PC, plus 2 if, RR, O. 11100000 ROEOE1. AR, dash, RR, dash 1. DJNZ at RR address 22, PCO dash comma, addrel, AR, O. A as AA, AO by 2, PC, dash, PC, plus 2 IL, RR, O. JCadr. 11110110F6. 22. PCO dash comma, address I1C1. A as AA, AO by 2, PC, dash, PC, plus 2 IICO. JNCadr. 11100110 times 10 to the power of 6th. 22. PCO dash comma, address IICO. AO by 2, PC, dash, PC, plus 2 IIC1. JTSADR. 11000110C6. 22. PCO dash comma, address IIAO. AO by 2, PC, dash, PC, plus 2 IIA, O. J and Sadr. 10010111096. 22. PCO comma, address IIA, O. C, A as A, AO by 2, PC, dash, PC, plus 2 ILA O. Dot Q. TI0011011036, PCO dash comma, address if TO1. JTO dress A as A, AO by 222, PC, dash, PC, plus 2 IITOO. Point 5. 0010011026, PCO dash comma, address if TOO. JNTO dress 22E, A as A, AO by 2, PC, dash, PC, plus 2 ILTO1. E 0101011056, PCO dash comma, address if T11. EJT1 address A8 AO by 222, PC, dash, PC, plus 2 if T10. M. JNT1 address 0100011046. 22. PCO dash comma, address if T10. AO by 2, PC, dash, PC, plus 2 ILT11. JFO address 101101110B6. 22. PCO dash comma, address IIFO1. A as A, AO by 2, PC, dash, PC, plus 2 IIFOO. JF1 address 0111011076. 22. PCO dash comma, address ILF11. A as A, AO by 2, PC, dash, PC, plus 2 I1F10. 0001011016. PCO dash comma, address JTFADR 22TF-0 if TF1. AO by 2, PC, dash, PC, plus 2 IITFO. JN address 10000111086. 22. PCO dash comma, address ILint0. A7A as AO by 2, PC, dash, PC, plus 2 ILint1. JBadr. B, VO 1001012F2. 22. PCO dash comma, address ILBB1. AO by 2, PC, dash, PC, plus 2 ILBBO. SP, dash, PC, plus 2, PSW dash dash. AA1010014F4. PC-O, address 8-10. Call address 22, PICO, address 07. A as AO by 2, PC. DBFEC. SP, dash, SP, plus 10, 0. I colon. AET 1000001183112. SP, dash, SP, dash 1. PC, Lisp. CI, dot E. SP, dash, SP, dash 1. AETA 1001000119312, PC, Lisp. PSW dash comma, dash, SP, int end. CLRC 1001011199711, C, minus 0. C, CPLC 101001111A711, C, dash, E. 0 dot, colon colon 1. Clafo 100001018511, FO, minus 0. G.2. Plfo 100101019511, FO, dash, FO, OJ. OL, U. CLAF 1101001001A511, F1, minus 0. CPLF 1101100101B511, F1L dash, M. MOVA AR11111R, R, ROF8FF11, A, dash, AR. Pound MOVA at AR1111000 ROFOF111, A, dash, AR. Colon G. L, LL. 0010001123. G. MOVA hashtag data 22, A, data 0D, DD, DD, D, D, do by 2. 299. MSM ADC 35/48, ADC 39/49, ADC 40/50. List of instructions, cont. Class I instruction code hexa. Location. Mnemonic. Decimal. Byte cycle description. 070, 0, D030, 0, do. MOVRRA10101R, R, ROA8AF11, RR, dash, A. MOV at RRA1010000 ROA0A111RR, dash, A. MOVRR, hashtag data. 10111R, ROB8BF. 22, RR, data D7D, D, DD3D, D, do by 2. MOV at RR, hashtag data. 1011000 ROBOB1. 22RR, data D7D, DDD3D, D, do by 2. MOVA PSW11000111C711, A, dash, PSW. MOVS way 110101110711, PSW, dash, A, E. XCHARR00101R, R, RO28-2F11, A, colon RR. S, XCHA at RR0010000 RO222111, A, colon, RR. STA at RR0011000 RO30-3111, AO dash comma dot, colon, row 3. E. MOVX6 at RR100000 RO80-8112, A, dash RR, external RAM. MOVX at RRA100100 RO90-9112 RR, dash, A, external RAM. C. MUPA at A10100011A312, A, dash PC dash O, A. MOVP3A at A11100011 times 10 cubed 12, A, dash PCOL1A. MOVP1P at R31100011C312, P1, dash, PCO7, dash R3. MOVP1 at R3111100011F312, P1, dash R3. MOVA P101100116311, A, dash, P1, latch data. MOVA P20111000117311, A, dash, P2, latch data. Entity 00100010012511 tint enable F if -1. Distantity 001101013511 tint enable FIFO. ENI 000001010511 accent enable F/F1. DISI 000101011511X and enable F/FO. Cellrabo 11000101C511, BS, -0. E. Cellrab 111010100511, BS, -1. Point 2. U. DBF, Selmbo 11100101 times 10 to the power of 5th 11-0. S. Selm 1111101001F511, DBF, -1. Antica K011110017511-1/3XTAL1E. 0. U. FLT 10100010A211P1, P2, bus floating. FLTT 11000010C211 CPU output signal floating. FRES 11100010 times 10 squared 11 FLT float reset. HLT 0000001011 CPU control clock stop. Halts 100000108211 XTAL12 stop. MOVA T 010000104211, A, dash, T. Sen. MOVTA 011000106211, T, dash, A, EE. G. Dash I plus 151 XTAL STRTT 010101015511, T, colon 2. Comma. ESTRTCNT 010001014511, T, T1 clock. Colon dot. Stop TCNT 011001016511, T, count stop. Colon IE. 5.GNOP 000000000011, PC, dash, PC, plus 1. 300. MSM ADC 3S/48, ADC 39/49, ADC 40/S0. Absolute maximum ratings. Parameter symbol conditions limits unit. Supply voltage VCC Ta equals 25 degrees C-0.3 T07 V. Input voltage 6 Ta equals 25 degrees C 0.3 to VCC V. Storage temperature TSTG -55 to +150 degrees C. Operating range. MSM ADC 35/48, ADC 39/49. DC to 11 MHz, VCC equals 5V plus or minus 20%. MSM ADC 40/50. DC to 6 MHz, VCC equals 50 plus or minus 20%. Parameter symbol conditions limits unit. Supply voltage VCC lose equals DC 11 MHz plus 2.5 to plus 6 V. RAM retention voltage VCC plus 2 to plus 6 V. Ambient temperature Ta -40 to plus 85 degrees C. MOS load 10. Fan out N. TTL load 1. 11 MHz version 01 MSM ADC 40/50, 6 MHz. 301. MSM ADC 35/48, ADC 39/49, ADC 40/50. DC electrical characteristics. V equals 5V plus or minus 10%, Ta equals -40 to plus 85 degree E. Parameter symbol conditions. L input voltage VIL. H input voltage, 1, VIH. H input voltage, 2, VIH. L output voltage, 3, Vol 10L equals 2 mA. L output voltage, 4, Vol 10L equals 1.6 RNA. H output voltage, 3, VOHIOH equals 400/LA. H output voltage, 4, VOHIOH equals 50/LA. H output voltage, 3, VOHIOH equals 20/LA. H output voltage, 4, VOHIOH equals 10/LA. Input leak current IL VSS VEN VCC. Output leak current, 5, 10 L VSS VO VCC. Reset pull up RR VEN VIHJ. Resistance VEN VIL. SS pull up resistance RSS oscillation. 6, stop/oscillation. P1, P2 pull up RP1, P2 VEN VIH/. Resistance VEN VIL. At hardware power. Down VCC equals 2V. Ta equals plus 25 degrees C, 7. At HLTS execu. Shin asterisk VCC equals 2V. Ta equals plus 25 degrees C, 7. Power supply current ICC at halt, 6 MHz. At halt, 11 MHz, S. At execution, 6 MHz. At execution, 11 MHz, S. Notes, 1, this does not apply to reset, XTAL1, XTAL2, and VU. 2, reset, XTAL1, XTAL2, VU. 3, bus, RO, WR, PSEN, AL. 4, other outputs. 5, high impedance state. Min. Tip. Max. Unit. Measuring. Circuit. Minus 0.30.8 V. 2.2 VCCV. 3.8 VCCV. 0.45 V. 0.45 V1. 2.4 V. 2.4 V. 4.2 V. 4.2 V. Plus or minus 10/LA2. Plus or minus 10/LA3. 20/550/750 KO. 2. 20/250/500 KO. 5/75 15/150 KO3. 110/LA. 110/LA. 4. 1.53 RNA. 2.55 RNA. 510 RNA. 1020 RNA. 6. This operates as a pull-down resistor when the oscillation is stopped in the HLTS or hardware power-down mode and as a pull-up resistor in other states. 302. 7. This does not contain flow-out current from I/O ports and signal pins. S. MISM SOC 35/4S, SOC 39/49. Underscore 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 1. MSM ADC 35/48, ADC 39/49, ADC 40/50. AC characteristics. V equals 5V plus or minus 10%, Ta equals minus 40 OE to plus 85 degree E. Limits. Parameter symbol 11 MHz clock variable clock, 0 to 11 MHz, unit. Min. Max. Min. Max. Cycle time TCY 1.36 1.36/ls. AL pulse width TLL 157/30 TSI 165 NS. Address setup AL TAL 72/15 TSI 110 NS. Address hold from AL TLA 51/15 TSI 40 NS. Bus port latch data setup TBL 110/5/30 TSI 115 NS. To ALE. Bus port latch data hold TLB 93/30 TSI 45 NS. From AL. Control pulse width. PSEN, RD, and WR. TCC 306/15 TSI 245 NS. Data setup before WRTDW 256/15 TSI 295 NS. Data hold after WRTWD 42/15 TSI 140 NS. Data hold after RDTDR 0100 NS. PSEN, RD to data in TRD 205/15 TSI 250 NS. Address setup to WRTA 206/15 TSI 345 NS. Address setup to data in TAD 408/15 TSI 325 NS. Address flow to RD, PSEN TAFC 00 NS. Port control setup to PROG TCP 102/15 TSI 80 NS. Port control hold from PROG TPC 64/15 TSI 300 NS. PROG to P21 input valid TPR 659/15 TSI 165 NS. Output data setup TDP 206/15 TSI 345 NS. Output data hold TPD 23/15 TSI 250 NS. Input data hold from PROG TPF 0150 NS. PROG pulse with TPP 710/15 TSI 205 NS. Port 21/0 setup to LTPL 159/30 TSI 255 NS. Port 2110 hold from LTLP 23/30 TSI 115 NS. Note, control output, CL equals ADPF. Bus output, CL equals 150 PF or 20 PF, TWD. 303. MSM ADC 35/48, ADC 39/49, ADC 40/50-. MSM ADC 49 operation guarantee range. Ta equals -40 to +85 degree E. II. 3 SEC. II. 100. Operation guarantee range. Dash. L. 10-1.5 MHz. E \. F. \. U. \. Dash 3 MHz. MSM ADC 40/50. I. 6 MHz. 11 MHz. 1. 2 3 4 5 6, V. Supply voltage, V. 11 MHz version of MSM ADC 40/50 IS under development. 304. MSM ADC 35/48, ADC 39/49, ADC 40/50. Timing chart. Instruction fetch, from external program memory. ITSIL. AL. TAFC. TCC. Bus. Read, from external data memory. AL. TCCI. Bus. 305. MSM ADC 35/48, ADC 39/49, ADC 40/50-. Write, to external memory. AL. FTCCI. Bus. 4 low order bits input/output of port 2 when expanded I/O is used. In external program memory access mode. P20-3. Output. Model. P20-3. Input. Model. 306. PCH. PCH. MSM ADC 35/48, ADC 39/49, ADC 40/50. Measurement circuit. 2. 11. VHRI. 3 0 VL GND == 3 4 VH I VL GND1 dash equals 5 input waveform 2 VHII ICL 1 equals output waveform : VL0 GND output waveform. Notes: 1. This is repeated for each specified input pin. 2. This is repeated for each specified output pin. 3. Input logic for setting the specified state. Dash equals I Z GND I 1 equals 0 TXXX 307 OKI and ERNI conductor MSMADC31F/MSMADC51F CMO single component 8-bit microcontroller. General description: the OKI MSMADC31F/MSMADCS1F microcontroller is a low-power, high-performance 8-bit single component device implemented in OKI's silicon gate complementary metal oxide semiconductor process technology. Integrated within the device is 4 KB of mask programmable ROM. MSMADCS1F only, 128 bytes of data RAM, 32 I/O lines, 2 16-bit timers/counters, a 5-source 2-level interrupt structure, a full duplex serial port, and an on-chip oscillator and clock circuitry. In addition, the device has 2 software selectable modes for further power reduction, idle and power down. Idle mode freezes the CPU's instruction execution while maintaining RAM and allowing the timers, serial port, and interrupt system to continue functioning. Power down mode saves the RAM contents but freezes the oscillator, causing all other device functions to be inoperative. Features: operating temperature, -40, +8 SOC. Operating frequency, O.S, 16 MHz. CMOS technology, 2J.TM silicon gate. Minimum instruction cycle, 1.0 J.TS, at 12 MHz, VCC equals SV plus or minus 20%. 0.7 SJ.LS, at 16 MHz, VCC equals SV plus or minus 10%. Low power consumption. Normal operation 16 mA at SV, 12 MHz. Idle mode 3.7 mA at SV, 12 MHz. Power down mode SOIJA at 2V. Instruction set includes 111 instructions. 8-bit CPU. On-chip oscillator and clock circuitry. 32 input/output lines. 4069 x 8 bits on chip ROM, MSMADCS1F. 128 x 8 bits on chip RAM. 64K address space for program memory. 64K address space for external data memory. 2 16-bit timers/counters. 5 source 2 priority level interrupt. Structure: full duplex serial port. Boolean processor. CMOS and TTL compatible. CMOS ROM-less development device. MSMADC31F. Differences between MSMADC31F/MSMADC51F and MSMADC31/MSMADC51. Operating frequency: O.S -16 MHz. MSMADC31F1/MSMADCS1F1. 0.5 -12 MHz. MSMADC31I MSMADCS1I MSMADC31F/MSMADCS1F. External clock input terminal. XTAL1. MSMADC31F, -1, /MSMADCS1F, -1. XTAL2. MSMADC31/MSMADCS1. Emulation mode. Output impedance of AL and PSEN pins becomes about 20 kFL while CPU is being reset in MSMADC31F/MSMADCS1F. Any other functions and electrical characteristics of MSMADC31F/MSMADC51F except for the above. Three differences are the same as those of MSMADC31I MSMADCS1. 308. CA. Control signals are /W signals. 1 dash 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 JI, IIL, LLL. P20, P27. P00, P07. Stali dash 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 4 dash. XTAL2. AL. 0.1,1, shocked. PSEN. I. 2x2. I2x reset. A. XC. L, L. O. Seri LE _ J. P30, P37. L ________________________________________________________________________________________________________________________:_:_____________________:______________________________________________:_____________________________________________________________________________gh11 C Z O T 5 Z R AJ R O O C G U 3 3 N 3 2 O O Co equals 2 O O 2 MISMSOC 31F/SOC 51F dash. Pin configuration. MSMADC 51FXXRS/MSMADC 31FRS. Top view, 40 lead plastic dip. PL0V. PLLPO.O/adu. PL2PO.L/AD1. PL3PO.2/AD2. PL4PO.3/AD3. PL5PO.4/AD4. PL and PO.5/AD5. PL7 PO and/AD and. Reset PO.7/AD7. RxD/P3.0 EA. TXD/P3.1 AL. IN field P3.2 PSEN. INTLI P3.3 P2.7/A15. 2/P3.4 P2 and/A14. TL/P3.5 P2.5/A13. WR/P3 and P2.4/A12. RDI P3.7 P2.3/all. XTAL2 P2.2/AL0. XTAL1 P2.1/A9. VSSP 2.0/A9. MSMADC 51FXXJS/MSMADC 31FJS. Top view, 44 lead plastic leaded chip carrier. 310, comma. C/I. 000, comma. C/I, F, OIAFFFF. L. L5J L4J I3J L, JLLET. PL5FJ0 P.04. PL6LRI Po.5. PL79 at Po.6. Reset JJFJ. P3.0/RxDFFJ. NE #J. P3.1/txdfi, P3.2/into-e, P3.3/int, L, P3.4/2i1, 3:3, 0000, 00a, TLTL, yen IPO.7, EA, ENC, if AL, RFPSEN, IP 2.7, QP 2.6, P3.5/T1FJ9 P2.5, RUR. R, 1R, R, 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 L1F191-2, I, 21S, PL2, Q, NNNNNIL, QAAA, MSM-ADC51FVXXGSKL MSM-ADC31FVGSK. Top view, 44 lead plastic flat package. P1.5, PL6, PL7, reset. P3.0/RXD, NC, P3.1/TXD, P3.2/INTQ, P3.3/1NTL, P3.4/2, P3.5, TL, C:0U0A1IAAI5, I, MN, MMM1, 0, SS:, CPCP, 00, 00, T1, for QFD package. PO.4, PO.S, PO.S, PO.7, EA, NC, AL, PSEN, P2.7, P2.6, P2.5, MEN 0.45 unit, mm. DDDD. I registered. C:/J equals TJI O equals at 0 equals at slash ODDDDDD I.mk max 10.9 min 14.9 underscore emism soc 31f/SOC 51f. Pin descriptions. Designation description. VSS ground potential. VCC supply voltage during normal, idle, and power down operation. Port 0 is an 8-bit open drain bidirectional 110 port. It is also the multiplexed low-order address and data bus during accesses to external memory. Port 1 is an 8-bit bidirectional 1/0 port with internal pull-ups. It can drive CMOS inputs without external pull-ups. Port 2 is an 8-bit bidirectional 110 port with internal pull-ups. It receives the high-order address byte during accesses to external memory. It can drive CMOS inputs without external pull-ups. Port 3 is an 8-bit bidirectional 1/0 port with internal pull-ups. It also serves the functions of various special features, as shown below. Port pin alternate function. P3.0 RXD, serial input port. P3.1 TXD, serial output port. P3.2 into, external interrupt. P3.3 int 1, external interrupt. P3.42, timer 0 external input. P3.st1, timer 1 external input. P3.6 WR, external data memory write strobe. P3.7 RD, external data memory read strobe. It can drive CMOS inputs without external pull-ups. Reset input pin. A reset is accomplished by holding the reset pin high for at least 1/L second, even if the oscillator has been stopped. The CPU responds by executing an internal reset. An internal pull-down resistor permits power on reset using only a capacitor connected to VCC. This pin does not receive the power down voltage since the function has been transferred to the VCC pin. AL address latch enable output for latching the low byte of the address during accesses to external memory. For this purpose, AL is activated twice every machine cycle or at a constant rate of 116 the oscillator frequency, except during an external memory access at which time one AL pulse is skipped. It can drive CMOS inputs without an external pull-up. PSEN program store enable output is the read strobe to external program memory. PSEN is activated twice each machine cycle during fetches from external program memory. However, when executing out of external program memory, 2 activations of PSEN are skipped during each access to external data memory. PSEN is not activated during fetches from internal program memory. It can drive CMOS inputs without an external pull-up. EA external access input pin. When EA is held high, the CPU executes out of internal program memory, unless the program counter exceeds off. When EA is held low, the CPU executes only out of external program memory. EA must not be floated. XTAL1 crystal 1 pin. It is an input to the inverting amplifier which forms the internal oscillator. It also receives the external clock signal when an external oscillator is used. External clock signal should be at %, duty and CMOS level. XTAL2 crystal 2 pin. It is an output of the inverting amplifier that forms the internal oscillator. 311. MSM-ADC31F LADC51F-. Electrical characteristics. Absolute maximum ratings. Item symbol. Supply voltage VCC. Voltage from any pin to VSS VAP. Storage temperature TSTG. Power dissipation PO. Operating range. Conditions. EMSM-ADC31F1/ADC51F1. 0.5 to 16 MHz, VCC equals plus or minus 10%. Rating. -0.5 to plus 7.0. -0.5 to VCC plus 0.5. -55 to plus 150. 1.0. EMSM-ADC31F/ADC51F, MSM-ADC31/ADC51. 0.5 to 12 MHz, V equals plus or minus 20%. Item symbol conditions rating. Supply voltage VCC FOSC equals 0.5 minus 16 2.5 to plus 6.0 MHz. RAM retention voltage VPD power down 2.0 to plus 6.0. Operating temperature top minus 40 to plus 85 units. V. Degree C. W. Units. V. Degree C. Notice, stresses at or above those listed under absolute maximum ratings may cause permanent damage to the device. This is a stress rating only and functional operation of this device at these or any other conditions above those indicated in the operational sections of this specification is not implied. Exposure to absolute maximum rating conditions may affect device reliability. DC and AC characteristics in the range of 12 MHz. DC characteristics. Ta equals minus 40 degrees Celsius to plus 85 degree, VCC equals 4 to 6 V, VSS equals OV. Item symbol condition min. Tip. Max. Unit. Input low voltage VIL. Except EA. Dash 0.5, 0.2 VCC 0.1. Input low voltage VIL 1, dash 0.5, 0.2 VCC 0.3. To EA. Input high voltage VIH. Except XTAL1, reset. 0.2 VCC plus 0.9, VCC plus 0.5. Input high voltage VIH. XTAL1 and reset. 0.7 VCC, VCC plus 0.5. Power down voltage VPD, 2.0 to 6.0. To VEC in PO mode. Output low voltage vol IOL equals 1.6 mA, 0.45. Ports 1, 2, 3, Note 1. Output low voltage vol 1 IOL equals 3.2 mA, 0.45. Port 0, AL, PSEN. Note 1. Output high voltage VOH IOH equals -10/LA 0.9 VEC. Ports 1, 2, 3. IOH equals -30/LA 0.75 VCC. IOH equals -60/LA 2.4. Note 1, vol is degraded when the ADC31F/ADC51F rapidly discharges external capacitance. This AC noise is most pronounced during the emission of address data. When using external memory, locate the latch or 312 buffer as close to the ADC31F/ADC51F as possible. V. 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 E. MSM ADC31F/ADC51F. DC characteristics, cont. Ta equals -40 degrees Celsius to +85 degree, VCC equals 4 to 6 V, VSS equals OV. Item symbol condition min. Tip. Max. Unit. Output high voltage VOH 110H equals -40 JLA 0.9 VCC, V. Port O on external bus mode, No 2. LPSEN. 10H equals -1S0 JLA 0.7 SVCC, V. 10H equals -400 JLA 2.4, V. Logical 0 input current ILVEN equals 0.4 SV, -200 PA. Ports 1, 2, 3. Logical 1 to 0 transition ITLVEN equals 2.0 V, SU PA. Current ports 1, 2, 3. Input leakage current 3 VSS. Port 0, EA. Maximum power supply ICC VCC equals 4 VSV 6 V. Current normal operation. Note 3, FOSC equals 12 MHz 12 16 20 mA. FOSC equals 8 MHz 8.3 11 14 mA. FOSC equals 3.s MHz 4.3 5.77.s mA. FOSC equals 0.s MHz 1.6 2.23 mA. Maximum power supply ICC 1 FOSC equals 12 MHz 2.s 3.7 mA. Current idle mode, Note 4. FOSC equals 8 MHz 1.8 2.7 3.7 mA. FOSC equals 3.s MHz 1.1 1.6 2.2 mA. FOSC equals 0.s MHz 0.6 0.9 1.2 mA. Maximum power supply ICC VCC equals 4.s V5 Vs.5 V. Current normal operation. Note 3, FOSC equals 16 MHz 18 20 23 mA. FOSC equals 12 MHz 14 16 18 mA. FOSC equals 8 MHz 10 11 12.5 mA. FOSC equals 1.2 MHz 2.0 2.3 2.6 mA. Maximum power supply ICC1 FOSC equals 16 MHz 4.05.06.0 mA. Current idle mode, Note 4. FOSC equals 12 MHz 3.03.7 s.0 mA. FOSC equals 8 MHz 2.32.73.2 mA. FOSC equals 1.2 MHz 1.41.s 1.6 mA. Power supply current IPDVs equals 2.0 V, so PA. Power down mode, Note S. Reset pull down resistor RRST 2040 125 kF. Capacitance of I/O buffer CIOFC equals 1 MHz, 10 pF. Ta equals 2 SOC. 313. MSM ADC 31F/ADC 51F-. Note 2, capacitive loading on ports 0 and May 2nd cause the VOH on AL and PSEN to momentarily fall below the 0.9 VCC specification when the address bits are stabilizing. Note 3, ICC is measured with all output pins disconnected, XTAL1 driven with TCLCH, TCHCL equals 10 NS, VIL equals VSS. Plus 0.5 V, VIH equals VCC-0.5 V, EA equals reset equals port 0 equals VCC. ICC may be higher if a crystal oscillator is used. Note 4, idle ICC is measured with all output pins disconnected, XTAL1 driven with TCLCH, TCHCL equals 10 NS, VIL equals VSS plus 0.5 V, VIH equals VCC-0.5 V, EA equals port O equals VCC. ICC may be higher if a crystal oscillator is used. Note 5, power down IPD is measured with all output pins disconnected, EA equals port 0 equals VCC, XTAL2 NC, reset. Equals VSS. Datum. Emitting. Ports. Address P2, PO. Write data. Clock parameters. Item symbol. Oscillator period TCLCL. High time TCHCX. Low time TCLCX. Rise time TCLCH. Fall time TCHCL. External clock drive. XTL2. External. OSCLLLATORIXTL1. Signal. VSS. XTAL1. PO. TCLCH. Degraded vol. I/O lines, peak/max. P1, P3 0.8 V. PL, P2, P3 0.8 V. Variable clock. Frequency equals 0.5 MHz to 16 MHz. Min. Max. 62.5. 20. 20. 20. 20. TCHCL. Input to the inverting oscillator amplifier and input to the internal clock generator circuits. XTAL2. Output from the inverting oscillator amplifier. 314. Unit. NS. 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 E. MISM SOC 31F/SOC 51F. AC characteristics. Top equals -40 degrees Celsius to 85 degrees Celsius, VCC equals 4V to 6V, VSS equals OV, 0.5 to 12 MHz, load capacitance for port 0, AL. And PSEN equals 1 OOP-F, load capacitance for all other outputs equals 80 PF. External program memory characteristics. Item symbol min. Tip. Max. Unit. AL pulse width TLHLL2 TCLCL40, NS. Address valid to AL low TOEFL TCLCL40, NS. Address hold after AL low tlax TCLCL35, NS. AL low to valid insta.lntlllv, 4 TCLCL100 NS. AL low to PSEN low TLLPLTCLCL25, NS. PSEN pulse with TPLPH3 TCLCL35, NS. PSEN low to valid insta. In tpliv, 3 TCLCL105 NS. Input insta. Hold after PSEN tpseeks 0, NS. Input insta. Float after PSEN tpsees, TCLCL20 NS. PSEN to address valid tpsob TCLCL8, NS. Address to valid insta. In taviv, 5 TCLCL105 NS. PSEN low to address flow tplas, 0 NS. External data memory characteristics. Item symbol min. Tip. Max. Unit. RD pulse with TRLRH6 TCLCL100, NS. WR pulse with TWLWH6 TCLCL100, NS. Data address hold after AL low tlax TCLCL35, NS. RD low to valid data in TRLDV, 5 TCLCL165 NS. Data hold after RDTRHDX0, NS. Data float after RDTRHDZ, 2 TCLCL70 NS. AL low to valid data in TLLDV, 8 TCLCL150 NS. Address to valid data in TOFV, 9 TCLCL165 NS. AL low to WR or RD low TLLWL3 TCLCL50, 3 TCLCL plus 50 NS. Address to WR or RD low TOVL 4 TCLCL130, NS. Data valid to WR transition TQVWX TCLCL60, NS. Data valid to WR high TQVWHL TCLCL150, NS. Data hold after WR TWHQX TCLCL50, NS. RD low to address float TRLAS, 0 NS. RD or WR high to AL high TWHLH TCLCL40, TCLCL plus 40 NS. 315. MSM ADC31F/ADC51F- AC timing diagrams. 316. External program memory read cycle. 1 dash 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 1 ZTCLCL dash 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 point 1. AL. Port OA0A7 insta in. Port Z address A8A15. External data memory read cycle. ITLLDV underscore ITWHLH underscore. AL. Dash dash TRLRH. Dash 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 I dash. Porto data in. TRLAS. Ports address A8A15 or SFRPZ. External data memory write cycle. AL. Porto. Ports. Address. ORS for PZ. TWHLH. Dash 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 TWLWH dash. Data out. TQVWH. Address A8A15 or SFRPZ. EEMISMSOC 31F/SOC 51F. AC testing input/output, float waveforms. Input/output float. F float I. PC. Test points 0.8. 2.4 \2.02 I. Dash. 2.4 \. J \:. 0.46. AC inputs during testing are driven at 2.4 V for a logic, and 0.45 V for a logic 0. Timing measurements are made at 2.0 V for a logic, and O.SV for a logic 0. For timing purposes, the float state is defined as the point at which a PO pin sinks 3.2 mA or sources 400 p.A at the voltage test levels. Serial port timing. I/O expansion mode. Ta equals -40 degrees Celsius to +S5 degrees C, VCC equals 4 to 6 V, VSS equals OV, 0.5 to 12 MHz, load capacitance equals SOPF. Symbol parameter min. Max. Units. TXLXL serial port clock cycle time 12 TCLCL, PS. TQVXH output data set up to clock rising edge 10 TCLCL 133, NS. TXHQX output data hold after clock rising edge 2 TCLCL 117, NS. TXHDX input data hold after clock rising edge 0, NS. TXHDV clock rising edge to input data valid, 10 TCLCL 133 NS. Serial port, I/O expansion mode. Machine cycle I02345678. Clock. Output data. Write to SAUFTXHDV-1ITXHDX. Input data ______J2.ylet equals --y colon, comma colon colon I backslash underscore n colon dot valid colon I backslash JL colon dot valid backslash underscore comma dot comma, VWOL underscore dot JIIO colon 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 I underscore, I backslash equals underscore, I backslash colon 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 wo colon underscore L backslash T. Clear RL 317. CD. Cycle. Step. XTAL1. AL. PM backslash. M slash WR. Port O. Port 2. 1. O. CPU effort 1. Port CPU. T. Dash colon port T. O. L day, RT. N, EU. D ta. I. IDM plus L. TJ. II. 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 TM plus L. JL. II. 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 Instruction decording II. IINStion execution. PC plus L1I. I underscore. I colon MTLI. II. II. III. III. N. -4. I. G. N. Percent. 21. -4. N. 6. N. Colon. I. C colon. D. I. N. 3L. I. 3L. 011. 8. Co. Colon. N. N. Underscore E. MSM ADC 31F / ADC 51F. External program memory fetch. Dash dash underscore underscore Milo M2 dash 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 dash. XTAL1. AL. Porto. Port 2. Read cycle 1, MOVXA, at RR. XTAL1 0 AL 0 PSEN 0 RI5 0 Porto 0 Port2 0 319 MISMSOC 31F/SOC51F- Read cycle 2 MOVXA at DPTR XTAL1 0 AL 0 J5RN 0 RD 0 Porto 0 J Port2 0 Write cycle 1 MOVX at RR A XTAL1 0 AL 0 PSEN 0 WR 0 Porto 0 Port2 0 320 dash 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 EEMSM ADC31F/ADC51FE Write cycle 2 MOVXA at DPTR A dash dash MLI XTAL1 AL Porto Port2 Port operation XTAL1 O AL 0-1-1 0-1-1 1 Port 0,1,2,3 Pin data CPU data Sampled 321 MSM ADC31F/ADC51F- Instruction set details Instruction code hexa Mnemonic Decimal Byte cycle explanation 07DDD to 020 do ADA RN00101N2N No 28-2F11 A AL plus RN Add A Direct 001001012521 AL A plus Direct A7AAAA2A AO by 2 Add A at RI0010011126 to 2711 AL plus RI Add a hashtag data 001001002421 A AL plus hashtag data D7DDD to D2D do by 2 Add ca RN00111N2N No 38-3F11 AL plus C plus RN ADDCA Direct 001101013521 AL plus C plus Direct A7AAAA2A AO by 2 Add ca at RI0011011136 to 3711 A plus C plus RI ADDCA hashtag data 001101003421 AL A plus C plus hashtag data D7DDD to D2D do by 2 Suba RN10011N2N No 98-9F11 A C plus RN SUBBA Direct 1001001019521 A AL C plus Direct A7AAAA2A AO by 2 Suba at RI100101196 to 9711 AL A C plus RIL RN Co Inca 000000 IINC RN00001N2N No 08-0F11 RN plus 1. E. Inc. direct 000001010521, direct, plus 1. A7 AAAA A2A, AO by 2. Inc. at RI 0000011106-0711 RI, RI plus 1. Inc. DPTR 10100011A312, DPTR, plus 1. DECA 000101001411, AL-A, L. DECRN 00011N2N, No 18-1F11, RN, 1. DEC direct 000101011521, direct, 1. A7 AAAA A2A, AO. DEC at RI 0001011116-1711 RI, 1. MLAB 10100100A414, B.L, A70J- ALX, B. DIVOB 100001008414, A.L, B7, OJ- A, /B. DAA 110101000411 cont NS of accumulator RBCD. If AAOJ9 or AC equals 111, then AA OJ plus 6. N. If A7 9 or C equals 111, then A7 A7 plus 6. ANLARN 010111N2N, No 58-5F11, A, N, RN. ANLA, direct 010101015521, A, N, direct. RN. A7 AAA A3 A2A, AO by 2. 3 ANLA hashtag data 010101005421, A, and hashtag data 0D7DDDD3D2D, do by 2. 322. Dash 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 EEMSM80C31F/SOC51FE. Instruction set details, co-nt. Instruction code hexa. Mnemonic. Decimal. Byte cycle explanation. D, D2D, do. ANL direct, A010100105221, direct, N, A. AAOAA2A, add by 2. ANL direct, 010100115332, direct, and hashtag data. Hashtag data A, AAOAA2A, add by 2. D2D, do by 3. Orla RN 01001N2N, No 48-4F11, A, or, RN. ORLA, direct 010001014521, A, or, direct. AAOAA2A, add by 2. Orla at RI 0100011146-4711, A, or RI. Orla hashtag data 010001004421, A, or hashtag data. D3D2D, do by 2. ORL direct, A010001042221, direct, or, A. AAOAA2A, add by 2. ORL direct, 010001114332, direct, or hashtag data. Hashtag data AAOAA2A, add byte 2. D do D2D, do byte 3. XRLARN01101N2N, no 68-6F11, A, XOR, RN. XRLA, direct 011001016521, A, XOR, direct. AAO4A2A, AO byte 2. XRLA at RI0110011166-6711, A, XOR RI. XRLA, hashtag data 011001006421, A, XOR hashtag data. D do D4 D3 D2D, do byte 2. XRL direct, A011000106221, direct, XOR, A, C, 0. A as A3 A2A, add byte 2. SIL XRL direct, 011000116332, direct, XOR hashtag data C. 0 hashtag data A as A3 A2A, AO byte 2. A. D do D3 D2D, do byte 3. 6. 0 CLRA11100100 times 10 to the power of 4th 11, A, O. I. CPLA11110100F411, A, dash, A. Q. AIA.IA31A21A, Lao. RJ. The contents of the accumulator. RLA 001000112311 are rotated left by 1 bit. LM, AIA.IA3IA2IA, IAO. The contents of the accumulator. RLCA 001100113311 and carry are rotated left by 1 bit. LJAIA.IASLA.IA31A21A, IAD. The contents of the accumulator. RRA 000000110311 are rotated right by 1 bit. LMAIA6I as IA.IA3IA2IA IAOP. The contents of the accumulator. RRCA 000100111311 and carry are rotated right by 1 bit. Swap A1100001000C411, A30:::, A, dash dot. 323. MSM ADC31F/ADC51F dash. Instruction set details, cont. Instruction code hexa. Mnemonic. Decimal. Byte cycle explanation. 070DDOSD0, do. MOVA RN11101NN, no E8F11, A, dash, RN. MOVA, direct 11100101 times 10 to the power of 5th 21, A, direct. A7AAA as AA, AO byte 2. MOVA at RI11100111E6E711, A, dash RIL. MOVA hashtag data 011101007421, A, dash hashtag data. D7DDDDSDD, do byte 2. MOVRNA111111NN, no F8FF11, RN, dash, A. MOVRN, direct 10101NN, no A8AF22, RN, direct. A7AAA as AA, AO byte 2. MOVRN, hashtag data 01111NN, no 78-7F21, RN, dash hashtag data. D7DDDDSDD, do byte 2. MOV direct, A11110101F521, direct, A. A7AAA as AA, AO byte 2. MOV direct, RN10001NN, no 88-8F22, direct, RN. A7AAA A3AA, AO by 2. MOV direct 1, 100001018532, direct 1, direct 2. Direct 2 AAAAAAA 8 by 2. AAA A1AA. A1A slash, by 3. 3. MOV direct, at RI10001186-8722, direct, RIL. 1 to A7 AAA A3A. A, AO by 2. C. MOV direct, 011101017532, direct, dash hashtag data. 1 ILD7DDSDD3DD, do by 3. C. MOV at RIA11110111F6F711 RIA. MOV at RI, direct 10100111A6A722 RI, direct. A7 AAA A3AA, AO by 2. MOV at RI, hashtag data 0111011176-7721 RI, hashtag data. D7DDDD3DD, do by 2. Move optr, 10010000932, OPTR, hashtag data. Hashtag data 16DSD14D3D. DLLDLO do by 2. D7 to DDD3DD, do by 3. Movka at A plus 1001000119312, A, plus, OPTR. OPTR. MOVCA, at A plus PC 1000000118312, PC, plus 1, A, plus, PC. Movka at RI11100011E2E312, A, dash RI, external RAM. MOVXA, at OPTR 11100000E012, A, DPTR external RAM. MOVX at RIA 11110011F2F312 RI, dash, A, external RAM. MOVX at OPTR, A11110000F012 DPTR dash, A, external RAM. Push direct 11000000 code 22, SP, plus 1. A7 AAA A3AA, AO by 2 SP, direct. Pop direct 11010000 do 22, direct, SP. A7A as A3AA, AO by 2, SP, 1. XCHARN110001NN, no C8CF11, A. Equals. RN. XCHA, direct 11000101C521, A. Equals. Direct. A7AAA as AA, AO by 2. 324. Underscore 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 on MSM80C31F/SOC51F. Instruction set details, co-nt. Instruction code hexa. Mnemonic. Decimal. Byte cycle explanation. 0720003020, do. XCHA at RI11000111C6C711, A, RI. Underscore C. SCOA at RI1101011106-0711, A3, OL, RI3, OL, 0 : CLRC 11000011C311, C, O. CL Rbit 11000010C221, bit, O. B7 Bo BBB3 B2B, Bo by 2. Set Quan 101001103111, C, dash 1. SET bit 110100100221, bit, dash 1. C. B7 Bo BBB3 B2B, Bo by 2. 0. CPLC 10110011B311, C, dash, C. 5. Q. CPL bit 10110010B221, bit, C. B7 Bo BBB3 B2B, Bo by 2. E. Q, ANLC, bit 100000108222, C, N, bit, C. B7 Bo BBB3 B2B, Bo by 2 Fidge. ANLC slash bit 10110000 Bo 22, C, N, bit, C. MB7 Bo BBB3 B2B, Bo by 2. 8. ORLC, bit 011100107222, C, or, bit, Co. B7 Bo BBB3 B2B, Bo by 2. ORLC slash bit 10100000A022, C, or, bit. B7 Bo BBB3 B2B, Bo by 2. MOVC, bit 10100010A221, C, dash, bit. B7 Bo BBB3 B2B, Bo by 2. MOV bit C100100109222, bit, dash, C. B7 Bo BBB3 B2B, Bo by 2. ACAL address 11A0AA0100001 byte 122, PC, plus 2. A-8EAA3A2A, AO by 2, SP, plus 1. SP, PC7, OL. SP, plus 1. SP, PC.OJ. PC, page address. Locale address 16000100101232, PC, plus 3. 8158148138128111089A. By 2, SP, plus 1. A7AOAA3A2A, AO by 3 SP, PC7, OL. SP, plus 1. OJSP- PC.OJC. PC, address.0C. U. C, RET001000102212, PC. OJ-SP. A, SP, 1. E, PC7, OL, SP. SP, 1E. A. RETI 001100103212, PC. OJSP. SP, 1. PC7, OL, SP. SP, 1. AJM Padra 1181089 AO00001 byte 122, PC, plus 2. 8786 AA3A2A, AO by 2, PCO, OL page address. LJM Padra 16000000100232, PC, address.0. A 15 a 14 a 13 a 12 a 11 a 1089 AO by 2. A 7 AOAA a 3 a 2A, AO by 3. 325. MISMSOC 31F/SOC 51F-. Instruction set details, cont. Instruction code hexa. Mnemonic. Decimal. Byte cycle explanation. 0, O. do D03020, do. SJM Perl 100000008022, PC, plus 2. R, RRs RR3 R2 RO by 2, PC, plus REI. JMP at A plus OPTR 011100117312, PC, A, plus, OPTR. JZREI 0110000062, PC, plus 2. R, RRs RR3 R2 RO byte if, A, equals 0 then, PC, plus REI. JN 001110000722, PC, plus 2. R, RRs RR3 R2 RO by 2 if, A, I0 then, PC, plus REI. JCRL 0100000042, PC, plus 2. R, RRs RR3 R2 RO by 2 if, C, 1 foot 1 inch then, PC, plus REI. JN curl 0101000052, PC, plus 2. R, RRs RR3 R2 RO by 2 IF, C, hashtag 0 then, PC, plus REI. JB bit, REI 0010000023 PC, plus 3. B, BBS BB3 B2 B1 Bo by 2 if, bit, equals 1 then, PC, plus REI. R, RRs RR3 R2 RO by 3. JN bit, REI 0011000032, PC, plus 3. B, BBS BB3 B2 B1 Bo by 2 if, bit, equals 0 then, PC, plus REI. R, RRs RR3 R2 RO by 3. JBC bit, REI 000100001032, PC, plus 3. B, BBS BB3 B2 B1 Bo by 2 if, bit, equals 1 then, bit, O. R, RRs RR3 R2 RO by 3, PC, plus REI. CLC. CJNEA, direct, 10110101B532, PC, plus 3. REIA, A as A3 A2 AO by 2 if, direct. C, R. RRs RR3 R2 R1 RO by 3 plus reland, C, O. 0 if, direct, A, then, PC, E plus REI and, C, L. E. CJNEA, hashtag data, 10110100B432, PC, plus 3. 0 REID, DDS DD3 D2 D1 do by 2 if hashtag data. R, RRs RR3 R2 RO by 3 then, PC, plus REI and C, O. If hashtag data, A, then, PC, plus REI and C, 1. CJNERN, hashtag data, 10111N2N, no B8 BF32, PC, plus 3. REID, DDS DD3 D2 D1 do by 2 if hashtag data. R, RRO RR3 R2 RO by 3 plus reland, C, O. If hashtag data, RN, then, PC, plus REI and, C, L. CJNE at RI, 10110111B6B732, PC, plus 3. Hashtag data rel d, dds dd3 d2 d1 do by 2 if hashtag data. If hashtag data, ri then, pc. pc, plus rei and, c, 1. OJNZRN, REI 11011 and 2N, no 08-0F22, PC, PC, plus 2. NRRs RR3 R2R, RO by 2, RN, RN, 1. If, RN, hashtag 0 then, PC, PC, plus REI. OJNZ direct, REI 1101010100532, PC, PC, plus 3. A as A3 A2 A1 AO by 2, direct, dash, direct, L. RRs RR3 R2R, RO by 3 if, direct, F0 then, PC, PC. Plus REI. NOP 0000000000011, PC, PC, plus 1. 326. E. MSM ADC 31F/ADC 51F. Notes on the instruction set and the addressing modes. RN. Direct. At RI. Hashtag data. Hashtag data 16. Address 16. Address 11. REI. Bit. Register R7 RO of the currently selected register bank. 8-bit internal data locations address. This could be an internal data RAM. Location, 0 to 127, or a SFRIE, 1/0. Port, control register, status register, etc., 128 to 255. 8-bit internal data RAM location, 0. 255, addressed indirectly through register R1 or RO. 8-bit constant included in instruction. 16-bit constant included in instruction. 16-bit destination address. Used by lcall and LJMP. A branch can be anywhere within the 64 KB program memory address space. 11-bit destination address. Used by ACAL and AJMP. The branch will be within the same 2 KB page of program memory as the first byte of the following instruction. Signed, 2's complement, 8-bit offset. Byte. Used by SJMP and all conditional jumps. Range is -128 to +127 bytes. Relative to first byte of the following instruction. Direct addressed bit in internal data. RAM or special function register. Instructions that affect flag settings 1. Instruction flag. Add. ADDC. SUBB. mul. DIV. DA. RRC. RLC. SEDC. COVAC. XXX. 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 0x. 0x. X. 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 I. CLRC. CPLC. ANLC, bit. ANLC/bit. ORLC, bit. ORLC, bit. MOVC, bit. CJNA. One note that operations on SFR byte address 208 or bit addresses 208 to 215, LE, the PSW or bits in the PSW, will also affect flag settings. COVAC 0 X X X X X X X 327 Phi EMSM ADC 31F/ADC 51 Phi dash 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 dash. Application examples. P1.0 1 2 P1.1 3 P1.2 P1.34 P1.45 6 P1.5 comma XTAL2 P1.6 7 MSM82C43 BB.2K P1.7 IO 11 P20 expander P2.0 1 P2.1 P21 VE reset P2.2 9 P22 10 JLF MSM ADC 51 FP2.3 P23 P2.4 P2.5 Prague 31 P2.6 EAP 2.7 CS 10 P3.0 RxD PO.O 39 1138 12 P3.1 TXD PO.1 37 110 P3.2 Thurify PO.2 13 P3.3 LTLI PO.3 36 14 P3.4 2 PO.4 35 15 P3.5 T1 PO.5 34 16 P3.6 WR PO.6 33 17 P3.7 RD AL PO.7 32 29 The following software driver is required to interlace to the 82C43. Mixing parallel output, input, and in 82C43. In 82C43. Control strobes on port 2. Input data from an 82C43 1/0 expander. Connect to P23 P20. P25 and P24 mimic CSI and Prague. P27 P26 used as inputs. Port to be read in ACC. A hashtag 110100000B. P50. P51. P52. P53. P60. P61. P62. P63. P70. P71. P72. P73. MOV. MOV. CLR. ORL. MOV. SETB. P2A, Output Instruction Code. P2.4, Falling Edge of Prague. P2 hashtag 01111B, set for input. AP2, read input data. P2.4, return Prague high. Address instruction. P21 P20 code P23 P22 code. 00 port 400 read. 01 port 501 write. 0 port 60 or low. Port 7 ANLD. I/O expansion using an 82C43. 328. 2. 3. 4. 5. 1. 23. I/O. dash 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 4 MISM SOC 31F/SOC 51F. Application examples, co-nt 19 XTAL1V VSS P1.0 7 F R P1.1 P1.2 CJP 1.3 8P 1.4 dash equals OPFXTAL2 P1.5 8.2K P1.6 P1.7 T P2.0 P2.1 Reset P2.2 MSM80C 51F P2.3 110 P2.4 P2.5 P2.6 EAP 2.7 10 P3.0 RxD PO.O 39 138 12 P3.1 TXD PO.137 13 P3.2 into PO.2 36 14 P3.3 int 1 PO.3 35 15 P3.4 2 PO.4 34 P3.5 N PO.5 16 P3.6 WR PO.6 33 1732 P3.7 RD LPSEN PO.7 29 N 19 XTAL1V1 7 F F RP 1.0 2 P1.1 P1.23 P1.34 dash : OPFT 11 8 P1.45 XTAL2 P1.5 6 7 8.2K P1.6 8 CR P1.7 P2.0 21 22 Reset P2.1 23 P2.2 MSM80C 51F P2.3 24 P2.4 25 110 P2.5 26 P2.6 27 31 EAP 2.7 28 10 P3.0 RxD PO.O 39 11 P3.1 TXD PO.138 0/0 12 P3.2 INT PO.237 13 P3.3 IFI PO.336 14 P3.4 2 PO.435 15 P3.5 N PO.534 16 P3.6 WR PO.633 17 P3.7 RD AL PO.7 32 PSEN 29 Multiple ADC 51Fs using half-duplex serial communication 329 MISM SOC 31F/SOC 51F-. Application examples, Cont. 19 1 RIJJ LOP 8.2K 10 LLT 31. Dot 330 XTAL2 Reset MSM80C 51F EA P10 IRXD P3.1 ITSD PL2I1 ANTOI P3.3 I1 ANTLL P3.4 ITOI P3.5 IT1 P3.61.1 PL7 IRDILPSEN 3029 1, comma PL02 P1 3 PL24 P1.35 PL46 PL57 PL6 PL7B P2.0 21 P2.1 22, 23 P2.22 P2.3 25 P2.4 26 P2.5 P2.6 27 P2.12B PO.0 39 PO.L 37 PO.23 PO.3 35 PO.4 PO.6 33 PO.6 PO.7 32 plus 5 VGND 20 VVSS 12 ADU 13 14 ADI 15 AD2 16 AD3 17 AD4 18 A05 ADS 19 AD7 MSM81 C55 101M RD 10 WE 11 AL dash dash CE L4 dash equals R reset TR timer in can be SUT-plied by system reset 6 or port line of ADC 61P. Adding a data memory and IO expander. Timer 19 PL0 11 F5 2 PLL 3 P1.2 PL3 510 PPL4 6 XTAL2 PL57 P1.68 P1.1 P2.0 Reset P2.1 P2.2 MSM80C 51F P2.3 P2.4 P2.5 EA P2.6 P2.7 PLO IRXD P3.1 ITSD LID P3.2 I1 ANTOI 14 P3.3 Li Antil 16 PL4 ITOI 16 PL6 IL33 17 P3.6 IWRI 32 P3.71 RDIL Multiple interrupt sources PAL 21 22 PAL 23 PA2 24 PA3 25 PM PA2 PA62 PA728 PCO 37 38 PCL 39 PC2 1 LID PC3 PC42 PC55 PBO 29 3 PBL31 PB232 PB3 PB434 PB535 P8636 PB7 110. MSM-ADC31F/ADC51F. MSM-ADC31/MSM-ADC51 instruction codes. 0123456 0 AJMP LJMP Inc. 0000 NOP address 11 address 16 RRA Inca Direct Inc at RO Inc at RL Page 0 1 JB SPID A Call Dec Address 11 address 16 RRCA Dec at RO Dec at RL 0001 REI Page 0 Direct AJMP 2 ATA 2 JBID Address 11 RETRLA ATA 0010 REI Page 1 Hashtag data Direct at RO at RL 3 JN-bit ACAL I/DDCA ADCA Address 11 RETIRLCA 0011 REI Page 1 Hashtag data direct at RO at RL 4 JSPID AJMP ORL Orla 2 Orla 0100 REI Address 11 Direct A Direct Hashtag data direct at RO at RL Page 2 Hashtag data 5 ACAL ANL ANLA JNCRL address 11 direct 0101 Page 2 Direct A Hashtag data direct at RO at RL 6 AJMP XRL 2 XRLA 0110 J0 address 11 Direct A Direct Hashtag data direct at RO at RL Page 3 Hashtag data 2 ACAL 2 ORLC 2 MOVA MOV at RO MOV at RL 7 JN0 address 11 JMP Direct 0111 Page 3 Bit at A plus DPTR Hashtag data AJMP2 MOV 8 SJMPRL address 11 ANLC MOVKIA DIVOB Direct 1 Direct 1000 Page 4 Bit at A plus PC Direct 2 at RO at RL 9 MOVPR ACAL MOV bit MOVKIA Suba Address 11 1001 Hashtag data 16 Page 4 C at A plus DPTR Hashtag data direct at RO at RL A AJMP MOVC MOV at RO MOV at RL 1010 ORLC/bit Address 11 Bit Inc DPTR MLB Direct Page 5 B ACAL CJNIA CJNE at RO CJNE at RL 1011 ANLC/bit address 11 CPL bit CPLC Hashtag data direct Hashtag data Page 5 REI. C push. AJMP. XCHA. Address 11 CLR bit CLRC swap A. 1100 direct. Page 6. Direct at RO at RL. Dpop. ACAL2 DJNZ. Sta. Address 11 SET bit set DAA direct. 1101 direct. Page 6, REI at RO at RL. eMovka. AJMP. Movka, MOVA. Address 11 CLRA. 1110 at DPTR. Page 7. At RO at RL direct at RO at RL. FMOVX. ACAL. MOVX. 2. MOV. 1111 at DPTRA. Address 11. At ROA at RLA. CPLA. Direct, A at ROA at RLA. Page 7. 2 byte 3 byte. Mnemonic. 2 cycle 4 cycle. 331. MISMSOC 31F/SOC 51F-. 89 ABCDEF. 1000 1001 1010 1011 1100 1101 1110 1111. Incro increased 1 increased 2 increased 3 increased 4 increased 5 increased 6 increased 7. Decro DECR1 DECR2 DECR3 DECR4 DECR5 DECR6 DECR7. ADA RO ADA R1 ADA R2 ADA R3 ADA R4 ADA R5 ADA R6 ADA R7. ADCA RO ADCA R1 ADCA R2 ADCA R3 ADCA R4 ADCA R5 ADCA R6 ADCA R7. Orla RO Orla R1 Orla R2 Orla R3 Orla R4 Orla R5 Orla R6 Orla R7. ANLA RO ANLA R1 ANLA R2 ANLA R3 ANLA R4 ANLA R5 ANLA R6 ANLA R7. XRLA RO XRLA R1 XRLA R2 XRLA R3 XRLA R4 XRLA R5 XRLA R6 XRLA R7. MOVRO, MOVR1, MOVR2. I. MOVR3, MOVR4, MOVR5, MOVR6, MOVR7. Hashtag data 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 hashtag data. MOV MOV MOV. MOV 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 MOV. MOV. Direct, 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 direct. RO R1 R2 R3 R4 R5 Rs R7. Suba, 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 I suba, suba. RO R1 R2 R3 R4 R5 Rs R7. MOVRO, MOVR1, MOVR2, MOVR3, MOVR4, MOVR5, MOVRs, MOVR7. Direct. Kjaner 1, Kjaner 2, Kjaner 3, Kjaner 4, Kjaner 5, Kjaners, Kjaner 7. Hashtag data, 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 hashtag data. REI XCHA 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 RO R1 R2 R3 R4 R5 R6 R7. OINSRO, DJNZ R1, DJNZ R2, DJNZ R3, DJNZ R4, OINER 5, OINER 6, OINER 7. REI 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 3 REI 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 MOVA RO MOVA R1 MOVA R2 MOVA R3 MOVA R4 MOVA R5 MOVA R6 MOVA R7 MOVRO AMOV R1 AMOV R2 AMOV R3 AMOV R4 AMOV R5 AMOVRS AMOV R7 332 OKI Semiconductor MSM80C154/MSM83C154 CMOS 8-bit one-chip microcontroller. General description. The MSMS3C154/MSMSOC154 is a high-performance S.LGIT one-chip microcontroller implementing large integration, high speed, and low power consumption by 2.1M silicon gate CMOS process technology. The MSMS3C154 features 16 KB ROM, 256 byte RAM, 32 I/O ports, 3 16-bit timer/counters, multifunctional serial port and clock generator. In addition, the MSMS3C154 has 3 standby modes, enabling further power reduction. The MSMSOC154 is identical to the MSMS3C154 except the omission of 16 KB ROM. Features: fully static circuit, on-chip program memory, on-chip data memory, external program memory address space, external data memory address space, I/O ports, port 1, 2, 3, IMPT ANS programmable, 16.IGIT timer/counters, includes watchdog timer and 32-bit timer, multifunctional serial port, 6 source to priority level, interrupt and multi-level, 16K XS-bit ROM, MSMS3C154 only, 256 XS-bit RAM, 64 KB, 64 KB, 32. 3. I/O expansion mode, UART mode, featuring error detection. Interrupt available by programming IP and IE registers. Memory map special function registers. Bit addressable data memory and SFRs. Minimum instruction cycle, 1.0p.s at 12 MHz operation. Multiply/divide instruction cycle. Standby functions. 0.75 ps at 16 MHz operation, MSM80C154-1. 16 MHz version of MSMS3C154, 12 MHz. 3.1s at 16 MHz operation. Idle mode, CPU halt. Power down mode, oscillator stop. Activated by software or hardware, providing ports with floating or active status. The software power down mode is terminated by interrupt signal enabling execution from the interrupted address. Lower power consumption achieved by 2.1M silicon gate CMOS process. Upward compatible with MSM80C51/SOC31. Packages: 40-pin DIP, 44-pin flat package and 44-pin PLCC. 333. C. CN. XL2, I. NN. C. 2, I. P2.0 L1, equals TCHI. 0. 0. M. R/signal RUI. P2.7 plus 1, K equals L. Dash L colon, J dash, plus 0. N. Chi. Co. ROM. Dash underscore. O.ji, TIA.ii 0. C. UI. X 8-bit. 1. 1. Address. C. :IJ. 3. PL0. PL7. P3.0, P3.7, timer/counter 0 and 1. Dash. MSM80C154/83C154. Pin configuration. MSM83C154XXRS/MSM80C154Rs. Top view, 40 lead plastic dip. MSM83C154VXXGS/MSM80C154VGS. Top view, 44 lead plastic package. PL0/T2V. PLL/T2XPO.O. PL2PO.L. PL3PO.2. PL4PO.3. PL5PO.4. PL6PO.5. PL7. Reset. P3.0 IRXDL. P3.1/TXDL. P3.2/into PSEN. P3.3/INTL P2.7. P3.4/to P2.6. P3.5/TL/HPDI P2.5. P3.6/WR1 P2.4. P3.7/LW P2.3. XTAL2. XTALL. VSSP 2.0. MSM83C154XXJS/MSM80C154JS*1. PL5. P1.6. P1.7. Reset. P3.0 JRXD. NC. P3.1/TXD. P3.2/LNTO. P3.3/INTL. P3.4/2. P3.5/TL. OUO. NMCIOO:0. 0. S. COCO. 0W. CC. C.NC.N. For QPD package. PO.4. PO.5. PO.6. PO.7. EA. NC. AL. PSEN. P2.7. P2.6. P2.5. Top view, 44 lead P-stick leaded chip carrier. X. W. Unit, mm. PL57J. PL6, equals. P1.7J. Reset LG. P3.0/RXD equals J. P3.1/TXD3J. P3.2/1 and TQ equals 4J. P3.3/1 and TLCSJ. TT. I. 6 feet 151 inches 43. 140. LJ 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 LJ. OF9 PO.43 PO.S. 2 PO.6. Is PO.7. CIEA. 3 NC. : 3 AL. CF2 PSEN. IP 2.7. P3.4/to IJCOP 2.6. P3.S/T1/HPOIC7J2 P2.5. R-I-R, R1 RR, R-R, 118 912 Q1I, 1112 A312 I2SI I2Q 1271 Q8. Pin functions. Pin name. .dddo. 1 == registered. 0 = I equals. C:::::::JC::::::J. equals E3I equals KJI C::J O equals registered GIC equals VDDDDDDD IMK max 10.9 min 14.9 description PO.0.7 bidirection LIO ports. They are also the data/address bus, input/output, of data and output of lower 8-bit address when external memory is accessed. They are open drain output when used as I/O ports, but tri-state output when used as data/address bus. PL0, PL7, PL.0 to PL7 are quasi-bidirection LIO ports. They are pulled up internally when used as input ports. Two of them have the following secondary functions. PL0, T2, used as external clock input pin for the timer/counter 2. PLL, T2X, used as trigger input for the timer/counter 2 to be reloaded or captured, causing the timer/counter 2 interrupt. 335. MSM80C154/83C154-. Pin functions, cont. Pin name description. P2.0, P2.7, P2.0 to P2.7 are quasi-bidirection LIO ports. They also output the higher 8-bit address when an external memory is accessed. They are pulled up internally when used as input ports. P3.0, P3.7, P3.0 to P3.7 are quasi-bidirection LIO ports. They are pulled up internally when used as input ports. They also have the following secondary functions. P3.0, RxD. Serial data input/output in the I/O expansion mode and serial data input in the UART mode when the serial port is used. P3.1, TXD. Synchronous clock output in the I/O expansion mode and serial data output in the UART mode when the serial port is used. P3.2, into. Used as input pin for the external interrupt 0, and as count-up control pin for the timer/counter 0. P3.3, LNT1. Used as input pin for the external interrupt 1, and as count-up control pin for the timer/counter 1. P3.4, 2. Used as external clock input pin for the timer/counter 0. P3.5, T1. Used as external clock input pin for the timer/counter 1 and power down mode. Control input pin. P3.6, WR. Output of the write strobe signal when data is written into external data memory. P3.7, RD. Output of the read strobe signal when data is read from external data memory. AL address latch enable output for latching the lower 8-bit address during external memory access. 2 AL pulses are activated per machine cycle except during external data memory access, at which time 1 AL pulse is skipped. PSEN program store enable output which enable the external memory output to the bus. During external program memory access, 2 PSEN pulses are activated per machine cycle except during external data memory access, at which 2 PSEN pulses are skipped. EA when EA is held at H level, the MSM83C154 executes instructions from internal program memory at address 023FFFH, and executes instructions from external program memory above address 3FFFH. When EA is held at L level, the MSM80C154/MSM83C154 executes instructions from external program memory for all addresses. Reset if this pin remains H for at least 1 JL second, The MSM80C154/MSM83C154 is reset. Since this pin is pulled down internally, a power-on reset is achieved by simply connecting a capacitor between VCC and this pin. XTAL1 oscillator inverter input pin. External clock is input through XTAL1 pin. XTAL2 oscillator inverter output pin. VCC power supply pin during both normal operation and standby operations. VSSGND pin. 336. MSM80C154/83C154. Data memory and special function register. Layout diagram. OFFH of 8H. OFOH. OEOH. ODOH. OCDH. OCCH. OCBH. OCAH. OC8H. OB8H. OBOH. OA8H. OAOH. 99H. 98H. 90H. 2. 8DH. 89H. 88H. 87H. 83H. 82H. 81H. 80H. 80H. 7FH. 30H. 2FH. 7F bit 78. Addressable I. 20H7 RAM 0. LFHR7. Bank 3. 18HRO. 17HR7. Bank 2. 10HRO. OFHIR7. Bank 1. 08HIRO. 07HR7. Banko. Underscore RO. Iacon R. B dash. ACC dash R. PSW. TH2. R. TL2. R. RCAP2H. R. RCAP2L. R. T2 con R. IPFR. P3K dash. IE. P2. R. SBUF. R. SCON. PLR. THL. R. Though R. TL1. R. TLO. R. TMOD. R. TCON. PCON. R. DPH. R. DPL. R. SP. R. PO. Direct bit addressing. Register AD addressing. Direct byte addressing. Dressing indirect AD. 337. MSM80C154/83C154-. Detailed diagram of data memory, RAM. OFFH 255. 7FH 127. 2FH7F7 times 10 to the power of 70th 7C7B7A 79 78 47. 2S77 76 75 74 73 72 71 70 46. 20H6F6 times 10 to the power of 60th 6C6B6A 69 68 45. 2CH67 66 65 64 63 62 61 60 44. 2BH5F5 times 10 to the power of 50th 5C5B5A 59 58 43. 2A57 56 55 54 53 52 51 50 42. 29H4F4 times 10 to the power of 40th 4C4B4A 49 48 41. 28H47 46 45 44 43 42 41 40 40. 27H3F3E3D3C3B3A393839. 26H373635343332313038. 25H2F2E. 22C2B2A292837. 24H272625242322212036. 23H1F1 times 10 to the power of 10th 1C1B1A 191835. 22H17 16 15 14 13 12 11 10 34. 21H of OE000COBOA090833. 20H070605040302020100032. 1FH31. Bank 3. 18H24. 17H23. Bank 2. 10H16. OFH15. Bank 1. 08H8. 07H7. Bank 0. 00. 338. US. SIL. W. A. 0. 0. Colon. AJ. L. U. W. A. 0. US. SIL. W. A. 0. 0. A. W. I. SIL. A. US. SIL. W. A. 0. 0. W. I. AJ. I. U. W. A. 0. SIL. SIL. W. A. O. O. I. U. W. A. O. Z. Dash. MSM80C 154/83C 154. Detailed diagram of special function registers. Special. Direct function. Byte register. Address bit address symbol. MSB, LSB. WDTT32 SAR IZCP 3 Hz P2 Hz P1 Hz ALF. Of 8HFF FDFC FB1 FA1 F9 F8 Iacon. OFOH F7 F6 F5 F4 F3. 1. F2. 1. F1 FOB. OEOH E7 E6 E5 E4 E3. 1. E2. 1. E1 EOACC. SciACFORs 1 RSOOV F1P. ODOH D7 D6 D5 D4 D3 D2 D1 DO PSW. OCDH not bit addressable TH2. OCCH not bit addressable TL2. OCBH not bit addressable RCAP2H. OCAH not bit addressable RCAP2LH. TF2EXF2 RCLK TLKN2 TR2C/T2CP/RL2. OC8H. I. CF1CE1 CD1 cubic centimeter 1 CB1 CA1 C9 1 C8. I. T2 con. PCT PT2 PSPT1 PX1 PTO PXO. OB8H. I. BF. 1. BDBC BB1 BA. 1. B9. 1. B8. I. IP. OBOH1 B7 IB6. IB5 I. B4. IB3 IB2 IB1 IBOI. P3. EAET2 ESET1 X1 ETO XO. OA8H. I. AF. 1. 1AD 1AC 1 of 1AA 1A9 1A8 IE OAOH I A7 1A6 1A5 1A4 1A3 1A2 1A1 1AOP2 99H not bit addressable SBUF SMO SM1 SM2 REN TB8 RB8 TIRI 98H I 9F19E 19D1 9C19B19A 199 198 SCON 90H I 97 196 195 194 193 192 191 190 P1 339 MSM80C 154/83C 154- Special Direct Function Byte Register Address Bit Address Symbol MSB, LSB 8DH not bit addressable TH1 8CH not bit addressable though 8BH not bit addressable TL1 8A not bit addressable TLO 89H not bit addressable TMOD TF1 TR1 TFO TROIE1 IT1 Leo ITO 88H 8F I8 EI8D I8C I8B I8A1 89 88 TCON 87H not bit addressable PCON 83H not bit addressable DPH 82H not bit addressable DPL 81H not bit addressable SP 80H 87 I86 I85 I84 I83 I82 I81 I80 PO 340 dash MSM80C 154/83C 154 Special Function Registers Timer Mode Register TMOD MSB LSB Name Address 765432210 -- plus -- TMOD 89H Bit Location Flag TMOD.OMO TMOD.LML TMOD.2 CIT TMOD.3 Gate TMOD.4 MO Gate C/TMLMO Gate C/TMLMO Function IJ ML MO Timer/counter 0 mode setting Straight face O 0 8-bit TI-MER/counter with 5-bit preschooler J _______________ 1 _T_TM_E/UR : ________________________ 1 8-bit timer/counter with 8-bit auto reloading -1 ITI/OU ERO E A ed ITIO -8 by I counter and though 8-bit timer/counter TFO is set by TLO carry and TF1 is set by though carry timer/counter 0 count clock designation control bit XTAL12 divided by 12 clocks is the input applied to timer/counter. O when C/T0. The external clock applied to the 2 pin is the input applied to TI-MER/counter 0 when C/T1. When this bit is 0, the TRO bit of TCON, timer control register, is used to control the start and stop of timer/counter 0 counting. If this bit is 1, timer/counter 0 starts counting when both the TRO bit of TCON and into pin input signal are 1, and stops counting when either is changed to 0. ML, MO, timer/counter 1 mode setting -1, 0, 8-bit timer / counter with 5-bit preschooler. I-ILII underscore, UIR underscore 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 dash underscore underscore dash underscore underscore dash underscore dash plus dash 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 41, 0, 8-bit timer / counter with 8-bit auto reloading. TMOD.5M1-1, T dash colon TIEJCUTRL, R, TI, NSOPP, D dash. TMOD.6 CIT. TMOD.7 gate. I. Timer / counter 1 count clock designation control bit. XTAL12 divided by 12 clocks is the input applied to timer / counter. 1 when C/T0. The external clock applied to the T1 pin is the input applied to TI-MER / counter 1 when cliff 1. When this bit is 0, the TRL bit of TCON is used to control the start and stop of timer / counter 1 counting. If this bit is 1, timer / counter 1 starts counting when both the TRL bit of TCON and INTL pin input signal are 1, and stops counting when either is changed to 0. 341. EMSM83C154/83C154E-83C154/83C154E-////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////// address. MSB LSB 765432210. PCON87HSMODHPDRPD, GF1 GFOPOIDL. Bit location flag function. PCON.OIDL idle mode set when this bit is set to 1. CPU operations are stopped when idle mode is set, but XTAL 1 foot 2 inches, timer/counters 0,1 and 2, the interrupt circuits, and serial port remain active. Idle mode is cancelled when the CPU is reset or when an interrupt is generated. PCON.1 POPO mode set when this bit is set to 1. CPU operations and XTAL 1,2 are stopped when PO mode is set. PO mode is cancelled when the CPU is reset or when an interrupt is generated. PCON.2 GFO general purpose bit. Testing this flag when idle mode is cancelled by an interrupt shows whether the interrupt is a normal interrupt or an idle mode release. Interrupt. PCON.3 GF1 general purpose bit. Testing this flag when PO mode is cancelled by an interrupt shows whether the interrupt is a normal interrupt or a PO mode release. Interrupt. PCON.4 reserved bit. The output data is 1 if the bit is read. PCON.5 RPD bit used to specify cancellation of CPU power down mode, idle or PO, by interrupt signal. Power down mode cannot be cancelled by interrupt signal if interrupt is not enabled by i.e., interrupt enable register, when this bit is 0. If the interrupt flag is set to 1 by an interrupt request signal when this bit is 1, even if interrupt is disabled, the program is executed from the next address of the power down mode setting instruction. The flag is reset to 0 by software. PCON.6 HPD the hard power down setting mode is enabled when this bit is set to 1. If the level of the power failure detect signal applied to the HPDI pin, pin 3.5, is changed from 1 to 0 when this bit is 1, XTAL 12. Oscillation is stopped and the system is put into hard power down mode. HPD mode is cancelled when the CPU is reset. PCON.7 SMOD when the timer/counter 1 carry signal is used as a clock in mode 1, 2 or 3 of the serial port. This bit has the following functions. The serial port operation clock is reduced by January 2nd when the bit is 0 for delayed processing. And when the bit is 1, the serial port operation clock is normal for faster processing. 342. MSM80C154/83C154. Timer Control Register, TCON. Name address. MSB LSB 765432210. TCON ATFLTRLTFOTROIE1ITL Leo ITO. Bit location flag function. TCON.OITO external interrupt 0 signal used in level detect mode when this bit is 0, and in trigger detect mode when 1. TCON.L Leo interrupt request flag for external interrupt O. Bit is reset automatically when interrupt is serviced. Bit can be set and reset by software when ITO equals 1. TCON.2 ITL external interrupt 1 signal used in level detect mode when this bit is 0, and in trigger detect mode when 1. TCON.3 IL interrupt request flag for external interrupt 1. Bit is reset automatically when interrupt is serviced. Bit can be set and reset by software when ITL equals 1. TCON.4 TRO counting start and stop control bit for timer/counter O. Timer/counter 0 starts counting when this bit is 1, and stops counting when 0. TCON.5 TFO interrupt request flag for timer interrupt O. Bit is reset automatically when interrupt is serviced. Bit is set to 1 when carry signal is generated from timer/counter O. TCON.6 TRL counting start and stop control bit for timer/counter 1. Timer/counter 1 starts counting when this bit is 1, and stops counting when 0. TCON.7 TFL interrupt request flag for timer interrupt 1. Bit is reset automatically when interrupt is serviced. Bit is set to 1 when carry signal is generated from timer/counter 1. 343. I. MSM80C154/83C154-. Serial Port Control Register, SCON. Name address. SCON98H. Bit location flag. SCON.ORI. SCON.1 TI. SCON.2 RB8. SCON.3 TB8. MSB 7. SMO 6. SM1 54. SM2 REN. Function 32. TB8 RB8. End of serial port reception interrupt request flag. TI. LSB. O. RI. This flag must be reset by software during interrupt service routine. This flag is set after the 8th bit of data has been received when in mode 0, or by the stop bit when in any other mode. In mode 2 or 3, however, RI is not set if the RB8 data is 0 with SM2 equals 1. RI is set in mode 1 if stop bit is received when SM2 equals 1. End of serial port transmission interrupt request flag. This flag must be reset by software during interrupt service routine. This flag is set after the 8th bit of data has been sent when in mode 0, or after the last bit of data has been sent when in any other mode. The 9th bit of data received in mode 2 or 3 is passed to RB8. The stop bit is applied to RB8 if SM2 equals 0 when in mode 1. RB8 cannot be used in mode O. The TB8 data is sent as the 9th data bit when in mode 2 or 3. Any desired data can be set in TB8 by software. ++++. SCON.4 REN. SCON.5 SM2. SCON.6 SM1. Reception enable control bit. No reception when ren equals 0. Reception enabled when ren equals 1. If the 9th bit of received data is 0 with SM2 equals 1 in mode 2 or 3, the end of reception signal is not set in the RI flag. Nor is the end of reception signal set in the RI flag if the stop bit is not 1 when SM2 equals 1 in mode 1. SMO, SML, mode, underscore 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 dot L underscore 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 run. 0 0 8-bit shift register IO dash 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 comma dash dash 1 dash O I1 8-bit UART variable baud rate dash plus dash 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 1 dash 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 SCON.7 SMO1 0 2 9-bit UART 1/32 XTALL 1/64 XTALL I baud rate dash 1 comma dash 3R S by UARTV IBLBDR E 344 dash MSM80C 154/83C 154 interrupt enable register i.e. name address MSB LSB 765432 0 IEOA8HEA ET2ESETX bit location flag function IE.OXO interrupt control bit for external interrupt O interrupt disabled when bit is 0 interrupt enabled when bit is IE ETO interrupt control bit for timer interrupt O interrupt disabled when bit is 0 interrupt enabled when bit is IE.2X interrupt control bit for external interrupt interrupt disabled when bit is 0 interrupt enabled when bit is IE.3 ET interrupt control bit for timer interrupt interrupt disabled when bit is 0 interrupt enabled when bit is IE.4 ES interrupt control bit for serial port interrupt disabled when bit is 0 interrupt enabled when bit is IE.5 ET2 interrupt control bit for timer interrupt 2 interrupt disabled when bit is 0 interrupt enabled when bit is IE.6 reserved bit. The output data is if the bit is read. IE.7 EA overall interrupt cont OL bit. All interrupts are disabled when bit is 0. All interrupts are controlled by IE.0 through IE.5 when bit is 345. EMSM80C 154/83C 154E. Interrupt priority register up. Name address MSB LSB 76543210. IPOBSHPCT PT2PSPTLPXLPTOPXO. F. Bit location flag function. IP.OPXO interrupt priority bit for external interrupt O. Priority is assigned when bit is 1. IP.LPTO interrupt priority bit for timer interrupt O. Priority is assigned when bit is 1. IP.2PXL interrupt priority bit for external interrupt 1. I priority is assigned when bit is 1. IP.3PTL interrupt priority bit for timer interrupt 1. Priority is assigned when bit is 1. IP.4PS interrupt priority bit for serial port. Priority is assigned when bit is 1. IP.5PT2 interrupt priority bit for timer interrupt 2. Priority is assigned when bit is 1. IP.6 reserved bit. The output data is 1 if the bit is read. IP.7 PCT priority interrupt circuit control bit. The priority register contents are valid and priority assigned. Interrupts can be processed when this bit is 0. When the bit is 1, the priority interrupt circuit is stopped, and interrupts can only be controlled by the interrupt enable register, i.e. 346 MSM80C 154/83C 154. Program status word register, PSW. Name address. MSB. I. LSB. __n, _ plus or minus IC 543210. PSWODOHFORS1 RSOOVF1P. Bit location flag function. PSW.OP accumulator, ACC, parity indicator. 1 when the 1-bit number in the accumulator is an odd number, and 0 when an even number. PSW.1F1 user flag which may be set to 0 or 1 as desired by the user. PSW.2OV overflow flag which is set if the carry C6 from bit 6 of the ALU or psi is 1 as a result of an arithmetic operation. The flag is also set to 1 if the resultant product of executing a multiplication instruction, multipl, is greater than OFFH, but is reset to 0. If the product is less than or equal to OFFH. PSW.3 RSO RAM register bank switch. --. RS1 RSO bank RAM address. 0000 07H. PSW.4 RS101108 HOFH. 10210H, 17H. 11318H1FH. PSW.5 FO user flag which may be set to 0 or 1 as desired by the user. PSW.6 AC auxiliary carry flag. This flag is set to 1 if a carry C3 is generated from bit 3 of the ALU as a result of executing an arithmetic operation instruction. In all other cases, the flag is reset to 0. PSW.7 psi main carry flag. This flag is set to 1 if a carry C7 is generated from bit 7 of the ALU as result of executing an arithmetic operation instruction. If a carry C7 is not generated, the flag is reset to 0. 347. MSM80C 154/83C 154 -- IO control register, LOCON. Name address. MSB3M. I. LSB. 7. 6BL. 40. Icon of 8 HWDTT32 SER IZC ALF P3 Hz P2 HP Hz. Bit location flag function. Icon.O ALF if CPU power down mode, PO, HPD, is activated with this bit set to. The outputs from ports 0, 2, and 3 are switched to floating status. When this bit is 0, ports 0, 2, and 3 are in output mode. Icon. P Hertz port becomes a high impedance input port when this bit is. Icon .2 P2 Hertz port 2 becomes a high impedance input port when this bit is. Icon .3 P3 Hertz port 3 becomes a high impedance input port when this bit is. Icon .4 IZC the OCOM pull-up resistance for ports 2 and 3 is switched off. When this bit is, leaving only the 00 COM pull-up resistance. Icon .5 SER serial port reception error flag. This flag is set to if an overrun or framing error is generated when data is received at a serial port. The flag is reset by software. Icon .6 T32 timer/counters 0 and are connected serially to form a 32-bit timer/counter when this bit is set to. TF of TCON is set if a carry is generated in the 32-bit timer/counter. Icon.7 WDT watchdog timer mode is set when this bit is set to, and if TF is set to after watchdog timer mode has been set, the CPU is reset and the program is executed from address 348 MSM80C154/83C154. Timer 2 control register, T2 con. Name address MSB == T == 2 C O N == 0 C8H plus dash underscore T underscore J underscore ELCLK3 LSB O EXEN2CP/RL2 bit location flag function. T2 con.0 CP/RL2 capture mode is set when TCLK plus RCLK = 0 and CP/RL2 = 1. I16-bit auto reload mode is set when TCLK plus RCLK = 0 and CP/RL2 = 0. Underscore 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 plus underscore dash equals underscore underscore C/RL2 is ignored when TCL underscore K underscore plus underscore R underscore C underscore L underscore K underscore equals underscore underscore 1 underscore underscore dot underscore 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 T2 con.1 C/T2 timer/counter 2 count clock designation control bit. The internal clocks XTALL2712, XTALL272, are used when this bit is 0, and the external clock applied to the T2 pin is passed to timer/counter 2 when the bit is 1. T2 con.2 TR2 timer/counter 2 counting start and stop control bit. Timer/counter 2 commences counting when this bit is 1 and stops counting when 0. T2 con.3 EXEN2 T2X timer/counter 2 external control signal control bit. Input of the T2X signal is disabled when this bit is 0, and enabled when 1. T2 con.4 TCLK serial port transmit circuit drive clock control bit. Timer/counter 2 is switched to baud rate generator mode when this bit is 1, and the timer/counter 2 carry signal becomes the serial T2CI, HC port transmit clock. Note, however, that the serial ports can only use the timer/counter 2 carry signal in serial port modes 1 and 3. Serial port receive circuit drive clock control bit. Timer/counter 2 is switched to baud rate generator mode when this bit is 1, and the timer/counter 2 carry signal becomes the serial port receive clock. Note, however, that the serial ports can only use the timer/counter 2 carry signal in serial port modes 1 and 3. --R T2 con.6 EXF2 timer/counter 2 external flag. This bit is set to 1 when the T2X timer/counter 2 external control signal level is changed from 1 to 0 while EXEN2 = 1. This flag serves as the timer interrupt to request signal. If an interrupt is generated, EXF2 must be reset to 0 by software. 1 T2 con.7 TF2 timer/counter 2 carry flag. This bit is set to 1 by a carry signal when timer/counter 2 is in 16-bit auto reload mode or in capture mode. This flag serves as the timer interrupt to request signal. If an interrupt is generated, TF2 must be reset to 0 by software. 349. D. MSM80C154/83C154-. List of instructions. List of instruction symbols. A. AB. AC. B, C, DPTR, PC, RR, SP, N, OR, XOR, plus, X, I, X, X, hashtag, @ asterisk, code address, data, accumulator, register pair, auxiliary carry flag, arithmetic operation register, carry flag, data pointer, program counter, register indicator, R equals 0 to 7, stack pointer, logical product, logical sum, exclusive OR, addition, subtraction, multiplication, division, denotes the contents of X, denotes the contents of address determined by the contents of X, denotes the immediate data, denotes the indirect address, equality, non-equality, substitution, substitution, negation, smaller than, larger than, RAM and the special function register bit specifier address, BO, B7, absolute address, AO, A5, immediate data, 10 to 17, relative offset, relative jump address offset value, AO, R7, direct address, RAM and the special function register byte specifier address, AO, A7, 350. Dash. MSM80C 154/83C 154. MSM80C 154/MSM83C 154 Instruction Table 0123456 0 AJMP 3 0 NOP address 11 LJMP RRA Inc. Inc. Inc at RO Inc at RL 0000 page 0 address 16 direct ACAL 1 JBC bit address.ll lcall RRCA DEC DEC at RO DEC at RL 0001 REI address 16 direct page 0 AJMP 2 JB bit address 11 RETRLA ADA ADA 0010 REI page 1 hashtag data direct at RO at RL ACAL 3 JNB bit address 11 RETIRLCA ADDCA ADCA ADDCA ADDCA 0011 REI page 1 hashtag data direct at RO at RL AJMP ORL212 ORLA 4 JC bit address 11 ORL direct Orla 0100 REI page 2 direct A hashtag data direct at RO at RL ACAL ANL, 5 JNC REI address 11 ANL direct ANLA 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 0101 page 2 direct A hashtag data direct at RO at RL 6 AJMP XRL XRL XRLA 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 JZREI address 11 direct 0110 Page 3. Direct, A. Hashtag data. Hashtag data direct at ro at rl. .lc, mov7 acal jmp mova, mov at ro, mov at rl. 0111. JNZ REI address 11. Bit at a plus dptr hashtag data. Direct. Hashtag data. Page 3. Hashtag data. 2. AJMP. MOV. 8. SJMP REI address 11. ANLC, MOVKIA. DIVOB direct 1, direct. 1000 bit at a plus PC. Page 4. Direct 2 at ro at rl. 9. MOV acal. MOV bit, MOVKIA, SUBBA. DPTR address 11. 1001. Hashtag data 16. Page 4. C at a plus dptr hashtag data direct at ro at rl. AJMP. A. Oralc bit address 11. MOVC Incorporated. MOLAB. MOV at ro, MOV at rl. 1010 bit dptr direct. Page 5. 3. ACAL. CJNEA at ro CJNE at rl. B. ANLC bit address 11 CPL bit CPL C# data, direct, hashtag data. 1011. Page 5. REI. C push. AJMP. XCHA. Address 11 CLR bit CLRC swap A. 1100 direct. Page 6. Direct at ro at rl. Dpop. ACAL DJNZ. XCHDA. 1101 direct. Address 11 SETB bit SETB CDAA direct. At ro at rl. Page 6, REI. F. EMOVXA. AJMP. MOVXA, MOVA. Address 11 CLRA. 1110 at DPTR. Page 7. At RO, ILRL direct at RO at RL. FMOVX. ACAL. MOVX. Address 11 CPLA. 1111 at DPTRA. Page 7. COLRO, A, ARL, a direct, A at ROA at RLA. 2 byte 3 byte. Mnemonic. 2 cycle 4 cycle. 351. MSM80C 154/83C 154 89 ABCDEF 1000 1001 1010 1011 1100 1101 1110 1111 0 Inc RO Inc R1 Inc R2 Inc R3 Inc R4 Inc R5 Inc R6 Inc R7 0000 1 Dec RO Dec R1 Dec R2 Dec R3 Dec R4 Dec R5 Dec R6 Dec R7 0001 2 ADA ADA 0010 RO R1 R2 R3 R4 R5 R6 R7 3 ADDCA ADCA ADDCA ADCA ADDCA ADDCA 0011 RO R1 R2 R3 R4 R5 R6 R7 4 Orla Orla, 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 Orla. 0100 RO R1 R2 R3 R4 R5 R6 R7. 5 ANLA, 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 ANLA. 0101 RO R1 R2 R3 R4 R5 R6 R7. 6 XRLA, 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 IXRLA, XRLA, XRLA. 0110 RO R1 R2 R3 R4 IR5 R6 R7. III. 7 MOVRO, MOVR1, MOVR2, MOVR3, MOVR4, MOVR5, MOVR6, MOVR7. 0111 hashtag data 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 hashtag data. 8 MOV MOV MOV. I MOV 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 MOV. 1000 direct, 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 I direct, direct. RO R1 R2 III. R3 R4 III. R5 R6 R7. 9 SUBBA, 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 ISUBBA, SUBBA, SUBBA. 1001 RO R1 R2 R3 R4. IR5 R6 R7. 2I. MOV R4. R. MOV R5, A MOV RO, MOV R1, MOV R2, MOV R3, MOV R6, MOV R7. 1010 direct 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 direct. Direct III. Direct direct. III. III. B. CJNERO, CJNER1, CJNER2, CJNER3, CJNER41, CJNER5, CJNER6, CJNER7. 1011 hashtag data, hashtag data, hashtag data, hashtag data, hashtag data, I hashtag data, hashtag data, hashtag data. III REI 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 III. REI 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 REI. I. CXCHA, XCHA, XCHA, XCHA. I. XCHA, 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 XCHA. 1100 RO R1 R2 R3 R4 R5 R6 R7. DDJNZ RO DJNZ R1 DJNZ R2, JNZ R3. I. DJNZ R4, DJNE R5, DJNE R6, DJNE R7. 1101 REI 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 REI. III. EMOVA, MOVA, 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 MOV. A. MOVA, MOVA, MOVA. 1110 RO R1 R2 R3 R4 R5 R6 R7. FMOV RO, MOV R1, MOV R2, MOV R3, MOV R4, MOV R5, MOV R6, MOV R7. 1111 AAAAAAAA. 352. Dash. MSM80C 154/83C 154. Instruction set details. I. Instruction code. C. Mnemonic byte cycles descriptio n. ID 7DOS0_030, 0, do. Add A, RR00101R, R, R011, AC, OV, C, A, plus, RR. Add A, direct 0010010121, AC, OV, C, A, plus, plus, direct. A7A as A underscore A3A, AO address. Add A at RR00100011RO11, AC, OV, C, A, plus, RR. Add A, hashtag data 001000100021, AC, OV, C, A, plus hashtag data. 17I. Is I underscore I, 10. ADDCA, RR00111R, RO11, AC, OV, C, A, plus, C, plus, RR. ADDCA, direct 0011010121, AC, OV, C, A, plus, C, plus, direct. A7A as A underscore A2A, AO address. ADDCA at RR00110. 11RO11, AC, OV, C, A, plus, C, plus, RRL. C. 0 ADDCA, hashtag data 0011010021, AC, OV, C, A, plus, C, plus hashtag data. B. HI. Is I underscore I, 10. T. SUBBA, RR10011111, AC, OV, C, A, plus, dash, C, plus, RR, C, R, RO. C. .QSUBBA, direct 10010101121, AC, OV, C, A, plus, dash, C, plus, direct. A7A as AO address, 3. C. 0 SUBBA at RR10010111RO11, AC, OV, C, A, plus, dash, C, plus, RR. U, colon. SUBBA, hashtag data 10010100021, AC, OV, C, A, plus, dash, C, plus hashtag data, E. 17I 15I. I, 10. Underscore. div of 10000100014, A, quotient, plus. A, slash, B. B, remainder. Da A110100100011 when the contents of accumulator bits 0 through 3 are greater than 9, or when auxiliary carry, AC, is 1,6 is added to bits 0 through 3. Bits 4 through 7 are then X amined, and when bits 4 through 7 follow, in compensation of lower bits 0 through 3 is greater than 9, or when carry, C, is 1, 6 is added to bits 4 through 7. As a result, the carry flag can be set, but cannot be cleared. CLRA 111000100011, A, plus dash 0. C, CPLA 1111. G. 010011, A, plus tat. RLA 0010001111 accumulator. C.C, CI plus I plus I plus I plus I plus I plus I. 1. 00. C. OU. 2. J. T. Colon C, E. Colon. RLCA 0011001111 accumulator. UEI equals. Plus dash 1 plus dash 1 plus dash 1. Plus IJU. 353. EMSM80C154/83C154E. Instruction set details, cont. I instruction code A. Mnemonic byte cycles description. ID, DDSDD underscore D, D, do. RRA0000001111 accumulator. C at JC, 1-1-1-1-1-1-1I. 0. OJ. 8.Q. 0 degrees RRCA 0001001111 accumulator. L. OJ. Dash 1. E. 1-1 II 1-1-1, LC, E. L. U. U. AO, underscore. In K0000010011, A, plus L. Inc RR00001R, R, RO11, RRL plus L. Inc direct 0000010121, direct address, plus L. A as AA underscore A. C. E inc at RR0000. F. 011 RO11, RRL, plus L. Inc DPTR 1010001112, DPTR, plus L. C. Dec A0001010011, A, plus L. E. Dec RR00011111, RRL plus RRLL, ROU. C. Dec direct 0001010121, direct address, plus direct address, L. A as AA underscore A. Dec at RR00010111 RO11, RL, plus RRL, L. ANLA, RR01011R, R11, A, plus A, N, RRL. ANLA, direct 0101010121, A, plus A, N, direct address. A as AA underscore A, AO. ANLA at RR0101011 RO11, A, plus A, N, RRL. ANLA, hashtag data 0101010021, A, plus A, and hashtag data C. 0 I is I 10. E. 2 ANL direct, A0101001021, direct address. 1. Equals. A as AA underscore A, AON, A. C. 0 ANL direct, 0101001132, direct address, plus, direct address. E hashtag data A as AA underscore A. And hashtag data. I is I underscore I, 10A. 0. 3. U. ORLA, RR01001R, RO11, A. 0. 0 ORLA, direct 0100010121, A, plus, A, or, direct address. J. A as AA underscore A, AO. ORLA at RR0100011 RO11, A, plus, A, or, RRL. ORLA, hashtag data 0100010021, A, plus, A, or hashtag data. I underscore I. 354. dash MSM80C154/83C154. Instruction set details, cont. 1. I instruction code A. Mnemonic byte cycles description. TO, DDSDD, D2D, do. ORL direct, A0100001021, direct address. A7A as AA, A, AO, A. ORL direct, 0100001132, direct address. Hashtag data A7A as A underscore A, AO hashtag data. On 17I. Is I underscore I, 10. C. G. XRLARR0110U. 2. 1R, R011, A. 1, XRLA, direct 0110010121, A. C. CA7A as A underscore A, AO. 0, colon. XRLA at RR01100111R011, A. 1, A. XRLA, hashtag data 0110010021, A. 317I. Is I underscore I, 10. OJ. 2, direct address. J. A as A underscore A, AOX or, A. XRL direct, 0110001132, direct address. Hashtag data A7A as A underscore A, AO hashtag data. I15I underscore I, 10. On MOVA, hashtag data 0111010021, A. C. 17I. Is I underscore I, 10 colon. U. 2 MOVRR, hashtag data 01111R, R021, RR. 1, 17I. Is I underscore I, 10. OJMOV direct, 0111010132, direct address. Pound, hashtag data A7A as A underscore A, A2A, AO. 317I. Is I underscore I, 12I, 10. 19. OJMOV at RR, hashtag data 01110111R021, RR. TJ. 1, 17I. Is I underscore I, 10. Al MOV DPTR, 10010000032, DPTR. E hashtag data 16I, 1 underscore 113 3I 1 foot 0 inches II. E17I. Is I underscore I, 12I, 10. CLRC 1100001111, C. Set C 1101001111, C. On. C. CPLC 1011001111, C. Colon. U. C. 1, B7BBSB underscore B, B2B, BO. C. ANLC.LBIT 1011000022, C. Colon. B7B6BSB underscore B, B, BOOJ. 1, A. ORLC, bit 0111001022, C. OJB7BBSB underscore B, B2B, BO. Colon. ORLC.LBIT 1010000022, C. B7B6BSB underscore B, B2B, BO. U. MOVC, bit 1010001021, C. B7B6BSB underscore B, B, BO. 355. MSM80C 154/83C 154-. Instruction set details, cont. Instruction code. 0 mnemonic bytes FV. C1ES description. D, DDS D4D, D2D, do. MOV bit C10010001022, bit address, plus, C. B, BBSB4 B3 B2B, BO. SETB bit 1101001021, bit address, plus 1. I. B, BBSB4 B3 B2B, BO. GG. COCLA bit 1100001021, bit address, plus 0. TT. 0:1B, BBSB4 B3 B2B, BO. CPL bit 1011001021, bit address, plus, bit address, 11. B, BBSB4 B3 B2B, BO. MOVAAR11101R2R, R011, A, plus, AR. MOVA, direct 1110010121, A, plus, direct address. A as a 4 a 3 a 2 a, AO. MOVA at AR11100111 R011, A, plus, AR. MOVA RA11111 R2R, R011, AR, plus, A. I. Point 2. MOVAR, direct 10100122, AR, plus, direct address, TJR2R, RO. 2A, A as a 4 a 3 a 2A, AO. 2. Equals MOV direct, A1111010121, direct address, plus, A. A as a 4A a 2A, AO. T. I. Direct address, plus, AR, co-MOV direct, RR10001R2R, R022. A 4 a 3 a 2A, AO. Co. MOV direct, 100011 R022, direct address, plus, RRL. At RRA, A as a 4 a 3 a 2A, AO. MOV at RRA11111011 R011, AR, plus, A. MOV at AR, 10100011 R022, AR, plus, direct address. Direct A 4A a 2A, AO. MOVKIA, 1001001112, A, plus, DPTR, 01. U.2 at A plus DPTA. TJ. T, 2 MOVCA at A plus PC 1000001112, PC, plus, 1. 8. A, plus, PC. Go. XCHA, RR110001 R2R, R011, A, sent, AR. A. I. XCHA, direct 11000021, A, sent, direct address, 011. Point 1 U. A 4 a 3 a 2A, AOSU. 2. Lilt, XCHA at AR110011 R011, A, sent, RRL. I, co_. A. AO, 3, sent, ARO -. XCHDA at AR11010111 R011. 356. Dash. MSM80C 154/83C 154. Instruction set details, cont. CDI instruction code. 0 mnemonic byte cycles description. I0, DOSD03020, do. Push direct 1100000022, SP, plus, SP, plus L. A as A3AA, AO, SP, plus, direct address. Pop direct 1101000022, direct address, plus, SP. A as A3A2A, AO, SP, plus, SP, L. ACAL address 11 AOA. A1000122, PC, plus, PC, plus 2. AA.ASA.A3A2AAO, SP, plus, SP, plus L. UI, SP, plus, PCO dash comma, E. SP, plus, SP, plus L. 0. SP, plus, PC. Minus 15. PCO, O, plus A dash comma. Locale address 16,000,100,1032, PC, plus, PC, plus 3. CDISI.A13A.AIIAIOA. A. SP, plus, SP, plus LE. A. As AA3A2A, AO, SP, plus, PCO dash comma. E, SP, plus, SP, plus L. Point 0, SP, plus, PC. IS. U, PC. IS, plus AIS. RET 0010001012, PCIS, plus, SP. SP, plus, SP, L. PC dash comma, plus, SP. SP, plus, SP, L. RETI 0011001012, PCIS, plus, SP. SP, plus, SP, L. PCO dash comma, plus, SP. SP, plus, SP, L. AJMP address 11 AOA. A00000122, PC, plus, PC, plus 2. UIE, AA.ASA.A3A.A, AO, PC. Dash 0, plus A. Dash comma. 0. LJMP address 16,000,000,1032, PC. IS, plus AISU. ISI.A13AI2AIIA.AA. A. As AA3A2A, A. 0 SJMP REI1000000022, PC, plus, PC, plus 2. E. R, RRs RR3 RR, R. PC, plus, PC, plus relative offset. JMP at A plus DPTR 0111001112, PC, plus, A, plus, DPTR. CJNEA, direct, 1011010132, PC, plus, PC, plus 3. REIA, A as AA3AA, AO if, A, asterisk, direct address. RR.RSR.R3R.R, R then. PC, plus, PC, plus relative offset. If, A. UI then A. 8, C, plus 1. U else. 2, C, plus 0. T. Underscore. Dot R. CJNEA, hashtag data, 1011001032, PC, plus, PC, plus 3. UREII, I. Is I1312I, 10 if, A, asterisk hashtag data E. R, RRs RR3RR, row then. 11, PC, plus, PC, plus relative offset. If, then C, plus dash 1, else C, plus 0. 357. MSM80 C154/83 C154. Instruction set details, cant. 8i instruction code. Mnemonic bytes. Cycle description. D7DD, DD, D2D, do. CJNERR, hashtag data, 10111RZRLRO32, PC. REI17I. Is I. 12210 if, RR, asterisk hashtag data. R7R.RSR.RRZRRO then. PC. If, RR. Then. C. Else. C. CJNE at RR, 1011011RO32, PC. Hashtag data, REI17I. Is I. 10 if, RR, asterisk hashtag data. R7R.RR.RRRRO then. PC. If, RR. Then. C. Else. C. DJNZRR, REI11011R2FLRO22, PC. R7RRs RR3R, R, row, RR. C, if, RR, asterisk 0.g. Then. PC. 1. DJNZ direct, REI110101032, PC. R7RRs RR3R, R, row if, direct address. Asterisk 0C. Then writing. PC. JZREI0110000022, PC. R7RRs RR3R, R, row if, A, equals 0. Then. PC. JNZREI0111000022, PC. R7RRs RR, R, R, row if, A, asterisk 0. Then. PC. JCREI0100000022, PC. R7RRs RR3RZR, row if, C, equals 1. Then. PC. JNCREI0101000022, PC. R7RRs RR3RZR, row if, C, equals 0. Then. PC. JB bit, REI0010000032, PC. B7BBSBB, BZB, BOIF, bit address, equals 1. R7RRs RR3RZR, row then. PC. JNB bit, REI0011000032, PC. B7BBSBB3BZB, BOIF, bit address, equals 0. R7RRs RR3RZR, row then. PC. 358. Dash. MSM80 C154/83 C154. Instruction set details, cant. Q, I instruction code A. Mnemonic byte cycle description. FD7DDSDDD, D, do. C. JBC bit, REI0001000032, PC. And 0. 0B7BBSBBB, B, BOIF, bit address, equals 1. C, U. R7RRs RRR, R, row then. Bit address. All. C, PC. MOVXA at RR11100001RO12, A. RO. F. XMOVX at DPTRA1111. W. 0000012, DPTP. C. NOP 00000000011, PC. Q, : and U. O. L. 359. MSM80C 154/83C 154-. Electrical characteristics. Absolute maximum ratings. Parameter. Supply voltage. Input voltage. Storage temperature. Operational range. MSM80C 154/83C 154. MSM80C 154-1/83C 154-1. Parameter. Supply voltage. Memory hold voltage. Ambient temperature. Symbol conditions. VTA equals 25 degrees C. 6 Ta equals 25 degrees C. TSTG. DC to 12 MHz, VCC equals plus or minus 20%. DC to 16 MHz VCC equals plus or minus 10%. Symbol conditions. V*1 FOSC equals DC 16 MHz. V. Ta. *1, 2.5 V, V. Rating. -0.5 -7. -0.5, V plus 0.5. -55 to plus 150. Rating. 2.5 to 6. 2 to 6. -40 to plus 85. 16 MHz version of MSM83C 154, 12 MHz. DC characteristics. VCC equals 5V plus or minus 10%, Ta equals -40 to plus 85 degrees C. Parameter symbol conditions min. Tip. Max. Unit. Input low voltage VIL -0.5 0.2 VCC OLV. Input high voltage VIH except XTALL and 0.2 VCC plus 0.9 VCC plus 0.5 V. Reset. Input high voltage VIH IXTAL1 and reset 0.7 VCC VCC plus 0.5 V. Output low voltage vol IOL equals 1.6 Ma 0.45 V. Port 1, 2, 3. Output low voltage vol IOL equals 32 RNA 0.45 V. Port 0, AL, PSEN. Output high voltage VOH IOH equals -60 IJA 2.4 V. Port 1, 2, 3, VCC equals 5 V plus or minus 10%. IOH equals 30 IJA 0.75 VCCV. IOH equals -10 IJA 0.9 VCCV. Output high voltage VOH IOH equals -400 IJA 2.4 V. Port 0, AL, PSEN, VCC equals 5 V plus or minus 10%. IOH equals -150 IJA 0.75 VCCV. IOH equals -401 JA 0.9 VCCV. Logical 0 input current IL6 equals 0.45 V -10 200 IJA. Port 1, 2, 3. Logical 1 to 0 transition ITL6 equals 2.0 V -500 IJA. Current, port 1, 2, 3. Input leakage current IL VSS. Port 0 floating, EA. Reset pull down resistor RRST 2040 125 KO. Pin capacitance CIATA equals 25 degrees Celsius, F equals 1 MHz. 5V, except XTAL1. 10 PF. Power down current IPD VCC equals 26V 150 IJA. 360. Unit. V. V. Degree C. Unit. V. V. Degree C. Mies. Uring. Circuit. 1. 2. 3. 2. 4. Dash. MSM80 C154/83 C154. Maximum power supply current. Normal operation ICC, MAL. V4 V5 V. Frequency. 0.5 MHz 1.62.2. 3.5 MHz 4.35.7. 8 MHz 8.311. 12 MHz 12.16. 6 V. 3. 7.5. 14. 20. Maximum power supply current. Idle mode ICC, MAL. V4 V5 V. Frequency. 0.5 MHz 0.6 0.9. 3.5 MHz 1.1 1.6. 8 MHz 1.8 2.7. 12 MHz 2.5 3.7. Asterisk 1, 2.5 V, V. Maximum power supply current. Normal operation ICC, MAL. Vs 4.5 V5 V5.5 V. Frequency. 1.2 MHz 2.0 2.3 2.6. 8 MHz 10 11 12.5. 12 MHz 14 16 18. 16 MHz 18 20 23. Asterisk 2, MSM80 C154-1/MSM83 C154-1. Measuring circuits. M. O. Z. VIHM. 0. VIL. Node 1. 2. 3. T. Equals. 0. Z. T. Equals. 0. Z. 3. VSS. Dash equals. T. Equals. 0. T. Equals. 0. 1 dash equals. Repeated for specified input pins. Repeated for specified output pins. Input logic for specified status. VIH. VIL. Maximum power supply current. Idle mode ICC, MAL. V. Frequency. 1.2 MHz. 8 MHz. 12 MHz. 16 MHz. M. O. 4.5 V. 1.4. 2.3. 3.0. 4.0. 2. 4. Vec. T. Equals. 0. Z. VSS. 5V. 1.5. 2.7. 3.7. 5.0. T. Equals. 0. T. Equals. O. L. Equals. 0. T. Equals. 0. 6V. 1.2. 2.2. 3.7. 5. 5.5V. 1.6. 3.2. 5.0. 6.0. 361. MSM80 C154/83 C154-. External program memory access AC characteristics. VCC equals 5V plus or minus 20%, VSS equals OV, XTAL12 equals 12 MHz, Ta equals minus 40 degrees Celsius to 85 degrees Celsius. VCC equals 5V plus or minus 10%, VSS equals 0V, 12 MHz. Port 0, AL, and PSEN connected with 100 PF load, other connected with 80 PF load. Ratings. Parameter symbol 16 MHz clock. Variable clock from unit DC to 16 MHz. Min. Max. Min. Max. XTAL12 oscillator period TCL-CL 62.5 ns. AL pulse width TLHLL85 to TCL-CL 40 ns. Address valid to AL low TAVLL 18.51 TCL-CL 44 ns. Address hold after LTLLAX 27.51 TCL-CL 35 ns. Low. AL low to valid insta in TLLLV 154 TCL-CL 100 ns. AL low to PSEN low TLLPL 32.51 TCL-CL 30 ns. PSEN pulse with TPLPH 152.53 TCL-CL 35 ns. PSEN low to valid insta TPLIV 82.53 TCL-CL 105 ns. In. Input insta hold after TPXIX00 ns. PSEN. Input insta float after TPXIZ 42.51 TCL-CL 20 ns. PSEN. PSEN to address valid TPXAV 42.51 TCL-CL 20 ns. F. Address to valid insta in TOF 1V 207.55 TCL-CL 105 ns. Address flow to PSEN TAZPL 00 ns. Low. External program memory read cycle. AL. Ta v dot equals LLTLL, colon dot. PL plus dash underscore TPLPH. TLLLV. 362. Dash. MSM80C 154/83C 154. External program memory access AC characteristics. VCC equals 5V plus or minus 20%, VSS equals 0V, XTAL12 equals 12 MHz, Ta equals minus 40 degrees Celsius to 85 degrees Celsius. VCC equals 5V plus or minus 10%, VSS equals OV, 12 MHz. Port 0, AL, and PSEN connected with 100 PF load, other connected with 80 PF load. Ratings. Parameter symbol 16 MHz clock. Variable clock from unit DC to 16 MHz. Min. Max. Min. Max. XTAL12 oscillator period TCL-CL 62.5 ns. AL pulse width TLHLL85 to TCL-CL 40 ns. Address valid to AL low TAVLL 18.5 LTCL-CL 44 ns. Address hold after LTLLAX 27.5 LTCL-CL 35 ns. Low. RD pulse with TRLRH 275 6 TCL-CLL 00. WR pulse with TWLWH 275 6 TCL-CLL 00 ns. RD low to valid data in TRLDV 207.55 TCL-CLL 05 ns. Data hold after RDTRHDX 00 ns. Data float after RDTRHDZ55 to TCL-CL 70 ns. AL low to valid data in TLLDV 408 TCL-CLL 00 ns. Address to valid data in TAVDV 457.59 TCL-CLL 05 ns. AL low to RD or WRTLLWL 147.5 227.53 TCL-CL 43 TCL-CL plus 40 ns. Low. Address to RD or WR low TAVWL 184 TCL-CL 70 ns. Data valid to WRTQVWX22.5 LTCLCL40NS. Transition. Data valid to WR-HITQVWH332.57 TCLCLL05NS. Data hold after WRTWHQX75 TCLCL50NS. Address flow to RD low TAZRL00NS. RD or WR high to AL. High. TWHLH32.5 102.5 LTCLCL31 TCLCL plus 40 NS. 363. MSM80C154/83C154. External data memory read cycle. AL. Port OSTR. Port 2 PCH. External data memory write cycle. AL. TLLWL.J__TWLWH. TLLAX__________________________________________ I. TQVWH. Port OSTR data, ACC. As, A15 PCH P2.0, P2.7 data or as, A16 DPH as, A15 PCH. 364. Dash. MSM80 C154/83 C154. Serial port CI/O extension mode, AC characteristics. VCC equals 5V plus or minus 20%, VSS equals 0V, XTAL12 equals 12 MHz, Ta equals minus 40 degrees Celsius to 85 degrees Celsius. VCC equals 5V plus or minus 10%, VSS equals 0V, 12 MHz. Parameter symbol min. Max. Unit. Serial port clock cycle time TXLXL12 TCLCLNS. Output data set up to clock rising edge TOVXH10 TCLCL133NS. Output data hold after clock rising edge TXHOX2 TCLCL75NS. Input data hold after clock rising edge TXHDX0NS. Clock rising edge to input data valid TXHDV10 TCLCL133NS. Machine cycle. AL. JTXLXLJ. Shift clock. RTOVXH. RTXHOXI. Output OATA dash comma backslash colon 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 XX colon 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 XX equals dash equals dash equals dash equals dash equals dash XX equals 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 XX equals dash dash colon equals XX colon 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 XC equals 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 XC colon 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 7 slash dash dash. TXHDV1. RTXHDX. Input data ALALALALAL. 365. MSM80 C154/83 C154. AC characteristics measuring conditions. 1 input/output signal. 2 floating. Equals X. Dot comma dot dash dash. VOH. VOH VIH VVLLHLX test point. VIL. Vol. Asterisk the input signals in AC test mode are either VOH, logic 1. Or vol, logic 0, input signals where logic 1 corresponds to a CPU output signal waveform measuring point in excess of VIH and logic 0 to a point below VIL. VOHI. I backslash VIH. Dash comma VIL. Vol. Floating. Asterisk the port 0 floating interval is measured from the time the port 0 pin voltage drops below VIH after syncing to GND at 2.4 mA when switching to floating status from a 1 output, and from the time the port 0 pin voltage exceeds VIL after Connecting to a 400 IJA source when switching to floating. Status from a 0 output. XTAL1 external clock input waveform conditions. Parameter symbol min. Oscillator frequency L/TCLCLDC. High time TCHCX20. Low time TCLCX20. Rise time TCLCH. Fall time TCHCL. External clock drive waveform. 366. NC. XTAL2. External. Oscillator XTAL1. Signal. VSS. Max. 16. 20. 20. Units. Megahertz. NS. 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 OKI semiconductor. MSM85C154 VS. M83C154/M80C51F piggyback. General description. The MSM85C154 is a device whose built-in ROM is replaced by external EPROM using the piggyback method. External EPROM capacity is up to 16 KB. It can be used for evaluation of programs. For MSM83C154 and MSM80C51F. Installation method for external ROM. Pin 1 for 27128. M85C154. OKI. Asterisk the MSM85C154 VS pin layout of bottom side is the same as the pin layout for MSM83C154XXRS. 367. MSM85C154 VS. Asterisk note. MSMB5C154 VS piggyback is originally designed for the programming of MSMC154 and it covers the function as the piggyback for MSMBach 51F. Please be careful not to use additional function which dedicated to MSMB3C154 in using the piggyback for MSMBach 51. The function, flag, and resistor listed below are dedicated to MSMB3C154. Icon, OFBH. TH2, OCDH. TL2, OCCH. RCAP2H, OCBH. RCAP2L, OCAH. T2CON, OCBH. IP, OBBH. IE, OABH. PCON, OB7H. IO control resistor. Timer 2. Upper side resistor. Timer 2. Lower side resistor. Capture resistor. Upper side. Capture resistor. Lower side. Timer control resistor 2. Interrupt priority resistor 2. Bit 5, bit address BDH, PT2. Bit 7, bit address BFH, PCT. Interrupt enable resistor. Bit 5, bit address ADH, ET2. Power control resistor. Bit 5, bit address nil, RPD. Bit 6, bit address nil, HPD. In using this piggyback for MSMBach 51F, do not set the above items, control bit should not be 1. All bits are set to 0 at initial reset. In high temperature atmosphere, malfunction may happen, output latches of the port 0 are set when interrupt occurs, in writing the instruction code of which LSB is 0 at address 0 of the EPROM. To avoid this problem, please be sure to write a JMP instruction, operational code is X1, at address 0 instead of LJMP instruction, operational code is 02. Operating frequency is from DC to 12 MHz. The MSMB5C154 VS has been developed assuming that it is used for evaluation of program. Please use the MSM83C154 mask ROM version as the device is installed on a product. 368. Program Development. Support Systems. OKI's 40 Program Development Support System. For the OLMS40 Series 4-bit, 1-chip microcontroller. OKI's 40 Program Development Support System. The OKI's 40 Program Development Support System designed for use with the CMOS 4-bit 1-chip microcontroller OLMS40 series consists of the MPB400 evaluation board and the MPB400DS key and display board, plus a number of OKI's 40 microcontroller interface boards. These components can also be connected by multibus interface or serial I/O interface to the SO series of development tools or serial I/O terminal units for even more efficient program development. Since the MPB400 includes a multibus interface, it can be connected online to SO series development systems equipped with an existing multibus interface to enable direct use of the system console and 1/0 units. With an MPB401 connected to the MPB400, online connections are also possible to serial interface systems, such as the FSOO personal computer. A floppy disk-based assembler/debugger is available for use in online type systems. CP/M registered ISIS-2 base. Note: CP/M is the registered trademark of Digital Research Inc. USA. ISIS-2 and Multibus are registered trademarks of Intel Corp. USA. 371. 2. D. OKI's 40- System Configuration. 1 Serial Interface Types. And 1 EDOO OKI Personal Computer. Note: 1. Where AD series development systems other than the IF800 are used, the system must be capable of using CP/M. 2. The MPB401 is connected directly to the MPB400 via a socket. 2 Bus interface types. MP84000S, CN1 CN2, MPB400, Multibus equipped 80. Sanes development system. Intel, MDS system. DSCE system. Note: for bus interface types, an online/offline switch located on MPB400DS is set to online position. 372. Features. The serial interface type employs serial interface equipped development tools available on the market or personal computers, together with the MPB400 board and MPB401. Host computer requirements. 1 CP/M80 version 2.0 or 2.2 must be operable as the operating system. 2 The host computer memory capacity must be large enough to operate at least 52 KB of CP/M. 3 Interface must be RS-232C TTL or 20 RNA current loop. 4 The RS-232C serial port must be accessible when the CP/M system calls function number 6. Direct console 110, on condition that a logical device CON is assigned to a physical device TTY. OKI personal computers IF800 Model 20 and Model 30 are standard host computers which satisfy these requirements. Features. Bus interface types employ multibus equipped development tools available on the market, example: the MPB400 and MPB400DS. Use of an FDD unit, floppy disk drive, which the development system has as standard equipment, enables Disk-based editing, assembling, and debugging. When debugging especially, a disk-based debugger enables loading, executing and correcting of users' application programs from a development system console. Host computer requirements. 1 Intel 8080A microprocessor or equivalent processor is used as the CPU. 2 Intel multibus or equivalent bus system is used. 3 ISIS 2 or CP/M80 MISID be operable as the operating system. 400 is not used as the 8080A or equivalent microprocessor I/O address. IS40. 3 field debugging types. User's application. Circuit. MPB202. Features. Field debugging types are used for final field evaluation of application circuits and programs after program debugging with serial interface or bus interface types has been completed. The small and compact MPB202 board used for this purpose is equipped with a socket for program EPROMs. 4 OLMS40 series evaluation. Dedicated board. User S application. Circuit. MPB421, 4 OLMS421. Or MPB422, 4 OLMS422. MPB400. Or MPB202. Features. The dedicated boards indicated in the diagram are required for a program evaluation of the OLMS421 or OLMS422 microcontroller. 373. D. IS40- Assembler. ASM40 is a floppy disk-based high-performance assembler which operates under CP/M and ISIS 2. This assembler is used to translate source files generated on disk by using an editor, available on the market, thereby generating object files, Intel hex format, assembly list files and symbol files in the specified devices. Features. 1. Free descriptive format source files. 2. Enables description of up to 9 types arithmetic expressions in the source program. Operand field. 3. Symbol file generation capacity. 4. 6 types of pseudo instructions available. 5. A type setting pseudo instruction enables checking the limitation of basic instruction sets for each OLMS40 microcontroller. 374. List of pseudo instructions. Pseudo function instruction. EQU assignment of operand value to name. Org setting of program start address. And indication of end of program. Setting of 0 in the 4 lower order bits of the assembler location counter, and NSE. Addition of 16. The NOP instruction is assigned to blank areas where no machine language instruction has been assigned. Tip indication of the OLMS40 series type. IS40. Debugger. The IS40 debugger can be used for effective debugging in both serial interface and bus interface type systems. Features. Example of use of commands. 1. Simple input format for debugging commands entered from the console of the connected development tool, personal computer. Load hatest.hex. LEST, FJ, LESTJ. 00J. Define.startJAC. Remove.jobjn2. uram.o.o.o.2.o.lff. PC equals 789. 2. Efficient loading / saving and display / change of object codes. 3. Real-time execution and step execution. 4. Display/change of microcontroller contents. URAM.0.I00-48.0.049812.5. Use of assembler symbols permitted, only in bus interface types. Go.o.uram.a.from.0.123.0.tilap7a4.0 and 10. Go.o.tilap. Command name. Load. List. Define. Remove. Display. Change. ESET. Exit. Go. Step. At. Verify. Save. Step.o.from.0.500.0.count to 30. Verify OA sample 2.0 BJUROM 400 to 7FF. Save.ofljobl.002.0.80.0.1FF. Command input format. Load L:, H/OL:, path name L:, ext. List L:, path name /off. Define L:, symbol equals X pair. Remove L:, symbol. Symbol, /symbols. Keyword L:, address. Keyword equals data ref. Keyword L:, address equals data. Data. Reset. Exit. Go L:, URAM/UROM L:, from L:, address exp. L:, till : .pc equals I address exp L:, and nl : .asm. Go L:, URAM/UROM L:, from 6 address exp. L:, till : port exp equals data exp L:, .asm. Step L:, URAM/UROM 6 from 6 address exp. L:, .count L:, .nl, .asm. At. Verify L:, H/OL:, path name L:, ext L:, URAM/UROM address. Save L:, H/OL:, path name L:, URAM/UROM address. L:, space. May be omitted, I. / denoting or. 375. 3. EEs 40 EE dash 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 dash. Debugger command samples. DB400. DB400. OLMS40 series online debugger. Var 1. 3. Asterisk load A, sample. Hex. Asterisk IB. Initial buffer. FEDCB A98765432110. 0. 000000000000000000000 1 00000000000000000 2 00000000000000000 3 00000000000000000 4 0000000000000000000 5 0.000000000000000000000 6 0.00000000000000000 7 0.00000000000000000 RW equals ORX equals ORE equals ORZ equals OXCH equals OA equals O. ACC equals OSI equals ODPH equals O. DPL equals OPP equals O. PF equals OPG equals O. Asterisk go URAM from 7 al till PC equals 7 CFN 2. Mode, IB to FBY/N/E. Y. PC equals 07 CF74 PA equals FPB equals FPD equals CPE equals 5 PF equals OPG equals OPK equals BPI equals A. PC equals 07 CF74 PA equals FPB equals FPD equals OPE equals 5 PF equals OPG equals OPK equals BPI equals A. Asterisk go from 7 al till PF equals 9. Mode, IB to FBY/N/E. N. Mode equals non to FB. 2 PC equals 07 CF74. PA equals FPB equals FPD equals FPE equals FPF equals 9 PG equals OPK equals BPI equals A. Asterisk FB. Final buffer. FEDCBA 98765432110. 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 1 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 2 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 3 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 4 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 5 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 6 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 7 0 f asterisk asterisk 9 times 10 to the power of 4th f 0 0 0 0 0 0 0 0 RW equals FRX equals 4 RE equals ERZ equals 9XCH equals asterisk A equals star. ACC equals 9 psi equals LDPH equals 2 DPL equals OPP equals star. PA equals FPB equals FPD equals FPE equals FPF equals 9 PG equals O. PK equals BPH equals 2 CIN equals O int equals L. Asterisk step from 7 al count 6. PC equals 07 al 3700 PA equals FPB equals FPD equals CPE equals OPF equals 9 PG equals OPK equals BPI equals A. PC equals 0700 ACPA equals FPB equals FPD equals CPE equals OPF equals 9 PG equals OPK equals BPI equals A. PC equals 0702 ADPA equals FPB equals FPD equals CPE equals OPF equals 9 PG equals OPK equals BPI equals A. PC equals 070465 PA equals FPB equals FPD equals CPE equals OPF equals 9 PG equals OPK equals BPI equals A. PC equals 070526 PA equals FPB equals FPD equals CPE equals OPF equals 9 PG equals OPK equals BPI equals A. PC equals 070637 A3 PA equals FPB equals FPD equals CPE equals OPF equals 9 PG equals OPK equals BPI equals A. Asterisk exit. 376. Dash. Ease 40. Selection of microcontroller and evaluation board/software. Microcontroller Dedicated Board Evaluation Board. OLMS40. OLMS42. MS47. Dedicated Hardware. Simulator. Serial Interface Type. R-M, P, B4, 01W.J-. Evaluation Microcontrollers. OLMS40 MSM5840 MPB400 Board Accessories. OLMS42 MSM5840 MPB400 Board Accessories. OLMS421 MSM5840 MPB421 Board Accessories. OLMS422 MSM5840 MPB422 Board Accessories. Software. Serial Interface Type FD40 SCP/M. Assembler/ Serial, Debugger CP/M Single Side Single Density 8-inch. 2. Serial, Monitor Software EPROMs. FD40B ISIS. Assembler/ Bus, Debugger ISIS 2 Single-Sided Single Density 8-inch. 2. Bus, Monitor Software EPROMSs. Bus Interface Type. PD40B CP/M. Assembler/ Bus, Debugger CP/M Single-Sided Single Density 8-inch. 2. Bus, Monitor Software EPROMs. 377. ES40- MPB400 Board. The MPB400 board is used for OLMS40 series. Microcontroller program generation and evaluation. With the MSM8085A used for control purposes. Several system configurations can be achieved in combination with other boards and software. Dimensions, 220 x 305 mm. MPB401 board. The MPB401 board, used together with the MPB400 board, consists of interface circuit with the development system and transfer speed converter unit. Dimensions, 105 x 205 mm. 80 x 115 mm. MPB202 board. The MPB202 board is equipped with an evaluation microcontroller and 4K bytes of program EPROM sockets. This miniature size board is used effectively in mounting evaluations when built into application equipment for final testing of debugged programs. Dimensions, 95 x 120 mm. 378. ES40. MPB421. The MPB421 board has been designed for OLMS421 microcontroller program evaluation, and is used connect to the MPB400. This board is equipped with LCD driver circuits and PLA EPROM sockets. Dimensions, 145 x 180 mm. 379. D. E6400 Program Development Support System. For the OLMS64 series CMOS 4-bit, 1-chip microcontroller. E6400 Program Development Support System. The E6400 Program Development Support System has been specifically designed for rapid and efficient program development of OKI's OLMS64 series of CMOS 4-bit, 1-chip microcontroller. Target chips, MSM6404, MSM6402, MSM6422, MSM6411, MSM6431, MSM6442, and MSM6408. Features: 1. In-circuit emulation when connected to an RS-232C interface equipped a host computer, or to an input/output device such as a CRT terminal and the ES8 option. 3. 6 types of break conditions, for interruption of emulation, including execution address and machine cycle counter. For EPROM writer, for 2732, 2732A, 2764, to enable programming, transfer, and verification of user program area contents. 5 user program debugging operations directed by debug commands entered from the keyboard of the connected input/output device. 6 program evaluation by use of dedicated evaluation chip, MSM6400E, thereby enabling 380. The same operations to be executed as when the MSM6404 chip is used. 7 built-in system diagnostic program. Host computer requirements. 1 operating system is one of the follows. 1. CP/M registered -80, ver 2.0 or later. Memory capacity of the host computer must be sufficient to run at least 52K CP/M. 2. MS-DOS registered, ver 2.11 or later. 3. PC-DOS registered, ver 2.11 or later. 2. At least one RS-232C communication port is implemented. 3. Data transfer is performed through RS-232C communication port using BDOS function. Call 6 on condition that console devices assigned to TTY-E6400. System configuration. The E6400 program development support. System consists of the E6400 emulator, a high-performance program emulator which includes the EASE host monitor, the E6400 evaluation, and the host computer, and the ASM6404 assembler. With the E6400 evaluation connected online to the host computer equipped with an RS-232C interface, the system covers all operations from assembly of the source program through program evaluation and debugging. Communication with host computer ICS used. Communication interface MSM82C51A. Driver/receiver SN75188N, SN75189N. Transmission format 110 to 9600 bps, switchable. 8 bits, 2 stop bits, non-parity. 7 bits, 2 stop bits, even parity. 7 bits, 2 stop bits, odd parity, switchable. EASE. ASM6400. E6400. Evaluation Kit 8. B. Note, CP/M is a registered trademark of Digital Research Inc. USA. EASE and ASM6404 for PC-DOS, MS-DOS are optional softwares. 381. E6400. ASM6400 assembler. The ASM6400 is a floppy disk-based high-performance assembler which operates on CP/M80, MS-DOS, or PC-DOS. This assembler is used to translate source files generated on disk by using an editor, available on the market, thereby generating object files, Intel hex format, assemble list files, and cross-reference list files in the specified devices. Features: 1. Free descriptive format source files. 2. Capacity to describe up to 10 types of operators in the source program operand column. 3. Ability to specify the number of characters per line and the number of lines per page in assembly list files. 4. Cross-reference list file generation capacity. 13 types of powerful pseudo instructions available. 6 object codes where internal page jump instructions and all page jump instructions are assigned. Automatically can be obtained by branch pseudo instructions. 7 control of assembly list file outputs by list or NLST pseudo instruction. 382. List of pseudo instructions. Pseudo function instruction. Tip specifies a type of target chip. EQU assignment of operand value to name. Set. Same as EQU pseudo instruction, but with redefinition capacity. Org setting of program start address. And indication of end of program. Automatic conversion to internal page or B all page jump instruction after checking. Branch destination. DB 8-bit data or ASCII character definition. DS. Reserves memory area for specified number of bytes. Setting of 0 in the 4 lower order bits of the assembler location counter, and NSE. Addition of 16. The NOP instruction is assigned to blank areas where no machine language instruction has been assigned. Date insertion of date in assemble list title. Page execution of assemble list page feed. TITL insertion of assemble list title. List designation of assemble list output. NLST inhibition of assemble list output. Dash 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 EAS E6400E E6400 emulator consisting of a host computer and the E6400 program evaluation kit. The E6400 emulator supports a wide range of development debugging operations efficiently and effectively. OLMS64 application programs can be debugged without user application circuits just as easily as completed systems. Features. 1 real-time tracing function does not affect execution time. The E6400 evaluation kit incorporates a real-time trace area for 2048 machine cycles. When the tracing for a particular user program area address has been set, the address, operation code, port, and probe status are traced. Each time the specified address is executed. 2 execution time measurement. The user program execution time can be measured by using the cycle counter on the E6400 evaluation kit. Max 16.777,215 cycles. This counter can also be used as a pass counter to indicate the number of times a specified address is executed. An emulation can be stopped after a specified address has been executed a specified number of times. 3 mass storage. With an 8192 bytes of static RAM area in the E6400 evaluation kit for use as a user program area, there is no problem with inadequate memory area during debugging. And, needless to say, user programs can be loaded/saved from the host computer. Furthermore, with an EPROM writer included on this board, the user program area contents can be written into EPROMs, and the EPROM contents can be read out. 4 EMPL break functions. The emulator can suspend, break, program execution by any of the following 6 break conditions. A. Breakpoint break. Break upon execution of specified address. Any address may be specified. B. External break. Break by application of external break signal. C. Halt/stop instruction break. Break by execution of halt or stop instruction. D. Trace buffer full break. Break when overflow of trace area occurs. E. Cycle counter overflow break. Break when overflow of cycle counter occurs. F. Probe match break. Break when probe data matches set data. 5. Extensive range of debugging commands. In addition to display/updating of all register, port, and RAM contents, the following commands enable all debugging operations to be executed efficiently. A. User program execution. I. Input format. STP number of instructions, start address. Input of this command results in the specified number of instructions in the user program being executed from the specified address, start address. Input format. G start address, break address, N. Input of this command results in the user program being executed from the specified address, start address. Emulation is subsequently stopped when the specified address, break address, is executed n times. Note, program execution is suspended temporarily each time the specified address is executed. I. Input format. G start address, break address RAM. Address N. Input of this command results in the user program being executed from the specified address, start IJ address. Emulation is subsequently stopped if the contents of the specified RAM address are N. When the specified address, break address, is executed. In this case, 2. Program execution is suspended temporarily whenever the specified address is executed. B. Use of floppy disks. Input format. LOD file name. Input of this command enables the specified file contents, user program, to be loaded into the E6400 evaluation kit code memory, which serves as the OLMS64 masked ROM area. Input format. Save file name start address, end address. Input of this command enables the contents of the specified range of code memory to be saved at the specified file name. Input format. Diagram 2. Input of this command enables execution of commands within the specified file. This execution can be suspended temporarily by using the pause command. 383. E6400. C. Instruction executed bit memory. The E6400 emulator includes an instruction executed bit memory which indicates which user program addresses have been executed. Program flow can be determined by examination of the contents of this memory. 6. Easy to remember command format. The EASE6400 emulator debugging commands consist of command mnemonics followed by parameters. Address or mnemonic. Command mnemonic configuration. A. First character denotes the function to be executed by the emulator. B. Second and following characters. 384. Name of function to be executed by the emulator, that is, MSM6400E evaluation chip or E6400 evaluation kit register. Memory, or port name, abbreviation. Example. *DDM01F.J. II \JIVI. Def. A. Denotes wait for command input from emulator. B. Denotes display of contents of specified object. C. data memory, equivalent MSM 6400E RAM area. Designation. D. Start address of contents to be displayed. E. End address of contents to be displayed. F. Carriage return denoting end of command input. Dash. E6400. E6400 emulator memory configuration. The E6400 emulator memory area which can be used by the user is outlined in the following diagram. The sections enclosed in boxes represent the register and memory areas which can be accessed from the host computer keyboard, and which can be displayed/updated by debugging command. CM. Code. Memory. 8192x8. OM. Data. Memory. Port 4. D. Probe. Compare. Register. BPTR. 8192 8192. XLXL. IE. 8192. XL. Cycle counter. Program. Counter. PC. Stack. Pointer. U. HL. Register O. Port 5. R equals J. Probe. Mask. So CE. 8192 8192. Accumulator. U. Carry. Flag. Register. C equals J. Port 1. I. PLI. 4. Port 6. U. Execution. Mode. Register. TM. Trace memory. Port 9. E. Porta. EJ. Port 2. I. P2I. 4. Port 7. D. Break. Control. Register. U. IB. Initial. Buffer. Port. R equals J. Port OI. IRQ. J. Port 3. IP3I. 4. Port 8. R equals J. Break. Status. Register. BS61. FB. Final. Buffer. XLXL 2048 X66 139 X8 210 X8. IL. Cycle counter enable bit memory. Sync output bit memory. Instruction executed bit memory. Trace enable bit memory. Breakpoint bit memory. Trace pointer. TP. BLK. Block. Memory. 8192XL. 385. E6400. Major memory operations. 1. Code memory. The code memory is an 8192 x 8-bit RAM area, which corresponds to the OLMS64 masked ROM area where user programs are stored. The MSM6404 ROM capacity is 4000 bytes. 2. Data memory. The data memory is a 256x4-bit RAM area corresponding to the MSM6400E RAM area. 3. Instruction executed bit memory. This memory is an 8192x1-bit RAM area which has addresses identical to the code memory. When a code memory program is executed, the bits corresponding to the executed addresses are set to 1. The program flow can thus be determined by checking the contents of this memory. 4. Breakpoint bit memory. The breakpoint bit memory is also an 8192 x 1 bit RAM area which has addresses identical to the code. Memory. If a particular bit in this memory is 1, program execution is suspended immediately after the code memory contents corresponding to that bit are executed. 5. Trace enable bit memory. The trace enable bit memory is another 8192 x 1 bit RAM area which has addresses identical to the code. Memory. If a particular bit in this memory is 1, port / register contents, etc., are stored in the trace memory when the code memory contents corresponding to that bit are executed. 386. 6. Sync output bit memory. The sync output bit memory is another 8192 x 1 bit RAM area which has addresses identical to the code memory. When the code memory contents are exec'd, the corresponding bits in the sync output memory are checked, and if a 1 bit is found, an output sync signal, active low, is passed to the probe terminal. 7. Cycle counter enable bit. The cycle counter enable bit memory is also another 8192 x 1 bit RAM area which has addresses identical to the code memory. When the code memory contents are executed, the corresponding bits in the cycle counter enable bit memory are checked. And if a 1 bit is found, the cycle counter is counted up in step with that machine cycle. 8. Probe comparison register / probe mask. The conditions for generating a break by input data from the probe match break, can be changed by altering these two settings. 9. Initial / final buffers. These two memories are 210 x 8-bit RAM areas used to store the initialized settings of the MSM6400E evaluation chip or the MSM6400E status immediately after a break when real-time emulation is executed. 10. Trace memory. The trace memory is a 2048 x 66-bit RAM area used to store trace data. The trace instruction is given by the trace enable bit. EE6400E. List of debugging commands. Load, save, and verify commands. load.dr, filename.j load programs into code memory. Save dr filename address, address.j save code memory program. ver.dr, smiley face, filename address, address.j verify file with code memory. EPROM commands. ppr address, address.j program code memory into EPROM. tpr address.j transfer EPROM into code memory. vpr address.j verify EPROM with code memory. Commands used to display / change internal status of IVA chip. PC. DPC display program counter. CPC address.j change program counter. SP. DSP.j display stack pointer. CSP data.j change stack pointer. AC. DAC.j display AOC. CAC data.j change ACC. Sci. DCY.j display carry flag. CCData.j change carry flag. HL. DHL.j display HL registers. CHLData.j change HL registers. FR. DFR.j display flag register. CFRData.j change flag register. PO-P8. DPN.j, n equals 0, 1, 2, 3, 8, display port n. CPN data.j, n equals 0, 1, 2, 3, 8, change port n. P9. DCMR.J display counter mode register, port 9. CCMRData.J change counter mode register. PA. DSMR.J display shift mode register, port A. CSMRData.J change shift mode register. PB. DCFR display control flag register, port B. Asterisk change CFR command is not permitted. PC. DEIF.J display enable interrupt flag, port C. CEIFData.J change enable interrupt flag. PO. DIRQ display interrupt request flag, port D. Asterisk change IRQ command is not permitted. MEL. DMEI.J display master enable interrupt flag. CMEI data.J change master enable interrupt flag. D.J display all internal status. Data and code memory display, change, and fill commands. DDM address, address.J display data memory. OMCOM address plus data. .J change data memory. FDM address, data.J fill data memory. DCM address.J display code memory. CMCCM address.J data. .J change code memory. FCF address, data.J fill code memory. 387. E6400-. Attribute memory display, enable, and reset commands. DBP address. Display breakpoint bits memory. BPEBP address. Enable breakpoint memory. RBP address. Reset breakpoint bits memory. DTR address. Display trace enable bits memory. TRETR address. Enable trace enable bits memory. RTR address ladres. Reset trace enable bits memory. IE. Die address. Display instruction executed bits memory. Readdress. Reset instruction executed bits memory. DCE address. Display cycle counter enable bits memory. CEECE address. Enable cycle counter enable BFTS memory. RCE address. Reset cycle counter enable bits memory. DSO address. Display sync out enable bits memory. SO address. Enable sync out enable bits memory. RSO address. Reset sync out enable bits memory. Trace memory display commands. TM. DTM display trace memory. DTL display trace list. Other hardware display and change commands. CC. DCC, display cycle counter. CCC number. Change cycle counter. DBC. Display break condition register. SBC plus or minus mnemonic. Set break condition register. Mnemonic means one of following keywords. BC here. BB. Break at breakpoint. XB. External break. CO. Cycle counter overflow. TF. Trace memory full. PM. Probe match. HS. HAL T/stop instruction executed. BSDBS, display break status register. PM. DPM. Display probe mask register. CPM data. Change probe mask register. CR. DCR, display probe compare register. CSER data. Change probe compare register. DEM display execution mode register. SEM mode rev. Change execution mode register. Mode ref means one of following keywords. Here. Miv. IBTOFB. In. IB to non. NN. Non to non. NF. Non to FB. FF. FBTOFB. DBL address, address dot. Display block memory. BLKSPB address, address dot. Set block memory into program block. SDB address ladress dot. Set block memory into data block. Bank 1 or 2 set attribute memory bank register. 388. Dash 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 EASE 6400E. Initial buffer and final buffer. DibJ display initial buffer. DFBJ display final buffer. CI keyword data. Change elements of initial buffer. Keyword AC, HL, FR, SMR, CMR, MEL. ELF, SCI, PN, N equals 0, 1, 3, 4, 8. IBCIOM address, data. J change initial buffer data memory. FBCF keyword data, change elements of final buffer. Keyword AC, HL, FR, SMR, CMR, MEL. ELF, SCI, PN, N equals 0, 1, 3, 4, 8. CFDM address data. Change final buffer data memory. FIDM address, data, fill initial buffer data memory. FFDM address, data, fill final buffer data memory. Assemble and disassemble commands. ASM address J mnemonic. Assemble to code memory. DASM address, disassemble to console. Emulation commands. G start address, break parameter, go, start real-time emulation. GD start address, break parameter, J go direct, start real-time emulation. Break parameter format is shown below. 1. Address. 2. Address, N. 3. Address, N, and address, M. 4. Add residential RAM, address, data. 1. STP number, address, start step execution. Other commands. At N equals 1, 2, 9, command, repeat. Help J display help file, E64, HLP. Exit to CP/M. Reset E6400 system. Reset J reset EVA, chip, MSM6400E. SIOH or F, set IO mode. Dev, CH2 port output control. ST mnemonic, family set. FDDDR, DRL, floppy disk unit set. DIRDR, display file directory. 389. O. E6502 Program Development Support System. For the MSM6502 CMOS 4-bit, 1-chip microcontroller. E6502 Program Development Support System. The E6502 Program Development Support System has been specifically designed for rapid and efficient program development of OKI's MSM6502 CMOS 4-bit, 1-chip microcontroller. Features. 1. Connecting the MPB6502 evaluation board to a host computer or to an I/O terminal such as a CRT terminal includes an RS-232C interface circuit. All debugging operations can be entered from the console keyboard. 2. Executes user programs with the trace in real time or in single-step mode. 3. Mass storage user program area, 4K bytes. 4. 6 types of break conditions, including execution address and machine cycle. Counter. 5. EPROM programmer, for 2716, 2732, 2732A, 2. Enable programming, transfer, and vary FING with user program area contents. 6. The same operation as the MSM6502. Because OKI designed the original evaluation chip, MSM6502E. 7. Built-in system diagnostic program. Host computer requirements. 1. Operating system is one of the follows. 1. CP/M registered -80, ver 2.0 or later. Memory capacity of the host computer must be sufficient to run at least 52K. CP/M. 2. MS-DOS registered, ver 2.11 or later. 3. PC-DOS registered, ver 2.11 or later. 2. At least one RS-232C communication port is implemented. 3. Data transfer is performed through RS-232C communication port using BDOS function. Call 6 on condition that console device is assigned to TTY. Communication with host computer. ICS used. Communication interface MSM82C51A. Driver/receiver SN75188N, SN75189N. Transmission format 390. 110 to 9600 bps, selectable. 8 bits, 2 stop bits, non-parity. 7 bits, 2 stop bits, even parity. 7 bits, 2 stop bits, odd parity, selectable. System configuration. The E6502 program development support. System consists of the E6502 emulator, a high-performance program emulator which includes the E65 host monitor, the MPB6502 evaluation board, and the host computer, and the ASM6502 assembler. With the MPB6502 evaluation board connected online to the host computer equipped with an RS-232C interface, the system covers all operations from assembly of the source program through to program evaluation and debugging. User's application circuit. MPB66Q2 evaluation board plus 5V plus 12V-12V 4.5A, 0.2A, 0.2A E65 ASM6502 FDD 8 II B. Note, CP1M is the registered trademark of Digital Research Inc. USA. E65 and ASM6502 for MS-DOS, PC-DOS are optional softwares. E6502 ASM6502 assembler. The ASM6502 is a floppy disk-based high-performance assembler. This assembler is used to translate source files generated on disk by using an editor, available on the market, thereby generating object files, Intel hex format, assembly list files, and cross-reference list files on the specified devices. Features: 1. Free descriptive format source files. 2. Capacity to describe up to 10 types of arithmetic in the source program operand field. 3. Ability to specify the number of characters per line and the number of lines per page in assembly list files. 4. Cross-reference list file generation capacity. 5. 13 types of powerful pseudo instructions available. 6. Object codes where all page jump instructions and inter-page jump instructions are assigned. Automatically can be obtained by branch pseudo instructions. 7. Control of assemble list file outputs by list or NLST pseudo instruction. List of pseudo instructions. Pseudo function instruction. EQU assign the operand value to the name. Set. Same as EQU pseudo instruction, but with redefinition capacity. Org define assembler location counter. End term INTE assembly. Automatic conversion to all page or B interpage jump instruction after check. ing branch destination. DB 8-bit data or ASCII character string. Definition. DS reserve n bytes area of uninitialized. Storage. Setting of 0 in the 4 lower order bits of the assembler location counter, and NSE. Addition of 16. The NOP instruction is assigned to blank areas where no machine language instruction has been assigned. Date insertion of date in assemble list title. Page execute page eject. TITL insert assemble list title. List turn on assemble list output. NLST turn off assemble list output. 391. 11. E6502- E6502 emulator. Consisting of a host computer and the MPB6502 program evaluation board, the EAS.E6502 emulator. Supports a wide range of development debugging Opera Ion FE, EAN.TLY. and Effectl.veli. MSM6502. Application programs can be debugged without user application circuits just as easily as completed. Systems. Features. 1. Real-time tracing function does not affect execution time. The MPB6502 evaluation board incorporates a real-time trace area for 2048 machine cycles. When tracking for a particular user program area address has been set, the port, HL register, and MEL flag status are traced each time the specified address is executed. 2. Execution time measurement. The user program execution time can be measured by using the cycle counter on the MPB6502 evaluation board. Max 16,777,215 cycles. This counter can also be used as a pass counter to indicate the number of times a specified address is executed. Emulation can be stopped after a specified address has been executed a specified number of times. 3. Mass storage user program area. With a 4096 byte static RAM area in the MPB6502 evaluation board for use as a user program area, there is no problem with inadequate memory area during debugging. And, needless to say, user programs can be loaded/saved from the host computer. Furthermore, with an EPROM programmer included on this board, the user program area contents can be written into EPROMs, and the EPROM contents can be read out. 4. EMPL break functions. The emulator can suspend, break, program execution by any of the following 6 break conditions. A. Breakpoint break. Break upon execution of specified address. Any address may be specified. B. External break. Break by application of external break signal. C. Halt instruction break. Break by execution of halt instruction. D. Trace buffer full break. Break when overflow of trace area occurs. E. Cycle counter overflow break. Break when overflow of cycle counter occurs. T. Probe match break. Break when probe data matches set data. 392. 5 extensive range of debugging commands. In addition to display/updating of all register, port, and RAM contents, the following commands enable all debugging operations to be executed efficiently. A. User program execution. Input format. STP number of instructions, start address. Input of this command results in the specified number of instructions in the user program being executed from the specified address, start address. And if the terminal to be used to display the contents has been specified by SDF command at this time, the display can be put into an easy-to-read format. Input format. G start address, break address, N. Input of this command results in the user program being executed from the specified address, start address. Emulation is subsequently stopped when the specified address, break address, is executed n times. Note, program execution is suspended temporarily each time the specified address is executed. Input format. G start address, break address RAM. Address N. Input of this command results in the user program being executed from the specified address, start address. Emulation is subsequently stopped if the contents of the specified RAM address are N. When the specified address, break address, is executed. In this case, 2, program execution is suspended temporarily whenever the specified address is executed. Underscore 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 on E6502. B. Use of floppy disks. Input format. LAD file name. Input of this command enables the specified file contents, user program, to be loaded into the MPB6502 evaluation board code memory, which serves as the MSM6502 masked ROM area. Input format. SAV file name start address, end address. Input of this command enables the contents of the specified range of code memory to be saved at the specified file name. Input format. Diagram file name. Input of this command enables execution of commands within the specified file automatically. This execution can be suspended temporarily by using the pause command. Input format. List file name. nlist. If the list command is entered, the emulator create the cp/m file and write into it the any characters which are output to the console till entering the nlst command. C. Instruction executed bit memory. The E6502 emulator includes an instruction executed bit memory which indicates which user program addresses have been executed. Program flow can be known by examination of the contents of this memory. 6. Easy to remember command format. The MPB6502 emulator debugging commands consist of command mnemonics followed by parameters. Address or mnemonic. Command mnemonic configuration. A. First character. Stand for the emulator function, display/update. B. Second and following characters. represent one of the MPB6502 evaluation board, or the MSM6502E evaluation chip element, regis, ter, memory, or port name. Example: *DDM 2\J ABC 0, 1F IBI DEF. A denotes wait for command input from emulator. B denotes display of contents of specified register / memory / board. C data memory, equivalent MSM6502 RAM area. Designation. D start address of contents to be displayed. E end address of contents to be displayed. F carriage return denoting end of command input. 393. D E6502, dash E6502 emulator memory configuration. The E6502 emulator memory area which can be used by the user is outlined in the following diagram. The sections enclosed in boxes represent the register and memory areas which can be accessed from the host computer keyboard, and which can be displayed / updated by debugging command. VM verify memory 4096x8 DM data memory 128x4 instruction executed bit memory trace enable bit memory breakpoint bit memory sync output bit memory CM code memory 4096x8 SG segment data memory 208x8 BTLSC pre-0E 4096x5 cycle counter enable bit memory TM trace memory 2048x66 trace pointer I TP111 cycle counter I CC241 program counter accumulator HL register stack pointer instruction data porto U carry EJ probe compare register E 394 IB initial buffer 139x8 E port 1 mel flag probe mask E port 2 E index register external probe E FB final buffer 139x8 EJ port 3 EJ break control register port 4 E emulation mode break status register BLK block memory 4096x1 U port 5 EJ E6502 major memory operations 1 code memory. The code memory is an 4096x8-bit RAM area, which corresponds to the MSM6502 masked ROM area where user programs are stored. The MSM6502 ROM capacity is 2000 bytes. 2 data memory. The data memory is a 128x4-bit RAM area corresponding to the MSM6502 masked RAM area. 3 verify memory. The verify memory is a RAM area with addresses identical to the code memory. When a user program is loaded into the code memory, identical contents are also set in this memory. Comparison of this memory with the code memory enables the operator to determine what sections of the user program have been changed after loading. For instruction executed bit memory. This memory is an 4096 x 1-bit RAM area which has addresses identical to the code memory. When a code memory program is executed, the bits corresponding to the executed addresses are set to 1. The program flow can thus be known by checking the contents of this memory. 5. Breakpoint bit memory. The breakpoint bit memory is also an 4096 x 1-bit RAM area which has addresses identical to the code memory. If a particular bit in this memory is 1, program execution is suspended immediately after the code memory contents corresponding to that bit are executed. 6. Trace enable bit memory. The trace enable bit memory is another 4096 x 1-bit RAM area which has addresses identical to the code memory. If a particular bit in this memory is 1, port, register contents, etc., are stored in the trace memory when the code memory contents corresponding to that bit are executed. 7. Sync output bit memory. The sync output bit memory is another 4096 x 1-bit RAM area which has addresses identical to the code memory. When the code memory contents are executed, the corresponding bits in the sync output memory are checked, and if a 1 bit is found, an output sync signal, active low, is passed to the probe terminal. 8. Cycle counter enable bit. The cycle counter enable bit memory is also another 4096 x 1-bit RAM area which has addresses identical to the code memory. When the code memory contents are executed, the corresponding bits in the cycle counter enable bit memory are checked, and if a 1 bit is found, the cycle counter is counted up in step with that machine cycle. 9. Probe comparl register / probe mask. The conditions for generating break by input data from the probe match break, can be changed by altering these two settings. 10. Segment data memory. The segment data memory is a 208 x 8-bit RAM area with coordinates 0 through 7 on the vertical axis and A through Z on the horizontal axis. This memory is used to display the status of each bit of the MSM6502 RAM. Liquid crystal display area at the specified coordinate and by the specified character. Displaying the status of this memory provides an image of the liquid crystal display status. 11. Initial final buffers. These two memories are 139 x 8-bit RAM areas used to store the initialized settings of the MSM6502E evaluation chip or the MSM6502E status immediately after a break when real-time emulation is executed. 12. Trace memory. The trace memory is a 2048 x 66-bit RAM area used to store traced data. The trace instruction is given by the trace enable bit 395 D E6502- debugging command table. Load, save, and verify commands. 1. Load dr, 1 file name load PR09 RAM into code memory. 2. Save dr, file name address save OKI memory program. 3. Ver dr file name address vanelty file with code memory. 4. LSG dr file name address load segment data. 5 SSGDR file name save segment data. 6 VCM address verify code memory with verify memory. EPROM commands. 1 PPR address program code memory into EPROM. 2 TPR address transfer EPROM into code memory. 3 VPR address verify EPROM with code memory. Display commands. 10 all register, flag, port. 2.dac ace register. 3.dhlhlr ister. 4.dcy carry lag. 5.dsp stack pointer. 6 old LCD driver on /off status, port 420 bit. 7 DEI enable interrupt flag, mel, tbcei, ext int ei. 8 DPN port n equals 0, 1, 2, 3, 4. 9.dpc program counter. 10 DCC cycle counter. 11 OCR probe compare register. 12 DPM probe mask register. 13 DBC break condition. 14 DBS break status. 15 OEM emulation mode. 16.dib initial buffer and final buffer. 17 DFB final buffer and initial buffer. 18 DSG segment data status. 19 DBP address, breakpoint bit memory. 20.DCE address, cycle counter enable bit memory. 21 DSO address, sync output enable bit memory. 22 die address, instruction executed bit memory. 23 DTR address, trace enable bit memory. 24 DDM address, data memory, M6502E internal RAM. 25 DCM address, code memory. 26 DVM address, verify memory. 27 DTM-TP address, line number trace memory. 28 DTL number, line number trace list. Change commands. 1 CAC data ace register. 2 CHL data HL register. 3 CCY oral carry flag. 4 CSP data stack pointer. 5 CLD oral LCD driver on /off status. 6 CEI data, enable interrupt flag. 7 CIR data index register. 8 CPN data port n equals 0, 1, 3, 4, 5. 9 CPC address program counter. 10 CCC, plus or, data cycle counter. 11 CCR data probe seek compare register. 12 CPM data probe mask register. 13 CBZ oral buzzer output select hard or soft. 14 SEM mode emulation mode. Mode. If IB to FB. In IB to non. NN non to non. NF non to FB. FN FB to non. 15 CI keyword data initial buffer. 16 CF keyword data final buffer. 17 CSGS meant data. 18 CCM address CoE memory. 19 COM address data memory, M6502E internal RAM. 20 bank 0 or 1 attribute memory bank. 396. E6502. Enable commands. 1 EBP address breakpoint bit memory. 2 ECE address cycle counter enable bit memory. 3 SO address sync output enable bit memory. 4 ETR address trace enable bit memory. Reset commands. 1 RBP address breakpoint bit memory. 2 RCE address cycle counter enable bit memory. 3 readdress instruction executed bit memory. 4 RSO address sync output enable bit. 5 RTR address trace enable memory. 6 res EM6502 EVA chip. 7 res MPB6502 board. Fill commands. 1 FCM address, data code memory. 2 FDM address, data memory. 3 FIDM address, data initial data memory. 4 FFDM address, data final data memory. Emulation commands. 1 GST address, break parameter, dash begin emulation. 2 GDST address, break parameter, underscore OJ begin emulation. If the optional ST address is given, emulator will begin emulation from ST address. And if optional break parameter is given, emulation will break on the first break parameter to be satisfied. Break parameter equals break address. Equals break address, pass count. Equals break address, pass count, and break address, pass count. Equals break address RAM address data. 3 STP number, ST address single step. Other commands. 1 ASM address assemble to code memory. 2 DASM address disassemble to console. 3 list. 4 NLST. DR, smiley face, file name list console output into disk file. And listing. 5 DBLK address display block memory. 6 SPB address set program block. 7 SDB address set DB block. 8 SIO for H set emulator to IO terminal mode. 9 exit rhythm to CP/M. 10 pause stop command file execution. 11 diagi start cell check program. 12 diagram DR, smiley face, file name execute command file. 13 at and repeat command. 14 help display help file. 15 SBC, plus or mnemonic, dash, mnemonic. Set/reset break condition register. BB break when breakpoint reached. XB external break. CO break on cycle counter overflow. TF break when trace buffer full. PM break on probe match. HT break on halt instruction. 16 SDF, plus or mnemonic, dash. SE reset dump format. 1 del delete the last character entered. 2 CNTRL/C return to CP/M. 3/P copy all subsequent console output to the currently assigned list device. 4 CNTRL/Q continue normal display. 5 CNTRL/S stop display. 6 CNTRL/R echo E current input line. 7 ESC abort any command in progress. 8 at and repeat the command. Note, the MSM6502 RAM area corresponds to the E6502 emulator data memory, and the mask ROM corresponds to the code memory. 397. E6502- samples. 398. AERS E65. E65 PLEminary Li 1.0. SEP, 3,1983 OKL Electric IND Co Ltd. Now, start up i1P86502 board. Hardware self-check. Normal NJ. i1PB6502 emulator preliminary lit. 0.5. Copyright OKI Electric IND Co. Ltd 1984. Active break condition breakpoint break. Halt instruction break. Now device no. AB. Key in other device no. Presented device no ABJ. Asterisk diagram in ID1. Initialization start. Asterisk FCM star. Asterisk LSG pic.dat. Sgram setup completed. Load RAMSER. Load completed. Asterisk list CRT.lst. Next address equals 0020. J now initialization end and list start. Diagram command end. Asterisk GDO1F. Bank, 1 execution mode non to non. Reset trace pointer E. Emulation go. Parameter equals OOLF, 0. Address break. Break PCOIF next PCOOJ. Next trace pointer 17J. Asterisk DDH0,3. LOC03-005552. DTI14,3. LOC01282 LIPort, O2, FFOHLOOCIOMAOXPFFTP. LOC013B4 LMA port, 022, FFOHLOOCIOMAOXPFFTP5. LOC equals 01411 INL port, O2, equals FFOHL equals OOCV equals OI1 EIOXPFFTP equals 6. Die 0,20. LOC equals 0001000001111 111111111111 LOC 020. Asterisk dash 0,13. LOC 0005 FDID. LOC UI do JCP 010. LOC 002 DB 0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000ɔ LOC equals 01282 Li2. LOC 013B4 LMA. Asterisk NLST. Asterisk exit. A. Dash. E6502. E6502 Program Development Support System. For the MSM6502 CMOS 4-81T1 chip microcontroller. Category Model Title. Hardware MPB 6502 4-bit 1-chip microcontroller evaluation board. E65 floppy disk-based host monitor star. Software. ASM 6502 floppy disk assembler star. Manual TM6502 E6502 development support system, user's manual. TCU 6502 user application circuit connection cables. TCS1 host CP/M registered computer connecting cables, 4F800 model 10/20/30. Accessories TCP1 power supply cables, plus 5V, 4.5A, plus 12V, 0.2A, -12V, 0.2A. TCX1 external probe cables. TCC1 board connecting cables. Asterisk available under following operating system. CP/M80, ver 2.0 or later. MS-DOS, ver 2.11 or later. PC-DOS, ver 2.11 or later. Options. Option name remarks. MPB 6502 EVA. A simplified evaluation board consisting of the MSM 6502E plus EPROM sockets. Board. And designed for the MSM 6502. Programs are evaluated by inserting the EPROM, where the user program is stored into an EPROM socket. Dimensions, 160 x 127 mm. 399. EASE OOC49 Program Development Support System. 4. MSM-ADC48R/MSM-ADC49R/MSM-ADC50R CMOS 8-bit microcontrollers. EASE ADC49 Program Development Support. System. The EASE-ADC49 program development support system has been specifically designed for rapid and efficient program development of OKI's MSM-ADC48Rs, MSM-ADC49Rs, and MSM-ADC50Rs CMOs. 8-bit, one-chip microcontrollers. Features. 1 in-circuit emulation when connected to an RS-232C. Interface equipment host computer or to an input/output device such as a CRT terminal. 2 4KB user program area available for code transfer to / from floppy disk, collation/updating of area contents, and continuous /step execution. 3 8 types of break conditions, for interruption of emulation, including execution address and machine cycle counter. 4 EPROM programmer, for 2716, 2732, 2732A, to enable writing, transfer, and comparison of user program area contents. 5 user program debugging operations directed by debug commands entered from the keyboard of the connected input output device. 6 built-in system diagnostic program. Host computer requirements. 1 operating system is one of the follows. 1. CP/M at -80, ver 2.0 or later. Memory capacity of the host computer must be sufficient to run at least 52K. CP/M. 2. MS-US registered, ver 2.11 or later. 3. PC-US registered, ver 2.11 or later. 2. At least one RS-232C communication port is implemented. 3. Data transfer is performed through RS-232C communication port using booz function. Call 6 on condition that console devices assigned to TTY MPB800 evaluation board data transfer system ICS used. Communication interface MSM82C51A. Driver/receiver SN75188N. SN75189N. Transmission format 110 to 9600 bps, switchable. 8 bits, 2 stop bits, non-parity. 400. System configuration. The EASE-ADC49 program development support system consists of the EASE-ADC49 emulator, a high-performance program emulator which includes the EASE-49 host monitor, the MPB800 evaluation board, and the host computer, and the ASM49 assembler. With the MPB800 evaluation board connected online to the host CP/M computer, such as an IF800, equipped with an RS-232C interface, the system covers all operations from assembly of the source program through to program evaluation and debugging. MPB800 evaluation board +5V + 12V-12V 4.5A 0.2A, 0.2A. EASE-49. ASM-49. 8. ICG. O. Note, CP/M is a registered trademark of Digital Research Inc. USA. When the EASE-ADC49 is used on the MSM-ADC50, the MSM-ADC39 evaluation chip on the emulation board is to be replaced by MSM-ADC40. EASE-49 and ASM-49 for PC-DOS, MS-DOS are optional softwares. EASE-ADC49. ASM-49 cross-assembler. The ASM-49 is a floppy disk-based high-performance assembler. It translates source files generated on disk by using an editor, thereby generating object code files and assembly list files. Features: 1 free descriptive format source files. 235 types of powerful pseudo instructions. Available for assembler control purposes. 3 macro definition ability. 411 types of pseudo instructions to enable. Conditional assembly. 5 assembly repetition processing, loop processing. 6 determination of variable values in the source program by input from a console. During assembly, and linking to existing source programs. Input and link pseudo instructions. 7 capacity to describe up to 13 types of operators in the source program operand column. List of pseudo instructions. Pseudo instructions function. Org expression location counter value defined as NNN. Expression equals NNN. DS expression reserves memory area for N number of bytes. The first and last byte values may be changed. Use org $+n to prevent change of values. Expression equals N. DW expression 16-bit data definition. DB expression a bit data or ASCII character. String definition. EQU assignment of operand value. To name. Set same as EQU pseudo instruction, but with redefinition capacity. IF expression evaluate expression value. And skip to next end div, end. Or EDF, end of file, if result is 0. Assemble the next instruction if result is not 0. NIF expression evaluate expression value. And skip to next end div, end. Or EDF, end awful, if result is not 0. End expression end of assembly. Macro definition. Go to label branch the subsequent assembly to the destination indicated in the label. Report expression denotes repetition block. Assembly is executed the number of repetitions indicated by the expression value. Rep definition of end of repetition. Block. List pass option invalidated, and output of full assembly list. Nullst inhibition of assembly list. Outputs apart from error. Messages. Title allocation of title at head of assembly list page. 401. U. EAS ADC49E. EAS ADC49 emulator. Consisting of a host computer and the MPB800 program evaluation board, the EAS ADC49 emulator supports a wide range of development debugging operations efficiently and effectively. MSM-ADC49Rs and MSM-ADC50Rs application programs can be debugged without user application circuits just as easily as completed systems. Features. 1 real-time tracing function does not affect execution time. The MPB800 evaluation board incorporates a real-time trace area for 1024 machine cycles. When tracing for a particular user program area address has been set, the port, program counter, and probe data status are traced each time the specified address is executed. 2 execution time measurement. The user program execution time can be measured by using the cycle counter on the MPB800 evaluation board. Max 16,777, 215 cycles. This counter can also be used as a pass counter to indicate the number of times a specified address is executed. 3 4096 byte user program area. A 4096 byte static RAM area in the MPB800 evaluation board is used as a user program area, and user programs can be loaded/saved from the host computer into this area. Furthermore, with an EPROM programmer included on this board, the user program area contents can be written into EPROMs, and EPROM contents can be read. For example, break functions. The emulator can suspend, break, program execution by any of the following 8 break conditions. A. BB, breakpoint break. Break upon execution of specified address. Any address may be specified. B. EB, external break. Break by application of external break signal. C. Cycle counter overflow break. Break when overflow of cycle counter occurs. D. TF, traceful break. Break when 4097 tracings executed. E. PM, probe match break. Break when probe data matches set data. F. If, instruction fetch. Break when machine code is fetched. G. MX, MOVX. Break by MOVX instruction. H. Error code. Break if incorrect machine code is fetched. 402. 5 extensi, range of debugging commands. In addition to display/updating of all register, port, and RAM contents, the following commands enable all debugging operations to be executed efficiently. A. User program execution. Input format. STP number of instructions, start address. Input of this command results in the specified number of instructions in the user program being executed from the specified address. Start address. Input format. G. Start address. Input of this command results in the user program being executed from the specified address. Start address. If no start address is specified, execution is started from the address indicated by the program counter at that time. B. Use of floppy disks. Input format. LOA file name. Input of this command enables the specified file contents, user program, to be loaded into the MPB800 evaluation board code memory, which serves as the MSMADC49Rs/MSMADC50Rs masked ROM area. The same contents can also be loaded into the utility buffer by using the LDU command. Input format. Say, start address, end address, file name. Input of this command enables the contents of the specified range of code memory to be saved at the specified file name. C. Instruction executed bit memory. The EASE-ADC49 emulator includes an instruction executed bit memory which indicates which user program addresses have been executed. Program flow can be determined by examination of the contents of this memory. Dash 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 EASE-ADC4GE. 6 easy to remember command format. The MPB800 emulator debugging commands consist of command mnemonics followed by parameters, address or mnemonic. Command mnemonic configuration. A. First character denotes the function to be executed by the emulator. B. Second and following characters. Name of function to be executed by the emulator, that is, MSMADC39 microcomputer or MPB 800 evaluation board register, memory, or port name, abbreviation. Example: asterisk DDM0, 1F 2\JIVI. UBCDEF. A. Denotes wait for command input from emulator. B. Denotes display of contents of specified register. Memory/board. C. Data memory, equivalent MSM80C49Rs/ MSM80C50Rs RAM area, designation. D. Start address of contents to be displayed. E. End address of contents to be displayed. F. Carriage return denoting end of command input. Major memory operations. 1. Code memory. The code memory is an 4096 x 8-bit RAM area, which corresponds to the MSM80C49Rs/ MSM80C50Rs program area, masked ROM, where user progress LMS are stored. 2. Data memory. The data memory is a 128 x 8-bit RAM area, corresponding to the data memory, RAM, on the MSM80C49Rs chip. The data memory area for MSM80C50Rs is 256 x 8 bits. 3. Utility buffer. The utility buffer is a 4096 x 8-bit RAM area used in temporary saving from the emulator when a load, save, or transfer command is entered. 4. Breakpoint bit memory. The breakpoint bit memory is also an 4096 x 1-bit RAM area which has addresses identical to the code memory. If a particular bit in this memory is 1, program execution is suspended immediately after the code memory contents corresponding to that bit are executed. 5. Trace enable bit memory. The trace enable bit memory is another 4096 x 1-bit RAM area which has addresses identical to the code memory. If a particular bit in this memory is 1, port and probe data is stored in the trace memory when the code memory contents corresponding to that bit are executed. 6. Sync output bit memory. The sync output bit memory is another 4096 x 1-bit RAM area which has addresses identical to the code memory. When the code memory contents are executed, the corresponding bits in the sync output memory are checked, and if a 1 bit is found, an output sync signal, active low, is passed to the probe terminal. 7. Cycle counter enable bit. The cycle counter enable bit memory is also another 4096 x 1-bit RAM area which has addresses identical to the code memory. When the code memory contents are executed, the corresponding bits in the cycle counter enable bit memory are checked, and if a 1 bit is found, the cycle counter is counted up in step with that machine cycle. 8. Probe comparison register / probe mask register. The conditions for generating a break by input data from the probe match break, can be changed by altering these two settings. 9. Trace memory. The trace memory is a 1024 x 56-bit RAM area used to store trace data. The trace instruction is given by the trace enable bit 403. D. IS80C49. IS80C49 emulator memory configuration. The IS80C49 emulator, which consists of a host CP/M registered computer and the MPB 800 evaluation board, has been designed for efficient debugging of MSM80C49Rs and MSM80C50Rs application programs. The various sections of the ES80C49 emulator which can be used are outlined in the following diagram. The sections enclosed in boxes represent the register and memory areas which can be accessed from the host computer keyboard, and which can be displayed /update by emulator command. Instruction executed bit memory. Trace enable bit memory sync output bit memory. Breakpoint bit memory cycle counter enable bit memory. 404 cm code memory 4096 xs OM data memory 12s XM external memory 256 xs option BTLSC pre-0E \1/ 4096 x1 program counter PC 121 probe compare probe register mask I PR S1 I PM SL interrupt VDD external probe IVDLLXPSL UB utility buffer 4096 XS TM trace memory 1024x56 trace pointer I TP10 cycle counter I CC24 accumulator instruction data program status word AC SL break control register I BC SL test to test 1 EJE 10s/PSSL break status register timer error code IBSSLTIS1ECSL Porto bus port I POSL port 1 PLSL port 2 P2SL emulator memory configuration dash ES80C49 execution example. In this sample program, 1 byte is read from port 1, and a parity check is executed on the first 7 bits. The MSB most significant bit is set to 1 if parity is odd parity, and reset to 0 if even parity. The result is then passed to port 2. Note that errors have been intentionally included in this program for demonstration purposes. Various emulator commands are used to correct the errors. It is assumed that the program has already been assembled, and the object code has been stored in hexadecimal format in a file called parity.hex in drive A. Program list 0000 0000 0000 0000 0000 0000 0000 0000 0000 0000 0000 0000 0000 0000 0000 0000 0000 0000 0000 0000 000I 0003 0005 0007 0009 000A 000C 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 000E 000F 002 002 003 0015 O0I6, O9, 537F, 140C, E609, 4308, 3A, 040A, BA08, 97, I2, A7, 77, EA0F, 83, 0000 errors. Symbol table. Asterisk 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 asterisk. This program reads a byte from port 1 and checks bits 0 through 6 for parity. If parity is odd, then bit 7 in the byte will be set and the result will be output to port 2. If the parity is even, bit 7 will be reset before the byte is output to port 2. Asterisk 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 asterisk. Parity. PARI. Wait. PAR0. PAR2. PAR3. Org. In. ANL. Call. JNC. ORL. OUTL. JMP. Asterisk main program star. A. PI. A. Hashtag 7FH. PAR0. PARI. A. Hashtag 8H. P2. A. Wait. Asterisk subroutine star. MOVR2, number 8. CLRC. JB0, PAR3. CPLC. RRA. Input byte from Pi. Mask out bit 7. Jump if even parity. Set bit 7. Output byte to P2. Set loop count. Initialize carry flag. Jump if bit 0 equals I. Toggle carry flag. DJNZR2, PAR2, loop 8 times and RET. RET. End. PAR0000C parry 0009 PAR2000F PAR300I2. 405. EAS ADC 49- AES 49. MPB 80080C49 emulator. Ver 4.3. Copyright June 1982. OKI Semiconductor. FCM0FFFFF, code memory is filled with FFH. Loa PARIT contents of the parity hex file are transferred to the code memory. DCM01F, code memory location contents from address 0 through 1FH are displayed. 000 equals 09537F14 OCE60943083A040ABA089712. 010 equals 12A777EA of 83 FFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFFF EBP17FFF breakpoint bits from address 17H through FFFHRST to 1. DBP02F- the breakpoint bit status from address 0 through 2FH is displayed. 000 equals 0000000000010000000. 010 equals 0000000001111111111. 020 equals 11111111111111. CP10 port 1 is set to 0, even parity. CP20 port 2 is set to 0. G0 start of emulation from address 0. Emulation begun. PC equals 008 terminated PO equals FFP1 equals 00 P2 equals 002 equals 1 T1 equals 1 XP equals FFAO equals 00RO equals R1 equals CA dash. Port 2 is correct in respect to even parity. CP11 port 1 is set to 1, odd parity. SDFALP1 P2 AC dump format is changed. G0 start of emulation from address O. Emulation begun. PC equals 008 TBRMI NAT ED P1 equals 01 P2 equals 09 AC equals 09 port 2 is not correct in respect to odd parity. CP13 port 1 is set to 3, even parity. Dash colon dash dash dash. Port 2 is set to 0. G0 start of emulation from address O. Emulation begun. PC equals 008 term in at. CP14 port 1 is set to 4, odd parity. CP20 port 2 is set to 0. G0 start of emulation from address O. 406. Dash. EAS ADC 49. Emulation begun. PC equals 008 TBRMINA TED P1 equals 04 P2 equals OCAC equals OC, port 2 is not correct in respect to odd parity. DTM-1010 trace contents of the last 10 cycles are displayed. PC equals 015 RET PO equals FFPL equals 04 P2 equals 002 equals 1 TL equals 1. PC equals 005 JNC09 PO equals FFPL equals 04 P2 equals 002 equals 1 TL equals 1. Possible interrupt. See Appendix 3. PC equals 0070 RL. PC equals 0090 UTL. PC equals 00 JMP. EBP5. CP20. G0. A hashtag 08 PO equals FFPL equals 04 P2 equals 002 equals 1 TL equals 1. P2 PO equals FFPL equals 04 P2 equals OC2 equals 1 TL equals 1. 008 PO equals FFPL equals 04 P2 equals 002 equals 1 TL equals 1. The breakpoint bit at address 5H is set to 1. Port 2 is set to 0. Start of emulation from address O. Emulation begun. PC equals 007 terminated PL equals 04 P2 equals 00 AC equals 04. STP55 steps, instructions, are executed. PO equals 0070 RLA hashtag 08 P1 equals 04 P2 equals 00 AO equals 00. PO equals 0090 UTL P2 PL equals 04 P2 equals OCAC equals OC. PO equals 00 JMP 00 PL equals 04 P2 equals OCAO equals OC. PO equals 00 JMP 00 P1 equals 04 P2 equals 00AO equals 00. PC equals 00 JMP 00 PL equals 04 P2 equals 00AO equals OC. In equals 1. 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 XP equals FFTP equals 0058. XP equals FFTP equals 0060. XP equals FFTP equals 0062. XP equals FFTP equals 0064. XP equals FFTP equals 0066. DCM0F code memory location contents from address O through FH are displayed. 000 equals 09. UM8. DOM0. 000 equals 09. RBP5. OPI1. Asterisk CP20. Asterisk G0. 53. 80. 7F14 OCE 609430830ABA089712. Code memory location contents at address 8H are changed to 80H. F. Code memory location contents from address O through FH are displayed. 53 7F14 OCE 6094383A040ABA089712. -RHE breakpoint bit at address 5H is set to 0, reset. Port 1 is set to 1, execution of odd parity again. Emulation begun. PO equals 008 terminated PL equals OI P2 equals 81 AO equals 81. 0P17F port 1 is set to 7F, execution of odd parity again. CP20. *G0. Emulation begun. PO equals 008 terminated PL equals 7F P2 equals FFAC equals FF port 2 is correct in respected parity. Say 01F PRTY1 program with file name of PRTY1.hex is stored. *FOM0FFFFF code memory is filled with FFH. *VPRO FFF0 EPROM is inserted into an EPROM socket and a blank check is executed. *LOA PRTY1 program with file name of PRTY.hex is transferred to code memory. PPRO1F0- transferred contents are written in the EPROM. VPR01F0- EPROM contents are compared with code memory contents. I see no error message, EPROM and code memory contents are identical. A return to CP/M, R, control. 407. EAS ADC 49-. List of debugging commands. Characters which can be used. AABBCCDDEEFFGGHH LYLNUPICURUSES 2 of WSIS 1 2 3 4 5 6 7 8 9 0, at plus. CNTL/CCNTL/PCNTL/OCNTLLRCNTLFT escape space. Display commands. 1 DAC display accumulator. 2 DBP 000FFF display breakpoint bit, S, status. 3 DBS display break status. 4.DCC display cycle counter. 5 DCE 000FFF display cycle counter enable bit, S, status. 6 DCM 000FFF display code memory. 7 DDM 007F display data memory. 8.000FFF display instruction executed bit, S, status. 9.DPO display port A, bus port. 10 DP1 display port 1. 11 DP2 display port 2. 12 DPC display program counter. 13 DPS display program status word, test 0, test 1, interrupt pin. 14 DRG display registers R0 through R7. 15 DSK display stack. 16 DS0000FFF display sync output bit memory. 17 DTI display timer. 18 DTM, XXX, YVYV move trace pointer, XXXX, and display trace memory, YVYV. 19 DTP display trace pointer. 20 DTR, 000FFF display trace enable bit, S, status. 21 DVD display VDD pin. 22 DXM, 00FF display X1 ernal memory. 23 DXP display X1 ernal probe byte, probe mask, and probe compare register. Change commands. 1 CAC, FF change accumulator. 2 CCC, ZZZZZZZZ change cycle counter, ZZZZZZZZ is a positive or negative decimal number. 3 CCM, FFF, FF change code memory. 4 COM, 7F, FF change data memory. 5 CPO, FF change port A, bus port. 6 CP1, FF change port 1. 7 CP2, FF change port 2. 8 CPC, FFF change program counter. 9 CPM, BBBBBBBB change probe mask, BBBBBBBB is a binary number. 10 CPR, BBBBBBBB change probe compare register, BBBBBBBB is a binary number. 11 CPS, FF change progr.m status word. 12 CTI, FF change timer. 13 CXM, FF change external memory. Fill commands. 1 FCM, 000, FF fill code memory. 2 FDM, 00, 7F, FF fill data memory. 3 FXM, 00, FF fill X1 kernel memory. Enable commands. 1 EBP, 000 FFF, enable breakpoint bit, S. 2 ECE, 000 FFF enable cycle counter bit, S. 3 SO, 000 FFF enable sync output bit, S. 4 ETR, 000 FFF, enable trace bit, S. 408. Dash. EAS ADC 49. Reset commands. 1 RBP, 000 FFF reset breakpoint bit, S. 2 RCE, 000 FFF reset cycle counter enable bit, S. 3 RE, 000 FFF reset instruction executed bit, S. 4 RSO, 000 FFF reset sync output bit, S. 5 RTR, 000 FFF reset trace enable bit, S. 6 residential reinitialize MPB 800 system. Utility and disk input/output commands. 1 cub, FF change utility buffer. 2 dub, 000 FFF display utility buffer. 3 fub, 000 FF fill utility buffer. 4 TCM, 000 FFF transfer code memory into utility buffer. 5 tub, 000 FFF transfer utility buffer into code memory. 6 TST test. 7 LOA, file name load program into code memory. 8 LU, file name load program into utility buffer. 9 save, 000 FFF, file name save code memory program. 10 SVU, 000 FFF, file name save utility buffer program. EPROM writer commands. 1 PPR, 000 FFF program code memory onto EPROM. 2 VPR, 000 FFF verify EPROM with code memory. 3 TPR, 000 FFF transfer EPROM into code memory. Emulation commands. 1 GHHH begin real-time emulation. HHH is the start address, hex. 2 STP step emulation, where EEE is the decimal number of instruction to execute. And HHH is the start address, hex. 3 SBC, mnemonic SE reset break control bit. Mnemonic O. 4 SDF, mnemonic SE reset dump format. Mnemonic. Command line editing and keyboard operation. 1 rubout delete the last character entered. 2 CNTL/C return to CP/M. 3 CNTL/P copy all subsequent console output to the currently assigned list device. Output is sent to both the list device until the next CNVP is typed. 4 CNTL/Q continue normal display. 5 CNTL/R echo E current input line. 6 CNTL/S stop display. 7 escape abort any command in progress. 8 add repeat last command. 409. U. EAS ADC49-. EAS ADC49 8-bit 1-chip microcontroller. Program Development Support System. Category Model Title. Hardware MPB 800 8-bit 1-chip microcontroller evaluation board. EAS 49 floppy disk-based emulator. Software. ASM 49 floppy disk-based assembler. Manual TM800 Program Development Support System User's Manual. TCU 800 User Application System Connecting Cables. TCS8 Host CP/M, R, Computer Connecting Cables, 4F800 Model 2030. Accessories. TCP8 Power Supply Cables, plus 5V 3.5A, plus 12V, 0.2A, -12V 0.2A. TCX1 External Probe Emulation Purposes. Available under following operating system. CP/M80, ver 2.0 or later. MS-DOS, ver 2.11 or later. PC-DOS, ver 2.11 or later. 410. EAS ADC51 MKLL Program Development System. 4. MSM83C154/ADC51 CMOS 8-bit, 1-chip microcontroller. EAS ADC51 GIL Program Development System. The EAS ADC51 MKLL Program Development System is a high-performance dedicated system featuring OKI's exclusive technology, and which has been specifically designed for rapid and efficient program development of the OKI MSM83C154/ADC51 8-bit single-chip microcontroller. System configuration. The EAS ADC51 MKLL program development system consists of the EAS ADC51 MKLL emulator, a high-performance program emulator which includes the EAS host monitor, the EAS AD51M KLL emulation kit, and the host CP/M at or PC-DOS computer, and the ASM51 assembler. A powerful assembler operated in CP/M at or PC-DOS. With the EAS ADC51 MKLL emulation kit connected online to the host CP/M computer, such as the F800, equipped with an RS-232C interface, the system covers all operations from assembly of the source program through to program evaluation and debugging. Host computer requirements. One operating system is one of the follows. 1. CP/M registered -80, ver 2.0 or later. Memory capacity of the host computer must be sufficient to run at least 52K CP/M. 2. MS-DOS at, ver 2.11 or later. 3. PC-DOS, ver 2.11 or later. 2. At least one RS-232C communication port is implemented. 3. Data transfer is performed through RS-232C communication port using booz function. Call 6 on condition that console devices assigned to TTY. Emulator data transfer. ICS used. Communication interface MSM82C51A. Driver/receiver SN75188N. SN75189N. Transmission format 300 to 19200 bps, switchable. 8 bits, 2 stop bits, non-parity. Asynchronous. 411. EAS ADC51 GIL EAS. ASM51. FDD. Host. Computer. RS-232C. Users. Application. Circuit. User cable. EAS ADC51 MKLL. Emulation. Kit. 1. connection to host computer. Terminal unit. CRT terminal etc. Rs232C. / Users. Application. Circuit. User cable. EASE-ADC51 MKLL. Emulation. Kit. AC power supply. 2. Connection to terminal unit. Fig1 system configuration. Note 1. CP/M is a registered trademark of Digital Research Inc. USA. 2. The AC power supply can be switched to 90-132V and 180V264V at a terminal inside the emulation kit. 3. PC-DOS stands for IBM Personal Computer DOS. 412. EASE-ADC51 MKLL. ASM51 assembler. The ASM51 is a floppy disk-based high-performance assembler. This assembler is used to translate source files generated on disk by using an editor, available on the market, thereby generating object files, Intel hex format, assemble list files, cross-reference list files, and symbol list files in the specified devices. Output files. 1. Object files, Intel hex format. 2. Assembly list files. 3. Cross-reference list files. 4. Symbolic list files. Features. 1. Free descriptive format source files. 2. Capacity to describe up to 10 types of operators in the source program operand column. 3. Ability to specify the number of characters per line and the number of lines per page in assemble list files. 4. 24 powerful pseudo instructions. 5. Control of assemble list file outputs by list or no list pseudo instruction. 6. Output file and output device can be specified when the assembler is started. ASM51 assembler functional. Block diagram. Source file. ASM51. Assembly list files. __ symbol list files. _____ cross-reference list files. Part of pseudo instructions list. Pseudo instructions function. EQU assignment of operand value to name. Set same as EQU pseudo instruction, but with redefinition capacity. Org setting of program start. Address. And indication of end of program. JMP automatic change to relative. Internal 2K page, or all pages. Jump instruction after checking. Branch destination. Call automatic chang to relative. Internal 2K page, or all pages. Call instruction after checking. Branch destination. Radix change to 2, 8, 10, or 16 depending on value of operand. DB 8-bit data or ASCII character. Definition. DW 16-bit data definition. DS reserves memory area for specified number of bytes. NSE setting of degree in the 4 lower order bits of the assembler. Location counter, and addition of 16. The NOP instruction is assigned to blank areas where no machine language instruction has been assigned. Date insertion of date in assemble. List title. Eject assemble list page feed. Operation. Title insertion of assemble list title. List designation of assemble list. Output. Nollis zuobition of assemble list. Output. 413. EASE-ADC51 GIL E _____. EASE-ADC51 GIL emulator. Connected to the host computer via an RSS-232C interface, The EASE ADC51 MKLL emulator supports a wide range of development debugging operations efficiently and effectively. MSM83C154/ADC51 application programs can be debugged without user application circuits just as easily as completed systems. Features: 1. Real-time emulation. Real-time emulation without insertion of await state is possible because of the MSM83C154E IVA chip. 2. Execution time measurement. The user program execution time can be measured with the cycle counter in the emulation kit. Max 4,294,836,225 cycles. This cycle counter start/stop is affected according to the cycle counter start address/stop address set by the command. 3. Mass storage user program area. This emulator provides a 64 KB RAM area, which is the entire address space of MSM83C154/ADC51, as the code memory. User program area. So, the largest program for MSM83C154/ADC51 can be fully loaded in this RAM area. It is also possible to assign 4 KB units of program memory area to the RAM area on the emulation kit or the ROM on the user's application circuit by using the mapping command. This emulator further provides the EPROM programmer to enable the user program area contents to be written to the EPROM or the EPROM contents to be read. EPROM supported Intel 2732, 2732A, 2764, or 27128 or equivalent. 4. Ample break functions. The emulator can suspend, break, program execution by any of the following break conditions. All conditions can be set and cancelled as desired. A. Breakpoint break. BRAK upon execution of the address where a breakpoint has been set. Any address to be specified. B. Address break. Break execution of the address specified when the emulation command input was applied. It is also possible to specify a break after the specified address has been executed n times. C. Power down break. Break occurred when IVA chip going to the power down mode. D. Break by external forced break signal. 414. Break by input of low-level break signal from outside via the attached probe cable. E. Break by trace memory overflow. Break occurs when the trace memory is filled up with trace data. I. Break by cycle counter overflow. G. Break by internal RAM/SFR area contents. Break occurs when the contents of the specified RAM/SFR in the MSM83C154E matched with the specified contents the specified number of times upon execution of the program at the specified address. 5. Comprehensive real-time trace functions. This emulator has the following 2 real-time trace areas not affecting the execution time. 1. Trace memory. This is the memory to trace, store, the status of the ports, carry flag and accumulator of the MSM83C154E when an instruction in the program memory area is executed. Up to 2048 machine cycles. Tracing is instructed in 3 ways as shown below. A. To start tracing each time the specified address is executed. B. To start tracing upon execution of a special instruction, ACAL, AJMP, LCAL, LJMP. RET, RETI, push or pop. C. To cause tracing by trace start/stop bit. 2. Flash trace memory. The memory to trace status of the whole internal RAM or SFR area in the MSM83C154E, when the instruction at the address specified by the emulator command, debug command, being executed. The contents of the internal RAM or SFR area can be stored up to 16 times in this memory. 6. Easy to use emulator commands. The emulator command, debug command, of this emulator consists of the command mnemon, IC and succeeding parameter, S, address or mnemonic. Command mnemonic structure. A. First letter represents the function to be performed by the emulator. B. Second letter and on represent MSM83C154E EVA or EA. SE80C51 MKLL emulation kit, register, memory, or port name. Dash. ES80C51 MKLL. Example. Asterisk DDM01F. 2\JIVI. UBCDEI. A. Indication 01 waiting lore command input IROM. Emulator. B. Instruction 01 displaying contents 01 specified. Object. C. Instruction of data memory, equivalent to internal RAM area in MSM83C154E. D. Start address of contents to be displayed. E. End address of contents to be displayed. I. Carriage return indicating end of command input. This emulator provides various emulator commands not only for display/modification of the contents of each register and port of the special evaluation chip MSM83C154E but also for efficient debugging operation. Input format. STP number of instructions start address. Inputting the above command causes the user program to be executed for as much as the specified number of instructions from the specified addresses, start address. It is possible to modify the display format to be easier to read by specifying the object of contents display by the SSF command. Input format. G start address, parameter. Parameter input format. 1. Break address. Break address. 2. Break address, N. 3. Break address RAM address, byte N. 4. Break address SFR mnemonic, byte N. Inputting the command as shown in 1 causes the user program to be executed from the specified address, start address, and breaks the program execution upon execution of any of the specified break addresses. Inputting the command as shown in 2 causes the user program to be executed from the specified start address, and breaks the program execution when it has passed the specified break address in times. Inputting the command, as shown in 3, causes the program to be executed from the specified address. Start address. When the user program at the specified break address is executed, the contents of the specified address, RAM address, of the internal RAM in the MSM83C154E are compared with the specified contents, byte, and the program execution is broken if they agree the specified number of times, n. Inputting the command, as shown in 4, causes the user program to be executed from the specified address, start address. When the user program at the specified break address is executed, the contents of the specified SFR in the MSM83C154ER. Checked. If the contents agree with the specified value, byte, the specified number of times, n. Breaking occurs. Input format. 1. LOD file name. 2. Save file name start address end address. 3. Ver file name start address end address. Inputting the command, as shown in 1, enables the contents, user program, of the specified file on the host computer to be loaded into the code memory on the EASE-ADC51 MKLL emulation kit, corresponding to the program memory area. User program area, of the MSM83C154/ADC51. Inputting the command, as shown in 2, enables the block of code in the specified range of the code memory to be saved using the specified file name. Inputting the command, as shown in 3, enables the block of code in the specified file to be compared with the block of code in the code memory. Input formal. 1. Diagram file name. 2. M. 3. At. Inputting the command, as shown in 1, enables the command in the specified file to be executed automatically. Use of the pause command in combination enables execution of the command in the file to be suspended temporarily. Inputting the command, as shown in 2, enables the command line defined by the Mac command to be 7. Executed. Inputting the command, as shown in 3, enables the last command to be executed again. Input formal. 1. List file name. 2. NLST. If list command is entered, the emulator create the cp/m file on the host computer and writes into it any characters which are output to the console until entering the NLST command. Use of the above diagonal command in combination enable the debugging work to be executed and stored in the file automatically. Input formal. STM mnemonic data number. Using the S command, you can search out the trace information in the trace memory, where the TM mnemonic is the element of the trace information in the trace memory that you wish to search, and data is a value of that element. Number is the time of an agreement. For example, entering SPO23, the emulator searches through the TR memory from the top and finds the position where the trace PO data is equal to 2, 3 times, and displays the trace information at that position. 415. EASE-ADC51 GILI. Disk access commands. 1. Load DR file name load program into code memory. 2. Save DR file name address save code memory program. 3. Ver DR file name address verify file with code memory. 4. Diagram DR file name execute command file. 5. List DR file name list console output into disk file. 6. NLST end listing. 7. Help display help file. 8. FDD DR, set disk drive. EPROM programmer commands. 1. PPR address, program code memory into EPROM. 2. TPR address, transfer EPROM into code memory. 3. VPR address, verify EPROM with code memory. 4. Type mnemonic set EPROM type. Assemble commands. 1. ASM address assemble to code memory. 2. DASM address disassemble to console. 3. DBLK address, display block memory. 4. SPB address, set program block. 5. SOB address, set data block. Trace commands. 1 DTM number display trace memory. 2 DFTM number display flash trace memory. 3 DTG display trigger mode. 4 DFA display flash trace address. 5 S mnemonic data number search trace memory data. 6 SFF mnemonic set flash trace display format. 7 STG mnemonic set trigger mode. 8 SFA address, set flash trace address. 9 RFA address, reset flash trace address. 10 RTG reset trigger mode. Emulation commands. 1 STP number. 2 GST address, break parameter. If the optional ST address if given, emulator will begin emulation from ST address. And if optional break parameter is given, emulation will break on the first break parameter to be satisfied. Break parameter equals break address, maximum 10. Break address, pass count. Break address RAM address, byte pass count. Break address SFR mnemonic, byte pass count. 3 SSF, plus / mnemonic. Plus 1, mnemonic. Set STP command display format. Display commands. 10 display register flag port. 2 DSFR mnemonic display SFR mnemonic data. 3 DSFR mnemonic, display mnemon IC data. 4 DPC display program counter. 5 DREG display all register bank. 6 SPUB display receiver data. 416. Underscore 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 EES ADC 51 MKLLE. Change commands. 1 CSFR mnemonic data change SFR mnemonic. 2 CSFR mnemonic. Change SFR. 3 C peak data change program counter. 4 CREG data change register bank. 5 CSB youth data change transmitter data. Code memory and data memory commands. 1 DCM address. Display code memory. 2 DDM address. Display data memory. 3 DXDM address. Display external data memory. 4 CCM address change code memory. 5 CDM address change data memory. 6 CXDM address change external data memory. 7 FCM address byte fill code memory with byte. 8 FDM address byte fill data memory with byte. 9 FXDM address byte fill external data memory with byte. Attribute memory commands. 1 DBP address. Display breakpoint bit memory. 2 DTR address. Display trace enable bit memory. 3 DSO address low display sync output enable bit memory. 4 die address low display instruction executed bit memory. 5 EBP address enable breakpoint bit. 6 ETR address enable trace enable bit. 7 SO address enable sync output enable bit. 8 FPB address byte fill breakpoint bit memory with byte. 9 FTR address byte fill trace enable bit memory with byte. 10 FSO address byte fill sync output enable bit memory with byte. 11 RBP address reset breakpoint bit. 12 RTR address reset trace enable bit. 13 RSO address reset sync output enable bit. 14 reset instruction executed bit memory. Buffer memory commands. 1 DBUF display buffer memory. 2 TBUF transfer data memory and SFR data into buffer memory. 3 LBUF load buffer memory into data memory and SFR. Cycle counter commands. 1 DCC display cycle counter. 2 C seek data change cycle counter. 3 time data set 1 cycle time. Break condition and status commands. 1 DBC display break condition. 2 DBS display break status. 3 SBC, + mnemonic. +1, mnemonic set break. Other commands. 1 res ease ADC51 MK11 system initialization. 2 res EMSM83C154E IVA chip reset. 3 SIO for H set emulator to IO terminal mode. 4 pause stop com3.nd file execution and wait key in. 5 exit return host computers OS. 6 DIRDR. Display file directory. 7 map address. Mapping. 8 MAC define command execution. 9 M execute defined command. 10 add repeat front command. 11 MADC51 set emulator to the MSMADC51 checking mode. 12 M83C154 set emulator to the MSMAD3C154 checking mode. 417. O. EES ADC51 GIL E ________. EES ADC51 MKLL Program Development Support System. For the MSM83C154/ADC51 CMOS 8-bit 1-chip microcontroller. Crystal oscillator. Connector. Clock select switch. Reset switch //. EPROM programmer. AC power. Connector. Probe cable. Connector. User cable. Connector. RS232C. Connector. 300, W, X105, D, X210, H, MM. Category model name component name. Hardware EES ADC51 MKLL emulation kit for MSM83C154/ADC51. Emulation kit. Software EES host monitor for floppy disk based, No 2. ASM51 assembler for floppy disk based, No 2. Manuals TM-ADC51 EES ADC51 MKLL emulator users manual. AM-ADC51 ASM51 assembler users manual. Accessories TCU-ADC51 user application circuit connection cable. TCSN host computer connection cable, 3, No 3. TCP2 AC power supply cable. TCX2 emulation probe cable. Note 1. Refer to the ASM51 assembler user's manual for assembler details. Note 2. PDOS 51/4 floppy disk, PC format, double side double density, 8 sectors x 40 tracks x2. PC DOS stands for IBM Personal Computer DOS. CP/M 88-inch floppy disk, IBM 3740 soft sectored format, single side single density. CP/M 80 is the registered trademark of Digital Research Co. Note 3. 2 cables are used for connecting the IF800 or equivalent computer to the EES ADC51 MKLL. Emulation kit 1 to the CH1 port, and the other to the CH2 port. Model name, TCS2. 418. The third cable is for connection of an IBM PC or equivalent computer to the EES ADC51 MKLL. Emulation kit. This CALB is connected to the CH1 port. Model name, TSC3. EES ADC51 MKLL. Optional software. OS. Name supplied software. CP/M80 MS-DOS PC DOS VMS Unix. PASM000. Preprocessor. Mac 51000. Macro assembler. RL51000. Linker. LLB51000. Librarian. SID5100. Symbolic debugger. Objects. 00. Object converter. Being developed. Optional hardware. Type remarks. Handy I/O terminal. EAS8 can be used as a terminal unit for the EAS80C51 MKLL emulation kit. Convenient portable model. 419. Mac 51 supports ORI package. For the MSM80C51 CMOS 8-bit microcontroller. Features. 1 Symbolic relocatable assembly language programming for ADC51/154 microcontrollers. 2 Produces relocatable object code which is linkable to other 8051 object modules. 3 Encourages modular program design for maintainability and reliability. 4 Macro assembler features conditional as assembly and macro capabilities. Mac 51 support software package. The following Mac 51 programs are available to develop user programs. PASM preprocessor. PASM is used to expand macro calls, conditional assembly statements, and include statements included in user-generated source programs, thereby generating expanded source programs. A number of items of development information are inserted in these developed source programs for Mac 51. Mac 51 assembler. Mac 51 converts source programs into relocatable codes to form relocatable object files. OBJ files. Print, symbol, cross-reference, and error files are generated as assembly information. 420. LLB51 librarian. The L1B51 program manages OBJ files for each module. Files consisting of a number of relocatable object modules, OBJ modules, generated by L1B51 are called the object library. L1B51 handles object library generation, and OBJ module addition, deletion, and upgrading. RL51 linker. RL51 links and relocates one or more OBJ modules to generate one absolute object module. RL51 also generates a list file consisting of symbol table and link map as link information. OBJ modules which serve as the RL51 input can be OBJ files generated by Mac 51, and OBJ modules located within the object library generated by L1B51. SID51 symbolic debugger. SID51 is used when a symbol using debugger is selected. Absolute object files are converted to intellect hex format files. Objects converter. Objects converts object file into intellect hex file. Outline of program development. The procedures involved in the processing from source program generation through ROM loading are described below in the sequence indicated in figure 1:1. For further details of individual utilities, refer to the respective manuals. Mac 51. One generation of Mac 51 assembly language. Source program by the editor. Source programs can contain basic and pseudo instructions, and assembler control, macro call, conditional assembly, and include statements. 2. When macros are used, macro definitions are generated in macro library files, with Mac extension, by the editor. Macro call. Statements are described within source programs. 3. Where macro call, conditional assembly. Statement, and include statement. Descriptions are included in a source program, there are expanded by PASM2. Form an expanded source program. 5. 4 source programs or expanded source programs are assembled by Mac51 to form relocatable object files. 5. A group of relocatable object files can be managed by L1B51 together in a relocatable object library files, lib extension. When required, object modules can be called from this object library by RL51. 6. Relocatable object files are converted to absolute object files by RL51. At this stage, one or more relocatable object files can be linked to relocatable object modules in the library file. 7. ABS modules are converted by SID51 or objects to IntelliJ hex format files. With ease ADC51 MKLL, hex file contents can be written into EPROM devices. ease ADC51 MKLL. Fig 1-to-1 Program Development Flow. 421. O. Memo. 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 OKI. OKI Semiconductor. 650 North Mary Avenue, Sunnyvale, CA 94086, USA. Tel, 408-720-1900 Fax, 408-720-1918 TELX, 2966870 Key SNTA. For further information please contact Old Electric Industry Co., Ltd. Head Office Annex 10-3, Shibora, 4. Tel, 3-454-2111. Fax, 3-798-7643. Telex, J22627. Electronic Devices Group. Overseas Marketing Department. Printed in USA. Old Semiconductor. 650 Nora Mary Avenue, Sunnyvale, California 94086 USA. Tel, 408-720-T900. Fax, 408-720-1918. Telex, 296,687 OKI SNTA. Old Electric Europe GmbH. Need a Sealerlawegate. 0 to 4000 Isilderl 2. Fed. Republic of Genany. Tel, 211-59550. Fax, 211-591,669. Telex, 853-4312 OKI. Old Electronics, Hong Kong, Ltd. 16 Thruer, Fairmont House. 8 Cotton Tree Rive, Hong Kong. Tel, 5 to 263,111. Fax, 5 to 200,102. Telex, 62,459 OKHX. OKI Semiconductor. Rep No, MCU 10-482458. SINE 1881.